Hi everyone, welcome to PrepFusion. So this is our marathon on random process. So in this video, we will study about random process. So we have already studied about random variable. So there were two marathons on random variable 1 and 2. So don't watch random process directly. First you need to study random variable, then only you will be able to understand random process. So random variable is like a prerequisite to random process. If you don't study random variable, there will not be any meaning of random process. So first you study random variable, then you come here. So it will be a roughly around 10 to 11 hour of marathon. So complete random process will be completed here. Every single thing about the random process which is helpful for your examination, that will be completed, and a lot of questions we are solving. Okay, roughly around 100 problems we are solving in random process, right? And expectation, I keep the expectation that I expect that we will be getting 7k views and 400 likes on this video. So this is the expectation from my side as your educator. Okay, so yeah, watch that video and later on you let me know in the comment section that how did you find this video, like what was the level of quality, what was the level of problems that you found out in this video. Okay then, yeah, thank you very much, happy learning. You can get started with the video now. Hi everyone, welcome to PrepFusion. So now we are going to start our new chapter, that is random process. A very easy chapter, and we have already covered random variable, right? Random variable have been already covered. So random process, in random process you already know 70% of the things. If you have covered the random variable, then in random process you already know 70% of the things. Very simple lecture. Okay, so just keep on looking whatever that I am teaching on the screen, and then we will solve the problems, right? So let's get started. First see the definition. You will not understand anything by the definition. So definition says that it is the collection of random variable which is changing with respect to the time. So random variable and time both are being introduced, and combined they are making random process. So let's see this question, and with respect to this question you will understand the meaning of this definition. So a time domain signal xt is defined as capital AT plus B, where A and B both are discrete random variables. A and B both are discrete random variables, right? A can take the values 1, 2, 3 and B can take the values minus 1, 0, 1. You need to draw the sample function of xt. Now what is this sample function? You don't know, right? So let's see the meaning. So A can take the value 1, 2, 3 and B can take minus 1, 0, 1. So what I am saying is that, A is taking the value 1 and B is taking the value minus 1. Or what may happen? A takes the value 2 and B takes the value minus 1. Or what may happen? A takes the value 3 and B takes the value minus 1. Or what may happen? A takes the value 2 and B takes the value minus 1. Okay, 1, 2, 3 already taken. Sorry guys. Now 1 and 0. So A takes the value 1, B takes 0. A takes the value 2, B takes 0. A takes the value 3, B takes 0. Now A takes the value 1, B takes 1, right? A takes the value 1, A takes the value 2, B takes 1, and A takes the value 3 and B takes also 1. So these are 9 functions, 9 time domain function possible, right? x1t, x2t till x9t based on the value A and B are taking. So these are known as sample function. All these are sample function. All these are sample function. And the collection of these sample function is known as random process. There you go. So this xt is nothing but a random process. You can call it random signal as well, or you can call it random process. So it is having a name of random process, or people call it random signal as well. So here A and B are not constant. A and B are random variable which can take value 1, 2, 3, minus 1, 0, 1. So can you plot x of t? Yes, I can plot x of t in this manner. There are basically 9 straight lines. 9 straight lines are there based on the value A and B are taking. So this x1t, x2t, x3t, x4t, all these are known as what? These all are known as sample functions. What is this? Sample functions. So what we are doing, we are plotting the sample function. Now this x of t will be known as random process. So a collection of random variables changing with time. So A and B, collection of random variables changing with time, that means it is a function of time. Did you understand the meaning of random process? Very simple thing, very straightforward. Let's see another example. This time what we are doing, x of t is a cos pi by 2t, where a is a uniformly distributed random variable between which can take the value between 0 to 2. So A is a random variable, this is a random variable which is taking values between 0 to 2. So what could be the value of x of t? X of t could be 0 as well, because if A takes the value 0, then x of t will be 0. Now what could be x to t? What could be the other sample? What if A takes the value 0.1? So how many sample functions are possible? What do you think? Infinite sample functions are possible, no? Are you able to understand this point? What will be x3t? What if A takes the value 0.2, or what if A takes the value 0.123? So in that manner, infinite sample functions are possible, right? So what if A takes the value 2? So based on the values that your random variable is taking, we are making the random process. Okay. So your random variable is a function of time. There was a random variable and then you multiplied a function of time with the random variable, then you got a random process. So this is the meaning of random process. Is that clear to you? Very simple thing. And in the same manner we can plot it as well. But here we have plotted only 8 sample functions. Sample functions will be infinity, but in the diagram we have plotted only 8 sample functions, right? Based on the value A is taking. A is taking value 0, 0, then this line you are getting. A is taking 0.25, then this is the line you are getting. A is taking value 0.5. A is taking value 1. So in that manner here A is taking value 2. So this is the graph you are getting. Very simple, very straightforward. So what is the random process? Random process is a time domain signal which is monitored by a random variable. A time domain signal which is monitored by random variables. All good? All fine? Now let's see a very important point. If you sample a random process at a particular time instant, what is the meaning of sample? That means you will collect the value of a random process at a particular time. What I mean to say is that my random process is xt. Now I will calculate its value. At t equals to some particular time. Let's just say I am calculating its value at t equals to 2 seconds. I am having my random process and I am calculating its value at t equals to 2 seconds. So what I will write? X of 2, what that would be? 2a plus b. Now what is this? Random variable. What is this? Random variable. And what is this? Constant. So what do you think? What is 2a plus b? What is 2a plus b? Is this a random process or random variable? So 2a plus b is nothing but a random variable only. There was x of t. I sampled it at t equals to, I can sample it at negative time as well. Let's sample it at t equals to minus 3 seconds. So when I am sampling my xt at t equals to minus 3 seconds, what you are getting? Minus 3a plus b. Basically, what was your random process? So random process was nothing but a random variable plus time. Random variable and time, both were there. Plus means not the plus sign. What I mean to say is that in random process you will be having random variable as well and you are having that time as well. But what you are doing, you are fixing the time. T equals to 2 seconds, time is fixed. T equals to minus 3 seconds, time is fixed. So what you are getting? You are getting a random variable. So what is the statement? This statement will be written in a lot of textbook as well. What will be the statement? When you sample a random process at a particular time instant, you get a random variable. Is this part clear to you? Basically, if this particular graph is given, and what do I do is that I calculate the value of this graph. I calculate the value of this random process at a particular time instant. Let's just say that time instant is t equals to 2 seconds. Just 1 second, guys. Yeah, so what I was saying that I was sampling my random process at a particular time instant. That means I am sampling my random process at t equals to 2. So all these points will represent a particular random variable. Are you able to understand this point or not? So all these points are nothing but a random variable only. So what you are doing, this was your xt which we have already seen. A can take the value 1, 2, 3, B can take the value minus 1, 0, 1. So you are sampling your x of t at a particular time, t equals to 2 seconds, you got 2a plus b. So now 2a plus b can take these many values, right? If a is taking value 1, b is taking value minus 1. So what will be the value of 2a plus b? If a is taking value 1 and b is taking value minus 1, so value will be 1. If A is 2, B is minus 1, what will be the value? 3. If A is 3 and B is minus 1, what will be the value? 5. So in that manner, it can take 9 values. So it is nothing but a random variable. So 2A plus B can take, so 2A plus B is nothing but a random variable which can take 9 values, which is 1, 3, 5, and then I will put 1 and 0. So basically B is 0, so values will be 2, 4, 6, and then you will put 3 and 1. So sorry, 1, 2 plus 1, 3, which I have already written. If I put the value of A equals to 1 and B equals to 1, so you will get the value 3. Then 5 also already written, and then 7. So 2A plus B can take these values 1, 3, 5, 2, 4, 6, 7. So 2A plus B is nothing but a random variable, a very, very simple point, right? So what would be written, that x of t, it is sampled at a particular time instant, which is t equals to t1. This will be sampled at t equals to t1. So what you will get, x of t1. What this will be? Random variable. And what this was? Random process. So random process sampled at t equals to t1, you are getting random variable, right? And what was your x1 of t? x1 of t was nothing but a sample function. So don't get confused between these two things. xt1 and x1 of t. What was your x1 of t? x1 of t. Here, x1 of t. That means based on the value of random variable, based on the value of a random variable, what values your xt is taking, that is known as sample function. So this is your sample function and this is your random variable. X of t1 is not a function of time, right? It is not a function of time. Not a function of time. Because t equals to t1 is a constant time, like it could be 2 seconds, 3 seconds or minus 3 seconds. So it is not a function of time, so it is a random variable. Otherwise it is a sample function, right? So don't get confused with the term. Only thing you need to remember is that if you are sampling a random process at a particular time instant, you will be getting random variable. So this was a random process. I am sampling my random process at time t equals to t1. What I will be getting? X of t1, which will be a random variable. Right? Now what I am doing is that I am sampling my x of t, which is a random process only, at t equals to t only. What I am doing? I am sampling my random process at t equals to t. T equals to t. So what I will be getting? X of t only. But in my mind I know that it is a random variable. Is that clear to you or not? So in some textbook, if you find that x of t is a random variable, what does that mean? That means they have taken random process and then they have sampled it at t equals to t. That's why they are calling it a random variable. Otherwise it is a random process only. Is that clear to you? Okay. Now what I am doing? I am sampling my random process. I am sampling my random process at t equals to t plus 2. That means whatever the time I sampled here, after 2 time I am sampling again xt. What I mean to say is that, let's just say this was my some x1t, or let's just say this was my some x1t. That means this was my one of the sample function. Okay, a lot of functions will be there, like a lot of function will be there, and all the function combined will be known as random process. But I am only considering one function. So I am considering one of the particular sample function. Like in this graph, I am considering one of the graph. So what I am doing? First I am sampling at t equals to t1. First I am sampling at t equals to t1. So what I will get? I will get my one of the random variable. Then what I will do? I am sampling at t equals to, here I sample at t equals to t only, not t equals to t1. I sampled at t equals to t, and then I am sampling at t equals to t plus 2. Now this tau could be positive, negative, it could be anything. So tau could be ahead as well, tau could be backward as well. Basically you can sample here as well, no? First sample you have calculated at t equals to t. Second sample you can calculate previously as well. That means one sample you already calculated. That was at t equals to t minus 2 seconds. So here value of tau will be minus 2 seconds, and this sample could be at t equals to 2 seconds. So value of tau will be plus 2 seconds. Is that clear to you? Okay, all good, all fine. So what you will get? X of t plus 2. So this is also a random variable. So this thing we are going to use again and again. Everywhere we are going to use it. What we are going to do? what we are going to do is that we will sample our x of t. First we will sample our x of t at t equals to t, and then we will sample our x of t at t equals to t plus 2. So we will get two random variables, right? And what was your x1t, x2t, x3t and so on? These were your sample functions. These were your sample function. So basic terminology is clear to you. You have the basic knowledge of a random process now, right? You already know the meaning of sample function. You already know the meaning of a random variables. You already know the meaning of a random process as well, right? Very simple thing. Nothing is there. This 15 minutes of discussion can be done in 15 seconds as well. We started with random process. We got to know that it is random variable with the function of time. If I am calculating the random process at a particular time instant, what I will be getting? I will be getting a random variable. Now, since your function of time is depending on the random variables, and random variables can take some particular values like -1, 2, 3, 0, so 0 to 2, any value they can take. So a lot of time domain function you will get. So those time domain function is known as sample function. So this is the conclusion of everything that we have studied till now, right? Let's see the statistical parameter of a random process. Now these statistical parameter, okay, statistical parameter, very tough word, to be very honest, very tough word to say. So these parameters we have already seen in random variable. Mean, we will see correlation, covariance, variance, mean square value. In random variable we have already seen. So what do you understand? This expectation operator, always looks for random variable. This line I have always told, right? This expectation operator always looks for random variable. So this line should be there in your mind. Expectation operator, E operator, always looks for random variable. Always looks for random variable. Basically this operator always work only on random variable. This operator always looks for random variable. You will understand the meaning of this line. Although in random variable as well I took this line, that it will always look for random variables, right? So what I am doing, I am going to calculate the mean function. What is this mean function? With respect to example you will understand. So what was there? X of t was our random process. Now what I am doing, I am sampling this x of t at t equals to t only. So when I sample this x of t at t equals to t only, what I will get? X of t only. Now this is my random variable. So when you write down mean of random process, what you will do? Expectation of xt. So now some people will think that, sir, expectation you always put only on random variable. How you are putting it on random process? So actually I am not putting this expectation operator on random process. I am putting this expectation operator on random variable only. This expectation operator will work on random variable only. Now this x of t is nothing but a random process sample at t equals to t. So what you are actually getting? Random variable. So this x of t is nothing but a random variable. Are you able to understand this point? Although this is not important for your examination, but expectation you always apply on random variable, not on random process. So x of t is nothing but the random variable which you have got by sampling your random process at t equals to t. So if they are asking you mean of a random process xt, what you will do? Expectation of xt. So this is what you need to remember for the examination. If they are asking find the mean function, and also you need to find expectation of x of 2. So these things you need to find. So you need to find the mean function of random process. So what you will do? What you need to find? Expectation of xt. Now expectation of a cos omega t. Now what they have given? Omega is constant. Omega is constant. T is the time domain function and cos is nothing but a function. So for expectation operator, for this operator, this cos omega t will become constant only, because omega is constant and t is a function of time. Expectation operator always looks for random variable. E operator always looks for random variable. So in this whole function a cos omega t, who is the random variable? A is the random variable. So this E will be always applied at A only. So cos omega t will become constant. So this cos omega t will come outside expectation of E. Is that clear to you or not? And what is the expectation of A? A is uniformly distributed between 0 to 1. So what is the expectation of A? Expectation of A is 1 by 2. So what is the answer you are getting? 1 by 2 cos omega t. So this is your expectation operator. Sorry, this is your mean function. Sorry guys, this is your mean function mu xt, which is 1 by 2 cos omega t. This is the answer. So what did you understand? Expectation operator will always look for randomness. It will always look for randomness. So what you will do, whatever the constant part you are having, omega is constant and t is the time. T is nothing but time. So for expectation operator, this will become constant only. So take out the constant, expectation of A, that will be 1 by 2 cos omega t. So this is the expectation of your random process. Expectation of a random process, or you can say mean function of random process. Now what they are asking? Ex of 2. Ex of 2. This is what they are asking. Ex of 2. So what do you understand? They are asking mu x of 2 at t equals to 2. So you put t equals to 2 here. What will be the answer? 1 by 2 cos 2 omega. So that will be the answer. Or what you would have thought, what they are actually doing here, you need to find the expectation of x of 2. So what is this x of 2? This x of 2 is a random variable. So what they are doing, you are having x of t, then you are sampling it at t equals to 2 seconds. Sampling it at t equals to 2 seconds. So what do you get? You get a random variable. So what is the value of x of 2? X of 2 is, x of 2 will be a cos 2 omega. Say yes or no. In place of t I am putting 2. Now what you need to do? You need to find the expectation of x of 2. Expectation of x of 2. So what you will do? Expectation of a cos 2 omega. Now cos 2 omega is a constant, right? Cos 2 omega will be constant because omega is a constant. 2 is already constant. So cos 2 omega will come outside into expectation of a. What is the expectation of a? Expectation of a is 1 by 2. So what is the answer you are getting? 1 by 2 cos 2 omega. So although this process you don't need to do, you can directly find the mean function and then you can put t equals to 2, your answer will be done. So are you able to understand what we are doing? It will be called as the mean of random process, but actually it is the mean of random variable. It will be called as a mean of a random process, but actually it is the mean of a random variable because you are sampling your random process at t equals to t. And this expectation operator will always look for randomness. Omega is already constant, t is not a random variable. So nothing is random variable here. So cos omega t can come outside. Expectation of a is 1 by 2. There you go. I am just telling one more fact that this is a function of time, right? Your mean is depending on the time, because if time changes, your mean changes. If I calculate the mean at t equals to 2 seconds, then I am getting 1 by 2 cos 2 omega. If I calculate the mean at 1 second, I will get 1 by 2 cos omega. So it is a function of time. Why I am saying so, you will understand later on. Okay, it will make a very important point. So as of now, in this particular problem, you are getting mean as a function of time. Okay, so why I told it is important, that you will understand later on in this lecture only. Let's solve this question. A and omega are constant. This time A is constant, omega is a constant, but this theta is a random variable. This is a random variable which is uniformly distributed between 0 to pi. You need to find the mean function. What you need to find? You need to find the mean function. Expectation of xt you need to find. Expectation of xt. What is xt? A cos omega t plus theta. So A is constant, that is outside. Expectation of cos. Now A is constant, I can take it outside. Can you take out cos omega t plus theta outside? Here you will say, sir, omega is constant, t is not random. So in the whole term, who is random? Theta is random. This guy is random. This guy is random. So yeah, your expectation operator is looking for this guy only. He is looking for this guy only. So you cannot take it out. No, you cannot take out complete cos omega t plus theta outside, because this theta is doing the problem. So if theta is random, then cos omega t plus theta will also be random. What I mean to say is that if theta can take the value from 0 to pi, then this whole function can take the values like cos omega t plus pi by 2, cos omega t plus pi by 4. So in that manner, this cos omega t plus theta also become a random variable only, no? Are you able to understand this point? So theta you cannot separate from cos omega t plus theta. So this whole function becomes a random variable. Is this okay for you? Very simple thing to understand. Now your target is only to calculate this particular thing while your f theta of theta is already given. What is this? Theta is a random variable uniformly distributed between 0 to pi. So what do you think, what will be your f theta of theta? That will be equals to 1 by pi when theta is going from 0 to pi, otherwise it is 0, right? This is your f theta of theta. Very simple thing. These things you have already understood in our chapter, which is random variable. So theta is uniformly distributed between 0 to pi. So it will be equals to 1 by pi, otherwise it will be 0. You can put the equal sign, you cannot put the equal sign as well. Doesn't matter because it is continuous, right? Since it is continuous, then equal sign doesn't matter. So f theta of theta is 1 by pi, where theta is going from 0 to pi, right? Now you need to find what is our target now. Our target is finding expectation of cos omega t plus theta. So what I will do, integration, right? Minus infinity to infinity, this function cos omega t plus theta, and then I will put the PDF here. So what is this? This is a function of cos, right? This is a function of cos, but actually it is a function of theta as well, no? This particular function is a function of theta, because who is the only random quantity here? Omega t is a random quantity? No. T is a random quantity? No. Cos is a random quantity? No. Only random quantity is theta. Only random guy is theta here. So what you will put here? F theta of theta dot d theta. Is that clear to you or not? I told you whenever I calculate expectation, let's just say here I am putting g of x. So this is a function of x. So I will put the PDF of x. Here someone will argue that, sir, it is a function of t as well. But can you define the PDF of t? No, you cannot define the PDF of t. Why so? Because it is not random. Omega is also not random. Only random guy is theta, and you can only define the PDF of theta. So here what you will put? F theta of theta dot d theta, right? So you know that f theta of theta is non-zero between 0 to pi. Cos omega t plus theta. Between 0 to pi, what is the value? 1 by pi dot d theta. Can you integrate it? Surely you can integrate it. Cos, what is the integration of cos? Sine omega t plus pi, right? Going from 0 to pi. One thing I am forgetting here, omega will also come downward. Integration you already know. Here omega will also come downward. Downward it will be differentiated. So integration you already know how to do it, right? So what you are getting? Sin omega t plus pi. It will go negative. This will be what I will put. I will put a pi here. Sin omega t plus pi. It will be in the third quadrant. In third quadrant, sin is negative. So minus sin omega t. So what is the answer you are getting? Minus 2 sin omega t divided by pi omega. And it will surely come as a function of time only. Why it will come as a function of time? Because you are integrating with respect to theta. So time will remain there as it is. You are integrating with respect to theta, no? So this time will remain there as it is. So what is the answer you are getting? Expectation of cos omega t plus theta is coming out to be minus 2 sin omega t divided by omega pi. Right? So this integration we have done. So what is the answer you are getting? Mean function you are getting as a was a constant, and then this is the answer you have got, which is minus 2a sin omega t divided by pi omega. This is the answer you have got. So what is this? This is mean, right? This is the mean of your random process. Again, it is a function of time. Why this is important, why this matters to you, I will tell later on. So it is very simple to find out, right? There is nothing difficult. You will write down expectation of a cos omega t plus theta, then a is a constant, you will take it outside, and then you will see where is the randomness. Randomness is there in theta, and this is how you can find it out. Your answer is coming out to be in this manner. All good, all fine. Okay, let's try out this question. You need to find x of t is a and b between 1 when t is between 1 to 2 and when t is between 2 to 3. A is uniformly distributed between -3 to 2 and b is normally distributed. This is how we should not be representing. This is how we should be representing. Normally distributed where mean is 3 and variance is 4. You need to find the mean function. That means what I need to do? Mean function will be equals to expectation of xt. That will be what you need to do. Expectation of xt. So this expectation will go inside. You will apply it here. So expectation of xt will be equals to expectation of a, expectation of b. Will you apply the expectation operator here? Yes, you will apply it, but you know that t is not random. So t never looks random. So if t is not random, then this expectation operator doesn't matter. If you are not putting equal here, then at least put here. Okay. What is expectation of a? Expectation of a, that will be -3 plus 2 divided by 2, -1 by 2. And what is expectation of b? That is 3 only. So what is the answer you are getting? -1 by 2. And here expectation of b is 3. 1 to 2 and 2 to 3. All good, all fine. So this is your mean function. Think about it and let me know, is it a function of time or not? This mean function, is it a function of time or not? Here you can see constant, not a function of time. It is a function of time. It is a function of time. Why? Because between 1 to 2 it is giving different value, and between 2 to 3 it is giving different value. If I say this is not a function of time, that means at all the time it will give the same value. That means my speed of teaching is not a function of time. It is not a function of time. That means always my speed will remain constant with respect to the time. But with respect to time, they are changing. No, between 1 to 2 it is giving -1 by 2 value. Between 2 to 3 it is giving value 3. That means with respect to time, this mean function is changing. So that means it is a function of time. Okay. So this question I took only for the purpose for telling that it is also a function of time, right? And one more thing I want to tell, this question can be solved in another manner as well. What I mean to say is that this expectation of cos omega t plus theta can be find out with one more method. What is that method? Expectation of cos omega t plus theta. Cos omega t plus theta. It can be find out as, what is cos omega t plus theta? Cos A cos B minus sin A sin B. Because what is my target? My target is that expectation should look for randomness. So what I can do here? First thing is that it can be broken like this, because negative sign can be separated. Right? Theta is having the randomness. That means cos theta is having the randomness. So now what may happen is that cos omega t can be taken outside. So expectation of cos theta minus here sin omega t can be taken outside. Sorry, sin omega t can be taken outside into expectation of sin theta. So my target is to find out expectation of cos theta and expectation of sin theta. So what will be expectation of cos theta? Minus theta to theta cos theta. Since it is a function of theta, so here what will come? F theta dot d theta, right? So theta is there from 0 to pi. Cos theta divided by pi dot d theta. So between 0 to pi, can you draw the graph? This is the graph of cos. Between 0 to pi, what will be the answer? Whatever the positive area you get, same negative area you get. Answer will be 0. So expectation of cos theta is 0. What is expectation of sin theta? So that will be between 0 to pi, sin theta divided by pi into d theta. Remember the area? Do you remember this area? Sin theta. So this will be pi, right? So do you remember this area? The area is 2 Vm by pi into pi. So you can do the integration, answer will come out to be 2 and already divided by pi is there. So answer will be 2 by pi. Okay. So eventually what is the answer you are getting? Expectation of cos omega t plus theta. So expectation of cos theta is 0, expectation of sin theta is 2 by pi. So what is the answer you are getting? Minus 2 by pi minus 2 sin omega t divided by pi. Minus 2 sin omega t divided by pi. So here if you put, what is the answer we are getting? Minus 2 sin omega t divided by pi by omega. Pi by omega. Something is wrong now. What I am missing out? Pi by omega, but here I am not getting pi by omega. And this is a big blunder. No, you are integrating with respect to theta. So why would you put omega here? Right? Why would you put omega here? Very, very big blunder. Okay, it is a very, very bad mistake actually. You are integrating with respect to theta now. So theta is not a function of anything. Theta is coming as straightforward. It is not 2 theta. If it was 2 theta, then I would have put 2 here. This is simply theta only. So why would I put omega? If I was differentiating, if I was integrating with respect to omega, then I would put omega here. But I am integrating with respect to theta. So why would I put omega here? So omega will not come. So this is the answer. Okay. And here also you can do the same thing. You will get the answer minus 2 sin omega t divided by pi. So just for the expectation, and then you know that it will be multiplied with a. Right. So this is just the method 2. Okay. Yeah. Now x of t is 1 with the probability of p, and it is minus 1 with the probability of 1 minus p. So although I am calling it x of t, but just think about it. So how many values x of t can take? Either 1 or minus 1. Is it really a function of time? It could be a function of time, but you don't know. It might happen that when t is between 0 to 2, it is taking value 1. Otherwise, it is taking value minus 1. It might happen that when t is between 0 to 5, it is taking value minus 1. Otherwise, it is taking value 1. X of t could be a function of time, but you don't know. By this definition, do you know that it is a function of time or not? It could be a function of time. It cannot be a function of time as well. What they are asking? Mean function. That means they want you to calculate the mean of x of t. Mean of x of t. Now you would think that my x of t can take only 2 discrete values, minus 1 and 1. 1 with the probability of, minus 1 with the probability of, 1 with the probability of p and minus 1 with the probability of 1 minus 1. And if I want to find the expectation of this xt, what I will do? Minus 1 multiply with 1 minus p plus 1 multiply with p. So what you are getting? P minus 1 plus p. So what is the answer? 2p minus 1. There you. This is the answer. So although it looked like it could be a random process, it could be a random variable, but I don't care. I know that for discrete thing, if I know what all values it can take, and if I know what all are the probability for them, then I can simply find their expectation. So what is the answer? This is the answer. This is the expectation of xt. Right? All good? All fine? Now we need to study. Mean is already completed. Next we need to study about correlation function. So correlation between two random process, or it can be defined for one random process as well. That also we will see. So between the random process, we need to find the correlation function. So what we have already studied, that if x and y are our two random variable, then correlation between x and y is defined as what I used to write down, rxy, right? Rxy. That was expectation of x into y. So what I would do is that I will multiply x with y and then I would find out expectation of xy. So this was known as correlation in random variables. So this we have already studied in random variables. Now we need to study in random process what is the meaning of correlation in random process. So there are two kind of correlation, autocorrelation and cross correlation. So first let's study about autocorrelation function. Autocorrelation function, ACF. So what I am doing, I am sampling my x of t at t equals to t1, what I will be getting? X of t1. I am sampling my xt at t equals to t2, what I will be getting? X of t2. What is this? Random variable. And what is this? Random variable. And what was this? Random process. Now I ask you, find the autocorrelation of random process xt. So what you will do? Here what you used to do? Two random variables were given, you would multiply them and you will put a expectation operator. Here also I will do the same thing. Two random variables I am having. X of t sampled at t equals to t1, x of t sampled at t equals to t2. I will multiply both of them and then I will put a expectation operator. There you go. Very, very simple definition. X of t sampled at t equals to t1, x of t sampled at t equals to t2. I will multiply both of them and put the expectation operator. So how I will represent it? I will represent it in this manner. Rxx, why xx? Because here also x, here also x. Here it was x and y, no? Here it was x and y. But now from Rxx you will not understand. So what do we do is that first is sample at t1, second one is sample at t2. So this is how we write it down. So how do we write down? Just the notation I am telling. Previously we used to write down Rxy. Now what we will write down? Rxx. Now from Rxx it is not clear. We know that both random variables are function of x only. But first one is sample at t equals to t1 and second one is sample at t equals to t2. There you go. If I ask you what would be your Rxx t2 t1, so you should know how to read it. Expectation of x sampled at t equals to t2 and then x sampled at t equals to t1. So this will be your Rxx t2 t1. So don't be stressed of the sign. No, whatever the sign is there, how do you notate it? What is the notation? Don't worry about that. Only thing you need to take care is what is the value. If I ask you calculate the random process of calculate the autocorrelation function of random process xt, what you will do is that first you will sample it at t equals to t1, then you will sample it at t equals to t2, multiply both of them, put the expectation operator. No matter how do you represent it, forget about it. Representation is not important, but this definition is important. All good, all fine. Now just let me know one thing. From here what do you see? These two are same only, no? X of t2 multiply with x of t1 or x of t1 multiply with x of t2. Both are same only, and then there is expectation operator. So both are the same thing. That means what do you understand? Rxx of t1 t2 is equals to Rxx of t2 t1. No need to mug up anything. Okay? No need to mug up anything. But whenever they ask you to calculate autocorrelation function, you will never do t1 t2. Then what I will do? I will sample my x of t at t equals to t. What I will get? X of t. And then I will sample it at t equals to t plus 2. What I will get? X of t plus 2. Now sir, it looks like that it is a random process, but no. These guys are the random process. You have sampled your x of t at t equals to t and you have sampled your x of t at t equals to t plus 2. So now these two are random variables. And if I ask you, find the autocorrelation. Why autocorrelation? Because both random variables are function of x only. That's why auto. Auto means both are x. Then we will study cross. One will be x, other one will be y. Right? So now if I ask you to define the autocorrelation of x of t, so what you will do? Autocorrelation function of x of t, what you will do is that x of t sampled at t and x of t sampled at t plus 2. And how it will be represented? So it will be represented as Rxx. First one is sampled at t, second one is sampled at t plus 2. Okay? Or how will I write down? Rxx. First one could be sampled at t plus 2 and second one is sampled at t. So what you will be getting? Expectation of x of t plus 2 into x of t. Both are same only. So don't mug up anything. Don't mug up anything. From this particular slide, autocorrelation function, from this particular slide, only thing you need to remember is this. That's it. I am putting that in a box. This is the only thing you need to remember. That how the autocorrelation function of x of t is defined. How autocorrelation function of x of t is defined. So this is how it is defined. Okay, not looking good, not looking good at all. So if I need to define the autocorrelation function, I will sample x of t at t and then I will sample it at t plus 2. I will multiply both of the samples and then I will put expectation operator. So this is how your autocorrelation function of x of t is defined. We will see questions, don't worry about that. So first we can solve the problems. So we will understand about cross correlation, don't worry about it. But see let's see this question and then we will come to cross correlation and then we will move forward. So what you need to find? You need to find the autocorrelation function of x of t. X of t is defined as a sine omega t plus phi, where omega and phi are constant. A is a A is normally distributed Gaussian random variable, right? Gaussian random variable with the having mean of 2 and variance of 4. You need to find autocorrelation function of x of t. So autocorrelation function of x of t, how it is defined? I will sample my, what you can simply write down, you can write down in this manner. Autocorrelation function of x of t. There you go. Okay. So what I will do? I will sample my x of t at t equals to t and I will sample it at t plus 2. I will multiply both of them and then I will put the expectation operator. What is x of t? A sine omega t plus phi into x of t plus 2. A sine omega t plus 2 plus phi, right? Okay. So what you are getting? A and A will be a square sine omega t plus phi into sine omega t omega 2 phi, right? Just let me know one thing. Who is random here? Omega t, function of t, omega is not random, omega is constant, phi is constant. So this whole term is constant with respect to the random variable. Sorry, with respect to the expectation operator. Basically, it is not random. Depending on time, omega constant, phi constant. Depending on time, omega constant, phi constant. Tau is also a function of time only, right? Tau is nothing but a function of time only. Tau is a function of time only because you are sampling your x of t at t plus tau. So tau is nothing but a function of time only, right? So it is also time. Basically, there is no randomness. So who is having randomness? Only a square is having randomness. So what you can do? Sine omega t plus phi can come outside. Sine omega t omega 2 phi expectation of a square. Can you find out the expectation of a square? Yes. What is the mean? 2. Here I should not write x, it is actually about a. And what is the variance? 4. Do you remember what was your expectation of a square? Expectation of a square was dc power plus ac power. That would be 4 plus 4 is equals to 8. So autocorrelation function ACF of x of t, which is given by first sample you have calculated at t, second sample you have calculated at t plus 2. It will be given by 8 sine omega t plus phi into sine omega t omega 2 plus phi. There you go. This is what they want you to calculate. So you let me know, this is a function of t as well and it is a function of 2 as well, right? It is a function of t as well, it is a function of 2 as well. T is time only. What is 2? Time difference. Time difference between two successive samples. What is 2? 2 is time difference between two successive samples. right? So it is a function of t as well, and it is a function of tau as well, right? So yeah, this is how we need to solve the problem. Let's see another problem and then we can come to cross correlation. So let's see this problem. Again, you need to find the autocorrelation function of x of t. So what you need to do here, a and omega are constant, but theta is going from 0 to 2 pi. So what I need to find? Okay, in the previous problem, I guess another thing we needed to find. Yeah, sorry guys, we will move to this one, but first here we need to find expectation x of 2 into x of 5. This is what I need to find. X of 2 into x of 5. This is what I need to find. So let's just say only this question is coming in my examination also. What will click to me? Only this question is coming. So what will click to me? That first I will sample my x of t at t equals to 2. So what I will get? X of 2. And then I will sample my x of t at t equals to 5. What I will get? X of 5. And then I need to multiply both of them and then put the expectation operator. So can I do it? Yes. You need to put 2, you need to put 5. So what I need to do? I will tell you method 2 as well, but as of now you see this one. So if I sample it at t equals to 2, what I will get? A sin omega 2 omega plus 5. So A sin 2 omega plus 5. And then I sample it at t equals to 5. What I will get? A sin 5 omega plus 5. So expectation of a square sin 2 omega plus 5 sin 5 omega plus 5, right? So what you are getting, sin omega plus 5, this can come outside because this is not having any randomness, and you know that expectation of a square is basically, now this is the scenario, expectation of a square is 8, that you already know, and rest of the things can come outside. So expectation of a square is nothing but 8 and sin 2 omega plus 5 into sin 5 omega plus 5. So this is the answer you are getting, right? Now another thing can come to you. If you have already calculated this thing, what you have already calculated? Expectation of x of t plus 2. This you have already calculated. So what you can do here, in place of t I will put 2 and in place of tau I will put 3. So what I will get? In place of t I am putting 2 and in place of tau I am putting 3. What I am getting? This is what I am getting. So this is the thing you need to put here. So if you put t equals to 2 and tau equals to 3, what answer you will get? Same answer you will get. So if you are already having the correlation, so if autocorrelation function you are already having, then you will understand that yes sir, this is the form that we have already seen, x of t into x of t plus tau. That means value of t is 2 and t plus tau is 5. So just put the values if I am already having the autocorrelation function. There you go, this is the answer. Okay. So two methods are there. If directly you want to calculate, then calculate in this manner. If you want to take the help of autocorrelation function, then this is how you can do it. All good? Let's find out the autocorrelation function of this xt, where a and omega are constant, theta is function of 0 to 2 pi. So what I need to do? Autocorrelation function of x of t. What autocorrelation tells you to do? That you calculate your x of t, then you calculate your x of t plus tau, multiply both of them and put the expectation operator. So here you know that in place of t I need to put t plus tau. So a and a will be multiplied, it will become a square cos omega t plus theta, and this will become cos omega t omega tau theta. Now what do you think, what I can take outside? Can I take these guys outside? Omega is constant, t is a function of time, but here randomness, here randomness. This is your random variable, this is your random variable. So yes, randomness is there. but this is a square is constant. So a square can be taken outside. Cos omega t plus theta, cos omega t omega tau theta. So this is your cos A cos B, right? Now what you can do is that, sir, directly I calculate this one, but let's try reducing it. What I am saying, let's try reducing this expression. I can reduce this expression in a good manner. Always you get the form of cos A cos B, you can try reducing the expression. So what you will do, multiply with 2 here and divide by 2 here. So divided by 2, multiply with 2. 2 is a constant value, right? So you can take out 2 outside. So a square by 2, 2 cos A cos B, what you will get? 2 cos A cos B, cos A plus B, cos A minus B. So cos A plus B plus cos A minus B. So what you will be getting? Omega 2. Why I did so? Because now you see, how can you break it? Cos 2 omega t plus omega tau plus 2 theta plus expectation of cos omega 2. Say yes or no. And what is this? Constant. There is no randomness, no? Omega is not random, tau is not random, cos is also not random. So this is complete constant. So this can come directly outside. So only thing is you need to calculate the expectation of this one. Look, basically I don't want to calculate the expectation of this much long expression. So what I did, multiply by 2, divide by 2. So this is what I am getting. So here you can see that this is becoming constant. So I don't need to calculate the expectation of this guy. Only expectation of this guy I will calculate now. So my target has become to add a page now. This is the first target, and then the second target is to find out expectation of cos 2 omega t plus omega tau plus 2 theta, right? 2 omega t omega tau plus 2 theta. So minus infinity to infinity, whatever the function is there, 2 omega t omega tau plus 2 theta. So this is a function of omega as well, t as well, tau as well, cos as well, but who is having the randomness? Theta is having the randomness. So f theta of theta dot d theta. So what about f theta of theta? F theta of theta is 1 by 2 pi, where theta is from 0 to 2 pi, and otherwise it is 0, right? So f theta of theta is 1 by 2 pi when theta goes from 0 to 2 pi. When theta goes from 0 to 2 pi, it is 1 by 2 pi. You calculate this integration and it will come out to be 0 only. Do it on your own. You will calculate it, what it will become? This will become sine, then you will put 2 pi. So cos 2 omega t plus omega tau plus 4 pi. Basically, when you integrate it, this will become sine 2 omega t omega tau 4 pi minus 5 4 pi, because I am putting the limit will be 2 pi, and then you will put the limit 0. This guy both are same. What will be the answer? 0. And how you can think? This is the graph of cos. If I draw this graph of cos with respect to theta, and then you are integrating from 0 to 2 pi. Basically, if this is 2 theta, if let us say cos theta, in cos theta, what kind of graph you will be getting? This kind of graph you will be getting, and this will be your 2 pi, right? But in cos 2 theta, what will be your time period? Time period will be pi. So this much graph you will be getting. Basically, this much graph you will be getting in 0 to 2 pi. If I consider the graph of cos 2 theta, this is the graph of cos 2 theta. Is that clear to you or not? This is the graph of cos 2 theta. You can make it in signal system. We have studied it. Now you are integrating for 2 time periods. Basically, positive area, same negative area. Then negative area, same positive area. Positive area, negative area. Negative area, same positive area. So total area will be 0. Look, if you want to integrate, you can integrate it. But you see that 0 to 2 pi will be 2 time periods. With respect to cos theta, or you can say with respect to cos 2 theta, it will be 2 time periods. So basically you are integrating for 2 time periods. with respect to cos 2 theta, it will be having 2 time periods. So you are integrating for 2 time periods. So if you integrate in 2 time periods, answer will be 0. Like if I don't want to do the mathematics, this is how I will think. Otherwise, I can do the mathematics as well. Sine 2 omega t plus omega tau plus 2 theta divided by 2, then integrating from 0 to 2 pi. These kind of examples we have seen in signal system. A lot of examples I told you, and there I told you that how you can do the integration without even mathematics, without even using the mathematics. So without using the mathematics, I need to think that how the graph will go. And if I am able to visualize the graph of sinusoid or cosinusoid, then I can tell that whether the integration will throw 0 or it will throw a non-zero value. So this will throw a 0 value. So answer will be 0. Answer will be 0. So what did you understand? This guy completely is coming out to be 0. And this is cos omega 2. So what you are getting? A square by 2 cos omega 2. This is your autocorrelation function of x of t. And very interesting thing you are getting here, that it is only a function of tau. Okay. Now this will be used somewhere. We will use it somewhere. But a very good conclusion we have made, that autocorrelation function of x of t is coming out to be a square by 2 cos omega tau, which is only the function of tau, not the function of time. It is only the function of tau, right? And what is the tau? Tau is nothing but the time difference between two successive samples. Now let's understand by cross correlation, and then we will take a break and then we will start studying again. But as of now, let's understand cross correlation. Cross correlation means it will be defined between xt and yt. So how it can be defined? What you will do? You can sample your x of t at t equals to t and y of t at t equals to t plus 2. Or what you can do? You sample your x of t at t equals to tau and y of t as t equals to t only. So what you will write it down? Rxy, t is sampled at, sorry, x is sampled at t and y is sampled at t plus 2. What I will write down? Rxy, x is sampled at t plus 2 and y is sampled at t. Both are equal? No. Both are not equal, no? This guy and this guy. Let's write it down in good manner. Rxy t plus tau dot t. Both are not equal, right? Now if I write down Ryx t plus tau, what is the meaning of this? Expectation, y is sampled at t, and x is sampled at t plus 2. Nothing but the notation. Don't worry about all this notation. Nothing you need to worry. Only thing you need to worry is this slide. That's it. Autocorrelation function is defined as x of t, t plus tau, multiply both of them, take the expectation operator. That's it. Nothing else you need to remember, right? So this is what you will be getting. And if I define Ryx t plus tau t, so what you will be getting? Y is sampled at t plus tau and x is sampled at t. So what do you see? This first and fourth guys are same. These two guys are same, and this second and third guys are same, because yt multiply with x of t plus tau, yt multiply with x of t plus tau, then expectation. So both are same. This is also same. Okay. So who are same, who are not same, don't worry. This is just for the theory. In the options, if these options are coming, then you can click on them. Otherwise, you just need to know the meaning of cross correlation. Cross correlation are defined between two functions, xt and yt. So what you do? One of the sample you are taking at t equals to t, another sample you are taking at t plus tau. You can take first sample at t plus tau, another sample at t. You can take first sample at t, but with respect to y. So all these things you can do. So this is how cross correlation between x and y is defined. You just need to know what is the meaning of Rxy. That means x at this one and y at this one. All good? All fine? Now where we were here. So autocorrelation function of x of t is coming out to be a square by 2 cos omega tau. So this is only a function of tau, no? This is only a function of tau. So this can be written as Rx tau. How this can be written? Rx tau. Basically, what you did, Rx, first sample calculated at t, another one at t plus 2. You calculated it and you got to know that it is coming out to be a function of tau only. You calculated this particular thing and you got to know that it is coming out to be a function of tau. So if it is only a function of tau, so instead of writing Rxx t plus tau, I will only write down Rx of tau. Is that clear to you or not? Say yes or no. Clear? All good, all fine. So this example we saw previously as well when we were calculating the mean. As far as I remember, I hope we have seen this example. A cos omega t, theta is here, it is going from 0 to pi, not going from 0 to 2 pi. Okay. So this example and the other example is different. Here cos omega t plus theta, everything is same, but theta is going from 0 to pi. But now here theta is going from 0 to 2 pi. So this example is different. Theta is going from 0 to 2 pi. So if you look at the slide, you will feel like that, okay, big mathematics is there, don't know what they are writing, omega t, omega tau. But actually when you study this lecture, you understood that it is very straightforward. This 1 hour of lecture will be revised within 5 minutes, right? Because there is nothing. Simple, you keep on writing the things and you keep on doing the mathematics. More examples are there. Yes, this example is also there. Here two random variables are there. Xt is a random process, a cos omega t plus theta. A is normally distributed having the mean of 2, variance of 4, and theta is uniformly distributed between 0 to 2 pi. A and theta are mutually independent. So you need to find the autocorrelation function of x of t. Try it on your own. I will take a break and then I will come back. So try doing it on your own. Use this information, okay? A and theta are mutually independent. So their function will also be independent. Do you remember this thing? If I say x and y are independent random variables. So I told you one thing. Expectation of gx hy will be given as gx dot hy. You remember this, right? So this property can be used somewhere. Use this property and solve this question. I guess as far as I remember, whatever the answer that you are getting here, the same answer you will get in this one. As far as I remember, okay? So try doing it. I will take a break and then I will come back. I am not sure if the answer will be same, but no, answer will not be same, okay? Answer will not be same because here expectation of a square you will have to calculate. Yeah, answer will not be same. So yeah, try doing it. Okay, I will take a break and come back. Yeah, welcome back. So did you try this one? What you need to find? Autocorrelation function of x of t. So that I can write down. As of now, I will write it down in this manner, right? Because I don't know whether it will be a function of tau or not. If it is coming out to be a function of tau, then I can write it down as Rx of tau, right? But first I need to write it down as t and then t plus tau. So what I need to do, I need to pick the x. Here double x you can also write down. So I will pick the x, first one sampled at t, other one sampled at t plus tau, multiply both of them and then you take the expectation. Okay, so what you are getting? A cos omega t plus theta into A cos omega t omega tau plus theta, right? So basically just forget about this step. You know that it will be a square only, so directly you write down as a square. Now the important part will come. Now can I break it down as expectation of a square into expectation of cos omega t plus theta, cos omega t plus omega tau plus theta? Can I break it down in this manner? Yes, I can break it down. Why so? Because a and theta are independent. Since a and theta are independent, a and theta are independent, then expectation of function of a into function of theta will be equals to expectation of function of a into expectation of function of theta. So basically you can separate them. So expectation of a square into expectation of cos omega t plus theta, cos omega t plus theta into cos omega t plus omega tau plus theta. Say yes or no, right? Have you find out the value of this one? Expectation of omega t plus theta, omega t plus omega tau plus theta. Somewhere we have find it out. Here also we are getting the same thing. Expectation of cos. Basically what I need to do is that, what I will do here, I will multiply by 2 and then divide by 2. So what I am getting, expectation of a square divided by 2, expectation of 2 cos a cos b. So cos a plus b cos A plus B. If I do the cos A plus B, what I am getting? This is what I am getting, plus cos A minus B. So you know that expectation of cos 2 omega t plus omega tau plus 2 theta, that will go into 0, but what you will be left with, your answer is coming out to be expectation of A square divided by 2 cos omega 2. Now what is expectation of A square? So from here you can see that expectation of A square will be equivalent to this. Also we have already calculated mean square, that would be 4, plus variance square, that will be 4. So 8. So 8 by 2 will be 4 only. So what is the answer you are getting? 4 cos omega 2. So this is the answer you are getting, because expectation of A square is 8. So 8 by 2, answer is 4 cos omega 2. So this was your Rxx of first sample at t and then t plus 2. That is equivalent to Rx of 2. This is the answer. Why it is equivalent to Rx of 2? Because it is only a function of 2. So I can write it down as Rx of 2. Is that clear to you or not? Is this question clear to you? Very simply, in a very simple manner, we can solve these kind of problems, right? Just write down what you need to calculate and see the answer. Here it was coming as a function of 2. This is also coming as a function of 2. But here you notice, here what do you notice? This is coming as a function of t and tau both. This is coming as a function of t and tau both, right? So it could be a function of tau, it could not be a function of tau as well. Anything is possible. More questions are there? No. Let's see the mean square value. What you need to find? You need to find the mean square value of x of t. So what was the mean square value of a random variable x? That was expectation of x square. So this will be expectation of x square t. What is the variance of random process xt? What would be the variance? In variance, what you will do? Expectation of x square t minus expectation of x minus expectation of xt, and then do the square. So whatever that we have studied in random variable, the same thing we are doing. In random variable, what was your mean square value? That was expectation of x square, right? What was your variance? That was expectation of x square minus expectation of x square, right? And what was your covariance? What was your covariance? Your covariance was, covariance you defined with respect to x and y, right? So covariance between random variable x and y was expectation of xy minus expectation of x dot expectation of y, right? So this was your covariance. This was your covariance. So all these you studied in random variables. Similar thing will happen. Covariance of random process xt. What does that mean? What I will do is that here what I used to do, x with y. So here what I will do, two random process I will have, two random variables I will have, one sampled at t equals to t, another one sampled at t plus 2 minus expectation of xt into expectation of x of t plus 2. So this will be known as your covariance of xt. So I can define it as one sampled at t, other one sampled at t plus 2. So this is how I can define the covariance. Very simple. So this is known as autocovariance. Autocovariance, because you are doing with respect to x and x, right? Autocovariance. It is actually coming out to be, what is this? This is your Rxx of t plus 2, right? Rxx of t plus 2, because what is this? Xt, one sample you are taking at x t equals to t, another sample you are taking at t equals to t plus 2. So xt multiply with x of t plus 2, multiply both of them, take the expectation operator, minus expectation of xt dot expectation of x of t plus 2, minus, what is this? Main function. And what is this? Main function, but in place of t you are putting t plus 2. So this is how you can write it down. Here also we used to write down the same thing, rxy minus mu x mu y. So people usually find random variable, random process stuff because of all these things, because of all these expressions. But rather than mugging up the expression, rather than remembering the expression, we know what we are doing. X of t sample at t, x of t sample at t plus 2, multiply both of them, put the expectation operator, minus expectation of xt dot expectation of x of t plus 2. There you go. This is your covariance. What this was? This was your correlation. Variance of xt, this was mean square value. So just relate it with the random variable. So keep on relating with the random variable, and this was your autocorrelation, how to find it. So autocorrelation means xt with x of t plus 2. And if I find autocovariance, then x of t dot x of t plus 2 expectation minus expectation of xt minus expectation of xt dot expectation of x of t plus 2, right? This is the multiplication. And if I find cross covariance, then what that would be? Cross covariance, if I write it down, cxy t t plus 2. So what I need to do? Cross correlation of xy. What does that mean? That means your x is sample at t and y is sample at t plus 2 minus whatever that is written here, just separate it with the expectation. So this is known as cross covariance. Cross covariance. Okay, all good. So let's write down the summary of whatever that we have already studied. So if I find mean of xt, that means they are asking me expectation of xt, although I was representing it as mu xt. But this is not important. This is important, that how your expectation operator will be used. Everywhere expectation operator will be used. So this is your capital xt, right? Mean square value, expectation of x square t. Variance, so it can be written as sigma square xt, okay? Sometimes I will write it down as sigma square xt, although it will be given that it is variance of xt. So sigma square xt, this is how I will write it down, okay? So sigma square xt will be equals to expectation of x square t minus expectation of xt whole square. Autocorrelation function of x of t. Autocorrelation function of x of t. So what you need to do? You need to take sample at t, you need to take sample at t plus 2, multiply both of them, take the expectation. And covariance, so autocorrelation function you are already having, autocorrelation function you are already having, minus separate the expectation operator. Very simple, very straightforward. Let's see the notation. This will be represented as, you are doing with respect to x and x only, one sampled at t, one sampled at t plus 2. Here also covariance is doing with x and x only, one sampled at t, one sampled at t plus 2. And one more thing you can write down, this would be given as, what is this? This is your rxx of t and t plus 2. And what is this? This is your rx of t dot, sorry, what I am doing, this is your mu x of t, this is your mu x of t multiply with mu x of t plus 2. There you go. This is the conclusion of everything that we have studied. And what this is known as? Total power, right? Total power of xt. Okay, and what is this? AC power, right? Basically, you can write down expectation of x square t is equivalent to sigma square xt, sigma square xt, this t should be capital because it could be a function of time as well. So sigma square xt, this is how I will write down, plus mu x square t. What is this? This is your mu x square t. This is your mu x t and then square. So mu x square t. So what is this? AC power and what is this? DC power. And what is this? Total power. So total power, AC power, DC power. Look, it feels like that if I ask you what is the average power of xt, what I'm asking, average power of xt. So you will think that we are talking about DC power. Average and DC feels like that average and DC both are the same thing. If I ask you the calculate of if I ask you to calculate that DC value of a random variable, forget about random variable. If I ask you calculate that DC value of small xt that we study in signal system. So in signal system, if I ask you the DC value of small xt or average of xt, both are the same thing. But when it comes to power, so average power means total power only. So this total power of xt only known as average power of xt. Okay, just remember it. I have seen when I was a student, I also had the confusion in this one. So whenever they are saying average power of xt, that means they are talking about mean square value only. Okay, so average power is not DC power. Fine, well and good. Okay, yeah. So let's see this question. This will just help you to revise everything. Whatever that we have studied, everything will be revised with this particular question. X of t is given 2a cos omega t plus theta. A is random variable, B is random variable, theta is also random variable. Okay, A is normally distributed having mean, variance. B is uniformly distributed between -1 to 1. Theta is also uniformly distributed between 0 to 2 pi. All three are mutually independent to each other. Someone will have a doubt that, sir, what if they are dependent? Then the question will become very tough, almost impossible to solve. Okay, almost impossible to solve. So 101% I am telling, if the questions are coming in the examination, they will be given independent. Okay, if they are in multiplication, let's just say if I frame something like at plus b, and now I ask you what is the expectation here. So you know that it will be t into expectation of a plus expectation of b. So now I don't need to give that they are independent, right? Independent, meaning of independent will come into action if there is multiplication. When the multiplication comes, then the meaning of independent will come into action, right? Otherwise there is no meaning. So if they are in multiplication, here a and theta, kind of you can say they are in multiplication, right? Because this is the function of theta and this is the function of a. They are in multiplication, and since they are in multiplication, then there is very, very high chance that in the examination they will give a, b and theta all are independent to each other. Okay, mutually independent means independent to each other. So we need to find mean square value, variance, all these things we need to find. But our two major things are that we will always focus on mean and autocorrelation function. After that we can calculate mean square value as well, variance as well. So first I am calculating mean and then I will calculate autocorrelation function of x of t. Okay, so let's get started with the mean. So mean of xt, just write down the expression, and you know that mean can be broken into, if there is a plus sign then mean can be broken, right? So mean I will break it into two parts, 2a cos omega t plus theta plus expectation of b. What is the expectation of b? Here you let me know all these expectation. Expectation of b. What is the expectation of b? Uniformly distributed between -1 to 1. Answer will be 1 minus 1 divided by 2, 0. What is the expectation of a? Already given, 0. Expectation of theta, if I need, I will calculate it. But as of now, what do you see? 2 into. Can I break it like this? Expectation of a dot expectation of cos omega t plus theta plus expectation of b. So how did I break the expectation operator? Because a and theta are mutually independent. So their functions will also be mutually independent. So this function will be independent to this function. Now you know that expectation of a is 0 and this is also 0. What is the answer you will get? 0 multiplied with 0 anything. 0 multiplied with anything will be 0 plus 0. 0 plus 0 will be 0. So what is the mean you are getting? Mean you are getting is that is 0. Now let's calculate autocorrelation function. So what I need to calculate? Autocorrelation function of x of t. So forget about the notation. What is the matter of concern for me? That what I do in the autocorrelation function is that first I will sample at t and then I will sample at t plus 2 and then I write it down. So first I need to multiply both of them. So here b is also there. So this multiplication will be a bit, I would not say it will be a bit typical, but it will be a bit time taking, right? Plus b is also there, and then this will be multiplied with 2a cos omega t, and in place of t you need to put tau plus b. So these two, first these two will be multiplied and then you will see the final answer. So can you say that, sir, can I break the expectation operator here? That can I write it down? Expectation of 2a cos omega t plus theta plus b multiply with expectation of 2a cos omega t omega tau plus theta plus b. Can I break it down like this? No. First I have to do the multiplication. Why I cannot break it? Think about it. Why I cannot break the integration? Why I cannot break the expectation operator here? Because you know that a, theta and b are mutually independent to each other. A, theta, b are mutually independent to each other. This is the function of a, theta, b all 3, and this is also a function of a, theta, b all 3. So they are the function of same variables. They are the function of same random variable. So they cannot be independent. What I mean to say is that, let's just say I am saying that x and y are independent to each other. Okay, x and y are independent to each other. What I am doing now? So now can I break it? Can I break it like this? No, because this is a function of y, all fine. But this is the function of both x and y. So you cannot break it like this, even if they are independent. But if this y was not there, then it would have been fine. So they are not purely the function of theta. So they are function of a, theta and b, and this is also a function of a, theta and b. So basically, this is actually a function of a, theta and b, and this is also a different function of a, theta and b. Not alone, they are not alone. So you cannot break it here. Inside you need to solve that. Inside you need to solve this particular multiplication. So let's try solving it. So you know that here what you will get, 4a square will be coming outside. This first you multiply this 2a cos omega t plus theta with this one. So what you will get, 4a square cos omega t plus theta multiply with cos omega t omega tau plus theta, plus then you multiply this guy with b. So 2ab cos omega t plus theta, fine, plus then you multiply b with this guy. So 2ab again cos omega t plus omega tau plus theta, then you multiply plus b with b square. There you go. Okay, so now all are in plus, so I can break it down into plus as well. So what I will be getting, expectation of a square, expectation of 4a square cos omega t plus theta cos omega t omega tau plus theta, plus expectation of, here it will become 2ab, right, and then cos omega t plus theta. Now you just see, you notice one thing here, this is a function of a, this is a function of a, multiply with this is a function of b, multiply with this is a function of theta, and then there is a expectation operator. So now you can separate them. Are you able to understand this point? Here a theta b, this whole term was function of a theta b, whole term was function of a theta b, you cannot separate them. But now function of a multiply with function of b multiply with function of theta can be separated, right? So what you will do, 2 into expectation of a into expectation of b into expectation of cos omega t plus theta, plus another thing I could have done here, here also I could have broke it, no? This is a function of a and this is a function of purely theta. I am only talking about the random variables. So function of a and a function of theta. So can I break it? Yes, here also I could have broken it. So what I will do, okay, fine, we know the answer of this one, that's why I did it. So let's do it. Here also function of a, function of b, function of theta. So again 2 into expectation of A dot expectation of B dot expectation of cos omega t omega tau plus theta plus expectation of B square, right? You know that this will be 0, this will also be 0, so whole multiplication will be 0, this is 0, this is also 0. We will talk about expectation of 4A square. 4 is constant, so it can come outside. 4 into expectation of A square. We will talk about expectation of A square, we will talk about expectation of B square, but can you let me know what will be the expectation of this one? Multiply with 2, divide by 2, what you will get? 1 by 2 cos omega 2. We have already done it. Cos omega t plus theta dot cos omega t plus omega tau plus theta. Already done it. A lot of times we have done it. Here also we did the same thing. Multiply with 2, divide by 2. What is the answer we are getting? 1 by 2 cos omega 2. So what do you think? What we are getting now? So this will be 4 into expectation of A square into 1 by 2 cos omega tau plus expectation of B square. This is how we have reduced it. So what is the expectation of A square? What do you think? Expectation of A square. So here you see that sigma A square will be equals to expectation of A square only, because mean is 0. If mean is 0, that means variance will be equals to your, if mean is 0, then variance will be equals to your mean square value, right? So expectation of A square is coming out to be 2. And what about expectation of B square? So expectation of B square will be equals to variance of B square plus the DC value plus DC value square. This is 0 only. So it will be also equals to variance of B square. What is the variance? I told you length. What is the length? 2 square divided by 12. B minus A whole square divided by 12. Or you can say what is the width? 1 minus of minus 1, that would be 2. 2 square divided by 12. What will be the answer? 1 by 3. So expectation of B square is 1 by 3. Expectation of A square is 2. Very simple. From here you can calculate the expectation of A square. From here you can calculate the expectation of B square. So expectation of A square is 2. So you will put here 4. Let's put it here. So what I am doing? I am calculating the autocorrelation function of x. Autocorrelation function of x of t. That is coming out to be, here I will put 2. Expectation of A square is 2. So I will put 2 here. So what I will be getting? 4 cos omega 2 plus, what is the expectation of B square? Expectation of B square is 1 by 3. So what this is coming out to be? Function of only 2. There you go. This was your, and this was your mean. Okay, mean is coming out to be 0. Is this a function of time t? No. This is not a function of time. So this is not a function of time t, and this is only coming out to be a function of tau. So two things we have calculated: autocorrelation function, and we have calculated the mean. Next, what we need to calculate? Mean square value of xt. Third, mean square value of xt, capital XT. Okay. So expectation of x square t. Now you already know x of t. This is your x of t, and you need to do the square. So what you will get? 2a cos omega t plus theta is there, no? So a square plus b square plus 2ab. So what is 2ab? 4ab cos omega t plus theta. 4ab cos omega t plus theta. Okay, and you will solve it then, but it will take a lot of time. But do you really think that we should do in this manner? You can solve it, no? Expectation of 4a square cos omega square t plus theta. So expectation of 4a square you already know, expectation of b square you already know, and this term will go down to 0. Basically you can show it in this manner. This is purely a function of theta. So let me solve it for you. I will solve it for you. Plus expectation of b square. There is easier method as well. This is what I am telling. 4 into expectation of b, expectation of a, expectation of b, multiply with expectation of cos omega t plus theta. So this is 0 only. So this term is gone. No need to worry about this term. So what you are getting, 4 into expectation of a square, we already know which is coming out to be 2, right? Expectation of a square is 2, expectation of b square is 1 by 3, 2. Okay. Now you see this one, expectation of cos square omega t plus theta. So what you will do, can I write it down in this manner, 1 plus cos 2 omega t 2 theta divided by 2, divided by completely 2. Eventually I need to solve the integration, so even if I solve the integration, this term would come. So here only I wrote it down. Do you remember this formula? Cos 2 theta is equivalent to 2 cos square theta minus 1. So cos 2 theta plus 1 divided by 2. Expectation of b square is 1 by 3. Right? 2 get cancelled out. Now my target would be to find out expectation of cos 2 omega t plus 2 theta. Only this is my target. Not 1 plus 1 by 2, because I know that 2 and 2 will get cancelled out because this is constant. So my target has become to find out 4 into, now you know that expectation of 1 will be 1 only, plus expectation of cos 2 omega t plus 2 theta, that I need to find out, plus 1 by 3. So this particular thing I need to find out, right? So my target is to find out the expectation of cos 2 omega t plus 2 theta, and I know that only random variable here is theta. So minus infinity to infinity cos 2 omega t plus theta. Here I will write down f theta of theta. You know that f theta of theta is 1 by 2 pi. F theta of theta. Basically, let's write down the step, f theta of theta dot d theta. So f theta of theta is there from 0 to 2 pi. It is there from 0 to 2 pi. Cos 2 omega t plus 2 theta, not theta only, 2 theta plus 2 theta divided by multiply with 1 by 2 pi dot d theta. You will solve the integration, you will get to know that it is coming out to be 0. And pretty obvious as well. Again pretty obvious, because you know that, sir, I will have to integrate cosinusoid, multiply with the constant value. I don't care about the constant value. But you are again integrating a cosinusoid for 0 to 2 pi. That means again 2 cycles will come. And in complete cycle, the average value is 0. So integration will throw out 0. You can solve the integration on your own. You will get to know that it is coming out to be 0. So this particular thing is coming out to be 0. So what is the answer you are getting? 4 into expectation of 1. What that would be? 1 only, right? So 4 plus 1 by 3. What is the answer you are getting? 4 plus 1 by 3. What is that? 13 by 3. Expectation of x square t. So eventually our expectation of x square t is coming out to be 13 by 3. But what if I tell you, you don't need to follow all this process. In the examination, I will follow this process only if this particular thing is asked. But what if they are asking autocorrelation function as well? Along with that, they are asking mean square value as well. What I will do? I know that my autocorrelation function is this thing. Expectation of first sample at t, another one sample at t plus 2. And what is your mean square value actually? Mean square value of xt. What does it tell? That what you will do, first you sample at t, other one also you sample at t only. This is your expectation of x square t. What does that mean? That means in rxx t plus tau, if you put tau equals to 0, then your job is done. So in whatever the answer that I got here, I need to put tau equals to 0. I need to put tau equals to 0. So what is cos 0? Cos 0 is 1. So what is the answer you are getting? 13 by 3. There you go. This is the answer. This was the method 2. So in the examination, if autocorrelation function is already given, if ACF is already given, if I already know the ACF, I know that mean square value simply means that you need to put tau equals to 0. There you go. That means both of the samples should be taken at t equals to t only. Both of the samples should be taken at t equals to t only. Right? So what is the answer you are getting? 13 by 3. Okay. Next thing, what we find out? This is also done. We find out the variance. Variance of xt we find out. So what that would be? Expectation of x square t minus expectation of xt whole square. So 13 by 3, expectation of xt, I guess it was 0 only, no? Yeah, this was 0 and here also this was 0 only. Yeah, so expectation of xt was 0 only. So answer is 13 by 3 only. So basically answer is 13 by 3 only. Okay, very simple point. This is the answer. Next, what we need to calculate? Covariance of xt. Covariance of xt. So what that would be? Expectation of x of t plus 2 minus, you separate the expectation. Now one thing you know, what is our expectation of xt? Expectation of xt we have calculated, it is coming out to be 0. Expectation of xt is coming out to be 0. So here I can directly put 0 and I know that this term will be gone because this particular thing is 0. But if I ask you what is the expectation of x of t plus 2, what do you think, what will be the answer? Expectation of xt is not depending on time. So expectation of x of t plus 2 will also be the same only, no? What if I say expectation of xt is 2? What if in place of 0 it was 2? So now if I ask you what is the expectation of t plus 2? So in place of t you need to put t plus 2. If I say my yt is 2, tell me the value of yt plus 2. My yt is 2t. This is what I am saying. So what will be the value of y of t plus 2? So in place of t you need to put t plus 2. Here do you see any function of 2? Do you see any function of t? No. So in place of t you need to put t plus 2. So where is t here? T is not even there, so what will be the answer? 2 only. So if your expectation is not a function of time, if your expectation of x of t is not a function of time, then expectation of x of t plus 2 will also be the same only, no? Are you able to understand this point? So if this is 0, then this will also be 0. All these points will be used somewhere, that's why I am telling. So this is 0, this will also be actually 0 only. Although it is not useful, just I am telling, right? So this will come out to be equals to expectation of what this is? Rx of t plus 2. So what this is coming out to be? This is coming out to be 4 cos omega t plus 1 by 3. Okay, so this is the answer. Well and good. Very simple, very straightforward. So covariance also we have find out. Next, what they are asking, mean of x of t plus 2. What do you think, what should be the answer? Second question, what they are asking in the second problem, what they are asking, mean of x of t plus 2. This is what you need to find. You know already one thing, that mean of xt is 0. So what do you think, what will be the answer of mean of x of 2? In place of t you put 0. Sorry, in place of t you put 2. Mean of xt is 0. So mean of x of 2, what does that mean? That in place of t you put 2. Do you see any t here? No. If I ask you what will be the expectation of x of t plus 2? So expectation of xt is 0. In place of t you put t plus 2. Do you see any t here? No. Answer would be 0. So on both of the side, in the right hand side I put, in the left hand side I am putting t equals to t plus 2. I put t equals to t plus 2. Here also I will put t equals to t plus 2, but there is no t here, so answer would be 0. So this question over here they are asking expectation of x of t plus 2, expectation of x of 4, what will be the answer? That would also be 0 only, no? Expectation of x of 4, that will also be 0 only. Now what is my expectation of x square t? This is coming out to be 13 by 3. So again, this is also not a function of time. What I mean to say is that, what if in the left hand side I am putting, in place of t I am putting t plus 2. So here also you will put t, in place of t you will put t plus 2. Yes, right? But there is no t, so answer would be 13 by 3. In the right hand side, in the left hand side, in place of t I am putting 4. So here also in place of t you will put 4. But do you see any t here? No. Answer will be 13 by 3. Are you able to understand this point? Answer will be 13 by 3 only. So for this one, answer will be 13 by 3 only. Now this is the question. Expectation of x of 3 dot x of 5. expectation of x of 3 dot x of 5. Now I can relate it with expectation of x of t dot x of t plus 2, which is given as rxx of t plus 2. So in place of t I will put 3 and in place of 2 I will put 2 because 3 plus 2 is 5. So what is my rxx of t plus 2? That answer I got 4 cos omega t plus 1 by 3. Now this is not even a function of t, so this t doesn't matter. Are you able to understand this point? This 3 doesn't matter, only tau matters. And what is tau? Tau is the time difference between both of the guys. 5 minus 3, answer tau is 2. This is not a function of time, this is only a function of tau. This is only a function of tau. And since this is only a function of tau, then t doesn't matter, no? Whatever the value of t you are putting, doesn't matter. Here t you need to put 3. So tau will be by default 2. So what you will do? You will put 2 here. So if you put 2 here, what you are getting? Cos 2 omega plus 1 by 3. And in the next example, what does it say? Expectation of x square 2, that I have already done. Expectation of x5 x3. x5 x3. What they are asking? x5 x of 5 x of 3. So here what will be the value of tau? Tau will be minus 2. Are you able to understand this point? If you compare it from here, then what do you think? What will be your t? Expectation of x of t, that means t should be 5 and tau should be minus 2. So here if you put minus 2, answer would be the same only, cos of minus 2 omega plus 1 by 3. So what is the answer you are getting? 4 cos of 2 omega plus 1 by 3. Answer is same only. So expectation of x of 3 dot x of 5 is same as expectation of x of 5 dot x of 3, which is pretty obvious, no? Right? X of 3 multiply with x of 5, or you do x of 5 multiply with x of 3, answer should be same only, no? And it is coming out to be same only. But if someone compares from here, what he will think that t is equals to 5 and tau is equals to minus 2. So you put that, what will be the answer? Same only. Are you able to understand this point? Very simple, very, very simple, right? Right? Yeah. So what this was? This was actually Rx of 2. Can you say it? This was actually Rx of 2 because tau value you are putting here, that was 2, and this was actually Rx of minus 2. So Rx of 2 is actually coming out to be Rx of minus 2. And you see the expression of Rx2. The expression of Rx2 was 4 cos omega 2 plus 1 by 3. Right? So your Rx of minus 2 will be what? 4 cos minus omega 2 plus 1 by 3. Why I am able to write down as Rx of tau, not t plus tau? Because this Rx, this autocorrelation function is function of tau only. That's why I can represent in this manner. Otherwise, I will have to represent in this manner. If it is a function of t, then I will represent in this manner. So what is the answer you are getting? 4 cos omega 2 plus 1 by 3. Both are same only. So one more thing, for this particular question, you got to know that Rx of minus 2 is coming out to be Rx of 2. There you go. So this question we have solved. From this particular problem only we will make a lot of conclusion, but two important things in this particular problem we saw. What is that? Two important things are that here your expectation is not a function of time and your autocorrelation is a function of only tau. What two things you saw? Two things we have seen, that expectation of xt is not a function of time and your autocorrelation is only a function of time difference. So these two things we have seen, and based on that we solve this problem, and we got to know that in this particular problem if I just put tau equals to 0, then my answer would have been solved. I could have got the value of expectation of x square t. Say yes or no, right? I don't need to solve all these things. Only if I put tau equals to 0, answer would have been done, right? And then we solved all these problems, x of 2 into x of 4. So I will not do that. First I will find x of 3, then I will find x of 5, and then I will multiply them, and then I will calculate the expectation operator. This is something that I am not going to do. First what I am going to find, always I am going to find autocorrelation function. Once this is find out, my job will be very easy, because once this is there, your job will be very, very straightforward. Say yes or no. Okay. So now we are going to understand a type of random process. So that type is wide sense stationary random process. So what really happened? There will be random process, then the classification will be strict sense stationary random process. Okay, this is a type, and then from here another type is wide sense stationary random process, and then another type is ergodic random process. Ergodic, I should not write it down in this manner. Let's ergodic we will see later on. This also we will see later on. We have studied about random process, and now we are going to study about WSSRP, because this is very, very important. 99% of the problems, or 99, or you say 99.95% of the problems will be coming on WSSRP only. So what is the meaning of wide sense stationary random process? So the random process that you saw here, this was your WSSRP. So what does that mean? That your mean of xt, or you call it mean function, should not be actually a function of time, or you can call it constant. It should not be a function of time. And what about the autocorrelation function of xt? What is autocorrelation function? How do you represent it? Rx of t plus 2. Rxx of t plus 2. It should be a function of only 2. Only 2. That means what I will write down? Is it constant? No. It is a function of time difference between two successive samples. Can I call it sampling time period? Can I call it sampling time period? Because what we will be doing, let's just say this is my some random process. This is one of my sample function x1t. First sample I am calculating at t plus t. Sorry, first sample I am calculating at t equals to t. Then I will calculate at t plus 2. Then I will calculate at t plus 2. Then only you can say that now function of time difference between two samples. 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 Here I can calculate at t minus 2 as well. So what is the time difference? That is also 2. So that means you are calculating the samples. You are calculating the samples after every 2 seconds. Let us say t was 0. Then you calculated the sample at 2. Then you calculated sample at 2 2. Then 3 2. So after every 2 seconds you are calculating the sample. What does that mean? This is sampling time period. So tau is nothing but a sampling time period. Okay. So tau is nothing but sampling time period. If both of the conditions satisfied, if random process satisfies both the condition, then the process will be known as WSSRP. This process will be known as wide sense stationary random process. That means if both the conditions are satisfied, if both of these conditions are satisfied, then your random process will be WSSRP. Is that clear to you or not? So what is the condition of a WSSRP? That mean should be constant and your autocorrelation function should be a function of a time difference between two successive samples. There you go. So this is the condition of WSSRP process, or you can say wide sense stationary random process. So see it and you keep it in your mind. Two conditions are there, mean should be constant and autocorrelation function should be a function of tau only. Constant means, what is the meaning of constant? Constant means it should not be a function of time t. Okay. So this is a question given. You let me know which of the statements are true, which of the statements are wrong. So for a WSSRP process, mean should be constant. Yes, true. Autocorrelation function is only the function of sampling time period. True. Mean square value and variance will be constant. Sir, here you did not talk about mean square value and variance. So sir, this should not be true. But it will be true as well. Why is that so? Just think about it. What is your mean square value? Mean square value is expectation of x square t. That can be written as expectation of xt dot xt. And that can be written as that you calculate the autocorrelation function. You calculate the ACF and then you put tau equals to 0. Now you know that for WSSRP, this particular thing, it is actually a function of tau only. And in this tau you are putting tau equals to 0. So whatever the variable part was there, that you are putting as a constant value, which is tau equals to 0. Here you see. Whatever the variable part was there, tau. Here what you did, you put tau equals to 0. What you are getting? Constant value. What does that mean? That means for WSSRP process, your mean square value is constant. Are you able to understand this point? That means it will not be depending on time. For WSS process, for wide sense stationary process, your mean square value is constant. And if mean square value is constant, then what is this? Sigma square xt. What is this? This is the variance. That is given by expectation of x square t minus expectation of xt whole square. This is also not a function of time. This is also not a function of time. So then this will also be not a function of time. That means it is constant. Constant means it could be function of anything. It could be function of anything, but it cannot be a function of time. What is the meaning of constant? Constant can't be a function of time. And what is the meaning of uniform? Although this will be used in a EMFT. So in EMFT we have already seen. What is the meaning of uniform? Uniform means can't be a function of space. Can't be a function of space. X, Y, Z or other coordinates could also be there. R, phi, Z or sorry, rho phi Z, or you can say R, theta, phi. Right? So should not be a function of space. Can't be a function of space. That means that is uniform. And what is the constant? Constant means cannot be a function of time. We will see it in EMFT. Just for your knowledge I am telling. So this is not a function of time. This is also not a function of time. So what is the answer? C is correct. Is that clear to you? But if someone is saying that a particular random process is given, let me know whether it is WSSRP or not. So what you will do, you will only care about these two guys. Once these two guys are there, then this is understood that mean square value and variance will be constant only. So you don't have to calculate variance separately. Are you able to understand this point? If a question is given that a random process is given, let me know whether it is WSSRP or not. So if this is the question, then you will not find these things separately. Mean square value, variance you will not find separately. Only you will find mean. If it is coming out to be constant, okay. Then I will find autocorrelation function. If it is coming out to be only function of tau, then I will say yes, it is WSSRP. Otherwise I will say no, it is not WSSRP. Okay. So mean square value, variance, very easily you can find out. How the mean square value will be find out? Just in place of tau I will put 0. So this particular option is also correct. Covariance is only the function of sampling time period. Yes, this will also be correct. What is your covariance? Let's write down covariance here. So what will be your covariance? So actually what is the covariance? Covariance is this. T plus tau minus expectation of xt, expectation of t plus tau. Right? What this is? This is a function of tau only. And what is this? Not a function of t. Not a function of t. That means these are not the function of t. And this is only the function of tau. What does that mean? That means this will also be only the function of tau. They are not the function of t, so I can write it down as mu x, mu x. Are you able to understand this point? What I mean to say is that this will be mu x square. Why it will be mu x square? Because I know that mu xt is not a function of t. That means it is constant. That means how will you find out mu x of t plus tau? You will find out by putting t equals to t plus tau. In place of t, you will put t plus tau. In place of t, you will put t plus tau. But it is not even a function of time. What does that mean? That means this will also be constant. And it will be equals to mu x t only, which I am calling equals to mu x. So mu x t plus tau will be equals to mu x, it will be equals to mu x t in case of WSSRP process. Here also you can see the example. Here also I told the same thing. Expectation of x of t is 0, expectation of x of t plus tau will also be 0, right? Why both of them will be same? Because it is pretty obvious that in place of t you need to put t plus tau, but it is not even a function of t. So in place of t you can directly put t plus tau, answer will be same only. So this is how you can represent the autocovariance. Cx of tau is equals to Rx of tau minus mu x square. Okay. So yeah, covariance is only the function of a time period. Autocorrelation function and covariance are constant. What do you think? They are constant. What is the meaning of constant? Should not be a function of time. Just let me know if this is a function of time. Yes, it is a function of time only. You cannot call them constant. Rx of tau is function of time only, because what is tau? Tau is sampling time period. So it is actually a function of time, no? Are you able to understand this point? What if, what is the meaning here in this particular question, in the last question that we saw? I calculated expectation of x of 3 dot x of 5. What if I had to calculate expectation of x of 3, x of 6? Answer would be same. No. Here value of tau was 2, but here value of tau would have been, what this would be equals to? Rx of tau, in place of tau I need to put 3, because the time difference is 3. So what you will get? Rx of 3. That would have been 4 cos 3 omega plus 1 by 3. So here if you are calculating the sample size different time, your answer is coming out, for correlation your answer is coming out to be different. That means it is depending on t. You cannot say it is constant. So this statement will not be correct, because tau itself is a function of time only. No, tau itself is time. Tau itself is second. What will be the unit of tau? That will be second only, no? So you cannot say that it will be constant. It will be a function of a time difference, or you can say sampling time period. It will be a function of sampling time period, which itself is time. So you cannot call it constant. So 4 statements are true, last one is wrong. Is that clear to you? Everything is clear to you, right? So for WSSRP process, mean will be constant, mean square value will be constant, and your variance will be constant. Autocorrelation function and autocovariance will be a function of sampling time period, or you can say will be a function of tau. There you go. Everything about WSSRP process I have already said in one line. All good, all fine. Let's see some question. Okay, no problems are there. Where are the problems? Where are the questions? Questions will come later on. So let's take a break and then we will see the property. So let me take a break now. I will come back. I will drink some water and then I will come back. We will see the properties, or we will see this slide. Some good conclusion I will make here, and then we will see the properties of your autocorrelation function. Okay, this Rx tau that we have got, Rx tau. So our discussion will go around this Rx of 2. For which process? For WSS process. For wide sense stationary process, our discussion will go around Rx of 2. Okay, so let me take a break and then I will come back. Yeah, welcome back guys. So we need to do this discussion, but before that I will take 1 minute. So what really happened was, like just as I paused the video, then the software started lagging, and whatever that I wrote previously, that got erased. Okay, now I had to write down everything again. Okay, I wrote down everything again, all the slides I wrote down again. Okay, so yeah, it took me more time actually. So if you are watching this video, like, you can put a like. Okay, you can put a like if you are watching it on YouTube. So this video will be uploaded on YouTube, right? So if you are watching it on YouTube, then you can put a like. It will make me feel good. Okay, just it will make me feel good. That's why you can put the like. Okay, because I had to write down everything again. And this particular graph I made, this is the graph of Rx of tau, 4 cos omega t plus 1 by 3. So this graph also I made, which I will explain later on why I made this graph. Okay, so yeah, let's get started with our discussion. We were studying about WSS process, wide sense stationary random process, and we saw that mean should be constant and autocorrelation function should be a function of sampling time period only, or you can say should be a function of tau, right? Now let's just say I know that all these correlation are function of tau only. What I'm saying, I already know that whatever the correlation I'm gonna calculate, it could be autocorrelation, it could be cross correlation, all these are function of tau only. So what is the meaning of RXX tau? That means expectation of first sample you are calculating at t and second sample you are calculating at t plus 2. Now what is the meaning of RXX of minus 2? The meaning is first sample you are calculating at t plus 2 and second sample you are calculating at t. This is the meaning of RXX of minus 2. If somewhere Rx of minus 2 is written, you should understand that first sample is leading, second one is lagging. Leading means we are considering that tau is positive. Are you able to understand this point? What I mean to say is that if Rxx of 2 is written and you know that this is only a function of tau, it is not a function of time. What I am saying is that correlation is only a function of tau. This is what I am saying. Tau is the time difference which is equals to 2. So you can think that if I am saying that first sample is calculated at 1, then second sample is calculated at 3. And if Rx of minus 2 is written, Rx of minus 2, what is the meaning of that? That means if I am saying that first sample is calculated at 3, then second sample is calculated at 1. Actually both are the same things. This thing and this thing both are same. So from here what is the conclusion you are making? That if your correlation is only a function of tau, this will work only when it is the correlation is only a function of tau, then you can write down that Rx of tau is equals to Rx of minus tau. So this you need to remember. This you need to remember that Rx of tau will be equals to Rx of minus tau, and this will work only when your correlation is a function of only tau. It is not a function of time t. Basically time t is not coming, the time difference is coming. Are you able to relate it here? So Rx of tau is equals to Rx of minus tau, and you can see in the previous example as well. Which example? In this particular example. Here you could know that this was your Rx of tau, right? This was your Rx of tau, which was a function of tau only, right? There is no term of time. So you can see that Rx of tau is actually equals to Rx of minus tau. This graph is even, right? This particular graph is even. Now what about Rxy tau? What is the meaning of Rxy tau? Rxy tau means the first sample you are calculating at t only, but second sample which is y you are calculating at t plus 2. X with t, second sample with t plus 2. What is the meaning of Ryx of tau? That means first sample you are calculating at t and second sample which is x, that you are calculating at x of t plus 2. Is that clear to you? Ryx of tau. That means first sample at t, second sample at t plus 2. Okay. What is the meaning of Rxy of minus 2? So what is your first sample? First sample will be x. Since there is a negative sign, that means you are calculating this as lead and second one as lag. What is the first sample? First sample is y. Since there is a negative sign, that means this is leading and this is lagging. What do you see here? This is coming out to be Ryx of 2. Ryx of tau, yt into x of t, yt into x of t plus 2, yt into x of t plus 2, and this will come out to be Rxy of 2. You can see that xt into y of t plus tau, xt into y of t plus tau, and then there is sign of e. So what do you understand here? Just as this is written, now I need to invert both of them. What I need to do? I need to invert the downward one. What I will do? I need to invert them. So Ryx, in place of tau I will put minus tau. So inverted, and then in place of tau you put minus tau. There you go. Okay, and along with that they are not equal. What is not equal? This is not equal. Here in place of tau you directly put minus tau. Job done. But here in place of tau you cannot put directly tau. Sorry, in place of tau you cannot directly put minus tau. If you are putting minus tau, that means downward also you need to invert. So Rxy of tau is equivalent to Ryx of minus tau. So did you understand the meaning? These meanings are very important. If minus tau is written, that means first one is leading, second one is lagging. Considering tau is positive, first one leads, second one lags. Okay, and here first one leads, first one is lagging, second one is leading. If plus tau is written, here also you can see the same thing. First sample is x, second sample is y. Plus tau is there, so the second sample is leading. Plus tau is there, second sample is leading. Minus tau is there, first sample is leading. Minus tau is there, first sample is leading. First sample is y, second sample is x. Well and good. Let's see the properties of Rx of tau. So what I am saying is that if x of t is WSSRP, I am considering that x of t is WSSRP, and if this is the scenario, then your autocorrelation function, which should be a function of time t and tau, will actually come out to be a function of tau only. Your autocorrelation function could be a function of time t or tau, or time t and tau, but actually it is coming out to be a function of only tau. Okay, so your autocorrelation function is the function of a time difference between two successive samples. So this is the property that if your x of t is WSSRP, along with that it is periodic, then your Rx of tau will also be periodic. We can see the example here. Which example? This example we will remember. 2a cos omega t plus theta plus b. This example has everything. Okay, it has every single property. So what did you get to know here? What was your Rx of tau? Rx of tau was 4 cos omega tau plus 1 by 3. Is it periodic? Yes, you can see the graph. So here only I will write down x of t. What was our x of t? Just for the sake of remembering it, 2 cos omega t plus theta plus b. This was our x of t because this will be used, right? And what was our a? A was normally distributed between 0 to 2. Theta was uniformly distributed between 0 to 2 pi, right? 0 to 2 pi only, no? Yeah, 0 to 2 pi, and b is uniformly distributed between -1 to 1. So just I am repeating this question here so that we can make conclusion out of it. Yeah, so first one we have seen that Rx tau will also be periodic. If x of t is periodic, then Rx tau will also be periodic, and if x of t is aperiodic, then Rx tau will also come out to be aperiodic. Okay, well and good. Next, what is the value of Rx of 0? Rx of 0 is equals to expectation of x square t, or you can call it total power of xt. Right, you remember it? You remember it or not? I hope you remember it. Here only we proved it. Although this is in a different manner, I have written it down, but you know that Rx of tau, this is coming out to be a function of tau only. Since this is coming out to be a function of tau only, so in place of tau, if you put 0, what you are getting? Expectation of x square t. That means in place of tau, what you are putting? 0. So Rx of 0 is actually coming out to be expectation of x square t. Here double x also you can write down, or single x you can write down. So sometimes I will be writing double x, sometimes I will be writing single x. So don't get confused. So Rx of 0 is coming out to be expectation of x square t. Okay, expectation of x square t, which is equals to total power of xt, right? And it can be equivalent to as well sigma square of xt. I will not write down sigma square of xt. I will only write down sigma square x plus mu square x. Why is that so? Because you know that this is not a function of time, this is also not a function of time. So this will be a constant value. What was our answer here? Here our answer was 13 by 3. Here our answer was 13 by 3. It will be a constant value. So here in place of writing t, I am not writing any t here. I am just writing sigma square x plus mu x square. Now if xt is WSSRP, which I have already given, so what will be your covariance? So covariance will be Rx of tau minus mu x square. If you don't remember it, what you will remember? That such generalized formula is, at least generalized formula you will remember, right? This generalized formula, at least you are going to remember. This is the general formula. So this formula you should never forget. And then you know that for WSSRP process, this will be a function of tau. This will also be a function of tau minus, this will not be a function of time. So this will become mu x into mu x square. So all these things we have already proved with respect to that particular question. We have already proved these kind of things. So Cx of tau is Rx of tau minus mu x square, considering xt is WSSRP. Now if you put Cx of 0, in place of tau if you put 0, let's see what do you get? Rx of 0 minus mu x square. What is Rx of 0? that is expectation of x square t minus mu x square. What that would be equivalent to? Sigma square x. So Cx of 0, what does it represent? Cx of 0 represent what? Variance. Variance of random process. So don't mug it up. In the examination, if they are saying that, what does Cx of 0 represent? Option A, mean square value, variance, or anything else, whatever they want to tell. So there what you will do, you will calculate it. That's it. This thing should be there in your mind, because on this particular property 2 to 3 times question have been asked in the examination, 2 to 3 times. So just remember it, Rx of 0, expectation of x square t. And even if you forget it, you can derive it, because what is your Rx of tau? Expectation of xt dot x of t plus tau. In place of tau, if you put 0, what you are getting? Expectation of x square t. There you go. Okay. Now this is a property. What this is saying, that Rx of 0, let's just say this is the graph of Rx of tau. So Rx of 0 will be greater than all other values, or it could be equal. Basically at 0 you will get the peak of the graph. You will say that, sir, at this value as well I will get the peak of graph, here also I will get the peak of graph. Yes, you can get the peak of graph at other points as well, but this point will be highest. This point can never be low. Basically this kind of graph is never possible, that at some other point you are getting the peak. You are getting the peak here, you can get the peak otherwise at other places as well, but the important part is this point Rx of 0 will surely be the peak, and we will prove it. But as of now you need to remember it, that your Rx of 0 will be greater than or equals to, because equals is also possible, whole Rx of 2. And I have put the mode here. Why I have put the mode here? Because even if you take the mode here, what will be the maximum value? 11 by 3. So even if you take the mode, even if you take the negative value upper side, then also this value will be greatest. Always Rx of 0 will be greatest. And this will always be positive. Why is that so? Rx of 0 will always be positive only. Why is that so? Because what does this represent? This represents the power. Rx of 0 is power, which will always be positive only, no? Power has to be positive. So this will always be positive. Rx of 0 will always be positive. That's why I am not putting mode here. Are you able to understand this point? So Rx of 0 will be the highest point. Other points could be equal, but they can never be greater than this. And we will prove it. Don't worry about it. So this is the statement. Rx of 0 will be highest. Rx of 0 will be greater than Rx of mode of tau. Sorry, Rx of tau then mode. Rx of tau then mode. Okay. And then this property you already know, that Rx of tau will be equal to Rx of minus tau, and with respect to graph as well you can see, with respect to here as well you can see, everywhere you can see that the autocorrelation function will be a even function of tau. What I can write down? Even function of tau. Even function of tau. All these properties we are writing for autocorrelation function, considering xt is WSSRP. A very, very important point. Everything you are writing considering xt is WSSRP, because if xt is WSSRP, then only your autocorrelation function will be a function of tau. Otherwise it will be a function of t and tau. And if it is a function of t and tau, that means if t is coming into action, then whole scenario will be different. But if only tau is coming into action, then all this scenario we are writing it down. Okay. So even function of tau. Right. So now we need to prove this property, right? So let's try proving it. It's not a proof, like just a crude way of understanding it. Just a rough way of understanding that Rx of 0 will be greater than or equals to mode of Rx of tau. So how will I understand it? So let's try solving this problem. With the answer of this problem, we can make the conclusion. So y of t is given, where y of t is equals to x of t plus minus x of t plus tau, where x of t is WSSRP. X of t is wide sense stationary random process. You need to find the total power of yt, right? So expectation of y square t. This is what you need to find. So expectation of y square t. What you need to do? You need to square it. So a square plus b square. If there is plus, then plus sign would come. If there is minus, then minus sign would come. What I am doing, I am just squaring it. A square plus b square plus 2ab. Right? So expectation of x square t plus expectation of x square t plus tau plus minus 2 into expectation of x of t. Now you know that x of t is WSSRP. X of t is WSSRP. If it is WSSRP, then you know one thing, expectation of xt will be expectation of x of t plus tau, and it will be a constant value, right? Similarly, this will also be a constant value only. This will not be a function of time. So this is also not a function of time. This will be equivalent to mu x square plus sigma x square, right? This will also not be a function of time. So this guy and this guy both are same. So can I write it down as 2 into expectation of x square t plus minus 2 into, what is this? Rx of tau, right? This is your Rx of tau. This is your autocorrelation function. And what is this? Expectation of x square t. Can you write it down as Rx of 0? Expectation of x square t is equal to Rx of 0. This should be there in your mind. You don't even need to think. What will be your expectation of x square t? Rx of 0 plus minus 2 Rx of tau. So we have solved the question. Answer we have got. Expectation of y square t is coming out to be 2 Rx of 0 plus minus 2 Rx of tau. One thing you know, this is the answer of the question. Now one thing you know, that what is expectation of y square t? That is known as total power of yt, right? So total power of yt has to be greater than 0. It has to be greater than equals to 0. Because power is positive, it has to be greater than equals to 0. It could be 0 as well, but since yt exists, if it is existing, that means power is non-zero. So it has to be greater than equals to 0, right? So what you can write down? 2 Rx of 0 plus minus 2 Rx of tau should be greater than equals to 0. From here what you can see, Rx of 0 should be greater than equals to plus minus Rx of tau. And plus minus Rx of tau could be written as mod of Rx of tau. So from here what you are getting, Rx of 0, or you can say that I am taking mod on both of the side. If you are taking mod on both of the side, mod of Rx of 0 is equals to Rx of 0 only. Mod of Rx of 0 will be equals to Rx of 0 only. Why is that so? Because this is positive, no? Rx of 0 is positive, so there is no meaning of mod here. So you are taking mod on both of the sides. This is what you can say, right? So yes, this is what we have proved. So this is not a mathematical proof, just a crude way of proving it. Okay, just a rough way. If someone asks all these things personally, then this is how I can prove it. But in the books you cannot write it down, okay? Because this is not a mathematical proof, no? This is just a crude way. Just we took a question, from there we made this conclusion that if it is a total power, it has to be greater than 0, then this is what we are getting. Otherwise, from the graph as well, you can directly remember that it will be the peak point. There you go. Okay. So all these properties we are continuously seeing. So for Rx of tau, what is the conditions you got? Like what is the necessary condition? Necessary condition is, first one, that Rx of 0 should be peak. This is the peak. That is maximum. It is the maximum. Second thing is, it should be even. Should be even. Is there any other condition? No. That's it. Only two conditions are there, that this should be peak and it should be even. There you go. So let me know which of the following is correct ACF. Which of the following is correct autocorrelation function or valid autocorrelation function? Peak here? Yes. Peak here? Yes. Correct. Is it even? Yes. Peak here? Yes. Is it even? Yes. Peak here? At other point as well there is peak, but at 0 you should have a peak. Yes. Is it even? Yes. Correct. Peak here? No. Although it is even, but still this should have been the peak. So not correct. What about this one? E to the power minus 2 tau plus 3. Can you draw the graph of e to the power minus 2 tau plus 3? So roughly here, in short I am making the graph, e to the power minus 2 tau plus 3. So at tau equals to 0, what you will get? 4. Because e to the power 0 will be 1. 1 plus 3, 4. And at tau equals to infinity, you will get 0. So this kind of graph you will be getting. Is it even? Yes. Are you having the peak here? Yes. Correct. So only wrong is this. It could be negative as well. No doubt about that. It could be negative as well. It could be going down and then it can rise as well. Anything can possible. Like going down, rising, all these things are possible. I never said that it could not be negative. Rx of tau could be negative as well. There is no doubt about that. Okay. Rx of tau could be negative and then it can rise up as well. Then it can become constant. Whatever it is, it can happen. All these things can happen. But only two conditions are there, that it should be even and maximum at tau equals to 0. That's it. Nothing else. Here maxima and it should be even. Okay. Let's see more point. So this is an important note. Like what I have seen is that this particular point is not taught in a good manner. Like it is not taught correctly. So let's see what is the correct observation of the point that I am going to deliver here. So what I am saying, xt is WSSRP. Along with that, there is no offset. I will tell you what is the meaning of this offset. So what is your Cx of tau? Rx of tau minus mu x square. So from here, what will Rx of tau will come out to be? Rx of tau will come out to be Cx of tau plus mu x square. So what is said that constant term, look, this is the term of Rx of tau, right? This is the expression of Rx of tau. This is the expression of Rx of tau. So this could be some function of tau plus this is the constant value. What I am saying, this is some function of tau and this is some constant value. So this is said that constant term in the expression of Rx tau shows DC power. This is what it looks like. That this is the constant term and this is function of tau. So this constant term will show the DC power. This is what it looks like. Say yes or no. In the expression of Rx of tau, this constant term will show the DC power. But let's go to this question. Here, what was our expression of Rx of tau? 4 cos omega tau plus 1 by 3. So according to you, according to this particular conclusion that we have made here, according to this conclusion, the constant value should show mu x square. That means, according to us, the answer should be coming out to be mu x square should be coming out to be 1 by 3. That means mu x should be equals to plus minus under root 1 by 3. Mu x could be positive as well, it could be negative as well. Because this is the constant term, no, this is a function of tau. Forget about it. Constant term is this, mu x square is 1 by 3. So mu x is plus minus under root 1 by 3. What was your actual mu x? 0. And here you are getting plus minus under root 1 by 3. So where did we go wrong? You missed one point. What is that point? That point is, I said, there should not be any offset in x of t. X of t should not be having any offset. What is the meaning of offset? No offset means this b is an offset. You are having a time domain function. Okay. A was random variable, theta was random variable. I don't care. But this was a purely time domain function. But here b, this is not a time domain function. This is a pure number, no. It can take any value between minus 1 to 1. In analog electronics, you study offset, right? Offset means whatever the output that you are expecting, along with that there is some other output as well. So that is known as offset. So here as well, this was a time domain function. But this b is coming pure. Alone it is coming. Because of this offset, you got this 1 by 3 extra. Because of this offset only, you got this 1 by 3 extra. You can check as well. If b was 0, let's just say if b was 0. So expectation of b square, if b was not even there, what I am saying is that if b is not even there, then this term will not come. And what was the expectation of b square? That was 1 by 3. So this 1 by 3 would not have come. So what will be the answer? You would got 4 cos omega tau only. And then you could see that if I had got Rx of tau equals to 4 cos omega tau, then what I would see? There is no constant term, no constant term. That means mean is 0. Mean square is equals to 0. That means mean is also equals to 0. So this I have concluded if b was not there. So b is the offset. This offset is doing all the problem for you. This offset is doing all the problem for you. Let's go to one of the previous problems. So yeah, let's see this particular question. Xt equals to a cos omega t plus theta, where a was a random variable, theta was also a random variable. We got the autocorrelation function as 4 cos omega tau. What we got? autocorrelation function as 4 cos omega tau, and it was function of tau only. We did not calculate the mean. But do you see any offset here? No. And what do you see Rx of tau? Rx of tau is coming out to be 4 cos omega 2. Is there any constant term? No constant term. No constant term. No constant term. What does that mean? That means mu x square is 0. What does that mean? Mu x should come out to be 0. Let's calculate the mu x. According to us, mu x should come out to be 0. So let's try calculating the mu of x for this. So what will be your mu x of t? That will be equal to expectation of xt, and that will be equals to a cos omega t plus theta, right? A cos omega t plus theta. Theta goes from 0 to 2 pi, a goes from 2 to 4. So expectation of a dot expectation of cos omega t plus theta, right? Expectation of a you already know, 2, and what will be the expectation of cos omega t plus theta? That will be equivalent to cos omega t plus theta f theta of theta. So f theta goes from 0 to 2 pi uniformly distributed. So this will be equivalent to divided by 2 pi dot d theta goes from 0 to 2 pi. Goes from 0 to 2 pi. You integrate this, you will get the answer to be 0 only. So this particular thing is equivalent to 0. So what is the answer? 0. So your mu xt is coming out to be 0 only, and which is pretty obvious because there is no offset. Since there is no offset, your answer Rx tau is coming out to be 4 cos omega tau. So whatever the constant term is coming here in the expression of Rx tau, whatever the constant term comes, that will be your mean. But there is no constant term, so mean will be 0. Are you able to understand this point? So this is a very, very important point. Like what I have seen is that people will say, that if xt is WSSRP, then constant term will show the DC power. But when it will show the DC power? When there is no offset in the expression of xt. Okay, let's see this question. For a random process xt, autocorrelation function is given as Rx of tau 3 plus 2 sin 3 tau 4 sin 2 pi tau divided by tau whole square. True statement. Which of the following statement is true? Okay. So xt is WSSRP, mean of xt is this, all these things you need to tell. So first let's see what is the value of Rx of minus 2. What is the value of Rx of minus 2? Rx of minus 2 will be, in place of tau you need to put minus 2. So 3. First thing you can see here is that this is a function of tau only, right? Your autocorrelation function is only a function of tau. So can I click on WSSRP? No. First I need to check whether it is a valid valid autocorrelation function or not. And what is the, how do we check the validity? For checking the validity, what we need to do is that we need to take care of these two things, that Rx of 0 should be peak and Rx of tau should be equal to Rx of minus tau. So here if I calculate Rx of minus tau, here in place of sine it should be cos. Really sorry guys. In place of sine it should be cos. Okay. So if I put basically in place of tau if I put minus tau here, and in place of tau if I put minus tau here, basically complete part will be squared. So Rx of minus tau will be equal to Rx of tau only. I don't need to write it down. Anyone can understand that Rx of minus tau will come out to be Rx of 2. And what is the value of Rx of 0? Rx of 0 is, look, this graph is periodic, but this graph is decaying. I hope you know the graph of sampling function. So this graph will decay and this graph is periodic. So basically total graph will decay only. So at 0 only you will get the maxima, that's for sure. What is the value you will get at 0? So 3 plus 2 cos 0, cos 0 is 1, 4. Now here 0 by 0 form will be made. So I hope you know how to solve it. Do you know how to solve it? Let's write down Rx of tau again. So your Rx of tau is 3 plus 2 cos 3 tau. 2 cos 3 tau plus 4 sine 2 pi tau divided by tau. So L'Hopital you will apply here. L'Hopital you will differentiate upper side, downward side. What you need to do? Rx of 0 you need to calculate. So here I can put 0. It will be 3 only. Here if I put 0, it will be 2 only. But here what I will do? I will have to apply the L'Hopital rule. 4 will be 4 only. Limit will go inside. In place of tau you need to put 0. So sine 0 divided by 0, that would be 0 by 0. Undeterminate form. You apply the L'Hopital rule. Upper side what you will get? 2 pi into cos 2 pi t. 2 pi into cos 2 pi tau. In place of tau you will put 0. So cos 0 is 1 and downward you will get 1. So this is what you will be getting. So what is the answer you are getting? 5 plus what is this? 16 pi square. 5 plus 16 pi square. Let's make the changes here. 5 plus 16 pi square. 5 plus 16 pi square. So what is this? Rx of 0. This will surely represent the DC power. Sorry, not DC power. Sorry guys. Total power, not DC power. This will represent the total power. Do you agree to this point? Because you know that what is your Rx of tau? Rx of tau is expectation of xt dot expectation of t plus tau. Then you will get Rx of tau. This could be a function of t as well. This could be a function of tau as well. But actually it is coming out to be a function of tau. And in place of this, if you put 0, what you will get? Expectation of xt dot expectation of xt. That will be expectation of x squared t. So yes, this is your expectation of x squared t that you are getting. So surely this is your total power. Now in this Rx of tau, this is the constant term. In this Rx of tau, this is the constant term. So can you say that this constant term will represent that DC power? Can you say mu x square, which is the constant term? This is a function of tau. This is also a function of tau. So which is the constant term? That is 3. So is this true? True only when xt is WSSRP plus no offset. Along with that, there should not be any offset. But do you have any information about xt? No. What did they write down? They wrote down that xt is just a random process. Did they say that it is WSSRP? Did they say that it is having any offset or not? No, they did not say. Or they could have talked about mean as well. They could have talked about anything. They just gave the expression of autocorrelation function. From this autocorrelation function, can you tell that whether this will be having an offset or not? You cannot tell, right? Luckily, in all the answer in this particular question, if there was no offset, let's just say if there was no offset, then this DC value will not come. This is just a lucky part, right? Just looking at this particular part, can you tell that it is having offset or not? If I give you only this Rx of tau, can you comment anything about x of t? You can only comment one thing, that autocorrelation function of x of t is only a function of tau. This is the only comment you can make. Can you tell about mean? No. Can you tell that whether xt is WSSRP? No. Can you tell whether this 1 by 3 is the DC power? No. Just by looking at the expression of Rx of tau, you cannot comment on DC part. You cannot comment on the DC value. But if they were saying that x of t is having no offset, if x of t is having no offset, then it is pretty sure that that this part would have been coming from the DC value. So here if I mention in this particular question, basically if I don't mention that xt is having no offset, then all these options will be wrong. Because I don't know anything about mean, so I cannot tell whether it will be WSSRP. I don't know anything about mean. I cannot say that this will be the mean. So this option will also be wrong. Total power is 5 plus 16 pi square. That is correct. Because in place of tau, if I put 0, I will get expectation of x square t, which is coming out to be 5 plus 16 pi square. This is the total power. Are you able to understand this point? And here also, when we wrote down this property, here I am not saying that x of t is WSSRP. Here I am assuming x of t WSSRP only for the sake of Rx is only a function of tau. And even if what I am saying is that even if Rx is not a function of tau, what I am saying, Rx is a function of t as well, Rx is a function of tau as well. Even if you put tau equals to 0 here, then also you will get expectation of x square t only. What I am saying, that my Rx of my autocorrelation function is a function of t as well and tau as well. What is the basic definition? Basic definition says this. So when I calculated it, I got to know that it is coming out to be a function of tau as well, it is coming out to be a function of t as well. And now if I put tau equals to 0, if I put tau equals to 0 here, what I am getting? Expectation of x square t. So expectation of x square t will be equals to Rx of t tau putting tau equals to 0. Not tau, t plus tau. Rx of t plus tau putting tau equals to 0. Irrespective of xt, whether it is WSSRP or anything, for any random process, in place of tau, if you put 0, you will get the mean square value. So for this mean square value, I can surely comment. For this mean square value, I can surely comment that this is the mean square value. There is no doubt about that. But can I comment anything on the mean? No. So only condition I have satisfied is that your autocorrelation function is a function of tau only. I cannot comment anything about the mean. But I told you when I was teaching WSSRP, I told you two conditions have to be satisfied. This condition should be satisfied and this condition also should be satisfied. So you can comment about the autocorrelation function. You can say that autocorrelation function is the function of sampling time period. It is a function of tau. This I can say, but I cannot say anything about mean. So if I am not able to comment about the mean, I cannot say that this process is WSSRP. I cannot comment anything about the mean as well. I cannot comment anything about the AC power as well. Because if I don't know the DC power, I cannot comment about the AC power. Is that clear to you? But just as in the same question, if I mention that given xt is having no offset, xt is having no offset. If xt is not having any offset, what does that mean? That means this constant part will show the DC power. So your mu x will be equals to plus minus under root 3. So here this answer would be correct. Along with that, you got to know that this is not a function of time. And this is not a function of time, and your autocorrelation function is coming out to be a function of tau only. What does it say? That yes, it is a WSSRP process. It is a WSSRP process. Are you able to understand all this point? Along with that, you can comment on the total power as well. Sorry, total AC power as well, because here your DC power is 3, so total AC power will be 2 plus 16 pi square, right? 2 plus 16 pi square. 2 plus 16 pi square. Total AC power will be 2 plus 16 pi square. Right? How I will find the AC power? AC power will be sigma square x, right? That will be equivalent to expectation of x square t minus mu x square. What is expectation of x square t? Expectation of x square t is 5 plus 16 pi square minus mu x square. What is the value of mu x square? Mu x square is 3. So what is the answer? 2 plus 16 pi square. 2 plus 16 pi square. This is the answer. So all these will be true only when x of t is having no offset. If x of t is having offset, or if they don't talk anything about xt, then you cannot comment. Is that clear to you or not? Let me tell whatever the discussion I have done. This was a very, very important point. Very, very important point. This no offset should be given. If no offset is given, then only you can comment that the constant part in the expression of Rx tau will be showing the average, will be showing the DC power. Okay, so this part will be showing the DC power. Only when what should be given? That x of t is having no offset. So that's why I took this example and deliberately I added b here. Deliberately I added b, so that you could get to know that whatever the Rx tau you are getting, and here if you put tau equals to 0, sorry, not tau equals to 0, here if you see the constant value, here if I see the constant value, it doesn't mean that it will represent the DC power. Okay, because here I can directly see my DC power is equals to 0. Okay, so it will only represent the DC power when your offset is 0. Now don't think that if offset is 0, always the mean will be 0. No, nothing like that. What I am saying, you might feel like that, sir, if offset is 0, then always your mean will be 0. What if I had said that this is 2? So what would be the mean? Expectation of A would have been 2 here, so answer would be 4. 2 into 2 would be 4. Are you able to understand this point? What I am saying, expectation of, this A is normally distributed with the mean 2 and variance 2. So here this would be 0. This would actually come out to be 0. So answer would have been 0 only, okay. This would be non-zero, but this would come out to be 0. You can calculate expectation of cos omega t plus theta. This will come out to be 0 only. So although in this example mean will always be 0, but other examples are possible. Other examples are possible where mean could be non-zero as well. Here in this example, your mean was 0. In this example, your mean was 0. And autocorrelation function was not having any constant value. So it doesn't mean that if offset is not there, then autocorrelation function will not have any constant value. It can have other constant value. Are you able to understand what I am saying? I am saying that it is not necessary that autocorrelation function will not have any DC value if offset is 0. It can have any DC value. Here DC value is coming out to be 0, but it could be non-zero as well. Are you able to understand what I am saying? It could be non-zero as well. Okay, this value could have been non-zero as well, even if there is no offset. Even if there is no offset. Okay, so that's why this point is necessary. That even if there is no offset, which point is necessary? That if there is no offset, then your Cx of tau, your Rx of tau could be written as a function of tau plus a constant value. And that constant value will represent the DC power. So directly from here you can see that mu x square will be equals to 3. So mu x could be equals to plus minus under root 3. It could be equals to plus minus under root 3. Xt would be WSSRP only because Rx of tau is a function of tau only. Along with that, mean is also coming out to be constant. So yes, it will be WSSRP. Total power you can put by putting tau equals to 0 here. If I put tau equals to 0 here, this is the value I am getting, and total power, total AC power will be total power minus the DC power, that would be 2 plus 16 pi square. All good, all fine. So this is a very good discussion that we have done. I hope you remember this particular discussion. In the test series, I will surely frame a question from this particular slide. Okay. Yeah. Solve this problem. X of t is equals to a cos omega t plus theta. Theta is uniformly distributed between 0 to 2 pi. And y of t is b sin omega t plus theta. Theta is again uniformly distributed between 0 to 2 pi. You need to tell me x of t is WSSRP, y of t is WSSRP or not. And then you need to find Rxy of t into t plus tau. Also you need to find Ryx of t into, so not t into, I should say t comma t plus tau. Basically you need to find cross correlation. What is this? This is your cross correlation function. But first task is to check WSSRP. So how do I check the WSSRP? First I will calculate the mean. So what is the mean you are getting? Here A is constant, only the random variable is theta. Okay, so A is constant, which can be taken outside. Expectation of cos omega t plus theta. So can you calculate the expectation of cos omega t plus theta? Just now we did it. Just now we did it. Where did we do it? In the previous example that I have taken here. Which example? In this example. Expectation of cos omega t plus theta, where theta goes from 0 to 2 pi. Theta goes from 0 to 2 pi, uniformly distributed 0 to 2 pi, expectation of cos omega t plus theta. That will come out to be 0. This will come out to be 0. Or you can do it as well. It will go from 0 to 2 pi cos omega t plus theta divided by 2 pi dot d theta. It will come out to be 0. So this is the answer, you are getting 0. So your mean is 0, which is not a function of time. So first condition we have satisfied. With the first condition we are happy. Now the second condition, Rx of t plus tau, or you can write down Rxx of t plus tau, which is expectation of xt dot x of t plus tau, right? So expectation of, what is xt? That is a, then a will be again multiplied, so it will become a square cos omega t plus theta cos omega t omega tau plus theta. And this calculation also we have done. Actually we have solved the complete problem only, no? Needlessly I wrote down this question. Because here only we have solved this complete problem. No, a cos omega t plus theta, theta goes from 0 to pi. Yes, you will get the answer a square by 2 cos omega 2. So needlessly I am solving it. Okay, right? So what is the answer you will be getting? Here you will multiply and divide by 2. So 2 cos omega t plus theta, cos omega t plus omega 2 plus theta, then you will get this answer a square by 2. Okay. Along with that cos omega 2, which is coming out to be a function of 2 only. So yes, this is WSSRP. The similar analysis you will do for y of t as well. This will also be WSSRP. Let's check for y of t. For y of t. So expectation of y of t, what that would be? Expectation of b sine omega t plus theta. So b can be taken outside since it is constant, sine omega t plus theta. Okay. So what will be the value of expectation of sine omega t plus theta? It goes from 0 to 2 pi sine d theta, and when you integrate it you will get to know it is 0. So what it is coming out to be? 0. So your mu yt is coming out to be 0, which is not a function of time, right? Okay, let's calculate the autocorrelation. So that would be expectation of yt into y of t plus 2. Expectation of what is yt? Sine omega 2 plus theta. Along with that b is also there, no? So this will become b square sine omega t plus theta into sine omega t plus omega 2 plus theta. So b square can be taken outside, divided by 2 I will do, because here I need to multiply with 2 as well. 2 sine omega t plus theta sine omega t omega 2 plus theta. So 2 sine A sine B. What is the answer you will be getting? 2 sine A sine B. What that is? A minus B into A plus B. So what will be A minus B? Cos omega 2 minus A plus B. That will be 2 omega t omega 2 plus theta. And you have solved it now. This will come out to be 0, right? Expectation of cos 2 omega t plus omega 2 plus theta will come out to be 0. So what is the answer you will be getting? B square by 2 cos omega 2. And it is actually coming out to be a function of tau only. So yes, it is coming out to be a function of tau. Function of tau and constant. That means yt is also WSSRP. There you go. This was the first question, which is pretty simple as well, right? Both are WSSRP. Now you need to calculate the cross correlation. What you need to do? Rxy t plus tau. This is what I need to calculate. Okay, I need to add a page. I think I should add 2 pages. From this particular problem, we need to make a conclusion. Okay, we need to make the conclusion. So what we need to calculate? Rxy of t plus tau. So that would be expectation of xt into y of t plus tau. So expectation of a cos omega t plus theta into b sin omega t omega 2 plus theta, right? So AB can come outside because they are constant. Now it will be divided by 2 and multiply with 2. So what you will be getting? 2 cos A sin B. 2 cos A sin B. So what is the formula of 2 cos A sin B? Or you can call it 2 sin A cos B. So what is the formula of 2 sin A cos B? Formula of 2 sin A cos B is sin A plus B. Sin A plus B. What is the answer you will be getting? Sin A plus B. Sin A plus B plus sin A minus B. So sin A minus B. sine omega tau, right? So now when you calculate the expectation of this guy, it will come out to be 0. When you calculate the expectation of this particular thing, it will come out to be 0, because for cosinusoid, if it is coming out to be 0 under one period from 0 to 2 pi, for cosinusoid this particular expression will come out to be 0. So similar thing will happen with sinusoid as well. This will come out to be 0 only between 0 to 2 pi under 2 time periods. This will also give the total area equals to 0. So what is the answer you are getting? AB by 2 sine omega tau, right? This is the answer we are getting. This is your cross correlation. What is the answer we are getting? Rxy of tau. And this would be equivalent to what? Ryx of minus 2. Say yes or no? Or let's not write it down as of now. Forget about it. This is what we are getting. Now someone will argue that, sir, this is not a valid autocorrelation function. This is actually not even autocorrelation function. No, this is cross correlation function. Basically, what people can have a doubt, those who are thinking too much, what they will say, that sir, x of t is WSSRP and y of t is WSSRP. So sir, their correlation should follow the property that you have written. But here you can see that Rxy of tau is not equal to Rxy of minus tau. Rxy of tau is not equal to Rxy of minus tau. So did I say anything about the cross correlation? When we were studying about WSSRP, what did I say? I was talking about the mean of xt and I was talking about the correlation of xt as well. I was talking about autocorrelation only. But here what I am doing, I am taking two processes. One process is xt, which is WSSRP. Second process is yt, which is WSSRP. Now, what is the property of their cross correlation? There is no property. That's it. The only property that will say is that this will be a function of tau only. What I mean to say is that before calculating this cross correlation, do you know that it will come out to be a function of tau only? It can be a function of t as well. You don't know. But when you calculated, you know that this is also WSSRP, this is also WSSRP. And when you calculated the cross correlation, you got to know that it is actually coming out to be a function of tau only. Along with that, nothing else I am taking. Along with that, nothing else I am telling. Only one thing I am telling, that if x of t is WSSRP, y of t is WSSRP, then their cross correlation, which is this particular thing, this is coming out to be a function of tau only. What I am saying, it is coming out to be a function of tau. That's it, nothing else I am telling. Is it even? No, it is not even. It is not even, no. Sinusoid is not even, sinusoid is odd. But I never said that cross correlation will be even. I said that autocorrelation will be even. Yes. What I said? Here I said that autocorrelation is an even function of tau. This is autocorrelation, but I am not commenting anything about the cross correlation. Only thing I am commenting about the cross correlation is that it will be a function of tau. Similarly, you can calculate Ryx of tau as well. What you can calculate? Ryx of tau as well. What that would be? Expectation of yt, y of t, x of t plus tau, x of t plus tau. Without even calculating, I can tell the result. Do you remember what was your Ryx of tau? I told you, but you, as of now, you don't know that it will be a function of tau, no? As of now, you don't know that it will be a function of tau. So better I should write down t plus tau, right? You don't know this will be a function of tau. It could be a function of tau, it might not be a function of tau. So what you will do, you will have to calculate it. So y of t into x of t plus tau. So let's calculate and then we will see whether it is a function of tau or not. So AB, what was y? Y was sinusoid, right? Sine omega t plus theta, and x was cosinusoid. So what you are getting? AB by 2, expectation of 2 sine A cos B. 2 sine A cos B. So what is the formula? Sine A plus B plus sine A minus B. Sine A plus B minus sine A minus B. So sine A plus B. What is sine A plus B? That is 2 omega t plus omega tau plus theta. 2 omega t plus 2 omega tau plus theta. minus sine A minus B. What is sine A? This is your 2 sine A cos B. So sine A plus B plus sine A minus B, no? Plus sine A minus B plus sine A minus B. So what is sine A minus B? Minus omega 2. Minus omega 2. Right? So what you are getting, this will be 0 only. Answer is coming out to be AB by 2 sine minus omega 2. This is coming out to be your Rxy, sorry, not Rxy, Ryx t plus 2. This is what it is coming out to be, and then you go to know that it is actually a function of tau only. Again I am writing yx. Here I should write down yx. It is actually coming out to be a function of tau only. Yes, there you go. So what is the conclusion that you have made? This is the conclusion that you have made. If xt and yt are WSSRP, if xt and yt are WSSRP, then their cross correlation of xt and yt will also be a function of tau. That's it. This is the only conclusion that we have made. Along with that, we know other things as well. What all are the things that we know? We know that if they are the function of tau, then I know this particular thing, that if I am interchanging downward, then I have to put a minus sign here. So in this expression, if you put minus tau, what you will get? AB by 2 sine omega tau. Are you getting the same thing? Yes. So Rxy of tau is coming out to be equals to Ryx of minus tau. So this thing I already know. Along with that, what else I know? Along with that, I know that Ryx of tau will be equals to Rxy of minus tau. So in place of tau, if you put minus tau here, are you getting the same thing? Yes. So this is the conclusion that you need to remember. Which conclusion? This conclusion you need to remember, that if xt and yt are WSSRP, then their cross correlation will also be a function of tau. That's it. xt is a random process which is wide sense stationary. Yt is a random process which is wide sense stationary. I took both of them and I calculated their cross correlation. Either I calculate Rxy or I calculated Ryx. Both will be a function of tau only. That's it. This is the only conclusion I am making. Whether it will be valid, invalid, those things are not even into action. Valid, invalid, all these things are coming into action only for one thing, that is autocorrelation. When xt is WSSRP, then all these properties it will follow. What are the properties? Shall we revise it? If xt is periodic, then Rx tau will also be periodic. If xt is aperiodic, then Rx tau will also be aperiodic. Right? And two other properties are also there, that the mean of x of t will be constant, and autocorrelation function will be a function of tau. Along with that, Rx of 0 will represent the mean square value. Okay, this will represent the mean square value, or you can say total power of xt, or you can call it mean square value as well. Right? Along with that, Cx of 0 will represent the variance. How it will represent the variance, that you can derive it. Right? Rx of 0 will be the peak, that will be the maximum amplitude. Other amplitude could be equal to this, or it would be lesser than that, and it will be an even function of tau. Very simple property, very straightforward. Right? And then in this slide we proved this particular property, and this was the slide where I talked about a valid ACF. And then this was an important slide, that constant value will represent the DC power only when x of t is having no offset. So x of t should not be having any offset. If I am saying that x of t is having no offset, then this will represent the DC power. That means mu of x will come out to be under root 3. Mu of x will come out to be plus minus under root 3. And if I said that there is no offset, if I say that if I don't comment anything about the offset, if I don't comment anything about the DC value, then there is a problem. I can only comment about the total power, rest all comments I cannot make. And just because they said that autocorrelation function is a function of tau, I cannot say that it is WSSRP, because WSSRP is having two conditions. Autocorrelation function should be a function of tau. Along with that, the condition is on mean as well, that mean should be constant. But if I cannot make any comment on mean, then I cannot click here, I cannot click here, I cannot click here. But just as they say no offset, then I got to know that this particular quantity will be representing my DC power. So DC power means I can calculate the mean. So now the mean is coming out to be plus minus under root 3. So yes, it will be WSSRP, and all these things are also true. So yes or no, right? Okay, then let's and then we saw this conclusion, that if x of t is, this is the only conclusion that we are making from here. This is the conclusion, that if x of t is WSSRP and y of t is WSSRP, and when you calculate their cross correlation, you get that the cross correlation is a function of tau as well. whether you are calculating Rxy or Rxy or Ryx. And what is the relation between Rxy and Ryx? Here if you write down tau, here you will write down minus 2. All good? All fine? Okay. Let's solve this question. Xt is WSSRP. Autocorrelation function of x of t is given as Rx of tau, which is only a function of tau. It is only a function of tau. So Rx of tau is expectation of xt dot x of t plus 2. So what do you think, what will be the value of expectation of x of t into x of t plus 2? So what you need to do here, what is the value of tau? Value of tau is 2. So answer will be Rx of 2. And you know that this will be equivalent to Rx of minus 2 as well. What will be the value of x of 2 into x of 4? You know that xt is WSSRP. This thing you already know that xt is WSSRP. So what will be the value of x of 2 into x of 4? That will be equivalent to Rx of 2 as well. You just need to take the difference. 4 minus 2 is 2. That's it. Okay. 4 minus 2 is 2. Rx of 2. Why is that so? Because this is depending only on the time difference. This is depending only on the time difference. What is the time difference between t and t plus 2? What is the time difference between t and t plus 2? The time difference is t plus 2 minus t. What is the answer you are getting? 2. So that's why you have wrote down Rx of 2. That's why you have wrote down Rx of 2. So just calculate the time difference between this guy and this guy. T plus 4, t minus 2. So what you will write down? Rx of t plus 4 minus t plus 2. Because I am calculating the time difference. T plus 4 minus t plus 2. So what you are getting? Rx of 6. What you will write down here? Rx of 2 minus 4. What you are getting? Rx of minus 2, and that you know that it will be equivalent to Rx of 2 as well. Right? What you will get here? Rx of time difference. 2t minus 7 minus 2t minus 3. So what you are getting? Rx of minus 10. Right? Or you can say Rx of 10. Now what about this one? Can you write it down in this manner? T minus 3 minus 2t minus 3. So what is the answer you are getting? Minus t minus 6. Doesn't make any sense, right? Because you know that this is only a function of tau, but here it is coming out to be a function of t. Doesn't make any sense. So can't calculate. Can't calculate. Are you able to understand this point? So here, this problem I will solve separately. X of t would be given. I will calculate x of 2t plus 3. In place of t, I will put 2t plus 3. Then in place of t, I will put t minus 3, and I will calculate the answer. Okay? Right? So whatever the answer I get, that I will click. Are you able to understand this point? Say yes or no. Or directly, basically in the function of Rx of tau, in place of tau, I will put minus t minus 6. Let's just say x of t was WSSRP, and my Rx of tau came out to be 4 cos omega tau. And now they are asking me to calculate this particular thing. So what I will do? 4 cos, in place of tau, omega remains as it is. In place of tau, what I will put? Minus t minus 6. So 4 cos omega t plus 6 omega. This will be the answer. Okay. So just let it be here. This they will not ask actually. They will not ask this. They will ask this kind of question: x of 2, x of 4. So you just need to calculate the time difference Rx of 2. Here also time difference. Or they can ask this thing as well. What is the time difference? 6. Here what is the time difference? 10. So Rx of 10. So for if xt is WSSRP, then your autocorrelation function will be a function of tau only. And if it is a function of tau, then only thing you need to take care is that is the time difference between two successive samples. So here the time difference is 6. Here the time difference is 2, here time difference is 10, and here the time difference itself is a function of t. Okay. Now next question, this is also a very good question. Xt is WSSRP, mean is mu x, autocorrelation function is Rx of tau. You need to comment on the nature of yt. In the first case, yt is 2x minus 3. In the second case, yt is 2xt plus 3xt minus 2. And in the third case, yt is x of 2t plus 3. So try doing one by one on your own. First try 2xt minus 3. Okay. So what is your yt? Yt is 2xt minus 3. So what is the process? Let me tell you. Yt is equals to 2xt minus 3. What do I know? I know that xt is WSSRP. This is given. Xt is WSSRP. This is given. This I already know. I need to comment on the nature of yt. That means I need to calculate the mean of yt and I need to calculate the autocorrelation of yt. These two things I need to calculate. So what will be the mean of yt? So mean of yt will be equals to expectation of 2xt minus 3, right? That will be equals to 2 into expectation of t minus 3. Now let me know, will this be a function of time t? No, because I know that expectation of xt will be equals to mu x, and let's just say, and expectation of x of t into t plus 2 will be equivalent to rx of 2. This will not be a function of time and this will be only a function of 2. And what will be this thing? Who knows, you might need to calculate it. Somewhere this might be used. So what will be this thing? This thing will be equivalent to, this will also not be a function of time. This will also not be a function of time. Or I can write it down as sigma x square plus mu x square, right? All good. So this is not a function of time, 2 mu x minus 3. So expectation of yt, this is also not coming as a function of time. So our first job is done. What was our first job? To calculate the mean. Mean is coming out to be 2 mu x minus 3, which is not coming out to be a function of time. First job is done. What is the second job? Calculate the autocorrelation function. So autocorrelation function will be given as this thing, expectation of yt into y of t plus 2. So expectation of, what is your yt? Yt is 2xt minus 3. Yt is 2xt minus 3. minus 3. And what is y of t plus 2? That is 2xt plus 2 minus 3. Say yes or no. So in place of t I am putting t plus 2. So what you are getting? 4 x of t into x of t plus 2 minus 6 x of t minus 6 x of t plus 2 plus 9. All good? What you are getting? 4 into expectation of x of t into x of t plus 2 minus 6 into expectation of xt minus 6 into expectation of x of t plus 2 plus expectation of 9. So this is a constant, it will come out to be 9. What this will be? Rx of 2. What this will be? Expectation of xt, that will be equivalent to mu x. What do you think, what is the answer of this one? Expectation of xt is mu x, which is not a function of time. That means this thing is also there, right? Because in place of t you need to put t plus 2 here. Are you getting any function of t here? No. That means in place of t, even if you put t plus 2, you will get the same answer. So this is also mu x and this guy is also mu x, and plus this is constant. So what you are getting? Constant function of tau. So what do you see here is that this is completely a function of tau. So this is your ry of 2. So what did you get to know? That your yt mean is coming out to be constant and your autocorrelation function is coming out to be only a function of tau. Is there any time term? It should not be a function of time t, no? Are you able to understand this point? It should be a function of tau. So yes, there is a function of tau. Along with that, there is some constant value as well. If I write down any random xt, that is equals to 2t plus 3. Is it a function of time? Yes. 3 is a constant. No, don't care about that. 2 theta plus 3. Is it a function of theta? Yes. 3 is a constant. Don't care about that. So 6 mu x minus 6 mu x plus 9. That is a constant value. Don't care about that. What did you get to know here? That yes, it is a function of tau only. That means yt is WSSRP. So this one is WSSRP. So can I write it down in this manner that yt equals to, in place of 2 I am putting a. In place of 2 I am putting a. axt plus b is WSSRP. Now second one, yt equals to x 2t plus 3. yt equals to x 2t plus 3. Very simple. This is more simple. What will be mu of yt? What do you think? That will be equivalent to expectation of 2t plus 3. Basically, expectation of yt, what will be your expectation of yt? That will be expectation of 2t plus 3. Now, expectation of, अरे यार क्या कर रहा हूँ मैं? Expectation of x 2t plus 3. Now you know that expectation of xt is equals to mu x, not a function of time t. It is a constant value. So now in place of t, what you are putting? 2t plus 3. So even if you put 2t plus 3, what it will be? Mu x only. So what will be the value here? Mu x. So your mu yt is coming out to be mu x, which is not a function of time t. So our first job is done. This is what we required. Now second is autocorrelation function. So as of now, I don't know whether it will be a function of time t or not, right? As of now, I don't know whether it will be a function of time t or not. Okay, it could be a function of tau, it could be a function of time t, or it could be a function of both as well. I don't know that. So first let's try calculating it. So what I will write down, expectation of yt dot y of t plus tau, basic definition. Then expectation of, in place of yt, what I will put, x of 2t plus 3. And here in place of yt plus tau, what I will put, x of, in place of t I need to put t plus tau. So what I will be getting, 2t 2 tau plus 3. What this will be equivalent to, rx of, what this will be equivalent to, since I know that x of t is WSSRP, x of t is WSSRP. So I know that expectation of x of t plus tau would be equivalent to rx of t plus tau minus t. That means it is equivalent to rx of tau. So here also it will be equivalent to rx of 2t 2 tau plus 3 minus 2t minus 3. What you are getting? 3 and 3 get cancelled, 2t 2t get cancelled, rx of 2 tau. This is the answer you are getting. This is your ry of t plus tau. Rx of tau, this was only a function of tau. Now in place of tau you need to put 2 tau. Basically let's just say your Rx of tau was 3 plus 2 cos 3 tau. Now in place of tau you will put 2 tau. What you will get? 3 plus cos 6 tau. So this is also a function of tau only, no? You are not introducing any time term. So do you see any time term here? Do you see the function t anywhere? No. That means what does that mean? That it is also a function of tau only. So this is also, here I will write down g tau. This is a function of tau because I am calling it as a f of tau. So this will be g of tau. So yes, this is also our desirable condition. So what did you get to know that? The mean is constant and the autocorrelation function is not a function of time, it is only a function of time difference. That means yes, this is WSSRP. So what I can write down, yt equals to x of at plus b will be WSSRP. Second thing also proven. Let's go to the third one. Yt equals to 2xt plus 3xt minus 2. 2xt plus 3xt minus 2. So what will be the mean? Two xt plus 3x of t minus 2. So that will be 2 into expectation of xt plus 3 into expectation of x of t minus 2. So what is expectation of x of t minus 2? That will be mu x only, and this will also be mu x. That will be equivalent to 2 mu x plus 3 mu x. That will be 5 mu x. Okay, so expectation of yt is coming out to be 5 mu x. Again, this is not a function of time t. why I am closing this. This was the requirement. Next is autocorrelation function. So expectation of y of t into y of t plus 2. So expectation of what is y of t? 2x of t plus 3x of t minus 2. 2x of t plus 2 plus 3x of t plus 2 minus 2. So expectation of 4x of t into x of t plus 2 plus 6x of t into x of t plus 2 minus 2 plus 6x of t minus 2 x of t plus 2 plus 9x of t minus 2 x of t plus 2 minus 2. There you go. 4x of t plus 2, 6x of t plus 2 minus 2 x of t minus 2 x of t plus 2, and then 9x of t minus 2 x of t plus 2 minus 2. So what is the answer you are getting? 4 will be a constant, x of t into x of t plus 2. What that would be? Rx of 2, right? Plus what you will be getting here? 6 into Rx of t plus 2 minus 2 minus t. What is the answer you will be getting? T minus, sorry, tau minus 2 plus 6 into Rx of tau plus 2 plus 9 into Rx of 2. This is the answer you are getting, and surely it is coming out to be a function of tau only. Function of tau, function of tau, function of tau, function of tau. Tau plus 2 it is there. Basically, if I say there is a function 3 sine theta plus 5, is it a function of theta? Yes. Now if I do 3 sine theta plus 2 plus 5, is it a function of theta? Yes. Again it is a function of theta only. So tau plus 2 you write down, tau minus 2 you write down. Our only concern was that there should not be any term of t. Tau can come, but there should not be any term of t. It is not coming, then your job is done. Right? That means this is also WSSRP. So what you can write down? That your y of t, which is equivalent to axt plus bx of t minus t naught. This will also be WSSRP. So you got three forms. Can you remember all these three forms? First one, yt equals to axt plus b. Now let me know what will be the value of this mean. What will be the value of mean? That will be a mu x plus b. What I am considering? I am considering xt is WSSRP. This is given that xt is WSSRP. Okay. So I know that yt will also be WSSRP. So what will be the mean of y? In random variable we have studied it. In random variable we have studied it. Ax plus b. Y equals to ax plus b. What we studied? Mu y is equals to a mu x plus b. Apart from that, what else we studied? Sigma y square. Sigma y square will be equals to a square into sigma x square. So similar thing I can do here as well. Your sigma y square. It will not be a function of t, right? It will not be a function of t. Since this is WSSRP, this is also WSSRP. So this will not be a function of t. So here I don't need to write down t here. Are you able to understand this point? So sigma y square will be equals to a sigma x square. Sorry, a square sigma x square. There you go. I cannot comment anything about ry of. If I need to find ry of tau, then calculate. Calculate. How will you calculate? This is how you will calculate. This is how you will calculate. The answer will come out to be 4 Rx of tau minus 12 mu x plus 9. So anyway you will have to calculate it. Calculation has to be done, right? Second one, yt equals to a x, or not a, x at plus b. So what do you think? What will be your mu y? mu y will simply be equals to mu x. And what will be your sigma y square? That will simply be equals to sigma x square only. Why is that so? Because this is not a function of time t, no. Basically, for mean and variance, there is no meaning of t. Whatever that is written inside, just forget it. If xt is WSSRP, so whatever that is written inside, just forget that. Because there is no meaning of t for mean and variance. Also for mean square value as well. Because they will be constant. They will be simply constant. So irrespective of time t, basically, even if you sample your sample function, at t equals to t, you sample it at 2 seconds, you sample it at 5 seconds, you sample it at t plus alpha plus 90 seconds or whatever you do it, everywhere the value will be same for WSSRP. So this is the meaning of basic WSSRP, that at all the points your statistical parameter, which are mean, variance and only I am talking about mean, variance and mean square value, they will be constant irrespective of time t. So if I am talking about WSSRP, I can forget about the time t, I can simply treat it as y equals to x. So mu y will be equals to mu x. There you go. Only when xt is WSSRP, along with that yt is also WSSRP. Yt is also WSSRP. So this is how I can treat them. Next is yt equals to axt plus bx t minus t naught. So what will be your mu y? Mu y will be equals to a mu x plus b mu x. A mu x plus b mu x. A mu x plus b mu x. Why is that so? Because xt will throw mu x only and x of t minus t naught will also throw mu x only, because you know that irrespective of time t you will get the same mean, right? And what about the variance? That would be equals to a square sigma x square plus b square sigma x square, right? A square plus sigma x square plus b square sigma x square. This is the answer you will be getting. Say yes or no. Is that true? Do you really think so? No, wrong, right? This is wrong, right? A square sigma x square plus b square sigma x square. Is this true? Do you remember? Z equals to y plus x. This was also a function, this was also a function. This was also a random variable, this was also a random variable. So what was your sigma z square? Sigma z square was sigma y square plus sigma x square. That's it? No. 2 sigma xy, right? So similar thing will come here, no? 2 ab sigma xy, right? What is this sigma xy? Sigma xy is sigma xy is cx of tau. What was sigma xy? Sigma xy, or you can write down it as cxy. This was your covariance between x and y. But here covariance between x and x only. So here what you will write down? C x of x and then the time difference between these two. So first sample you are calculating at t, second sample you are calculating at t minus t naught. So that will be equivalent to minus t naught. Are you able to understand this point or not? And so now the answer would be coming out to be, I will again explain this point, don't worry. A square sigma x square plus b square sigma x square, or let's write it down in a good manner. Answer would come out to be a square plus b square sigma x square plus 2ab t naught as well. Why minus t naught is replaced with plus t naught? So let's see it. So you know that if xt is WSSRP, if xt is WSSRP, then cx of tau will be equals to rx of tau minus mu x square. Now cx of minus 2, let's write down cx of tau only. So cx of tau, cx of minus 2 will be equals to rx of minus 2 minus mu x square. Rx of minus 2 is equals to rx of tau only minus mu x square, which is equals to cx of tau. So cx of minus 2 is coming out to be cx of tau only. Now you might not be able to understand this particular thing, sigma y square. What is this sigma y square? Sir, explain it in a better manner. So let's do it right from the scratch. Yt equals to axt plus bx of t minus t naught. what I need to calculate? I need to calculate the sigma y square. So what will be my sigma y square? Sigma square yt. This is what I need to calculate. So we are doing it from the scratch only. So that will be equivalent to e square yt minus e of yt whole square. Although I know that this will be WSSRP, which I have already proven. So since I know that this will be WSSRP, so do I need to care about this time t? No, I don't need to care about this t. But let's keep it here. Do you know what is the value of expectation of yt? So yes sir, expectation of yt I can calculate from here. That will be a mu x plus b mu x. Expectation of yt square, what that would be? That would be a square plus b square plus 2ab. Just do the square, no? A square plus b square plus multiply of both of them, multiply with 2. So 2ab mu x square. This is the answer you are getting. Now expectation of y square t. What I need to calculate now? Let's calculate expectation of y square t. So that will be equivalent to a square b square plus 2ab, right? Now a square expectation of x square t, expectation of x square t. So let's keep it as expectation of x square t only, plus b square expectation of x square t minus t naught. That will be equivalent to expectation of x square t only, plus 2ab expectation of x of t minus t naught. So that will be equivalent to Rx of, what is the time difference? T naught was capital or small? T naught I am putting capital, here I put as small. Okay, don't worry. Everywhere I am putting as small only. So let's make it larger. So what is the time difference? Time difference is capital T naught. So here I can put minus T naught or I can put plus T naught as well. So there you go. This is your expectation of y square t is coming out to be. So now what do you see? Sigma square yt is coming out to be expectation of y square t, which is a square expectation of x square t, a square expectation of x square t plus b square expectation of x square t plus 2ab rx of 2ab rx of t naught, 2ab rx of t naught minus a square mu x square, b square mu x square, b square mu x square minus 2ab mu x square. So directly you can see a square expectation of x square t minus a square mu x square. What is the answer? A square sigma x square plus b square expectation of x square t minus b square mu x square. What is the answer? B square sigma y square. Sorry, sigma x square plus 2ab rx of t naught minus mu x square, rx of t naught minus mu x square. What that would be? Cx of t naught, and 2ab is outside. So what you are getting? 2ab cx of t naught. There you go. This is your sigma square yt. So what did I write down? If yt is equals to axt plus bxt minus t naught. So here sigma square yt would be equivalent to a square sigma x square plus b square sigma x square plus 2ab sigma, or I can write down, since I am writing it down as cx t naught. There you go. This is the answer. So this we have proven. Similar thing we have studied in our random variable as well. What if this is given? Now this will not make sense, no? This will not make sense. What we have studied actually, we studied this thing, ax plus bz. So sigma y square was coming out to be a square sigma x square plus b square sigma z square plus 2ab sigma xz. Here we are writing down sigma xz as cxz, covariance. So covariance of x and z. So here also covariance of xt x of t minus t naught. So what will be the covariance of x of t minus t naught? That will be equivalent to cx of t naught. So this is what I have written. A square sigma x square plus b square sigma x square plus 2ab cx of t naught, that means covariance of x of t and x of t minus t naught. So what is your cx of t naught? Cx of t naught is covariance of x of t dot x of t minus t naught, which is equivalent to rx of t naught minus mu x square. So yes or no? Okay. So all this decision is done. So this will also be WSSRP. So here directly you can write down a square plus b square sigma x square plus 2ab cx of t naught. Okay. And if you are getting confused, then for you I have proved it as well. So all this proof also I have given. Although proof was not required, whatever that you have studied in your random variable, based on that only you could have wrote it down. Y equals to ax plus bz. So a square sigma x square plus b square sigma z square plus 2ab sigma xz. So sigma xz was the covariance between x and z. So similarly here as well, 2ab cx t naught, where cx t naught is covariance between x of t and x of t minus t naught, which is cx of t naught, which is equivalent to rx of t naught minus mu x square. So all this decision, everything we have done. So roughly around 3.5 hours we have spent here in the first lecture, and I know that every single thing you have understood. Within 30 minutes you can revise it, right? Within 30 minutes revision could be done. If I just see, last question was basically commenting on axt plus b, axt plus b x t minus t naught, x of at plus b. All these are WSSRP. All these are WSSRP. If xt is WSSRP. Okay, well and good. And then this was that if xt is WSSRP, then simply you can take out the difference and you can write down the autocorrelation function. 4 minus 2, t plus 4 minus t minus 2, answer will be rx of 6. So simply take the difference and that will be your rx of 2. Let's not write down can't calculate here. This doesn't make any sense. Let's not write down can't calculate, because rx of 2, whatever that you are getting, there you put minus t minus 6. Here xt and yt are WSSRP, then the cross correlation of xt and yt will only be a function of tau. That also conclusion we have made. We will use it somewhere. Okay, very important. Somewhere we are going to use it. People usually directly remember it, but we proved it with respect to a question. Okay. Then this was the important point, that if there is no offset, then only you can say that constant part will be representing your DC power. Otherwise you cannot say that it will be representing your DC power. Okay, so constant part will represent that DC power only when xt is WSSRP, along with that it is having no offset. Okay, and then this property we proved. So these are the properties, very important. Rx of 0, very important. This will represent the mean square value of xt, and then all these things you already know, right? This thing also you already know. Rxy of tau is equal to ryx of minus tau. So I just told you the meaning of Rxy of minus tau. That is, first one is advanced, second one is not having any advancement, it is sampled at t only. So this also we know. So yeah, and then WSSRP, mean is constant, and your autocorrelation function is a function of tau only. And then these questions we saw where this was WSSRP only, we solved everything about this particular question. So here we talked about mean square value, variance, autocorrelation function, and convolution. Okay, so yeah, this was a good discussion that we have done. Now hardly we will see 5 to 6 slides for the concept, and then we will see the problems as well. A lot of problem solving needs to be done, right? We solved very less questions. More problems we are going to solve in the next lecture. So for first 15 to 20 minutes we will see some concept. We need to study about ergodic random process. We will study about ergodic random process, and then we will see questions only. So next lecture will be mostly based on problem solving. Okay then, yeah, thank you very much. Hi everyone, welcome back. So we were studying about random process. In random process, what all we saw? First we saw the basic introduction to random process, then we studied about statistical parameters, and then we studied about WSSRP, and we were solving the problems as well. So this was our flow, right? So now also we will solve the problems only, but before that we just need to understand some basic terms. So we will understand the meaning of some basic terms, and then we will move to problems. So 10 to 15 minutes there will be discussion, and then there will be questions only. Okay, yeah. So let's get started. So we need to tell the difference between deterministic signal and random signal. If random signal is written, what is the meaning of random signal? And if a deterministic signal is written, what is the meaning of deterministic signal? So random signal is nothing but a random process only. So random process has multiple names. They can call it random signal, they can call it stochastic process as well. Okay, so how a random process is defined? Let's just say I write down xt a cos omega t plus theta. Is this a random process? No, because there is no random variable. But if I say a is a random variable which is uniformly distributed between 0 to 2, or if I say theta is a random variable which is uniformly distributed between 0 to 2 pi, yes, now it becomes a random process. Now it is a random process. So random process means it will have a lot of sample functions like x1t, x2t, xt3. It will have a lot of sample functions. So this waveform will be different than this waveform. It will be different than this waveform. So all these waveforms are different. So in random process, in one random process, you can get multiple time domain waveforms, right? What you will be getting? Multiple time domain waveforms. Okay. Now let's understand the meaning of deterministic signal. See the word deterministic. That means there will be only one time domain waveform. So whatever the signals that we study in signal system, in our signal system, what kind of signals we studied? Let's just say xt equals to a cos omega t plus theta. There you go. That's it. This will be your deterministic signal, because this is only one waveform, only one time domain waveform. A will be a fixed value, theta will be a fixed value, omega will be a fixed value, and t is the time domain. So with respect to xt versus t, with respect to time t, only one waveform is there. With respect to time t, only one waveform is there. One waveform, only one waveform. With respect to time t, only one waveform will be there, xt versus t. So this is known as deterministic signal. That means only one waveform. So whatever the signals that we studied in signals and system, whatever the signal that we study, that is known as deterministic signal. Very simple thing. Okay, very straightforward, very simple. So deterministic signal you know, random signal you know, right? It will be used somewhere in our further analysis. That's why I am using it here. Okay, let's see this question. Xt equals to a sin omega t plus theta is given. Theta is uniformly distributed between 0 to 2 pi. First question is saying find the statistical mean of x of t. So now what is the meaning of time average mean? I will tell you, but let's find the statistical mean of x of t. What is the meaning of statistical mean? That means the mean that we are currently studying. Expectation of xt. This is what you need to find. So expectation of xt. What is xt? Sin omega t plus theta. Okay, a is constant. So a into expectation of sin omega t plus theta, because theta is a random variable. So expectation always looks for randomness. So now you know that you can find the expectation of sin omega t plus theta. What you will do is that you will have to integrate from 0 to 2 pi sin omega t plus theta, multiply with 1 by 2 pi into d theta. So when you integrate from 0 to 2 pi, what answer you will be getting? 0. So expectation of xt is equals to 0, right? This is statistical mean, means whatever the mean that we have studied. Statistical mean of capital XT. That means they are talking about the mean that we have studied in random process. Now they are saying time average mean of XT. So what is the meaning of time average mean? Time average mean. So here what you will do? Limit t tending to, or forget about it. What you will do? You will integrate your XT. You will integrate your XT with one time period and then divide by the time period. Along with that, you will put limit t tending to infinity. There you go. What you are doing? Integrate your xt for one time period, divide by the time period, and then limit t tending to infinity. Okay, very simple process. This is known as time average mean. This is the mean that we studied in our signal system chapter. So time average mean, and here I have written time average mean of a small xt. That means now they are considering this as deterministic signal. Deterministic signal. So now theta will not be your random variable. Theta will be a constant value now. Are you able to understand this point? So whenever I say time average mean, that means randomness is gone. Whenever I say time average mean, that means randomness is gone. Theta will be taking a particular value between 0 to 2 pi. Fine. So let's find the time average mean. So what will be the time average mean? Limit t tending to infinity 1 by t for one time period sine omega t plus theta. So let me know if you integrate your sinusoid for one time period. If I integrate my sinusoid for if I integrate my sinusoid for one time period, positive area will be equals to negative area. What is the answer you are getting? 0. Okay. Statistical autocorrelation of xt. That means what you need to find? Autocorrelation function of xt. What is autocorrelation function of xt? Expectation of xt dot x of t plus 2. Expectation of what is xt? A sin omega t. So basically you can find it, right? A lot of time we have found it out. A lot of times. The same example we have taken a lot of time. Omega t plus theta and then sin omega t plus omega 2 plus theta, right? So here what I will do? A square I will take outside, divide by 2, multiply by 2, 2 sin a cos b. What will be the formula? Cos a plus b, cos a minus b minus cos a plus b, right? Cos a minus b minus cos a plus b. So answer, final answer you will be getting is a square by 2 cos omega 2. The D2 same example we have seen. There it was written b sin omega t plus theta. Do you remember that example? A cos omega t plus theta, and then second example was b sin omega t plus theta. And then I asked you xt is a random, xt is WSSRP, yt is WSSRP. So you find out the mean as well and you find out the autocorrelation function as well. So very easily till this point it should be there in your mind that sinusoid omega t plus theta is coming with theta being uniformly distributed between 0 to 2 pi. My answer will be a square by 2 cos omega 2. Although you don't need to mug it up, you can derive it always in the examination, but it should be there in your mind. It should be stuck in your mind. In both of the cases, cos will come, sine will not come, because what is the formula of 2 sine a cos b? Sorry, what is the formula of 2 sine b? Cos a minus b minus cos a plus b. So cos a plus b will be gone, cos a minus b will be left. So it will throw cos omega 2 only. And let's find time average autocorrelation function. Time average autocorrelation. Why we are doing so, sir? You will understand. Okay, don't worry about that. Time average autocorrelation. So what we will do? Similar thing we need to do. Here what we did, in place of expectation, we did the integration and then divided by the time and limit t tending to infinity. Similar thing we will do here. We will do the integration of x of t dot x of t plus 2 d2, integrate for one time period, divide by time period, limit t tending to infinity. Do you need to mug it up? Absolutely not, right? Although no one will ask you these questions. It is just for the sake of understanding the next topic that we are going to study. We are just building up the concept for next topic, okay? Nothing else. So actually no one will ask you, but yeah, just doing it for the sake of understanding a particular topic. So 1 by t, for one time period we are integrating sine omega t plus theta, sine omega t omega 2 plus theta dot, yeah, this is a blunder. Why I am putting d2 here? dt should come, no? So here everything you do with respect to time only, right? But here in the expectation we do everything with respect to the random variable. If random variable is theta, then I will integrate with respect to theta. If random variable is a, I will integrate with respect to a. If random variable is omega, I will integrate with respect to omega, right? But here always we will do with respect to time, because x of t is purely a function of time. A, theta, omega all are constant there. Well and good. Okay. So now integration can I leave up to you? I think I should leave the integration up to you. What you will do? Here I forgot a square, right? Because a sin omega t was there, no? So a square will also come. So divide by 2, multiply by 2. So 2 sin a, sin b. So cos a minus b, cos a plus b. Cos a minus b. Integration is always there. Can't forget the integration. Integrating for one time period. Cos a minus b. Then minus cos a plus b. Integrating for one time period. So when you integrate this one, you will get to know that answer is coming out to be 0. And here cos omega tau will be constant, right? I am writing down the answer here. Limit t tending to infinity a square by 2t. Cos omega tau is constant and you are integrating dt for one time period. What is the answer you will be getting? So cos omega tau is a constant and then you are integrating dt for one time period. What is the answer you will get? T. So t to t will get cancelled out. What is the answer you are getting? A square by 2 cos omega tau. So what is the answer you are getting? A square by 2 cos omega tau. Okay. So luckily here statistical autocorrelation and time average autocorrelation are same. Here also statistical mean and time average mean, what we were getting? 0. Both are same. It is always not necessary that both will be same. Okay. So till this point in this slide, what do you understand? In this lecture, what do you understand? We understood the meaning of deterministic signal. We understood the meaning of random signal. Random signal is nothing but random process. Deterministic signal means the signal that we have studied in signal system. Okay. Purely a time domain signal, nothing else, no random variable. Then we saw the meaning of statistical mean. Then we saw the meaning of time average mean, statistical autocorrelation and time average autocorrelation. In our case, in this particular question, first thing is that, is this WSSRP? Yes, this is WSSRP as well. How do we know? Because mean of xt is 0 and autocorrelation function of xt is only a function of tau, right? To check WSSRP, what you need to do, you need to find the statistical mean and statistical autocorrelation function. So we find out statistical autocorrelation function, we find out statistical mean as well. Mean was constant and autocorrelation function was function of tau only. So yes, it is WSSRP. Along with that, time average mean is equals to statistical mean and the time average autocorrelation function is equals to statistical autocorrelation function. Okay. So if these things are met, then this process is known as ergodic random process. So what does ergodic random process will say? The first condition is that it has to be WSSRP. First is it has to be WSSRP. Second, statistical mean should be equals to time average mean and the statistical autocorrelation function should be equals to time average autocorrelation function. If these three conditions are met, then it is known as it is ergodic random process. Very rare, like till this point they never asked about ergodic random process. Okay, it will be mentioned in some of the question that this particular process is xt is ergodic random process. This will be mentioned. So at that time student will be having the doubt that sir, what is this ergodic? We never studied it. So that's why I am teaching it. Okay. So in the question, if ergodic random process is written, what you will think? That sir, it is WSSRP. Along with that, these things are also true. So when you analyze all these things, there is a very interesting point about ergodic random process. That is, first thing is that if the process is ergodic, that means it is surely WSSRP. Because first condition is for ergodic random process, it has to be WSSRP. And then these are the things. Then another interesting thing we observe that if you find out your Rx of tau and then you put limit tau tending to infinity, that means you see the value of your autocorrelation function at infinity. You see the value of your autocorrelation function at infinity, that will be equals to mu x square. That means you can call it DC power. So if ergodic random process is written, if ergodic in the examination ergodic random process is written, so what all things you can get from here? First thing you will say from ergodic random process, you will say that sir, mean is constant. Mean is constant. Second thing you will say that autocorrelation function is a function of tau. And third thing you can say that in my autocorrelation function, if I go to infinity, it will give me mean square of mean, or you can call it DC power. Along with that, these things are also surely true. Rx of 0, what it will give you? Expectation of x square t. This is always true. And then Rx of tau is equal to Rx of minus tau. All these things are surely true, right? So if ergodic random process is written, then already for WSSRP, this advantage I could take, this advantage also I could take, but in ergodic, this advantage also I can take. In WSSRP, this was also there, this was also there, and this was also there. But in ergodic, this advantage also I can take. Okay. So here another one advantage we have taken. So that's it. This is the meaning of ergodic random process. So only thing you need to remember till this slide, only thing you need to remember is that if ergodic random process is coming, then Rx of infinity will be equals to mu x square. And if they have just mentioned ergodic, that means it is surely WSSRP as well. If they have mentioned ergodic, that means surely it is WSSRP as well. Okay, that's it. We will solve the problems now, and in the end we will see more concept. Okay, so let's solve the question. What they have given for a stationary ergodic process xt. Did they mention it is wide sense stationary? No, but they have mentioned ergodic. That means it is surely WSSRP. So if only ergodic is mentioned, you know that it is surely WSSRP. Okay. Magnitude of mean you need to find. What you need to find? Magnitude of mean. So I told you for ergodic random process. What did I tell you? Limit tau tending to infinity, Rx of tau. So if you put tau tending to infinity, what you will get? Can you put the limit of tau tending to infinity here? Simple mathematics. Tau tending to infinity. Tau square divided by 25 plus 9 tau square. So tau square very large. 9 tau square will also be very large. So what is the answer you will be getting? 1 by 9. Okay, and that will be equals to. So basically you need to find the value of this function at tau equals to infinity. That will be 1 by 9. So that will be equals to mu x square. So what is the value of mu x you are getting? Plus minus 1 by 3. Okay, so that's the mean. All good. Now another question, very simple question, very straightforward. Okay, it is not necessary that it will be based on ergodic only. Pure question. Now we are just solving the problems, nothing else. It could be from WSSRP, it could be from anywhere. Just solve the question. If this question is coming in your examination hall, what they are just wait a second, guys. Yeah, sorry for the interruption. Welcome back. What we need to find? Rx of T1 T2. What is the meaning of Rx of T1 T2? So you should know. Although it will be mentioned in the examination that if they ask you to find Rx of T1 T2, so they will give the definition. Definition means they will give you that they want to ask this particular thing. Okay. So most probably like definitions and all will be given in the examination. Don't worry about that. Just one second again. Yeah. So Rx of T1 T2 you need to find. So that will be equivalent to expectation of x of T1 dot x of T2. So expectation of x of T1 will be 6 e to the power a T1. So 6 into 6, that will be 36, right? 36 e to the power a T1 e to the power a T2. There you go, right? Very simple thing, right? 6 into 6, 36, a T1 a T2. So what is the answer you are getting? 36 expectation of e to the power a T1 plus T2. This is what we need to find. So this is our target. What is our target? Our target is to find the expectation of a to the power T1 plus T2, where T1 T2 are two particular time instant, but a is the random variable. So let's try finding expectation of e to the power a T1 plus T2. That will be equivalent to what? E to the power a T1 plus T2. What is the PDF of a? What is the PDF of a? That is 1 by 2, right? Because a is uniformly distributed between 0 to 2. That means PDF of a will be 1 by 2 between 0 to 2 dot dA. So what you are getting? 1 by 2 is here. E to the power a T1 plus T2 divided by T1 plus T2, because you are integrating with respect to a, right? Not with respect to t. 0 to 2. All good, all fine. This is what we need to integrate. PDF is already there, 0 to 2 dot dA. Just we are finding the expectation, which is very simple, right? So what is the answer you are getting? 1 by 2 T1 plus T2 e to the power 2 T1 plus T2 minus e to the power 0, that is 1. So that's it. This is the answer. And you can surely see that it is a function of T1 plus T2, not the time difference. Basically, for WSSRP, Rx of T1 T2 should be a function of T2 minus T1, right? Not T2 plus T1. Why T2 minus T1? Because what we have studied, what we used to study, T plus tau is equals to Rx of what? T plus tau minus T. That means it should be the function of time difference. So time difference between these two guys, that should be t2 minus t1. So it should be a function of t2 minus t1, but it is coming out to be a function of t1 plus t2. What does that mean? Not WSSRP. Okay. So here, what will be the final answer? Final answer will be 36 divided by 2. So 18 divided by t1 plus t2. 18 divided by t1 plus t2 e to the power 2 t1 plus t2 minus 1 e to the power 2 t1 plus t2 minus 1. So this is the answer you are getting. Okay. And surely it is a function of t1 plus t2, so surely it is not a WSSRP. Let's go to the next one. Xt is WSSRP they have given, Rx tau they have given, Yt is defined as xt minus 6a xt minus 0.5. What will be the value of a that would minimize the mean square value of Yt? This is the question. First you let me know, another question could be asked that Yt is WSSRP or not? Yt is WSSRP or not? Do you remember the last lecture? In the last lecture, in the last what we studied, Yt equals to axt plus b x t minus t naught. If xt is WSSRP, then Yt, which is equals to axt plus b xt minus t naught, this will also be WSSRP. This we have studied in the last lecture. So will Yt be WSSRP? A value is 1, b value is minus 6a, t naught value is 0.5. So yes, surely it is WSSRP. Although they did not ask it, but it can be asked, right? Now, what we need to minimize? We need to minimize the mean square value of Yt. What we need to minimize? Mean square value of Yt. This is our target, that mean square value of Yt should be minimized, which should be a function of a. Surely it will be a function of a. So let's see. What is the mean square value of Yt? That is expectation of y square t. So always, whatever that you need to find, focus on that in any kind of problem. And I'm not only talking about communication system, in any kind of problem, always in the examination you should read the question from downward. What I need to find, based on that I will read the information given. So here I will not get started with the what is the mean square value of xt. Why do I find that? Now I will get started with this. In between, if I need any value, then I will take the reference of this guy. Are you able to understand this point? So as of now I am not looking at it, because first I will start solving the problem, right? So y square t I need to do, so a square. Now here I would get to know that yes, now I need this guy, a square plus b square a square plus b square minus 2ab plus 2ab, but 12a xt x of t minus 0.5. There you go. Do you understand this point? Right? Very simple. So expectation of x square t, from here let's find out expectation of x square t. What that would be? That would be equivalent to Rx of 0. So that would be equivalent to 0.5. So expectation of x square t will be 0.5 plus 36a square expectation of x square t minus 0.5. Let me know what will be the answer of this one, and minus 12a expectation of x of t minus 0.5. Let me know what will be the answer of this one. And here as well, instead of writing 0.5, I am writing expectation of x square t. So what do you think, what will be the answer of all these guys? Do you know the answer of this guy? Expectation of x square t 0.5. Rx of 0 I am writing down, or 0.5 I can write down. 0.5 plus 36a square. What do you think, what is the answer of expectation of x square t minus 0.5? Not a function of time, right? Expectation of x square t is not a function of time. Since it is not a function of time, then expectation of x square t minus 0.5 will also be the same only, right? It will also be the same only, will be equals to 0.5 only. Very simple thing, right? 0.5. So multiply with 0.5, what it will become? 18a square plus, not plus, minus 12a. What this value will be? X of t minus 0.5, and then there is expectation operator. What does that mean? Rx of t minus 0.5 minus t minus 0.5 minus t t minus 0.5 minus t. So that is equivalent to Rx of 0.5. So what is the answer you are getting? 0.5 plus 18a square minus 12a. Rx of minus 0.5 or Rx of 0.5 you can write down. Here you put 0.5. What is the answer you are getting? 0.5 e to the power minus 1 by 4. Okay. So what is the answer you are getting? 0.5 plus 18 square minus 6a e to the power minus 1 by 4. This is the answer you are getting for mean square value. But what they are asking, this is not the final answer. What they are asking, what should be the value of a that would minimize the mean square value? So for minimization or maximization, what do? You differentiate. So this is a function of a, right? This is a function of a. So a function of a is given as 18a square minus 6a e to the power minus 1 by 4 plus 0.5. You need to minimize it. What does that mean? That means I will differentiate with respect to a. What will be the answer? 0. So what I am doing? 36a minus, when I differentiate this one, what I am getting? 36a, and when I differentiate this one, what I will get? 6 e to the power minus 1 by 4, because differentiation of a will be 1 only, right? 6 e to the power minus 1 by 4, that would be equivalent to 0. So what is the answer you are getting? 1 by 6 e to the power 1 by 4. This is the answer of A. Okay, very simple. Expectation of y square t I needed to find. So I started finding, then I got to know that this value will be same, and this value will be equals to Rx of 0.5. I put Rx of 0.5 here, 0.5 e to the power minus 1 by 4. Here also 0.5 will come, but this will be a constant value. Then I need to differentiate it. Just I differentiated, I got to know it will be 36a, and this will be minus 6 e to the power 1 by 4. So what is the answer you are getting? 1 by 6 e to the power 1 by 4. Okay, yeah, let's go to the next one. Xt is WSSRP with an average power of px and 0 mean. Xt is WSSRP, average power is given. What does that mean? Mean square value is given. What is this? This is nothing but a mean square value, because I told you average power means, what is the meaning of average power? Average power means nothing but a mean square value only. That means total power. So if you feel like that average should be DC power, but no, I have already told you, whenever average power is written, that means they are talking about total power. Okay, yt equals to xt, a xt cos pi by 3t plus theta. Theta is going from 0 to 2 pi. Theta and xt are independent. You need to find the average power of a random process yt, and then you need to find the average of yt. Average of yt means what they are asking? Expectation of yt. And here what they are asking? Average power of random process yt, expectation of y square t. Okay, so let's get started. What we need to find? Expectation of yt. So what that would be? Okay, a is not a random variable. A is a constant value, right? Theta is only the random variable. So a into expectation of xt multiply with expectation of cos, because why I can do this? A is a constant, I can take outside, and xt and theta are independent. Xt and theta are independent, so I can break the expectation operator. So expectation of xt dot expectation of cos pi by 3t plus theta. So I can find the expectation. It will also come out to be 0, but already expectation of xt is given as 0 only, right? Expectation of xt already given 0. Here, from here you can see that expectation of xt already given 0. Okay, now you need to find expectation of y square t. So what is the answer you are getting? A square x square t cos square pi by 3t plus theta. Okay, so a square is already constant. Expectation of x square t. Now this is a function of xt and this is a function of purely theta, so I can separate them, right? expectation of cos square pi by 3t plus theta. So a square, expectation of x square t. What is this? Px, mean square value. What does that mean? Expectation of x square t is px only, no? Right? Are you able to understand this point? So expectation of x square t is px. What about this one? Cos square pi by 3t. Cos square pi by 3t plus theta. What I will do? 1 plus 2 cos 2 theta. Okay, not 2 cos. It will be 1 plus cos 2 theta divided by 2. Which formula I am applying? What do you think? Which formula I am applying? The formula that I have applied is cos square. This formula should be there in everyone's mind. Cos 2 phi is equals to 2 cos square phi minus 1, and that will be equivalent to 1 minus 2 sin square phi as well. Right? So cos 2 phi plus 1 divided by 2, this is what I have applied. And when you find the expectation of cos 2 pi by 3t plus 2 theta, with theta being from 0 to 2 pi, you would know that 2 cycles they are talking about, and in 2 cycles this will throw 0 only. So what is the answer you will get from this one? From this one, what answer you will get? 1 by 2, right? You can do it on your own. We have done it a lot of time. In place of 2 pi by 3, always it used to be omega, but now in place of omega, 2 pi by 3 is written. But you don't need to care about this thing. You need to care about 2 theta. 2 theta means it will be going for 2 cycles, theta being from 0 to 2 pi. So you can simply integrate. You will get to know that this will come out to be 0. Okay, expectation of cos 2 pi by 3t plus 2 theta will come out to be 0. So expectation of 1 by 2 will be 1 by 2 only. So answer will be a square by 2 px. Okay, so this is the answer of expectation of y square t. So very simple way is there. Needlessly people find random process stuff because they don't solve the problem. They try to mug up the results, but don't mug up the results. Very simply you can solve this problem. If you have enough practice, here also you will get to know what will happen. Here also you will see that a square will come outside. Expectation of x square t is px. You will write down directly, and then you will see it is cos square pi by 3 plus theta. That will go somewhat around 1 plus cos 2 theta divided by 2. 2 theta means 2 cycles, 0. So from here only you will write down this answer, a square by 2 px. Are you able to understand this point? Okay. So yeah, this is the answer. This answer we have got, and expectation of yt is already 0. So this answer also I know. Now xt is given. This is a good question, where a is uniformly distributed between 0 to 1. Yt is defined as the integration of xt only. Here I need to write down x of alpha because the limit is of t, right? And then 2 pi by t is there. Omega is equal to 2 pi by t. You need to find the maximum possible value of expectation of yt. What you need to find? Expectation of yt you need to find. That's the bottom line. And maximum possible value you need to find. So expectation of yt will be equivalent to what? Expectation of how yt is defined? 2 pi by t. For half period, what you are doing? You are integrating for half period. From t to you are going to t plus t by 2. So you are integrating for half period. Okay. What you are integrating? You are integrating x alpha dot d alpha. That means what will be x alpha? A cos omega alpha dot d alpha. This is what you need to find. Okay. Now expectation of, now you see where the expectation operator will go. 2 pi by t, is it a constant? Yes. A is a random variable. So expectation will always look for the randomness. So where is the randomness? Only here is the randomness. So what it will do? 2 pi by t will be outside, t by 2. Now the whole operator, whole expectation operator will work on the expectation operator can go inside the integration, right? This can go inside the integration. So this operator can go inside the integration because integration is also not random. Only random thing is expectation of a, but it will work on the whole, right? It will work like this. But in this particular function, only random thing is a. So cos omega alpha will be constant. So what will happen? It will look something like this. Expectation of a cos omega alpha dot d alpha. Okay. So what you are getting? 2 pi by t. Now for the integration, you are integrating with respect to alpha. Expectation of a will be a constant value, that will be equals to half. right? A plus b divided by 2, that will be equals to half. So t by 2 cos omega alpha dot d alpha. That means now you need to integrate the graph of cosinusoid for half time period. You need to integrate in a manner that you get the maximum area, because this needs to be maximum. Expectation of yt, you want it to be maximum. You want this to be maximum. Now this is constant, 2 pi by t is constant, 1 by 2 is constant. That means now this guy should be maximum. And how this guy will be maximum? Let's see the graph of cosinusoid. This is the graph of cosinusoid. This is the graph of cosinusoid. In that manner it will keep on going, right? How much is this window? This window is also t by 2. This window is also t by 2. Also this window is also t by 2 only, from here to here. Right? T by 2 window. This is also t by 2 window. This is also t by 2 window. Now what if someone says that, sir, this is also t by 2 window only? Because we need to integrate for t by 2 window. Someone will say that, sir, I will integrate from here to here. What someone will say, I will integrate from 0 to this point. So positive area will be equivalent to negative area, answer will be 0. Someone will say that, sir, I will integrate from here to here. So negative area equals to positive area. What will be the answer? 0. So mean will come out to be 0. Right? Someone will say that, sir, I will integrate from here to here. So whatever the area we get, that area will be negative. Whatever the area we get here, that area will be negative. So mean value will come out to be negative. But we want the maximum possible value. What do you think what I should integrate? From here to here. This area I should calculate. Say yes or no. Do you agree to this point or not? Right? Basically the integration should be maximum. That means the area should be maximum. Area will be maximum in this particular lobe. And do you remember the area of this lobe? In signal system I told you, you always need to remember the area. What will be the area? So let's solve this first. This is pi by 2 only. So what is the area? Area is 2 Vm by pi. What is the maximum value? Maximum value is 1. So 2 Vm by pi into the width. What is the width? T by 2. If you don't know, then you can remember from now onwards. If there is a sinusoid or cosinusoid, this could be sinusoid as well, this could be cosinusoid as well, and this length is alpha. This particular length is alpha, and amplitude is Vm. So what will be this area? This area will be 2 Vm by pi into the length alpha. So here what we are doing, 2 Vm value is 1 because this magnitude is 1 here. Cos omega alpha only is there, right? So 2 Vm by pi into the width. What is the width? T by 2. Okay, you can watch the first marathon of signal system, either in first or in second marathon. You will get these kind of concept there. Okay, so 2 to 3 area you should always remember, so that you don't need to integrate. So here you will not integrate. First you will have to find out what will be this value, then you will have to find out what will be this value, then you will put the integration. It will take a lot of time. Simple thing is 2 Vm by pi into T by 2. So what is the answer you will get? Answer will be 1. So that's the answer. This is the answer. Okay, so what we needed to do, we need to find the expectation of yt but maximum, and it is all depending on this particular thing, and that is coming out to be 2 Vm by pi into T by 2. Answer is 1. Let's go to the next one. Yeah, this is a big problem actually. So you can read this and then you can read this slide as well. So a lot of problems are there, but it is very easy. What they are asking us to find. Ergodic random process is given. So by default I know that it is WSSRP as well. Rx of tau is given. What does that mean? That means autocorrelation function is given. You can see that maximum value is here and it is even as well. That means, yeah, valid autocorrelation function it is. You need to find the mean, covariance, mean square value, covariance graph also. What you need to find? Mean, variance, mean square value, and covariance graph also you need to find. You will find the expression of covariance. Along with that you need to draw the graph as well. Then this particular thing you need to find. What is this? I don't know. Limit t tending to infinity 1 by t minus t by, you should know what it is. Okay, this particular thing you need to find. And then process is sampled at a frequency f of s. Okay. What should be the minimum value of f of s such that successive samples are uncorrelated, successive samples are orthogonal, successive samples are independent, covariance of successive sample is 12.5, correlation of successive sample is 40. Even if you are not able to solve these problems, then it is fine. But these questions should be solved. expectation of x square 200, expectation of x 101, x 96. These questions should be solved. So you do it on your own. Okay, you do this one also on your own and try this one also on your own. You will be able to solve it. Ergodic random process is given. This is something that you have already seen. So try thinking about it, what it is. Okay. So let's get started. Let's start with the mean. Mean we need to find. What is given? Ergodic random process is given. Since ergodic random process is given, I told you one thing, that in the graph of Rx, you go to infinity, what you will get? This particular thing you will get. So what is the value of Rx of infinity? Rx of infinity going towards 25. So Rx of infinity is 25. 25 is equals to mu x square. That means the value of mu x is plus minus 5. Okay. Second, mean square value. Mean square value. What is mean square value? Rx of 0. 50. Very simple, very straightforward. Second, third thing, variance. What is variance? Variance has a very simple formula. That would be, why I'm not writing t here, because I know that it is WSSRP, so it will not be a function of time t. So that will be equivalent to, let's write down the formula, expectation of x square t minus expectation of x whole square. So expectation of x square t is 50, expectation of x whole square is 25. So what is the answer you are getting? 25. So variance is 25. Next, covariance. So what you need to find? Covariance, and you need to draw the graph as well. So what will be your covariance? Cx of tau. Cx of tau is given by Rx of tau minus mu x square. Till this point it should be remembered, right? You don't need to write down the basic definition again and again. Let me write down the basic definition for you. What was the basic definition? That first sample at xt, second sample at t plus tau, multiply both of them and calculate the expectation, and then you separate the expectations. And you know that this will be equivalent to Rx of tau, and since this is W plus RP, so this guy and this guy will be equal. So what is the answer? Rx of tau minus mu x square. Rx of tau minus mu x square. What is the value of whatever the graph is given? Rx of tau, whatever the graph is given, in that graph you need to subtract by 25. So you will get the graph of Cx of tau. Are you able to understand this point? Whatever the graph is given, whatever this graph is given, you subtract 25, you will get the answer. That means this particular graph is given. There you go. This will be the answer. The magnitude will be basically at what will be the value of Cx of 0? Cx of 0, this I am drawing the graph of Cx of tau. Cx of tau versus tau. So Cx of 0 will be equals to Rx of 0 minus 25. What is the value of Rx of 0? 50. 50 minus 25, that would be 25. So basically whole graph will be subtracted by 25, no? Whole graph will go down by 25. So wherever you are getting 25 value, that value will be 0. So this value will be 0. What is the value of tau here? 10. What is the value of tau here? 10. So Cx of tau, this is the graph of Cx of tau. Is that okay for you? Very simple, very straightforward, right? Now what do you think? What is the second thing? Ergodic random process is given. You are integrating x square t for a particular time period, okay, for a particular time window, and then dividing by that time window and limit t tending to infinity. What do you think what it is? What we have seen for ergodic random process. For ergodic random process, what we have seen? Rx of tau. What is Rx of tau? Statistical autocorrelation function, which is given by this thing, is equivalent to what? Is equivalent to, you integrate for one time window x of t, here small x of t I should write, because of x of t, x of t plus tau dot dt 1 by t limit t tending to infinity. And here if I put tau equals to 0, if I put tau equals to 0, What answer I will get? You are integrating with respect to t, so don't worry, you can put tau equals to 0 here. So what answer you will be getting? Limit t tending to infinity 1 by t, and one time window you need to take, that means you can take the window from minus t by 2 to t by 2. If you are putting tau equals to 0, what you are getting? X square t dot dt. This they are saying equals to alpha, and what is the value of Rx of 0? Rx of 0 is 50. So what is the answer? 50 only. So basically it was nothing but a mean square value of xt. It was nothing but mean square value of xt only. Here actually small x square should have been written, but even if large is written, don't worry about that. Even if they write down capital X, don't worry about that. But ideally small x should be written here. Now what they are saying, the process is sampled at a frequency f of s. What does that mean? That means what, let's just say this was your process. Let's just say this was your process. So what you are doing, Rx of tau, how will you get Rx of tau? That first sample you will get at t equals to t, and then second sample you get at t equals to t plus 2. That means what is the time difference between two samples? Tau. So this is known as sampling frequency. That means after every tau window, this is known as sampling time period. Tau is sampling time period. Sampling time period. That means after every tau window you are calculating two samples. Sampling time period. Sampling time period. Right? If I say expectation of first sample I am calculating at t, second sample I am calculating at t plus 2, what answer I will get? Rx of 2. If I say first sample I am calculating at t plus 2, and second sample, the next sample, that will be at t plus 2 tau. T plus 2 tau. So what is the answer? Rx of 2 tau. Right? Not 2 tau, sorry guys, really sorry guys. Rx of tau, really sorry, brain fade moment. T plus 2 tau minus t minus 2. So Rx of 2. What someone can say? That sir, first I am calculating at t minus 2, and second I am calculating at t. Again they are successive samples. What will be the answer? Rx of minus 2, that will be equivalent to, or okay, what is the time difference? Time difference is t minus t plus 2, so Rx of 2 only. Are you able to understand this point? So between successive samples, what is the time window? Between successive samples, the time window is 2. Between successive samples, time window is 2. So this is what they are saying. And what do you mean by Fs? So Fs is a sampling frequency. That means it is simply the inverse of 2. It is simply inverse of 2. So 1 by 2. So basically they are asking the value of 1 by 2. So process is sampled at frequency Fs. Did you understand the meaning of that? That after every tau window the process is being sampled. That's why you got the waveform of Rx of 2. Right? So what should be the minimum value of Fs such that successive samples are uncorrelated? What is the meaning of uncorrelated? Do you remember it? Uncorrelated. Uncorrelated. Uncorrelated random variable. Let's understand uncorrelated random variable. What are the condition? Expectation of xy was equivalent to expectation of x dot expectation of y. So in case of random process, what will happen? Expectation of x of t plus 2 will be equivalent to expectation of xt dot expectation of x t plus 2. What is expectation of xt? That is mu x. What is this? This is also mu x. And what is this? This is your Rx of tau. So Rx of tau should be equivalent to mu x square. What is the value of mu x square? 25. So what they are asking? The minimum value of tau. The minimum value of tau such that your Rx value is 25. What is that? Minimum value of tau is 10. Are you able to understand this point or not? The minimum value of tau such that Rx value is 25. This is what they are asking. Someone will say that sir, at tau equals to 12 as well. This is the answer. Okay. So this cannot be minimum value, right? If tau is the minimum value, then sampling frequency will be maximum. Are you able to understand this point? What I am saying, if I say tau equals to 10 millisecond. So if tau is minimum, then sampling frequency will be largest, no? If tau is minimum, sampling frequency will be largest. As of now, did you understand the point? What we need to find? What did they say? the random process is uncorrelated. That means first sample that you are calculating x of t and second sample or second random variable that you are calculating, that is x of t plus 2, both should be uncorrelated. So this is the condition. Now since x of t is WSSRP, x of t is WSSRP, so this guy will be equals to mu x and this guy will also be equals to mu x, and this is your Rx of tau as well. So Rx of tau should be equals to mu x square. So Rx of tau should be equals to 25. So what is the minimum value of tau? What is the minimum value of tau such that Rx of tau is equals to 25? So Rx of tau is equals to 25 at tau equals to 10 millisecond, right? At tau equals to 10 millisecond. This is the minimum value of tau. So when I find out f of s, I will do 1 by 2. So if this is minimum, then this will be maximum, no? Right? So what will be the answer? 1 by 10 milli. So 1 by 10 milli will be 100 hertz. So tau minimum was 10 millisecond. So answer will be 100 hertz, but it is the maximum frequency. So here question should be changed. What should be the maximum value of f of s? What should be the maximum value of f of s? All good? All fine? Did you understand this point? That means what should be the maximum frequency with what you should sample such that random successive samples are uncorrelated. Successive samples means x of t, second sample is x of t plus 2. Successive samples are orthogonal. What is the meaning of orthogonal? Do you remember the meaning of orthogonal? Orthogonal random variable. Orthogonal random variable. So what we used to do, expectation of x dot y should be equal to what? 0, right? So successive sample should be orthogonal. So first sample is x of t, second sample is x of t plus 2. They should be orthogonal. What does that mean? Rx of tau should be 0. Can you ever get Rx of tau equals to 0? Can you ever get Rx of tau equals to 0? No. What does that mean? Not possible. Never possible. Never possible. This is the answer of second. Okay. This is the answer of orthogonal. This was the answer of first one, which is uncorrelated. Orthogonal, never possible. Next, what they are asking? Successive samples are independent. Independent. Successive samples are independent. Independent and uncorrelated will be same here. It is not generally same, right? What is the meaning of independent random variable? Independent random variable. Independent random variable x and y. If I am saying that x and y are independent random variable, that means expectation of function of x and function of y. Function of x, function of y. This is the meaning. But here what they are saying, successive samples are independent. What does that mean? This is the first sample, this is the second sample. Independent and uncorrelation becomes the same here. Luckily in this problem they are same, but actually they are not same, right? So this will be equivalent to mu x square, which is equals to 25, which is Rx of tau. So your tau minimum will be 10 millisecond and your Fs max will be 100 Hz. Covariance of successive sample is 12.5. Covariance. What is the meaning of covariance? Covariance of successive sample should be equals to 12.5. 12.5. Covariance of successive sample, that means expectation of x of t into x of t plus 2, and then you separate them. Expectation of xt dot expectation of x of t plus 2. That should be equivalent to 12.5. So what is this? This is your Rx of tau. I am converting everything into Rx of tau because that is my matter of concern, no? Because graph of Rx tau only is given. Now someone will say that sir, Cx tau graph is already there, so 12.5 will be somewhere here, so answer will be 5 milliseconds. Yes, answer will be 5 milliseconds. I know that, but if only this graph is given and only this question they are asking, what I mean to say is that this graph was given and only this question was asked. They did not even ask you to draw the graph of this covariance. You are not having the graph of covariance. Directly they are asking only this question. This graph is given and directly they are asking this question. So how would you solve it? So this is how I will solve it. I will not make the graph of covariance. This is how I will solve it. What I will say, mu x square, that will be 25. So 12.5. So basically I need my Rx of tau should be equals to 37.5. Okay, 37.5. Rx of tau should be equals to 37.5. That will be somewhere here. So from 50 to 25 you are going. That means you are losing 25 amplitude. So from 50 to 37.5 if you need to go, here will be your 37.5, somewhere here, somewhere in between. Very simple mathematics I am telling. From 50 to 25, that means you are losing by 25 amplitude. So if you are going from 50 to 37.5, that means you are losing by 12.5 amplitude. So this point will be 37.5. So you are losing by 12.5 amplitude. So what will be this value? 5 millisecond. Right? So tau minimum is 5 millisecond. Did you understand this point? Rx of tau should be 37.5. This is my target that I understood. And then I know that I need to find the value of tau from the graph. Now it is just about mathematics. 50 to 25 losing by 10. So 50 to 12.5 losing by 5. So tau minimum will be 5 millisecond. That means your fx of max will be 1 by 5. That would be 200 hertz. So this is the answer, such that your covariance is 12.5. If your covariance is 12.5, that means fs of max should be 200 hertz. And directly from this graph as well, you could see that this point will be 5 millisecond only. This was very simple question. Next, what they are asking, correlation of a successive sample is 40. Correlation they are asking now. Another page should be added. Just to copy this page. Next slide में ये क्या है भाई? अच्छा, continuous time, discrete time. Yeah. So correlation of successive sample. Correlation of successive sample. Correlation of successive sample, which is given by this. That should be equivalent to 40. This is what they are asking. So where I will get it 40? From 50 to 40 I need to go. So from 50 to 25 if I am going, I need 10. 50 to 25. That means if you lose by 25, in the x-axis you work for 10. If you lose by 1, that means in x-axis you work for 10 by 25. And from 50 to 40 you need to go. 50 to 40 you need to go. That means you lose by 10. That means on the x-axis you will work for 4. So your Rx of tau will be 40 at tau equals to 4. At tau equals to 4 it will be 40. Are you able to understand this point? At tau equals to 4 it will be 40. Like I am not writing down the equation of line. I am just using my pure intuition. On y-axis if I fall by 25, on y-axis if I fall by 25, on x-axis I work for 10. On y-axis if I fall by 1, on x-axis I will work for 10 by 25. On y-axis if I fall by 10, that means on x-axis I need to work for 10 into 10 by 25, which will be 4. That means here I need to work for 4. Tau minimum value will be 4. There you go. So here tau minimum will be 4 millisecond. So fs maximum will be 1 by 4 milli. That would be 250 hertz. Okay. 40. Now expectation of x square 200. Since xt is WSSRP, xt is WSSRP. So expectation of x square 200 will be equivalent to expectation of x square t, and which is equivalent to 50. 101 96. That means Rx of 96 minus 101. What that would be? Rx of 5. Rx of minus 5 you can say. That would be equivalent to Rx of 5. And that would be equivalent to 37.5. Right? At Rx of 5 you are getting 37.5. Expectation of x of 100. That would be equivalent to expectation of x of t, because it is constant. So what is the expectation of x of t? That is equals to plus minus 5, right? Here we have find out the expectation, it is plus minus 5. Covariance of x of 7, x of 9. What does that mean? Expectation of x of 7, x of 9 minus expectation of x of 7 into expectation of x of 9. So what is the first thing? This is Rx of 2, right? 9 minus 7 Rx of 2. What is this? Expectation of x of 7, that will be equivalent to expectation of x of 100, that will be equivalent to plus minus 5. So this is your mu x, that would be mu x square. So what is the value of Rx of 2? Rx of 2. So when I work by 10, I go for 4. So it will be 45. Rx of 2 you need to find, right? So Rx of 4 is 40. How I will do it? When I am at 0, or you can simply tell by the slope as well. Tell by the slope. What is the slope of this line? Slope of this line is minus 25. That will be equivalent to y2 minus y1 upon x2 minus x1. So y2 will be coming out to be 45. Okay. So by the slope as well you can solve it. Answer will be 45. So Rx of 2 will be 45 minus 25. That would be equivalent to 20. Now y equals to x of 2 minus x of 4. Variance of y you need to find. What you need to find? Y is a random variable. Y is nothing but a random variable because it is the fixed value, no? X of 2 minus x of 4. Again let me check. X of 2 minus x of 4. Yeah. X of 2 minus x of 4. Basically this was a process. So at t equals to 2 you are sampling it. What do you get? X of 2. At t equals to 4 you are sampling it. What do you get? X of 4. So what I need to find? Variance of y I need to find. So first what I need to find? Expectation of y, because variance of y is equivalent to expectation of y square minus expectation of y whole square, right? So what is your expectation of y square? That would be expectation of x square 2, x square 4, 2x2, x4, a square plus b square minus 2ab, plus 2ab actually, but there is a negative sign, so minus 2ab. So what is the answer you are getting? Expectation of x square 2, expectation of x square 4 minus 2, expectation of x of 2, x of 4. So 50 plus 50 minus 2 Rx of 2, right? So 100 minus Rx of 2. What is Rx of 2? Here only we used it. Somewhere Rx of 2 value I wrote down, no? 45. 2 into 45. That answer is 10. So expectation of y square is 10. How did we do it? Very simple, right? Expectation of y square, that is x of 2 minus x of 4. So here I wrote down x of 2 minus x of 4. So what I am getting? X square 2 plus x square 4 minus 2 x of 2 x of 4. So expectation of x square 2 will be 50. Expectation of x square 4 will be also 50 minus 2 x of 2 x of 4, that will be equivalent to Rx of 2. So Rx of 2 is 45. Answer is 10. And what is the expectation of y? That will be equivalent to 0. Why is that so? Because expectation of y will be equivalent to expectation of x2 minus expectation of x of 4. So whatever the expectation of x of 2 you are getting, the same expectation you will get for this guy as well. So answer will be 0. So expectation of y square, so your sigma y square, that would be equivalent to expectation of y square, and that would be equivalent to 10. There you go. This is the answer. This is the answer of last question. Okay, it was a very good question, just covering everything that can be asked from the graph of Rx of 2. Everything, every single thing that can be asked. Ergodic random process was given, that means it is WSSRP for sure. Then you go to know what is the meaning of successive samples. Along with that, mean, variance, mean square value, covariance graph, everything you can find. Mean, how you can find? Going at tau equals to infinity. Mean square, that would be the value of square of mean. Basically mu x square will be equals to 25, so mu x will be plus minus 5. Either it could be plus 5 or it could be minus 5, you are not sure, whatever the value could be there. Then mean square value, simply it will be Rx of 0, that would be 50. From there you can find the variance as well. Then covariance, Cx of tau will be equals to Rx of tau minus mu x square. Rx of tau minus mu x square is 25. So just shift the graph by 25 downward, you will get the covariance graph. Then second thing, it was only written as expectation of x square t. So they were asking in the problem B, they were asking mean square value only. Then sampling frequency, you know, sampling frequency means inverse of the time that you are taking to collect two successive samples. First sample I am calculating at t, second I am calculating at t plus tau, third I am calculating at t plus 2 tau, fourth t plus 3 tau, right? Then all these things uncorrelated, I already know the meaning. Orthogonal, expectation xy equals to 0. Uncorrelated means expectation xy equals to expectation of x dot expectation of y. Independent and uncorrelated, for this particular problem they are same. Then covariance is 12.5 and then correlation is 40, you can solve it. Then expectation of x square 200, which is equals to expectation of x square t only. Then next one is Rx of minus 5. Then next one is simply the expectation of xt. And then covariance, that would be Rx of 2 minus mu x square. So Rx of 2 is 45, that we can cover from the graph as well. How we will cover that also I have told you. You can write down the equation or you can simply think, right? Because this is a linear graph. In linear graph we can think it. In signal system we have studied these kind of topics in a very good manner, right? And then y equals to x of 2 minus x of 4, variance of 4 you need to find. That means expectation of y square minus expectation of y whole square I need to find. Expectation of y will be 0 only because expectation of x of 2 minus expectation of x of 4 will be 0, and my target would be expectation of y square. So what I need to do, expectation of x square 2 plus x square 4 minus 2 x of 2 x of 4, that would be equivalent to minus 2 Rx of 2 and then plus expectation of x square 2 plus expectation of x square 4, which will be equivalent to 50 plus 50 minus 2 into Rx of 2. Rx of 2 is 45, so answer would be 10. So this is the end. Okay, so this question we have solved. Well and good. Now, like every one of you would be knowing what is the meaning of continuous time, what is the meaning of discrete time. Like at least basics of signal system you have done, right? So whatever that we were studying in continuous time, till this point everywhere x of t was there, but x of n is also possible. What I mean to say is that they can introduce discrete time as well, and n will take integer values only. I hope you know it. N can take only integer value. When we come to discrete time, that means n can take integer value only. So let's just say the value could be that n equals to 0, this is the value. Then at n equals to 1, this is the value. Whatever the value it could be there. N equals to 2, this is the value. N equals to minus 1, this is the value. Or negative value is also possible. So basically value of n will be discrete now. So whatever that we were studying in continuous time, the same thing we can study in discrete time as well. So tau will be replaced with, t will be replaced with n. So we were studying in continuous time, that can be studied in discrete time as well, and t plus tau will be replaced with n plus k. So basically here I used to write down Rx of tau, that was expectation of x of t, expectation of x of tau. So here what I will write down, Rx of k, that would be expectation of x of n dot n plus k. Just simple, straightforward. Whatever that you have studied in time domain, in place of t you need to replace by n, in place of t plus tau, basically in place of tau you need to put k. That's it. What else we can see? Let's just say mean square value. Mean square value was expectation of x square t. So here what will be the mean square value? That would be expectation of x square n, expectation of x square n, right? Other things are also possible, like you can write down, let's just say correlation, or let's write down cross correlation. Cross correlation also we will see in one of the problem, don't worry. So I would write it down in this manner for WSSRP. This thing I have wrote down for WSSRP. Okay. So similarly here as well for WSSRP, what you will write down, Cx of k, that will be equivalent to Rx of k minus mu x square. This will also be WSSRP. So basically t is replaced with n and t plus tau is replaced with n plus k. So let's get started with our problem. So here in this question I am asking the same kind of problem but with respect to the discrete time. So what is given, very straightforward. At discrete time random process, x of n is 0, x of n is having 0 mean, that means mean of x of n is 0, and it is stationary, that means it is WSSRP. Okay. If stationary is written, no, we will talk about it. We will talk about stationary random process. So WSSRP is actually a part of stationary random process. That means whatever the property WSSRP will hold, stationary random process will hold all those property. So if stationary is written, that means WSSRP will also be there. So if only word stationary is written, that means you need to understand that it is WSSRP only. And surely in your examination question will come from WSSRP only. Okay. Now another random process dn is defined, which is x of n minus x of n minus 1. First you let me know if your dn is WSSRP or not. dn is WSSRP or not. What we have studied? Y of t is equals to a x of t plus b x of t minus t naught. This was your WSSRP. So similarly here, y of n, a x of n plus b x of n minus n naught. This will also be WSSRP. This was your, if xt was WSSRP, or if your x of n is WSSRP, then your y of n will also be WSSRP. Okay. So yes, d of n is WSSRP, although they did not ask it. In the examination, they did not ask it. They just defined d of n as this thing. Now what they are saying, sigma square of d of n is equals to sigma square of x of n divided by 10. This is that they have given. You need to find Rx of k divided by sigma square x at k equals to 1. This is what you need to find. So what is given? D of n. This is your d of n is equals to x of n minus x of n minus 1. They have defined sigma square dn is equals to sigma square xn divided by 10. So let's try finding the value of sigma square dn. What we need to find? We need to find the value of sigma square dn. What that would be equivalent to? Expectation of d square n minus expectation of dn. Right? Expectation of d square n minus expectation of dn whole square. Can you find out the expectation of dn? Yes. Expectation of dn will be equals to expectation of xn minus expectation of xn minus 1. Now you know that x of n is WSSRP and having 0 mean. What does that mean? That means this will also be equal. Here it will be capital, capital, capital. This will also be equal. Say yes or no? Because it is independent of time. So this is 0, this is 0, 0 minus 0 is equals to 0. So expectation of dn is 0, this is equals to 0. So what you need to find? Expectation of d square n. Expectation of d square n you need to find. So that will be equivalent to expectation of d square n. That means this square you need to do. A square plus b square, again small I am writing r. A square plus b square minus 2ab. Right? A square plus b square minus 2ab. So what you are getting? Expectation of x square n plus expectation of x square n minus 1 minus 2 expectation of x of n x of n minus 1. So what you are getting? Expectation of x square n. Did they talk anything about expectation of x square n? No. Basically expectation of x square n will be equal to sigma square x of n. No. Are you able to understand this point? What I mean to say is that sigma square x of n will be equivalent to expectation of x square n minus expectation of x of n whole square. So this value is already 0. So expectation of x square n is actually equals to sigma square x of n. And similarly expectation of d square n is actually equals to sigma square d of n plus what this will be equivalent to? This will also be sigma square x of n only, because it is, since it is WSSRP, so sigma square x of n is equivalent to sigma square x of n minus 1. Right? So this will be sigma square x of n minus 2 rx of minus 1. Right? X of n minus 1. So what it is? Rx of minus 1, which will be equals to Rx of 1 as well. So what you are getting? Sigma square dn 2 sigma square xn minus 2 Rx of 1. So sigma square dn what I need to find, eventually I need sigma square x. So I have to replace sigma square dn, which is sigma square xn divided by 10. So sigma square xn divided by 10. Whatever we used to do in time domain, if this question was based on time domain, you would be very easily able to solve it because t would be there. So if you feel like that, sir, I am uncomfortable with n, so replace n with t. That's it. What I am saying, if you feel like that, sir, I am uncomfortable with n, then replace n with t and solve the problem. You will get your correct answer. And replace k with tau. Are you able to understand this point? Okay. Basically, nothing is happened. T is replaced with n. Nothing else has happened. So 2 sigma square x of n minus 2 rx of 1. So what you will be getting here? So 2 rx of 1, 2 minus 1 by 10, that would be 1.9 sigma square x of n. So what is the answer you are getting? Rx of 1 divided by sigma square x of n, that is equivalent to 1.9 divided by 2, that is 0.95. What was asked? They asked Rx of k divided by sigma square x at k equals to 1. Why they are writing sigma square x? Because they know that it will be a constant value, no? Sigma square x will be a constant value, it will not be a function of n, because it is WSSRP. Since it is WSSRP, so it will be a constant value only, no? Right? At k equals to 1. At k equals to 1. So what it is coming out to be? 1.9 divided by 2, that is 0.95. Okay, very simple, very straightforward. So yeah, another question we have solved. It was very simple only, just we are introducing discrete time this time. From continuous time we are moving towards discrete time, right? Next we will understand the meaning of independent and identically distributed random process. So similar thing, IID-RV, what we have studied, IID-RV. So there what I told you, all the random variables are looking similar. They are having same mean, they are having same statistical parameter, they are ditto same. A, B, C, all are uniformly distributed between 0 to 2, but they are independent of each other, right? So this particular thing, IID-RP, this is defined for random variable only. So what I will do, I will sample my x of t at t equals to t1, I will sample it at t equals to t2, I will sample it at t equals to t3. What I will get? I will get these random variables. From x of t, I have got 3 random variables. What I have got? From x of t, I have got 3 random variables, which are x of t1, x of t2, x of 3t. Now, if they are IID-RV, if they are identical and independently distributed, then you will say that your x of t is IID-RP. Then you will say that your x of t is independent and identically distributed random process. So actually, if they are saying that your random process is IID, if your random process is IID, that means from this particular random process, whatever the random variables that you are getting, they are IID. Are you able to understand this point? If I say my random process is IID, that means from my random process, whatever the random variables that I am getting, they are IID-RV. That is the meaning of IID random process. All good? All fine? Similar thing you can do with discrete time as well. That means you can sample it at n equals to n1, you can sample it at n equals to n2, and you can sample it at n equals to n3. What you will get? You will get x of n1, x of n2, x of n3. This is your IID-RV. So that means, it means that your x of n will be IID-RP. So if I am saying that my random process is independent and identically distributed, that means if I calculate the sample at n equals to n1 or n2 or n3 or n4, so whatever the sample I calculate, what I will get? Random variables. These random variables are identically and independently distributed. So whenever I say random process is IID, that means my random variables are IID. Okay, let's solve the question. So this is also a very good question. Yeah, so you read it. An independent and identically distributed random process x of n, where n is going from minus infinity to infinity, takes only two values, minus 1 and 1, with equal probabilities. You need to find the mean, variance, mean square value and everything. So I will take a break because it's been roughly around 80 minutes. I am speaking continuously. So I will take a break. If you want to try it, you can try it. You can understand like what will be the mean square value. I guess you will be able to understand. Also, you will be able to understand that whether it is WSSRP or not. Okay. So yeah, try doing it, and then I guess at least A you will be able to solve. This you will be able to solve. This also you can try. Okay. So yeah, let's meet. Let me take a break and then I will come back. Yeah, welcome back, guys. So did you try this question? So IID-RP is given x of n. So this is a discrete time random process, right? So x of n can take only two values, -1 and +1. What they are saying is that x of n can take only two values. Usually we used to write down x of n like this, but now they are writing it down something like this. Okay, so don't get confused. This is how they are writing down x of n. So x of bracket n is equals to x of n only. So it can take only two values, -1 and 1, and both are having the same probabilities. That means probability of this is 1 by 2 and probability of this also is 1 by 2. This is what they are saying. Okay. And there is one notation given that x of n going from -infinity to +infinity. What does that mean? That means when you make the graph of x of n, then all the values are possible. All the values of n are possible. It is defined for all the values of n. I am making the graph of x of n versus n. So it is defined for all the values of n. That means it is defined for n equals to 0 as well, n equals to 1 as well, n equals to 2 as well, n equals to 3 as well, -1 as well, -2 as well, till -infinity. Okay. And it can take only two values, either 1 or -1. Now I don't know whether it will take value 1 here or it will take value -1. Randomly it can take any value. It can take value 1 here. Here also it is taking value 1. Here it may take value -1. Here it may take value 1. Here it may take value -1. Here it may take value again -1. So it can take any kind of value, but only two kinds of values it will take, 1 or -1. It will not take 0, it will not take +2, it will not take +3, it will only take 1 and -1. And n is defined from -infinity to infinity. That means at all the values of n it will be defined, 1 or -1. Well and good. Now what we need to find? We need to find the mean. So very simple. What is the mean? So discrete values are there. If it is taking the value -1, what is the probability? 1 by 2. In random variable we have seen it. Taking value -1, probability is 1 by 2. Taking value 1, probability is 1 by 2. What is the answer? 0. Second, mean square value. What is your mean square value? Expectation of x square n. This was your expectation of xn. So expectation of x square n. That means x square can take how much value? Basically, if x is taking value -1, then x square will take -1 square. What I mean to say is that if x of n is taking value -1, then x square will take value -1 square with the probability of 1 by 2. 1 square with the probability of 1 by 2. So what is the answer? 1. So x square will take only, x of n is taking -1 and 1. So x of n square will take how much value? -1 square will be 1 only, and 1 square will also be 1 only. So x of n square will take value 1 only, no? Right? Are you able to understand this point? So -1 square into 1 by 2 plus 1 square into 1 by 2, answer is 1. Mean square value. What is next? Variance. So what that would be? Expectation of x square n minus expectation of xn whole square. So what that would be? 1 minus 0, that would be 1. Next, autocorrelation function. So what do we do? Expectation of x of n into x of n plus k. Now this will be interesting. Expectation of x of n dot x of n plus k. So what you will do? You know that x of n is IID-RP. What do you know? X of n is IID-RP. That means here there is a word called independent, right? Independent. Also there is a word called identical. They did not say it is WSSRP. What I am saying, they did not say it is WSSRP. You know that independent and identical. This you know, right? Since they are independent, what you can write down? This thing you can write down. Since they are independent. This I wrote down because they are independent. Now I will write it down this as expectation of x of n dot expectation of x of n. How I can write it down? Because they are identical. Basically this thing and this thing. What I mean to say is that if you are sampling your x of n, if you are sampling your x of n at n equals to n, then you are getting x of n. And if you are sampling your x of n at n equals to n plus k, then you will get x of n plus k. Both these samples or both these random variables are identical. So if they are identical, that means their mean will also be same, no? I am not saying this property I am not writing down because they are WSSRP. I am not even telling they are WSSRP. Nowhere in the question they are saying that it is WSSRP. They only said that they are identical. Since they are identical, that means their mean will also be identical. So this is how I can write it down. What is the mean of this one? 0. What is the mean of this one? 0. So what is the answer? 0. So as per you, your autocorrelation function is coming out to be 0. And this answer is wrong. Wrong. Why it is wrong? So always whenever this condition is given, no, IID RP, okay, always you need to take care of one thing, that you will solve it for two cases, k not equals to 0, k equals to 0. What I mean to say is that, what is your autocorrelation function? Autocorrelation function is x of n plus k. So you will solve it for two cases, k equals to 0 and k not equals to 0. When k is equals to 0, if you put k equals to 0 here, what you are getting? Expectation of x of n dot expectation of x of n. Sorry, expectation of x of n dot x of n. X of n dot x of n. What it will become? X of n square. And when k is not equals to 0, so what you will do? You will apply the property of independence. Independence. Along with that, you can apply the property of identical as well. So I am applying the property of independence. So what I will get? This is what I will get. Okay, and when I apply the property of identical, this is what I will get. This when I apply the property of identical. So whenever my x of n or even x of t, it is given that it is IID RP. So my answer of Rx of k, will look something like this. My autocorrelation function will look something like this. Expectation of xn square for k equals to 0 and expectation of xn whole square for k not equals to 0. Expectation of xn square for k equals to 0, expectation of xn whole square for k not equals to 0. This is something you don't need to remember, but this is something you need to take care for the case of IID RP. Here they did not give it is WSSRP, they give IID RP. If it is IID RP, then I know that I can break it down. I can break it down like this. But when I am breaking it down, I forgot the condition that what if k is equals to 0? If k is equals to 0, this will become x square n. And if it is becoming x square n, the value of e x square n is 1, not 0. So completely if you are putting 0, that is wrong. So expectation of x of n is 0. Basically this will come out to be 0, no doubt about that. But this will come out to be 1. Are you able to understand this point? So this will be your Rx of k. At k equals to 0, it is coming out to be 1, otherwise it is coming out to be 0. So you don't need to mug it up, but it should be there in your mind that I will solve for two different cases, k equals to 0, k not equals to 0. This is not the case of WSSRP, they have given it is IID RP. Now you got to know that my autocorrelation function, how can you write it down? X of n is equals to 1 when n is equals to 0, otherwise it is 0. That is your delta of n, right? This is your delta of n, no? Impulse sequence. So this is nothing but an impulse sequence only, right? So this is nothing but impulse sequence. So this is your Rx of k. This is your Rx of k. So from here, what do you understand? If this is your Rx of k, which is equals to delta of k, that means it is only a function of a time difference. Only a function of a time difference. Also, your mean was constant. Mean was constant and this is a function of time difference. That means yes, this is WSSRP. So although in the beginning of the problem, In the beginning of the problem, WSSRP was not given. So I cannot use any property of WSSRP. Then I solved it. IIDRP was given. If IIDRP is given, I need to take two cases, k equals to 0, k not equals to 0. When k is equals to 0, it will become equals to the mean square value. When it is not equals to 0, they will be multiplied. That means it will become mean square of mean. It will become square of the mean, right? So what is the value of mean? 0. 0 square will be 0 only. So this is your Rx of k is coming out to be delta k. That means it is only the function of k. That means it is WSSRP. So Rx of k is actually coming out to be delta of k. So can you draw the graph of Rx of k? Yes. I can draw the graph of Rx of k versus k. That is delta of k. Is it even? Rx of k is equals to Rx of minus k. Basically, whatever the property that we wrote, is it following that? Yes. Rx of 0 is greater than or equals to Rx of k. Yes, this is the peak point. And Rx of 0 should show the mean square value. What is the value of Rx of 0? That is 1. Is it showing the mean square value? Yes, it is showing the mean square value as well. So yeah, everything is followed. Okay. So this was a very good point of this particular question. If you said that autocorrelation function is 0, that is wrong. Now what about the covariance? So covariance will be the same only, right? Why it will be the same? Covariance you need to find. Covariance, variance. So how will I find covariance? Covariance is this. Right? And you know that this value is 0. This value is also 0. So what is the answer you are getting? Covariance is actually your Cx of k, that is coming out to be. Covariance is your Cx of k, that is coming out to be equals to Rx of k only. This is the answer. Right? अरे भाई क्या सीन है? Let me turn off the net. Yeah. Now you need to find mean, variance, mean square value, autocorrelation function and covariance of x of n plus alpha. So all the statistical parameter will be the same only, no? Since x of n is WSSRP, then statistical parameter of statistical parameters of x of n, that will be equivalent to statistical parameter of x of n plus k, x of n plus alpha. Say yes or no. Are you able to understand this point? If I ask you the mean, it would be the same. If I ask you the mean square value, it would be the same. If I ask you the variance, it would be the same. If I ask you autocorrelation function, everything would be the same. Right? All good? All fine? Third, expectation of x of 7, x of 3, x of 7 square. Okay. First one, x of 7, x of 3. That would be equivalent to Rx of 3 minus 7. Right? Difference 3 minus 7. In time domain, what we used to do? T plus tau. So t plus tau minus t. So here 3 minus 7. That would be Rx of minus 4. This is the graph of Rx of k versus k. So what is the value at minus 4? What is the value at minus 4? That is equivalent to 0. Right? Expectation of x7 square, which is equivalent to mean square value, which is equivalent to 1. Right? X7 square is mean square value only, which is equivalent to 1, because it is WSSRP. Right? Since it is WSSRP, so this 7 doesn't matter. Next, n plus 3 n minus 6. N plus 3 n minus 6. So Rx of n minus 6 minus n minus 3. Rx of minus 9. What is the value of Rx of minus 9? That is also 0 only. So only Rx of 0 is non-zero. All other things are 0 only, right? Okay. Now another random process y of n is defined as 3x of n plus 2x of n minus 1 and z of n as x of n minus 2x n minus 2. You need to find the statistical parameter, you need to find cross correlation as well, and then you need to find this value. So let's get started. What we need to do, y of n and z of n, let me know whether they will be WSSRP or not. They will surely be WSSRP. This will surely be WSSRP. Why is that so? Do you remember one thing? Y of n, a x of n plus b x of n minus n naught. If x of n is WSSRP, then y of n will also be WSSRP. So in the examination, if they are asking that if they are WSSRP, then directly you will say yes, they are WSSRP. But now question is something else. We need to find the statistical parameter. So y of n is 3, 2, 1, minus 2. Okay. Surely I will have to add pages. So let's find the mean. First one is mean of yn. So that would be 3 into mean of xn 0 plus 2 into mean of x of n minus 1. Mean of xn will be equals to mean of xn will be equals to mean of x of n minus 1. It will be equals to mean of x of n minus 2 as well, and that is equals to 0, right? So what is the answer? 0. Here mean of xn 0 minus 2 into mean of xn 0. Second, mean square value. Or let's find the autocorrelation function. From there only we can find the mean square value. So let's find the autocorrelation function. So for autocorrelation function, I will do it in the next line only. Since I know that they will be WSSRP, already I know, so I can write it down as Ry of k directly, because I know that it will be a function of k only, right? Expectation of y of n into y of n plus k. This is what I need to do, right? So expectation of what is y of n? Y of n is 3x of n plus 2x of n minus 1 into 3x of n plus k plus 2x of n plus k minus 1. So what is the answer you are getting? 9x of n dot x of n plus k plus 6x of n x of n plus k minus 1. 6x of n minus 1 x of n plus k plus 4x of n minus 1. Just take care of the notation, and if you feel like that, sir, I am uncomfortable with the discrete time, you should not be uncomfortable. Then what you can do, replace n with t and k with tau. Very simple, right? But you should not be uncomfortable. No, x of n plus k 9, 6, then again 6, and then again 4, right? 9 rx of k plus 6 rx of k minus 1 plus 6 rx of k plus 1 plus 4 rx of k, right? So just checking the calculation, there should not be any error in the calculation. Are you able to understand what I am doing? Expectation goes inside 9 into rx of n plus k minus n. What you will get? K only. N plus k minus 1 minus n. What you will get? K minus 1. N plus k minus n plus 1. What you will get? K plus 1. And n plus k minus 1 and n plus k minus 1 minus n plus 1. So what you will get? Rx of k, right? So 13 Rx of k plus 6 Rx of k minus 1 plus 6 Rx of k plus 1. This is the answer we are getting, right? What is your Rx of k? Rx of k is delta k, right? Rx of k is delta k. This we have proved here. Rx of k was delta k. So here I can write down 13 delta k plus 6 delta k minus 1 plus 6 delta k plus 1. So what do you see? Ry of k is this. Can you draw the graph of Ry of k? Surely I can draw the graph of Ry of k as well. What I will do, I will simply copy this graph So what I am doing, I am making the graph of ry of k. So what that would be, at 0 the value will be 13, then value is 6 and then minus 1. Sorry, here also 6 and here also 6. And surely it should be same only. Why is that so? Because we know that this is y of n is at WSSRP, and since it is WSSRP, then ry of k should be equivalent to ry of minus k. So it was pretty obvious that it will come symmetric only. So this is the answer. Now if someone asks you what is the mean square value, so mean square value you can directly tell here. Mean square value is 13. In the examination, most probably they will ask you autocorrelation function only, right? If they ask you mean square value, then you don't need to put a k here. You will directly do y square n. So you will write down 9x square n, and x square n value I already know, that is 1, and you will put 4x square n minus 1, right? So 9 plus 4, that would be 13 only. So very easily you will be able to get it. Otherwise you can find out the autocorrelation function and then you can tell the mean square value. Now what about the variance? So variance is equals to mean square value only, that will be 13. Why so? Because your mean is 0, right? Your mean is 0. Since the mean is 0, so variance and mean square value will be the same. Next, what I can find? Cx of k, sorry, cy of k, cy of k. So what will be your cy of k? So cy of k will be equals to ry of k minus square of the mean. Since this is 0 only, so what is the answer you are getting? Cy of k is equivalent to ry of k. Okay. So this is the first question we have solved. We have got everything about random process y of n. Now the similar thing we need to do for z of n as well. Mean we have already find out. What we need to find out? Now we need to find out the autocorrelation function. So what we need to find out? Rz of k. So next we need to find out Rz of k. So what will be your Rz of k? That would be expectation of z of n into z of n plus k, right? First sample at n, second sample at n plus k. So what you will be getting? Expectation of z of n multiplied with z of n plus k. So x of n minus 2 x of n minus 2, x of n minus 2 x of n minus 2. X of n plus k minus 2 x of n plus k minus 2. So expectation of x of n plus k minus 2 x of n plus k minus 2 minus 2 x of n minus 2 x of n plus k plus 4 x of n minus 2 x of n plus k minus 2, right? Let me check the calculation. N plus k, n plus k minus 2, n minus 2, n plus k, n minus 2, n plus k minus 2. Notation looks difficult, but things are pretty easy. What this would be equivalent to? Rx of k minus 2. What this will be equivalent to? Rx of k minus 2 minus 2. What this will be equivalent to? Rx of k plus 2 plus 4. What this will be equivalent to? Rx of k. Say yes or no, right? Well and good. So what is the answer you are getting? 5 Rx of k minus 2 Rx of k minus 2 minus 2 Rx of k plus 2. Can you draw the graph? Surely you can draw the graph as well, right? And you can directly see here Rx of k is delta k. So what is your Rz of k? So eventually your Rz of k is coming out to be 5 delta k minus 2 delta k minus 2 minus 2 delta k plus 2. This is your Rz of k. What you can do? You can draw the graph in the same manner. I will copy the same graph on the next page, and then I would see that mean square value is 5, right? Mean square value is 5. Rest are minus 2, minus 2, minus 2, minus 2. Okay, minus 2, minus 2. So mean square value is 5. Variance will also be 5. And mean is 0. And since mean is 0, then you know that your cross autocorrelation autocovariance will be equals to your autocorrelation function. All these things we can tell very easily. We can tell all these things. What else they are asking us to calculate? Also find cross correlation function. That means RYZ RZY we need to find. RYZ RZY we need to find. Okay, so cross correlation function we need to find. Now you know that y of n is WSSRP. Here we will see something that we have already revised. Y of n is WSSRP. Z of n is also WSSRP. So let me know their cross correlation. Their cross correlation function will be a function of what? It will be a function of k. This we have proved in the last lecture. How did we prove it? What did we prove? That yt is WSSRP and xt is WSSRP. So if you calculate their cross correlation, or if you calculate ryx of t plus tau, it was coming out to be a function of tau only. So their cross correlation function will be a function of k only. So here what I will do, what I need to calculate, I am calculating the cross correlation of y with z. So here directly I can write down k, because I know that it will be a function of k only, and you can see it here. Surely it will come out to be a function of k. So what this will be equivalent to? That first sample you are calculating at n only, but sample of z you are calculating at n plus k. Y of n. What is y of n? Y of n is 3x of n plus 2x of n minus 1. 3x of n plus 2x of n minus 1. And what is z of n? Z of n is x of n plus k minus 2x of n plus k, x of n plus k minus 2 x of n plus k minus 2, right? So what is the answer you will get? 3x of n x of n plus k minus 6 x of n x of n plus k minus 2 plus 2 x of n minus 1 x of n plus k minus 4 x of n minus 1 x of n plus k minus 2. So what is the answer you are getting? 3 rx of k, right? This is rx of k minus 6 rx of k minus 2 plus 2 rx of k plus 1 and minus 4 rx of k minus 1. Right? We did it all correct? Say yes or no. Let me check the calculation again. Just there is a issue could be of calculation only. N plus k x of n plus k minus 2 minus 6 plus 2 n minus 1 x of n plus k minus 4 x of n minus 1. Yeah. So what is the difference here? K minus 1, 4 k minus 1, here k plus 1, 2 k plus 1, then 6 k minus 2 and k. So in these kind of problems you should always check. I would say you should always check in the examination as well. Whenever you are doing, I know that this is a big calculation, so I will always check, right? So what we are getting? Ryz of k, and you can see that it is purely coming out to be a function of k. There is no term of n, so n is purely gone. So that we have already proved in the last lecture, that their cross correlation will be a function of k only. So another page we need to add, and we will get to know that our answer for Ryz of k, Ryz of k is coming out to be 3. What is Rx of k? Rx of k is delta k. 3 delta k minus 6 delta k minus 2. Now here there is no property applied that it should be even, it should be odd. This is not WSSRP, nothing like that. Only conclusion was that their cross correlation will be a function of k. That's it. F of k will be equals to f of minus k. I never said that. Only thing I said that their cross correlation will be a function of k, and you can directly see that yes, it is coming out to be a function of k, right? Plus 2 delta of k plus 1 minus 4 delta of k minus 1. Now what if they ask you to find out r z y of k? Will you do the calculation again? No. You know that r z y of k will be equals to r y z of minus k. That means 3 delta of minus k minus 6 delta of minus k minus 2 plus 2 delta of minus k minus 1 minus 4 delta of minus k minus 1. So delta has the ability of eating up the negative sign. So your r z y k will come out to be 3 delta k minus 6 delta k plus 2 plus 2 delta k plus 1 minus 4 delta k plus 1. So these are the answers. Okay, you can draw the graph on your own, right? I hope calculation is correct. It would be correct only since we have spent and there you go. Minus k plus 1 it was, no? Plus 2 minus k plus 1. So it would be k minus 1. This would be k minus 1. Basically, you need to invert this graph. Whatever the graph you get here, r, y, z of k, just you need to invert the graph, nothing else. R, y, z of k. Okay, so just invert the graph, nothing else. Yeah. So r, y, z of k, r, z, y of k is also, we have find out. What else we need to find out? This was a big question. It took more than half an hour. More than half an hour it is taking. Now, y of 3 into z of 5. Y of 3 into z of 5. This is what we need to find. Yeah, easily I can do it. Y of 3 into z of 5. So already I have some result, right? What they want me to find? Y of 3 into z of 5. Now, if this question is coming in the examination, only this question is coming. So what I would do? I will find out the y of 3 value from here. From this expression, I will find out the y of 3. I will find out z of 5. I will multiply both of them and I will get my answer. But now what I have done? I have calculated the cross correlation. No? I have calculated the cross correlation. So this is something that I need to find. But I can see that I can relate it with something. That my r y z of k is expectation of y of k. Sorry. Expectation of y of n into z of n plus k. So here if I put n equals to 3 and k equals to 2, my job will be done. So basically this particular thing, expectation of y of 3 z of 5 is coming out to be r y z of 2. In place of k you put 2. Your job is done. So in place of k I need to put 2. So 3 delta 2 minus 6 delta 2 minus 2 plus 2 delta 2 plus 1, that would be 3, minus 4 delta 2 minus 1, that would be 1, right? So I just need to put 2 here, 2 here, 2 here, 2 here. What is the answer? Delta 1 is 0. Basically you know what is delta k, no? Delta k is 1 when your k is equals to 0, otherwise it is 0. So here also 0, here also 0, 2 minus 2 is 0, this is also 0. So what is the answer? Minus 6. This would be the answer of expectation of y of 3 z of 5. Answer is minus 6. This is the answer. If this question was coming in the examination, I would have done y of 3 z of 5. I would find y of 3 z of 5 and then I multiply both of them. Okay, it would be very easy to find. Answer would come out to be minus 6 only, right? So this will be the answer, that is minus 6. So this was a, you can feel like that it took us roughly around 35 minutes, but actually it was very easy. Nothing was there. Only important thing was, whenever IID-RP is given, whenever identically and independently distributed random process is given, so you should take care of autocorrelation function. Directly you cannot say that this is 0, then it will be wrong. What you need to do, for k equals to 0 and for k not equals to 0, different cases would be there, and this is what will be the final conclusion. For k equals to 0, you will write down the mean square value, and for k not equals to 0, you will write down the square of mean, and this will be your answer. All good? All fine? Yeah. Let's move to the next problem. So yeah, just we are doing a quick revision of a cross correlation. So what is your Rxy of tau? That is expectation of x of t, y of t plus 2, right? Considering that xt and yt are WSSRP, then only their cross correlation function will be a function of tau. Otherwise, it can be a function of t and tau as well, right? But if they are WSSRP, then their cross correlation will also be a function of tau. What will be your Ryx of tau? Expectation of y of tau, sorry, y of t. First one goes with t, second one goes with t plus tau, right? And what will be Rxy of minus tau? That means first one goes with t plus tau and second one goes with t. So y of t into x of t plus tau, that would be equivalent to Ryx of tau. So Ryx of tau is equivalent to Rxy of minus tau. Rxy of tau is equivalent to Ryx of minus tau. And Ryx of tau will be equal to Rxy of minus tau. So this we have already seen that if I am inverting here, then another negative sign I need to use. If I am inverting here, another negative sign I need to use. Now another property is there, one more important property is there. Okay. So what do we know? What do we know? That Rx of 0 is greater than or equals to Rx of tau. Say yes or no. Similar kind of property is there for cross correlation as well. What I am saying, similar kind of property is there for cross correlation as well. So there what you will write down, greater than equals to sign is there. I am just telling you to how you will remember it. Greater than equals to sign is there. We are not going to prove it. Here the property is already written. In this slide, property is already written, but I am not going to show it. I am telling how will you remember it. So here what you are writing down, Rx of tau, because here only one random process is there. You are only talking about xt. Now I am talking about cross correlation. That means I am talking about x as well, I am talking about y as well. So I will write down Rxy of tau. Now what we are talking about? We are talking about x as well, we are talking about y as well. So what I can write down here? I need x, I need y as well. So this is mean square, this is mean square. Now it has become square of mean square. Here it was only mean square value. Here it has become square of mean square, so I need to put under root as well. So this is the property. This is one of the property. That under root of, from here only I derived it. Not derived it, from here only I can write it down. What we already know for x of t, if x of t is WSSRP, then their cross correlation, sorry, then their autocorrelation function at tau equals to 0 will be giving the highest value. Right? Now what about the cross correlation? What about cross correlation? Then you would get to know that highest value will be if you calculate Rx of 0 and then you calculate Ry of 0 and then you take their under root, that would be the highest value. Let's try checking it with the previous example. What I mean to say is that I have calculated Ryz of k. So what I need to do? I need to check the mean square value of Ry of k, that is 5, and mean square value of Rz of k. Mean square value of Rz of k. This is the graph of Rz of k only. This is the graph of Rz of k. So mean square value of Rz of k, basically what is the value of Rz of 0? That is 5. What is the value of Ry of 0? That is 13. Okay. So what I mean to say is that under root multiply with should be greater than or equals to R zy of k magnitude. So 13 into 5 under root 65. It is roughly around 8 point something. So in the expression of Rzy of k, in the expression of Rzy of k, are you getting magnitude over 8? Are you getting any magnitude which is greater than 8? No. 3 minus 6, 2 minus 4. 3 minus 6, 2 minus 4. So nothing is greater than 8. Are you able to understand this point or not? Okay. So in the examination, how they can ask these kind of problems is that they will write down that x of what they will write down, that x of n is WSSRP. With respect to that, you are defining y of n and z of n. They will give the expression. Then which of the statement is true? Right? In the first statement, what they will write down? Rxy of tau is equals to Rxy of minus tau. Similarly, for discrete time as well, you can define it. Rxy of k will be equivalent to Ryx of minus k. Similarly, here Ryx of k will be equivalent to Rxy of minus k. right? And then this is the property. This is one of the other property. So let me erase it from here. So how will you remember? From this particular property only I can remember it. Here I am talking about cross correlation. I am talking about cross correlation between x and y. If I am talking about cross correlation, that means I will need the mean square value of x as well. I will need the mean square value of y as well. I will multiply both of them and then I will take the under root. Do you remember another thing? In mathematics, arithmetic mean is always greater than or equal to geometric mean. Isn't it like the arithmetic mean? So what will be their geometric mean? Their geometric mean will be Rx of 0 plus Ry of 0 divided by 2. So AM will always be greater than GM. So basically in textbook or in a lot of notes as well, you will just see that this particular line is written. This particular line is written. This line is written. Rx of 0 plus Ry of 0 divided by 2 is greater than equals to under root Rx of 0 dot Ry of 0 is greater than equals to mod of Rxy of 2. And this is equivalent to mod of Ryx of minus 2 as well. Say yes or no? Because Rxy of minus 2 is equals to Rxy of 2, Rxy of 2 is equals to Ryx of minus 2. So basically this is how I can relate it. Okay. All good, all fine. So how will you remember the property? Will you be able to remember this property? So only fear is that there will not be any question from this property, but they can write it down in the option and they will ask you whether this is true or not. So it is true. So how can you remember that for x of t, what we used to write down? That Rx of 0 is greater than equals to mod of Rx of 2. So here what is the scenario? Here it is cross correlation. That means I would need Rx of 0 as well. I would need Ry of 0 as well. I will multiply both of them and take the under root. And another thing is AM is greater than equals to GM. So because of this, this is your arithmetic mean, this is your geometric mean. So AM is greater than GM and that is greater than Rxy of 2. So it should be there in your mind. Okay, it should be there in your mind. Well and good. Okay. Now next question. X of t and y of t are WSSRP. Wt is defined as a x of t plus b y of t. Z of t is defined as a x of t minus b y of t. You need to find the autocorrelation function of Wt, autocorrelation function of Zt. Then xt and yt are orthogonal. Then what will be the autocorrelation function? And then you need to find the cross correlation function. So from here we will make one interesting conclusion as well. So what we need to find? We need to find the autocorrelation function of Wt. Can you say Wt will be WSSRP? Can I say this will be WSSRP? Directly I cannot say, right? As of now I cannot say. What is the property that I told you? The property was, what was the property? Property was y of t axt plus b x t minus t naught. So this was also xt, this was also xt only. But from here you will get to know that this is also WSSRP. Okay. No. This will not come out to be WSSRP. Sorry guys. Yeah. So the property was for this one, x and x. This was WSSRP. Then this was WSSRP. But now here two different random processes are there. X and Y. Two different random processes are there. So you cannot say directly Wt is WSSRP and Zt is WSSRP. Directly you cannot say, right? So let's try finding the autocorrelation function. Along with that we can find the mean as well. So let's find the mean first only, because we will prove whether they are WSSRP or not. So that will be equivalent to mean of x. Since xt is WSSRP, then it would be a mu x plus b mu y. And what will be the mean of this is Wt. And what will be the mean of Zt? A into mean of x, that is mu x minus mu y. Okay, not a function of t. Both are constant. So first condition is satisfied, but we need to care about autocorrelation function. They are constant. But our matter of concern will be autocorrelation function. So who is our matter of concern? Matter of concern is autocorrelation function of Wt. That will be equivalent to expectation of Wt dot Wt plus 2. What is Wt? Axt plus byt. dot ax t plus 2 plus b y t plus 2. Expectation of multiplication is there, no? Basically this is the multiplication. So expectation a square x of t plus 2 plus ab x of t y of t plus 2 plus ab y of t x of t plus 2 plus b square y of t plus 2. A square x of t x of 2, what it will give you? Rx of 2. Now ab expectation of xt dot y of t plus 2, what that would be equivalent to? Rxy of 2. How can you write down that it will be a function of 2 only? Why you did not think that it could be a function of t as well? Because you know that if xt and yt are WSSRP, then their cross correlation, it is nothing but a cross correlation, then their cross correlation will also be a function of 2 only. If xt is WSSRP, yt is WSSRP, then their cross correlation will also be a function of 2. It will not be a function of t. Say yes or no, right? Plus ab, what you will write it down? Here y is first, right? Y is first, r yx of 2 plus b square r y of 2. So what is the answer you are getting? A square rx of 2 plus b square ry of 2 plus ab rxy of 2 plus ab ryx of 2. This is your autocorrelation function Rw. Is it coming out to be a function of 2 only? Function of 2, function of 2, function of 2, function of 2. Yes, it is coming out to be a function of 2 only. So yes, this is a function of 2 only, and this was constant mean. What does that mean? That means yes, it is WSSRP. Okay. First I thought that it will not be WSSRP, but it is actually WSSRP only. Right? So yes, it is WSSRP, and this is even as well. What I mean to say is that Rw of minus 2. So a square Rx of minus 2 will be equals to Rx of 2 only. B square Ry of minus 2 will be equals to Ry of 2 only, plus AB Rxy of minus 2. Rxy of minus 2 will be equivalent to Ryx of 2 plus AB Ryx of minus 2 will be equivalent to Rxy of 2. So isn't it same? That means from here what you can see, and it is pretty obvious as well, because since it is WSSRP, so it should follow the property as well. So yes, it is following the property. Okay. So just nothing you need to mug up here. Here nothing you need to mug up. Okay. We are just getting the answer, and we can see the conclusion. What is the conclusion? If xt is WSSRP, yt is WSSRP, then their cross correlation will be a function of 2. And now you defined a wt that is coming out to be you defined a wt as axt plus byt, then this is the autocorrelation function you are getting. You are not remembering the answer. You are not going to remember the answer. The flow should be clear that this is how I will get the answer. But you will remember the answer for a particular condition. That condition is if xt and yt are orthogonal. So that we will see. But as of now, we are finding it out without any condition. So this was the first one, autocorrelation function of yt. Sorry, autocorrelation function of wt. Now I will find the autocorrelation function of zt. So that would be zt into z of t plus 2. That would be expectation of axt minus byt. Dot a x t plus 2 minus b y t plus 2. X of t dot x of t plus 2 minus ab x of t y of t plus 2 minus ab y of t x of t plus 2 plus b square y of t into y of t plus 2. So what is the answer you are getting? Autocorrelation function of zt is coming out to be autocorrelation. It will come out to be a function of 2 only, which we already know. So that will come out to be a square Rx of tau, and from the last, from here, what you are getting, b square Rx of tau, sorry, Ry of tau. This is b square Ry of tau. So b square Ry of tau. Then from here you are getting minus sign, minus AB Rxy of tau, minus AB Rxy of tau, minus AB Ryx of tau. Is it a function of tau? Yes. What does that mean? It is also WSSRP. Okay, so both are WSSRP. Both are WSSRP. Well and good. Now just let me know one thing. So two answers we have got. For the first question we have got the answer. I will move to the second question, but let me know the answer of one thing. What is that? That if xt and yt both are WSSRP, along with that they are orthogonal as well. Along with that they are orthogonal as well. So let me know the value of Rxy of tau. Because since they are WSSRP, then their cross correlation will also be a function of tau. So what will be their value? Right? And since they are orthogonal, what that would be equivalent to? 0. If xt and yt are orthogonal, along with that it is WSSRP as well. So y of t plus tau will be equivalent to y of t only. Are you able to understand this point or not? And they are orthogonal to each other. And since they are orthogonal, that means their cross correlation will be equivalent to 0. What is the meaning of orthogonality? Right? So similar thing is happening here. Or you can say R yx of tau. What that would be equivalent to? That will also be equivalent to 0. You agree to this point? Okay. So when xt and yt are of course WSSRP, along with that they are orthogonal as well, then their cross correlation will be equal to 0. So what does that mean? That means your, let's find out what was your Wt and Zt. What was your Wt? So let's write down Wt. Wt was axt plus byt. So your autocorrelation function Rw of tau, a square Rx of tau, a square Rx of tau plus b square Ry of tau, plus b square Ry of tau. Now these two guys will be 0. Rxy of tau, Ryx of tau will be 0. So what is the answer? This is the answer you are getting. Considering the fact that xt and yt are WSSRP plus orthogonal. Okay, if both are orthogonal, then this is the condition you are getting. Orthogonal means basically all the samples will be orthogonal. Now someone will have a doubt that, sir, you are saying that x of t and y of t are orthogonal. That means this should be equals to 0. But you are equating this equals to 0. So when I say random process are orthogonal, that means all the samples are orthogonal. That means all the random variable that you can get. Basically, if I sample x of t at t, then what I will get? I will get this random variable. Then I sample y of t at t plus 2. What I will get? I will get this random variable. So all the samples, whatever the sample you get, all will be orthogonal to each other. That means xt will be orthogonal to yt, y of t plus 1, y of t plus 2, y of t plus 3, y of t minus 1, y of t plus 0.5, y of t plus 0.6. That means xt will be orthogonal to all the samples of yt, and yt will be orthogonal to all the samples of xt. So this doubt may arise here, that, sir, how did we write it down? So what I will write it down here is that xt will be orthogonal to all the samples of yt, whether it is y of t plus 2, y of t plus 2 tau, whatever it is. And similarly, your yt will be orthogonal to, orthogonal perpendicular sign I am making, orthogonal to x of t plus tau, or whatever it is. This is the meaning of orthogonal. Okay, xt and yt, two orthogonal random process are there. That means all the random variable that you get, they will be orthogonal to each other. Okay, so if they are orthogonal to each other, then if you need to write down Rw of tau, if you need to write down the autocorrelation function, so that will be a square Rx of tau plus b square Ry of tau should be there in your mind. And secondly, this was my zt, axt minus byt. So here as well, what will be the answer you will be getting? A square Rx of tau plus minus b square. What will be minus b square? Plus, if I apply this formula only, so in place of b, what you are putting? Minus b. So what it is coming out to be? Same answer. So this is a very good conclusion that I will be using in the next lecture. Okay, next lecture somewhere this conclusion will be used. So it should be there in your mind. What is the condition? Condition is there that this is the condition that xt and yt both are surely WSRP and they are orthogonal to each other. Okay, this is the condition. If they are orthogonal to each other, then forget about the cross correlation. Okay, forget about cross correlation. So this expression you are not going to remember. This thing you are going to remember. So whatever the conclusion that we have made from here, that you are going to remember. If in the examination orthogonality is not mentioned, then this is how you will solve it. The way we have solved it. W of t plus tau. You find out W of t, you find out W of t plus tau. Multiply both of them, you will get your answer. Orthogonality is mentioned, then forget about the cross correlation. Only write down the answer. All good, all fine. Did they ask you to find anything else? They are asking you to find the cross correlation as well. It will not give any conclusion. Can you do it on your own? Can I leave it up to you? Cross correlation of yt with zt. Again, it will just be calculative, but it will not give any conclusion. This is the bottom line. There will not be any conclusion. You don't need to remember any conclusion for cross correlation. Okay, so you try doing it on your own. Leave it up to you. Homework, kind of, you can say it is homework. And please don't ask me in the group, sir, what is the answer of this one? I also don't know. Basically, some big answer would come. You can calculate it. A of xt plus b of yt, and then x of t plus tau minus b of y of t plus tau. It will not be that difficult as well. So let's do it. Okay, let's do it, because I know that if I give any homework, then again and again. Okay, limit also reached. I have to carry the page. I remember I gave a homework in digital electronics, and there till this date I get the doubt that, sir, what is the solution of this particular question? I gave one homework in network analysis as well. Till this date I always get a doubt, sir, what is the solution of this question? Although solution I always write down in the notes. Like if I give any homework, although nowadays I have stopped giving the homework, because I know that if I give the homework, again and again this doubt will keep on coming. So I have stopped giving the homework. Previously I used to give the homework and then I used to write down the answer in the notes only, but I would not make the video. But people said that we need the video as well. So let's do it. Okay. So what we need to find? We need to find the cross correlation. I know that it could be a function of t as well. It could be a function of t plus tau as well. It could be a function of purely tau as well. I don't know anything. So r, y, z, t plus tau I will write down. Not y, z, r, w, z. R, w, z, t plus tau I will write down. That will be expectation of wt z of t plus tau. What is wt? Wt is axt plus byt dot a of xt plus tau minus b y t plus tau, right? So expectation of a square x of t plus tau minus ab x of t y of t plus tau plus ab y of t x of t plus tau minus b square y of t into y of t plus tau. So here only difference is we are getting the negative sign. So a square Rx of 2 minus b square Ry of 2 minus ab Rxy of 2 plus ab Ryx of 2. This is the answer we are getting. Again, it is a function of 2 only, right? But it is of no use. And surely it will be a function of 2. Why is that so? Why is that so? Why do you think before even doing the calculation I can tell that it will be a function of 2 only? Because I know that my Wt is WSSRP and my Zt is also WSSRP. This was also WSSRP and this was also WSSRP. Then their cross correlation function will be a function of 2 only. So yes, it should be a function of 2 and it is coming out to be a function of 2 only. And if they are orthogonal, then if xt and yt are orthogonal, then these will be gone. So what will be the answer? A square Rx of 2 minus b square Ry of 2. You don't need to mug it up. Okay. Just for the sake of calculation, I asked you to calculate this, nothing else. Let's go to the next slide. So this particular topic, a lot of questions we have seen, right? Everything we were seeing problems and problems. We were solving problems and problems, right? So in 2.5 hours, we have solved a lot of questions. Now we will see the next concept. The next concept says, what is the meaning of strict sense stationary random process? So actually WSSRP is a type of strict sense stationary random process. What I mean to say is that these two conditions are already there in WSSRP. No. Let me make a graph. No, let me make a Venn diagram. With the Venn diagram, you will be able to understand. This box is for random process. Okay, this complete box is for random process. This is showing strict sense stationary random process. This is showing ergodic random process. The middle one will be WSSRP. That means even if SSRP, triple SRP is mentioned, then also you will say that it is WSSRP. Even if ergodic is mentioned, then also you will say that it is WSSRP. So both ergodic as well and triple SRP will follow all the properties of WSSRP. You can see that mean is constant and your autocorrelation function is a function of 2. Along with that, there is another property in triple SRP and there was another property in ergodic random process as well. What was that property? The time average will be equals to statistical average and the time average correlation will be equals to the statistical autocorrelation. So this was the different property, right? Here also there is a different property. What is that different property? That we will see. So the different property says that joint PDF does not change when all times are shifted equally. What is the meaning? X of t, random process. This x of t is also random process. What I will do? I will sample it at t equals to t1. I will sample it at t equals to t2. What I am getting? X of t1. What I am getting? X of t2. What is this? Random variable. What is this? This is also random variable, right? What I am doing is that I am calling this random variable as y and I am calling this random variable as z. Okay, let's see. Now what I am doing? I am sampling this as t1 plus h. I am sampling xt now at t1 plus h, and now I am sampling this as t2 plus h. So what I will get? X of t1 plus h. What I will get? X of t2 plus h. What is this? This is also random variable and this is also random variable. I am calling this random variable as w and I am calling this random variable as v. So joint PDF of these two guys will be equals to joint PDF of these two guys. This is what this property says. That's it. So I sampled at a particular time. And then I took their joint PDF. Because I am getting two random variables, I can take their joint PDF. Then what I did, I am sampling after, basically this was my waveform. So I sampled first at T1 and then T2. I got two random variable, I took their PDF. Okay, I took their joint PDF. Now what I did, after some time, that means at T1 plus H, and after some time of this, that means at T2 plus H. So after the same time from T1, I did the same thing after the same time from T2 as well. Are you able to understand this point? T1 plus H, T2 plus H. So I sampled at T1 plus H and T2 plus H, T2 plus H as well. What I got? I got two random variables again, and then I calculated their joint PDF. Both of the joint PDFs were equal. That's it. Okay, well and good. So this is the property of strict sense stationary random process. Nowhere it will be used. Nowhere it will be used. It can be asked in one of the option that which of the property strict sense stationary random process follows. So one property, two property, three property, all three properties are correct. So that's why for the sake of options, I am telling you this particular property. Okay, nowhere it will be used. Nowhere it will be used. Now let's study about Gaussian random process. So what is the meaning of Gaussian random process? So x of t was a random process. What I did, I sampled at t equals to t1, sampled at t equals to t2, and sampled at t equals to t3. What I got? X of t1, x of t2, and x of t3. What they are? Random variables. If they are Gaussian random variables, if they are Gaussian random variables, then your x of t is known as Gaussian random process. Very simple thing, right? Gaussian random process. That means you are sampling your x of t at t equals to t1, t2, t3. What you are getting? Random variables you are getting. If these random variables are Gaussian, then x of t is known as Gaussian random process. Very simple thing, right? Now, why, sir? Why separately you are teaching Gaussian random process? Because in 99% of the cases, this only will come into action. In digital communication, noise will be given. We will study about the noise in the next lecture. So, noise will be given. That noise will be Gaussian. Now, if any random process is Gaussian, we can take some advantage. What all are those advantage? The advantage is that if your x of t is Gaussian plus WSSRP, then x of t will be SSSRP as well. Basically, I was having some x of t which was only WSSRP, which was only following these properties. So it is not necessary that it will be SSRP as well, right? It is not necessary that it will be SSSRP as well. But another information was given that your random process is Gaussian as well. So Gaussian plus WSSRP, that means surely it will be SSSRP as well. Is that clear to you or not? Okay. Another property we can use. So generally you know that uncorrelation is not equals to independence. Say yes or no. What is uncorrelation? This is your uncorrelation. And what is independence? Again and again I have wrote it down like 4 to 5 times I have wrote it down. This is your independence. So both are not equal. We have done this discussion in random variables a lot of time. They are not equal generally. But if your xt is Gaussian, then uncorrelation will be equals to independence. That means in the examination, if they give that my random process is Gaussian and my random process is uncorrelated as well, that means successive samples are uncorrelated as well. That means they will be independent as well. So 2 points we need to remember. Process is Gaussian plus WSSRP. Gaussian plus WSSRP, then surely it will be SSRP as well. And generally our uncorrelation doesn't mean independence. If your random process is uncorrelated, that doesn't mean it will be independent as well. Their samples will be independent as well. It is not necessary. But if your random process is uncorrelated, along with that it is Gaussian as well. Uncorrelated, along with that it is Gaussian as well. Then 101% they will be independent as well. Their samples will be independent as well. These two properties can you keep in mind for Gaussian random process? Surely you can keep in mind. Two properties you can keep in mind. Say yes or no. Not tough, right? They will be used in the next lecture. in white noise. Okay, we will study about PSD, then we will study about white noise. So there it will be used. Now one important discussion we are going to do. What we are going to do? We are going to multiply our x of t with a cos omega t plus theta. What you will get? This is a multiplier. What this is? This is a multiplier. What you will get? Y of t. You need to tell whether y of t will be WSSRP or not. What you need to tell? Y of t will be WSSRP or not. Don't take stress of a SSSRP. Okay, it will not be asked. WSSRP only will be asked. So you will never have to calculate any joint PDF or anything like that. No, all these things will not be asked. WSSRP will be asked, and for WSSRP you know what is the process. And then we study about Gaussian random process. Now what we are doing? We are studying something else. That xt is WSSRP. It is already given. Now it is being multiplied with a cos omega t plus theta. You will get some yt. You need to comment on the nature of yt, whether your yt is WSSRP or not. Okay, considering that a, theta and xt all are mutually independent. Case 1, this is the case 1. When pt is deterministic signal, that means a is constant, omega is constant, theta is constant. In the case 2, a is uniformly distributed between 0 to 2, theta and omega are constant. Case 3, a and omega are constant, but theta is uniformly distributed between 0 to 2 pi. Case 4, a is uniformly distributed between 0 to 2 and theta is uniformly distributed between 0 to 2 pi and omega is constant. So for all these 4 cases, you let me know for which of the case yt will be WSSRP. And if it is WSSRP, find out its autocorrelation function, along with that find out its mean as well. So this is the job you need to do. Very simply, in a very simple manner you can do it. Okay, so let me take a break because it's been roughly around 70 minutes. I will take a break. You try it on your own. If you have put a good amount of concentration, then you will be able to solve it on your own. The whole question should be able to solve on your own. Okay, so let me take a break and then I will come back. Yeah, welcome back guys. So did you try this question? So what is happening in this particular problem is that your yt is xt being multiplied with the particular value, which is a cos omega t plus theta, right? A cos omega t plus theta. Now this a cos omega t plus theta will keep on changing based on the cases, case 1, case 2, case 3, case 4. So what is our first case? In our first case, our yt is purely a into xt cos omega t plus theta. Here there is only random variable is, only random process is x of t. Only randomness this guy got. A is not random, omega is not random, theta is not random. So if I calculate the mean expectation of yt, then what I will see that a cos omega t plus theta, it will purely be out because they are not having any randomness, right? Expectation of xt. So whatever the expectation of xt would be there, your answer would come out to be a into mu x. Will I write down mu x of t? No, because x of t is WSSRP. So I am assuming that expectation of xt is equals to mu x, and I am pretty sure that it will not be a function of time. So answer would be a mu x cos omega t plus theta. What I can see, it is a function of time, right? What does that mean? Yt is not WSSRP. Yt is not WSSRP. So for the first case, it is not WSSRP. Is that clear to you? Okay, so in first case, when this pt was a deterministic signal, basically it was not having any randomness, then your yt is not coming out to be a WSSRP. Second one, yt is axt, just a second guys. Yeah, so your yt is axt cos omega t plus theta, right? Now this time a is also random, so randomness is there in a and xt. So if I find out expectation of yt, what I will get? There is no randomness in cos omega t plus theta, but here I can see randomness. Now I know that a and xt both are independent. What I can see, a, theta, xt, they are mutually independent. So what I can do is that expectation of a multiply with expectation of xt. Now what we can see, cos omega t plus theta. Expectation of A will be 2 divided by 2, that would be half, and this is mu x. So directly I can see that this is also a function of t. So yt is not w plus rp. But what if I defined A in a manner that, let's just say what if my A was uniformly distributed between -1 to 1? Then my mean of A would have been 0. Then this whole answer would come out to be 0. Then you would say that it is not a function of t. So just by looking at it, in general case, I cannot say that whether it will be W plus RP or not. Are you able to understand this point? Just by looking at the mean, what I am saying is that I set up my A in a manner, or here also I could have done the same thing. I could have set up a mu of x in a manner that mu of x is equals to 0, or I could have set up expectation of A in a manner that expectation of A is equals to 0. Then just by looking at the mean, I would not be able to tell whether they are W plus RP or not. So then I would have to find my autocorrelation function as well. So let's try finding autocorrelation function here. Autocorrelation function. Okay, I'm not sure whether it will come out to be a function of t, or it will be coming out to be a function of tau, or it will be a function of both. So let's check what we are getting. So expectation of y of t, we are calculating for y, right? Y of t plus tau. So what you are getting, expectation of A and A will be multiplied A square x of t cos omega t plus theta x of t plus tau cos omega tau plus theta, right? This is what you will be getting. Now you know that if since all of them are mutually independent, so expectation of A, expectation of xt x of t plus tau, and this can be written as expectation of cos omega t plus theta cos omega t plus omega tau plus theta, that I know that multiply by 2 divide by 2, it would come out to be cos 2 omega t, because this we have done a lot of times, right? Omega tau plus 2 theta plus cos omega tau. So this will be the answer you will be getting, right? So basically what is the answer we are getting? Let's go to the next page. Ry of t plus tau. So answer we are getting is expectation of A square divided by 2. What is this? Rx of tau. Rx of tau, because I know that xt is a W plus RP, which is already given. Xt is a W plus RP, it is already given. So expectation of A square divided by 2 into Rx of tau. Now this function, what about this function? This will come out to be as it is, no? Because there is no randomness here, right? There is no randomness. Actually, I did not have to do all this analysis. There is no randomness, no? There is no randomness here, right? So what you are getting? What you are getting is that cos 2 omega t plus omega tau plus theta plus cos omega tau. This is the answer you are getting, and you can directly see that it is both a function of time t and tau, so not W plus RP. Okay. So ideally it is not W plus RP. Now in the worst case, what may happen in the examination? Let's just say they will set up A in a manner that this will become 0. Okay. So you will say that it is not a function of time, and but what you will do, you will find out that autocorrelation function of yt. So once you find out the autocorrelation function, you will get to know that it is a function of t as well, it is a function of tau as well. Then you can say that it is not W plus RP. But what will happen? What if in the examination they are saying that you calculate its PSD, power spectral density? So that we are going to study in next lecture. And in the next lecture we will study PSD, and I will tell that PSD is defined only for W plus RP. But in some PSU examination or even in ESC examination, they will give this condition. They will give this condition only. This is the multiplier. Same setup they will give. A is uniformly distributed between 0 to 2, or not 0 to 2. They will give A is uniformly distributed between -1 to 1, and then they will ask you PSD of output. Now I am just saying that, sir, PSD is defined only for W plus RP, but this output is not coming out to be W plus RP. So how will you define it? So there what you will do, although the question is wrong, you cannot define W plus RP for this one. Sorry, you cannot define PSD for this one because it is not W plus RP. PSD is only defined that we will see in the next lecture. It is only defined for WSSRP. But what if in the examination they are still asking you? In GATE it will not happen, but in some PSU examination it may happen. If they are asking you, what you will do? Who is creating the problem? This particular thing is creating the problem, no? Right? Because this is a function of time t. Otherwise, this is a function of tau, this is also a function of tau, and this will be a constant. So who is creating this problem? This is creating this problem, so put that equals to 0. Although it is wrong, this should not happen. Ideally, it is not WSSRP, but in the examination, still if they are asking, then this is what you need to do. That put that equals to 0 and proceed in the problem. Is that okay for you? So that we will see in the next lecture. There also I will tell you that this is how you need to proceed. But till this date in the GATE examination, always they have framed the question in a correct manner. But in a lot of other examination as well, because this is very famous. Multiplying your xt with a particular cosinusoid. This is pretty famous setup. Okay, when we study modulation, we will study more about it. So this is a particular famous setup, and this has been asked a lot of time. There they will give A uniformly distributed between -1 to 1, and they will expect you to find power of output or power spectral density of output. All these things are defined only for what? Only for WSSRP. But YT is actually not WSSRP. If your A is uniformly distributed between -1 to 1. But still, if they are asking, that means what I need to do is that whatever the term that is creating the problem, put that equals to 0. Okay. But ideally, as of now, we will write down it is not WSSRP. But let's take the third case where again my YT is AXT cos omega t plus theta. But this time my theta is uniformly distributed between 0 to 2 pi. So now you will see what will be your expectation of YT. That would be expectation of A is constant, right? A will be constant. Expectation of xt multiplied with expectation of cos omega t plus theta, right? How I can write so? Because they are mutually independent. So this is mu x, but you know that this value will be 0. You are integrating your cosinusoid for one time period. You know how to find out? At least 10 times we have find it out. So this will be 0. So what do you see? Not a function of time. So yes, we need to hold on now, right? So mu yt is not a function of time. It is coming out to be 0 because this particular term is 0. Let's go to ry of tau now. The same example we have already done. Right? So what we need to do? Expectation of, just a second guys, expectation of yt into y of t plus tau. So expectation of a square x of t multiply with x of t plus tau cos omega t plus tau cos omega t plus omega tau plus theta. Okay, so what you are getting? A square is constant only. So let's take a square outside. Expectation of x of t plus tau, and here multiply by 2, divide by 2. So expectation of cos a plus b cos a minus b. And you know that this expectation will come out to be 0, and from here what you will get? A square by 2, this is your Rx of tau cos omega tau. So there you go. This is coming out to be a function of tau only. A very, very important result as well. This is coming out to be a function of tau only. So it is only a function of tau. So yes, now your yt is WSSRP. So which condition helped us? When your theta is uniformly distributed between 0 to 2 pi, or it could be between -pi to pi as well. What I am saying, theta is uniformly distributed between -pi to pi as well, it would give the same result. Basically, the length should be 2 pi. This length should be 2 pi. -pi to pi, that means length should be 2 pi. Because in a length of 2 pi, this integration will go to 0. What I am saying, what I want, my major concern is the length should be 2 pi, because in the length of 2 pi this will go to 0. In the length of 2 pi this will also go to 0. It is not necessary that it should go from 0 to 2 pi. The only concern is it should go from -pi to pi, length is 2 pi. It can go from minus pi by 2 to 3 pi by 2 as well. Again the length is 2 pi, because in the length of 2 pi this integration will become 0. This integration will become 0. So here it is becoming constant and here it is becoming only the function of tau. So this is the desirable condition, that your x of t was WSSRP, you are multiplying with a cos omega t plus theta, where theta is uniformly distributed between minus pi to pi. That means theta has to be random. If theta was not random, here theta was not random, then function of time t. Here also theta was not random, function of time t. But just as theta became random, it is not a function of time t, mean is also constant and autocorrelation function is also constant. Similar thing will happen in the option D as well. Okay, in the option D as well the similar thing will happen. You should try it on your own. You should be able to do it on your own. Not only try, you should be able to do it on your own. If you are not able to do it, then there is something wrong either with the educator or with the student. Okay, now it's up to you to decide who is wrong, right? Because you should be able to do it now. So A is also random here, xt is also random here, and this particular thing is also random here, and I know that this will throw out 0. So my answer would be 0, which is not a function of time t. And if I find out ry of tau, y of t into y of, basically what I can do is that the similar things will be copied, no? So I will just copy these part. You can see that similar things will be copied. Similar things will be copied. The only concern will be here that now A is also random. So here what you will get, expectation of A square. Are you able to understand this point? Look, A square x of t plus tau, all these things will come, right? You already know it. X of t plus tau, both are random, and this is also random. Theta is also random. So this particular part is also random. Along with that, A is also random. So expectation of A square will also come. What is the value of expectation of A square? Expectation of A square. Here only you can see that expectation of A square is length square, that is 2 square, 4 divided by 12, 1 by 3. Expectation of A square is 1 by 3. Let's keep it as expectation of A square only. Okay, let's keep it as expectation of A square only. Don't put the value. Expectation of A square divided by 2 Rx of tau cos omega tau. This is your Ry2. And surely your Yt is WSSRP. So next time if I frame, there is a Yt something like this, Axt cos omega t plus theta, or there is a Yt A sin t omega t plus theta. For sin t you will solve on your own, okay? And in both of the cases, A is some random variable, I don't know what it is, but theta is a random variable which is uniformly distributed between minus pi to pi, you can say, or you can say it is uniformly distributed between 0 to 2 pi, or you can say it is uniformly distributed between minus pi by 2 to 3 pi by 2. Basically the length is 2 pi. If this is the scenario, then your, in both of the cases, in this case as well and in this case as well, your Ry of tau will come out to be what? Expectation of A square divided by 2. In place of xt, what you will put? Rx of tau. And here, whether it is cosinusoid or sinusoid, in both of the cases, cos omega tau will come. There you go. This will be the answer, and it should be remembered. You have to remember it. Should be there in your mind. In the worst case, I will derive it. Don't take the pressure of remembering it. If you don't have much time left for your examination, you feel like that, sir, I cannot remember it, then you can derive it very simply. Within 20 seconds, you will be able to derive it, right? So expectation of A square divided by 2 into Rx of tau cos omega tau. For sinusoid as well, the same answer will come. You can do it on your own. Now someone will say that, sir, how can I remember it? Here, sir, I will have a doubt that, sir, whether sin will come or cos will come. Like in longer run, sir, when I don't study this chapter for 2 to 3 months, when I come back and I try writing down Ry of tau here, sir, I will think whether sin omega tau should come or cos omega tau should come. Ry of tau is even. So here sine omega tau cannot come, no. Ry of tau is even, no. This is even. So if it is even, then here even function only will come, because this is also even, this is a constant. So even into even will be even. So here sine cannot come, because if sine is coming, then minus sign will come outward. So this is the way to remember that whether it is sinusoid or cosinusoid, always cos will come. So Ry of tau is expectation of a square divided by 2 Rx of tau cos omega tau. Another way I will tell you, look, let's just say, let's go to signal system. If xt is equals to a, what is the power? A square, right? Xt is equals to a, power is a square. If your xt is equals to a cos omega t, what is the power? A square by 2. So whenever this guy comes, no, cos, it reduces the power to half. Whenever this guy comes, cos comes, it reduces the power to half. Initially, if I talk about the power here, if I talk about the value of Ry of 0, what that would be? Expectation of a square divided by 2 Rx of 0. And what is the value of cos 0? Cos 0 is 1 only. Cos 0 is 1. So this is your Ry of 0, right? So what really happened here? Initial power was, xt was having power Rx of 0. What happened? Who came? Cos came. Cos came with a. Cos came with a. Let's just say xt was 1. What I am saying is that xt was 1. Xt was 1. What would have been the power? 1 only. But now if xt is a cos omega t, what would be the power? A square by 2. So cos came with a. Cos came with a. So a square divided by 2 Rx of 0. Previously the power was Rx of 0. Then cos came, but it came with a. So a square, and it will do half power. So a square by 2 into Rx of 0. Since a is your random, since a is random, so expectation of a square divided by 2. If a is not random, then directly a square by 2 Rx of 0. Just I am telling you some good points, that if there was a straight line I was having, my power was a square. Just as the cos came into action or sine came into action, sine can also come, no? A sine omega t. So if any cosinusoid or sinusoid is coming, they will reduce the power to half. What they have done? They have reduced the power to half. Similar thing is happening here as well. Xt was a random process. It was having a power of Rx of 0. Cos came with the amplitude of a. So what it will do? A square by 2 Rx of 0. Are you able to understand this point or not? Okay. So cosinusoid or sinusoid always reduces the power to half. But you don't need to mug up all these things. You don't need to remember all these things. Just try remembering xt is being multiplied with a cos omega t plus theta. Major condition is that theta should be random. Okay, theta should be random. Theta cannot be constant. If theta was constant, our yt was not WSSRP. So theta has to be. Is it lagging? Yeah, sorry for the interruption, guys. Actually, the screen started lagging. So whatever that I wrote, that got erased. So I had to write down some slides again. So what we were discussing about this multiplier. Here what was happening? Xt was being multiplied with the a cos omega t plus theta. It could be sin omega t plus theta as well. If this pt was completely deterministic signal, then yt was not WSSRP. If a was random, then also it was not WSSRP. What is the desirable condition? What is the major condition? What is the major requirement? The major requirement is that theta should be random, and it should be random in a manner that the complete width of the randomness, that theta should take the value in a width of 2 pi, in a length of 2 pi, theta should take the value. It could be from 0 to 2 pi, minus pi to pi, or it could be from minus pi by 2 to 3 pi by 2. So if this is the scenario, then whether it is cosinusoid or sinusoid, in both of the cases, what you will get? You will get a WSSRP process. Yt will be WSSRP. Okay. In both of these cases, yt will be WSSRP. Given that if xt is WSSRP, then your yt will also be WSSRP. And if it is WSSRP, then you can define its autocorrelation function as a function of tau only. So that autocorrelation function will be coming out to be expectation of a square divided by 2 Rx of tau cos omega tau. Expectation of a square divided by 2 Rx of tau cos omega tau. Okay. Well and good. So this you should be able to remember. We are going to use this expression in the next lecture. Somewhere in the next lecture, and somewhere to solve the problems as well, we are going to use this expression. Okay. Well and good. Let's move to the next topic. The next topic is, now we will pass our random process through a LTI system. So our random process xt will be passed through a LTI system who is having its impulse response as ht. Impulse response of a LTI system is ht. So this is your LTI system. Okay. And then you are getting output yt. So how your yt output is defined? In signal system we have studied yt is given as xt convolution ht. Say yes or no. Yt is given as xt convolution ht. So how I can define my yt? So yt could be given as h of alpha x of minus alpha plus t d alpha. In signal system here we used to write down tau, right? H of tau x of minus tau plus t d tau. But here we are not going, here we are writing alpha. Why is that so? Because tau is our shift, no? Tau is our sampling time period. In this whole chapter, tau is our sampling time period. So that's why I am writing alpha here. So h of alpha x of minus alpha plus t d alpha, right? So this is our output yt, which is very simple. Now what if I ask you what will be the expected value of yt? Expected value of yt. What you will do? Expectation of minus infinity to infinity h of alpha x of minus alpha plus t dot d alpha. Now here ht is a deterministic signal. It will be a system, right? xt is a random process. xt is a random process, but ht is a deterministic signal. This will be deterministic. Basically it will not be random, right? It will be a particular system. It will not be random. So expectation will go towards x only. Are you able to understand this point? What I am saying is that if this expectation operator goes inside, so h of alpha will be as it is, but this guy will get the expectation dot d alpha. Now since xt is WSSRP, so expectation of x of t will be equals to expectation of any random function which is t minus alpha will be equivalent to mu x only. It will not be a function of time. So mu x will be a constant that can come outside. So what you will be getting? Mu x minus infinity to infinity h of alpha dot d alpha. All good, right? So this is the answer you are getting, minus infinity to infinity h of alpha dot d alpha. So this is one of the answer, that your mu of y is coming out to be mu of x minus infinity to infinity multiply with minus infinity to infinity h of alpha dot d alpha. This is one of the answer you are getting. Now secondly, if you remember the transforms, do you remember the formula of h of omega? Do you remember the formula of h of omega? Minus infinity to infinity h of t e to the power minus j omega t dt. Now in place of omega, if I put 0, what do I get? Minus infinity to infinity h of t dot dt. In place of t, can I put alpha? Surely I can put alpha. Minus infinity to infinity h of alpha dot d alpha. Similar thing I can do with h of s as well. In place of s, if I put 0, what I will get? Minus infinity to infinity h of t e to the power minus st. So in place of s, if I put 0, that would be 1. So similarly, in place of h, I can put alpha. So this area h alpha d alpha from minus infinity to infinity, this area is equivalent to what? So your mu of y is equivalent to mu of x, whatever the frequency spectrum you get. It could be h of omega, it could be h of s. So I am writing h of s here, and then in place of s you will put 0. What this is known as? What this is known as? In place of omega, if you put 0, this is known as DC gain. DC gain of your system, of LTI system. DC gain of LTI system. So this is the DC gain. Why DC gain? Because you are calculating your transfer function at omega equals to 0. Omega equals to 0 means DC. So this is known as DC gain. So what did you understand from this slide? What you need to remember? only thing, two things you need to remember, that xt is a WSSRP which is passed through a LTI system. Surely your h of t is deterministic. It is a particular system, so there is no randomness. It will be deterministic. You need to tell something about yt. So first thing we are going to tell, that is the mean. What mean we are getting? We are getting the mean of output equals to mean of input multiply with the DC gain. Multiply with that DC gain. So in place of h of omega, what you will put? Omega equals to 0. In place of h of omega, what you will put? Omega equals to 0 you will put. Or in place of h of s, what you will put? S equals to 0 you will put, and then you will multiply with mu of x. This is the answer you are getting. Okay. Now we are going to write down, what we will write down? Autocorrelation function. And when we write down the autocorrelation function, we will get to know that our yt will be WSSRP only. So another statement you can write down, if your xt is WSSRP and it is passed through a LTI system, then your output will also be WSSRP. So WSSRP passed through a LTI system and output is also WSSRP only, because you can see that mean is constant, right? It is not a function of t. It is not a function of t. So mean is constant. Now we are going to write down autocorrelation function. So that will be function of tau only. So basically both of the conditions are met. That means yt will be WSSRP only. So this slide is clear to you, right? There is nothing difficult in this slide. All these things should not be mixed. Okay, well and good. Now see this question. There is this particular system. You are calculating your output yt here. This is the xt. Xt is it is not a signal. It is a random process with mean 4. It is a random signal with mean 4. You need to find the mean of output yt. You know that mean of output yt will be equivalent to mean of input xt with, in place of omega, what you need to put? Omega equals to 0. So in this system, I will put omega equals to 0. What people will do is that, sir, the first they will find out y of s divided by x of s. That will be h of s. And then they will put s equals to 0. But I told you, what is this? This is actually the DC gain, no? Basically, I need to put omega equals to 0. So in this circuit only, I will put omega equals to 0. If I put omega equals to 0, basically, how much impedance this inductor will provide? Omega L. And if I put omega equals to 0, if I put omega equals to 0, so how much impedance it will provide? 0. Capacitor will provide infinite impedance. This 12 will provide 0 impedance. So what you will be getting? What kind of circuit you will be getting? Resistance R, then inductor is shorted, then 3R, then inductor is shorted, capacitor is open circuited, and then 4R. This kind of circuit you will be getting. R, 3R. Okay. Whatever it is, 4R doesn't matter. So this kind of circuit you are getting. What we need to find? We need to find the gain at 0 frequency. So what will be the gain? This is your input. This is your input side. This is your output side. So what will be the value of h of 0? That would be 3R upon 3R plus R. 3 by 4. So basically your input mean, the mean of your input will be multiplied with the DC gain. So if a particular circuitry is given, you don't need to find its transfer function. In the circuitry only you will put omega equals to 0. In this circuit, if I put omega equals to 0, what is happening is that this is becoming shorted, this is also becoming shorted, this is becoming open circuited. So R and 3R is coming into series and nothing else is into the action. This 4R is not into the action because it is open circuited. Right? So what is the gain we are getting? 3 by 4. So what is the mu x? 4. Gain we are getting 3 by 4. So our mu y is 3. Okay? Very simple, very straightforward. Right? So first thing we have got to know, that is what will be the mean of your output. Mean of your output will be equals to the mean of the input multiplied with the DC gain, or you can say complete area of this HT. Mean into area of this HT, or forget about remembering this formula. This formula is more important. So this formula says that mu of y is equals to mu of x multiply with h of s at s equals to 0, or you can say h of omega at omega equals to 0. That means mu of x multiply with the DC gain. Very simple. Let's go to the next slide. So now we need to comment on autocorrelation function. So again, xt is WSSRP. It will be passed through ht. Yt will also be WSSRP. So it will have an autocorrelation function of Rx of tau, and it will have a autocorrelation function of Ry of tau. Till this point, what we know? We know that Yt is given as xt convolution ht, and mu of y is equals to mu of x multiply with h of 0. Till this point, all these things we know. Now I need to comment on what will be my Ry of tau. What will be my Ry of tau? Ry of tau. So see from here, what is this xt? So Ry of tau will be equals to Rx of tau. From xt, what you are writing now? Rx of tau. From ht, what you will write down? H of tau. Along with that, another h of minus tau will also come. There you go. This will be your Ry of tau. What will be your Ry of tau? Yt is equals to xt convolution ht. Look, this is derived. There is a derivation for this one, but that derivation is not important. So what I will do? Yt equals to xt convolution ht. So Ry of tau will be equals to Rx of tau convolution with h of tau convolution with h of minus tau. Basically, your h of tau will be inverted, and then you will do the convolution. So two convolution you need to do. First you can do these two convolution, and then whatever the result you are getting, convolve with this guy. Or what you can do, first you do this convolution, whatever the result that you are getting, convolve with this guy. Okay. Or what you can do, first these two convolution, whatever the result that you are getting, convolve with this guy. So this kind of a convolution you have to do. This will be your Ry of tau, should be there in your mind. Ry of tau will be equals to Rx of tau convolution with h of tau convolution with h of minus tau. So this kind of thing is there, that kind of you can assume it in, like if I need to show the block diagram, so how will I show it? If I need to show the block diagram, this is how I will show it. Rx of tau, first it will be convolved with h of tau, then it will be convolved with h of minus tau, and then you will be getting the final answer. Basically, this was the scenario. Your scenario was x of t was being fed to h of t. X of t was being fed to h of t, and your output was yt. X of t was being fed to h of t, and your output was yt. Your output was yt. Here we got to know that our mu x, mu y was coming out to be mu x multiply with the DC gain, or you can call it mu x multiply with the full area. Okay. What about the autocorrelation function? So autocorrelation function is coming out to be Rx of tau convolution with h of tau convolution with h of minus tau. Should be there in your mind. Directly this kind of expression can also come, and a lot of problems will be solved based on this expression. Now what they are asking you to find the expression of Rxy of tau, Ryx of tau, all these expression we need to find. So let's get started with the first one. I need to find Rxy of tau. So that would be what? Expectation of xt y of t plus 2. That would be equivalent to expectation of xt. What will be your y of t plus 2? What will be your y of t plus 2? What is your yt? Yt is minus infinity to infinity h of alpha x of minus alpha plus t d alpha. So what do you think, what will be my y of t plus 2? Minus infinity to infinity h of alpha x of, in place of t, what you will put? T plus 2 d alpha. So there you go. So your yt is minus infinity to infinity h of alpha x of minus alpha plus t to d alpha. Okay. Now you know that this integration is there for alpha. So x of t is a constant. Integration is there for alpha, so x of t is a constant. No, so this x of t can go inside. Say yes or no. Why we are doing so, you will understand. What I am saying is that I will take x of t inside. H of alpha as it is. X of t is a constant only, so it can come inside. X of t, sorry, not t, x of minus alpha plus t plus 2 dot d alpha. Is that fine for you? Okay. Now what do I know? This is the expectation operator. It will look for randomness. H of alpha is not random. D alpha just the d alpha is just a value, and integration is from minus infinity to infinity. So who is random here? This guy is random. So what it will do? Minus infinity to infinity, h of alpha as it is, expectation operator will go here. I am writing it down in this manner. All fine? Okay. Minus infinity to infinity, h of alpha. What this would be? This would be your Rx of minus alpha plus tau. What is the time difference? T minus alpha plus tau into T dot d alpha. What do you think what this is? H of alpha dot Rx of minus alpha plus tau dot d alpha. Minus infinity to infinity, h of alpha, x of minus alpha plus t dot d alpha. What it was? It was your h of t convolution with x of t, right? Just one second, guys. Yeah, so what I was saying, what this was? H of t convolution with x of t, right? Okay, h of alpha, x of minus alpha plus t dot d alpha, it was h of t convolution with x of t. So similarly here, in place of t, what is there? Tau is there. Here it was t, here it is tau. And in place of x, what is there? Rx is there. So what do you think what is the answer here? H of tau convolution with Rx of tau. So this is coming out to be equivalent to Rxy of tau. In the similar manner as well, you will get Ry of tau as well, this expression. But this derivation is a bit complex, so I kind of avoided it. We are getting the expression of Rxy of tau. So let's not keep it in a box. Whatever the final answer that I write down, that we will keep in the box. Rxy of tau is coming out to be Rx of tau convolution with h of tau. This is the answer you are getting. Now just let me know one thing. What would be your Ryx of tau? Ryx of tau will be equivalent to Rxy of minus 2. Say yes or no. So what I will do? Do you remember the convolution property? Xt convolution ht is equals to yt. If I make one inversion, only one inversion I have to make. So output will also be inverted. No? So here your output is Rxy of tau is Rx of tau convolution with h of tau. So Rxy of minus tau will be what? Rx of tau convolution with h of minus tau. So Ryx of tau is equivalent to Rx of tau convolution with h of minus tau. So what we have find out? Rxy of tau we have find out, Ryx of tau we have find out. And another thing we know, Ry of tau. So do you remember this expression is very important. Ry of tau is very important. So what is the final answer for Ry of tau? That is Rx of tau convolution with h of tau convolution with h of minus tau. Now what this is equivalent to? So Ry of tau, this is what this is equivalent to? Rx of tau convolution with h of tau, that is Rxy of tau. Rxy of tau convolution with h of minus tau. And now this convolution with this guy, what that is equivalent to? So again Ry of tau, that will be equivalent to Rxy of tau convolution with h of tau. Because Rx of tau convolution with h of minus tau, Rx of tau convolution with h of minus tau, Rx of tau convolution with h of minus tau is equivalent to Ryx of tau. So Ryx of tau convolution with, this is h of tau, this is also h of tau. So there you go. These three are the expressions. Along with that, two other expressions also we will remember. What all are those expressions? These are Rxy of tau and Ryx of tau. So how will I remember? Rxy of tau. Always you will remember that in the left hand side, x will be convolved with something. Y will never be convolved. Can you see y is being convolved? No. Y is in the final answer. Y will never be convolved. X will be convolved. Now here x is coming first, no? X is coming first and x knows that I will be convolved here. So x will say that I am happy. That's why there will not be any inversion. But here y is coming first and x knows that I will be convolved. X will say that, sir, I will be convolved and still I am not first. So I am not happy. So I will make an inversion. So these are the final things. should be there in your mind. First one should be there in your mind. Even if you forget this one, you can derive it, and once you have derived it, you will get these answers, right? And I have told you the trick as well, Rx y of 2. So you know that in the left hand side, x will be convolved. So x will say that, sir, I will come first, and here also I am coming first. I don't have any problem. Rx of 2 convolution with h of 2. Here Ryx of 2. So x will say that, sir, I will be convolved, but still I am not first. So I will have the problem. I will make an inversion. So Rx of 2 convolution with h of minus 2. So these are the results. These are the 5 results which you should be remembering. What else they are asking? Cxy of 2, Cyx of 2 and Cy of 2. So yeah, we can find it out. Cxy of 2. So that will be equivalent to Rxy of 2 minus, what will come here? Expectation of xt multiply with expectation of y of t plus 2. Basically, what is your Cxy of 2? If I start right from the beginning, what is your Cxy of 2? That is expectation of xt y of t plus 2 minus expectation of xt expectation of y of t plus 2. Now this I know that it will be Rxy of 2 minus expectation of xt mu x, expectation of yt plus 2 or yt, because yt is WSSRP, no? Yt is WSSRP. So expectation of yt or expectation of y of t plus 2 will be the same, or you can write it down as Rxy of 2 minus, you know that this will be equivalent to mu of y will be equivalent to, what is your mu of y? Mu of y is mu of x h of 0. So mu of x square h of 0. Okay, in the similar manner you can write down these answers as well. You don't need to remember, basically, just it is for the sake of writing it down, you can write it down, nothing else. What will be your Cy of 2? Cy of 2 I am writing down. What will be your Cy of 2? So Cy of 2 will be Ry of 2 minus mu y square, right? So what this will be equivalent to Ry of 2, what is mu y? So Ry of 2 minus mu x square h square 0. So just for the sake of writing it down, I am writing it, nothing else. Okay, but these are the things that you should remember. So x of t is being passed through a LTI system, okay, linear time invariant system, whose impulse response is h of t, and you are getting a output yt. Shall we write down the conclusion? Let me make a slide where I will write down all the conclusion that we should remember. Xt, yt, and this is ht. You should write it down on your own as well. Okay, what you are doing? You are applying a xt and you are getting yt. Xt is WSSRP, which is given. This will be deterministic. This will also be WSSRP, right? Okay. So now you let me know how your yt will be defined. Yt will be defined as xt convolution with ht. How your mu of y will be defined? Mu of y will be defined as mu of x h of omega. In place of omega, you will put omega equals to 0. Ry of 2 will be defined as Rx of 2 convolution with h of 2 convolution with h of minus 2. Okay. Then Rxy of 2. So x will say that, sir, I will be convolved, and if I am happy, if I am first, then I am happy. Ryx of 2 can say that, x will say that, sir, I will be convolved, but still I am not first, so I am not happy. Now based on these two guys, I can write down Ry of 2. So these two are convolved, then it will give you Rxy of 2 convolution with h of minus 2. And if this and this guy is convolved, then what it will give you? Ryx of 2 convolution with h of 2. Okay, well and good. So this is the conclusion of everything that we have studied. So if you just remember this slide, then your job is done. So if your xt, which is WSSRP, is passed through a LTI system, then your output will also be WSSRP with all these results. Well and good. Let's solve a question. We will solve more problems. In this lecture, this will be our last question. In this particular lecture, this will be our last question, but in the next lecture, we will solve more problems on this concept. So don't worry. But this will be our last question of this particular lecture. So xt is the WSSRP, whose mean is given, Rx tau is given, ht is given. You need to comment on yt. First one is you need to find the mean square value variance of output. Along with that, you need to tell ry of tau, cy of tau as well. So all these things you need to tell. So let's get started. First question. Mean of output will be equals to mean of input h of omega at omega equals to 0. So this is your h of t, which is 2 delta t minus 1. Can you find out its Fourier transform h of omega? That will be 2 e to the power minus j omega, right? So h of omega at omega equals to 0, what it will give you? 2. So 2 mu x, that means answer will be 1. So mu of y is coming out to be 1. Okay. Sir, you did not tell any formula for mean square value. Yeah, I did not tell any formula for mean square value, but I told the formula for ry of tau. So your ry of tau will be equals to rx of tau convolution with h of tau convolution with h of minus tau. So your h of t is 2 delta t minus 1. So what will be your h of tau? H of tau will actually be 2 delta of tau minus 1, right? And what will be your h of minus tau? So that will be 2 delta of minus tau minus 1. And delta has the ability of eating up the negative sign because delta is even. So h of minus tau is coming out to be 2 delta t plus 1 and h of tau is coming out to be 2 delta t minus 1. So what is the answer we are getting? Rx of tau convolution with 2 and 2 are constant, right? 2 and 2 are constant. So they can come outside. So here you will get 4. They can come outside. Delta of t minus 1 convolved with delta of tau plus 1. Now do you remember the property? Which property? X of t convolution with h of t is yt. Then x of t plus t1 convolution with h of t plus t1, sorry, h of t plus t2 will give you y of t plus t1 plus t2, right? So minus 1 plus 1, delta t convolved with delta t will be delta t only. Minus 1 plus 1 will be 0 only. So what you will be getting? Delta t only. So 4 rx of tau convolved with delta tau. Anything convolved with delta tau will give you the same result. So what you are getting? ry of tau is coming out to be 4 rx of tau. ry of tau is coming out to be 4 rx of tau. Rx of tau is 3 e to the power minus 2 tau. So ry of tau is coming out to be 12 e to the power minus 2 mod of tau. So this is your ry of tau. So what should be your mean square value? Mean square value will be 12 because if you put tau equals to 0 here, mean square value is actually equals to ry of 0. And what will be your variance? Variance of y, that will be mean square value minus square of the mean, that will be 11. So everything we have find out. Next we need to find out cy of tau. So cy of tau is ry of tau minus mu y square. So ry of tau minus mu y square. Mu y square is 1. So this is the answer. Next, rxy of tau, ryx of tau, cxy of tau, cyx of tau, all these things we need to find. So next is rxy of tau. So x will say that, sir, I will come in the left hand side, but still I am coming first, so I am happy. So rx tau is already given. What is h of tau? H of tau is delta of t minus 1. So what you are getting? Rx of tau minus 1. 12, not 12, sorry. Rx of tau is 3. So 3 e to the power minus 2 mod of tau minus 1. That will be the answer. Okay. And if I ask you ryx of tau, So directly I will say that it will be equivalent to Rxy of minus 2. So in place of Rxy of plus 2, you put minus 2. So 3 e to the power minus 2 minus 2 minus 1. What you will be getting? 3 e to the power minus 2. Minus sign will be eaten up by this modulus, tau plus 1. Or you can go by the basic definition as well, because R by x of tau will be equivalent to, so I know that x will come here, but x will say I am not coming first. So what I will do? I will put h of minus 2. So Rx of tau convolution with h of minus 2 is 2 delta of tau plus 1. Okay, here it was 2 as well, no? So 2 I forgot. The answer will be 6. 6, 6, 6. So 2 delta tau plus 1. So what do you think? What will be the answer? 2 Rx of tau plus 1. Is this the same? Here you can see that 2 Rx of tau plus 1. What that would be? Rx of tau is 3 to the power minus 2 tau. So 3 into 2 will be 6 e to the power minus 2 tau plus 1. This will be the answer. Yes, answer is matching, right? And what do you think? What will be your Cxy of tau and Cyx of tau? Cxy of tau and Cyx of tau. Cxy of tau, that will be Rxy of tau minus mu x mu y, right? You understand this? What did I do here? Because I know that x of t, y of t plus tau will come. Expectation of x of t multiply with expectation of y of t plus tau will come. That will be equivalent to mu x dot mu y only, right? So Rxy of tau. What is Rxy of tau? Whatever it is, let's keep it as it is. Rxy of tau. Mu x mu y we already know. Mu y is 1, mu x is 0.5. So answer will be 0.5, right? And your Cyx of tau will be equivalent to Ryx of tau, but this constant part will remain there as it is only. So Ryx of tau minus 0.5. There you go. This is the answer. Okay. So this is the full question. This is how we need to solve it. But here actually we needlessly did all this calculation. Why is that so? Because you can find out the expression of yt directly, no? What I mean to say is that, let's say method 2. This question would have been very easy actually if I had started like this. Y of t is x of t convolution h of t. I don't want to do any calculation. Forget about the formula or anything. What is x of t? X of t is x of t only. What is h of t? 2 delta t minus 1. 2 delta t minus 1. So what do you see here? Y of t is coming out to be 2 x of t minus 1. There you go. This is your y of t. So now you need to find the mean of 2x of t minus 1. What that would be? 2 into mean of xt only, right? Because you know that xt is WSSRP. If xt is WSSRP, then time doesn't matter. So 2 into 0.5, what will be the answer? 1. Mean square value of 2x t minus 1. That means what you need to find? Expectation of square of this one. Expectation of square of this one. That would be 4x square t minus 1. So 4 will come outward. T minus 1 doesn't matter because xt is WSSRP. So what is the answer? 3. So 4 into 3, 12. Were we getting the 12 answer only? Yes, 12 only. And then variance you can find on your own. Next, what I need to find? Autocorrelation function. Autocorrelation function I need to find, right? So I need to find the autocorrelation function of y. That means expectation of yt into y of t plus tau. So what that would be? Expectation of, what is yt? Yt is x t minus 1 multiply with 2x t plus tau minus 1. So 2 and 2 will come outside. 2 expectation of 4 expectation of x of t minus 1, x of t plus tau minus 1. So what is the answer I am getting? Here what is the time difference? T plus tau minus 1 minus t plus 1. Rx of tau only. So Ry of tau is coming out to be 4 Rx of tau only. So look, I am not applying any formula. right? Ry of tau is coming out to be 4 Rx of tau only, right? So in that manner I could have solved it. Are you able to understand this point? Similarly, you could have solved cross correlation as well. Rxy of tau. What you could have done? Rxy of tau. So what is your Rxy of tau? That is xt convolved with y of t plus tau. So not convolved, sorry, multiplied. Y of t plus tau. What will be your y of t plus tau? 2 into x of t plus tau minus 1. So 2 can go outside. It would be Rx of tau minus 1. So are we getting the same thing? 2 Rx of tau minus 1. Yes, we are getting the same thing. This was your Rxy of tau. So this question was actually very easy, very straightforward. So in my examination, my first target would be, can I write down the expression of yt? If I am able to write down the expression of yt, then forget about the formula. No formula, simply concept. But if you are not able to write down the concept of, if you are not able to write down the expression of yt in terms of xt, then you will go to our formula for LTI system, and formula are these. This is the formula. Surely we will see more problems based on this, but as of now, let's end this lecture. In the next lecture, we are going to study about power spectral density and white noise, and we will solve a lot of questions. This particular thing, whatever that we have studied here, that will be interrelated with the next lecture. Okay, so relation will be there. So based on that, both combined, we will see a lot of problems. So as of now, in this slide, you have understood about xt being passed through a LTI system. So what will be your output yt? What will be the mean? And what will be their autocorrelation functions, cross correlation functions. Okay then, yeah, thank you very much. And sorry for the disturbance in between, because the slides went off. The screen started lagging. Okay, so let's meet in the next video. There we will study about power spectral density and white noise, and we will solve a lot of questions. So next video will be the last video on random process. Thank you very much. Yeah, hi everyone, welcome back. So in this video, we are going to study about power spectral density and white noise. Okay, so these two topics we need to study, but here we will be highly using Fourier transform. So first we will do a quick overview of Fourier transform. Okay, it will be a quick revision. So even if you have already studied Fourier transform, although everyone should study Fourier transform, then only they should be coming to communication system. Okay, the prerequisite of communication system is signal system. So you should have already studied signal system, then only you should have come here. Right, so we will do a quick revision of a Fourier transform, and then we will proceed. So let's get started. X of t can have two kind of Fourier transform, x of omega, x of f, right? What is the formula of x of omega? So formula of x of omega is minus infinity to infinity x of t e to the power minus j omega t dt. Here we are assuming x of t is our deterministic signal. Basically we are going into signal system now. We are not studying communication system. We are studying signal system only. Just a quick revision. This is the formula of x of omega. What is the formula of x of f? Minus infinity to infinity x of t e to the power minus j 2 pi ft dt. Right? What is the formula of xt? If I am writing down in terms of x of omega, then what I will do? Minus infinity to infinity x of omega e to the power j omega t dot dt. Whenever you see in the integration, whenever you see x of omega, always make sure to put 1 by 2 pi outside. In the integration, whenever you see x of omega, always make sure to put 1 by 2 pi outside. And what is the formula of x of t in terms of x of f? So in terms of x of f, this is the formula. X of f e to the power j 2 pi ft dt. Okay. Now some properties. If a Fourier transform of x of t is Fourier transform, we are talking about Fourier transform here. So if Fourier transform of x of t is x of omega, x of f, then Fourier transform of x of minus t will be x of minus omega, x of minus f. And Fourier transform of x conjugate t would be x conjugate omega, but another negative omega would also come. What will be the Fourier transform? And here also x conjugate minus f. What will be the Fourier transform of x of at? All these things you should be already knowing, right? X of omega by a 1 by mod of a, 1 by mod of a, x of f by a. And what do you think, what will be the value of this one? Minus infinity to infinity x omega dot d omega. What that would be? So you go to this formula. If I go to this formula, if I go in this formula, what do I see? 2 pi into this 2 pi goes here. If I put in place of t, if I put 0, so what do I get? This particular thing I will get. In place of t, if I put 0, what I will get? Minus infinity to infinity. Sorry guys, this you are different. This you are integrating with respect to omega, not with respect to t, right? This is with respect to omega, because you will put the limit of omega, so only t will be left. Put the limit of, you are integrating with respect to f, so you will put the limit of f, so only t will be left, right? So here if you see x of omega d omega, in place of t if I put 0, what I will get? This is the expression I will be getting, and 2 pi goes here, so this is the answer I will be getting, right? And what about this one? Minus infinity to infinity x of f dot df, what it will represent? Minus infinity to infinity x of f dot df. So in place of t, what you will put? 0. What you are getting? X of t at t equals to 0. So all these are very basic thing of signal system, right? Now these two are very important signals. What is the Fourier transform of a sin 80 by pi t? Sin 80 by pi t. So you look at this guy, sin 80. So Fourier transform of this function, this is known as sampling function. So Fourier transform of sampling function will be rectangular. So sin 80 by pi t. Sin 80 by pi t, it would be rectangular. Now two things are there. What will be this value and what will be the amplitude? So this value will be from here, you will pick sin 80 by pi t. This you need to remember. This should be the form sin 80 by pi t. So a, this value will be minus a, and this value will be plus a. And what will be the amplitude? Amplitude will be a. So this form should be there in your mind. Amplitude a sin 80 by pi t. Similarly here as well, amplitude a sin 80 by pi t, but whole square. So here the answer will be rectangular. Sorry, not rectangular, triangular. Sorry guys. For the first one it would be rectangular when there is no square. If there is a square, then it would be triangular, right? Now what will be this value and what will be the amplitude? So this value will be, you need to pick from here. If this is a and 2 already is there, so this will be minus 2a and this would be plus 2a. Here directly a was there, so directly minus a. If you need to pick from here, so 2a you pick. So this would be minus 2a, this would be plus 2a. What will be the amplitude? So you will pick a by pi from here and this capital A. So this amplitude will be a by pi. Okay, so this is the Fourier transform which we have already studied. If you have studied signal system from some other resource, then I am telling you this is how you need to remember. People usually derive it, but in the communication system, to solve the problem in a quicker manner, you need to remember a particular form. So this is the form sin 80 by pi t. Amplitude is a, sin 80 by pi t from minus a to a. Sin 80 by pi t, so from minus 2a to 2a, sin 80 by pi t whole square is there, and amplitude will be a by pi. So this is how you need to compare and write down all the Fourier transforms. Okay. Now what is the Fourier transform? Some standard signal and their Fourier transform. What is the Fourier transform of delta t? That is 1. And what is the Fourier transform of 1? That would be 2 pi del omega, or in terms of f if you write down, that would be delta of f, right? A to the power j omega naught t. What is the Fourier transform for that? So Fourier transform of 1 is 2 pi del omega, so e to the power j omega naught t, just it is the property, right? So what will happen? In place of omega, in the previous expression, in place of omega you need to put omega naught. And if you need to write it down in terms of f, then what you will write down? In terms of f, it would be delta of f minus f naught. What about cos omega naught t? Or cos 2 pi f naught t. So cos omega naught t is basically e to the power j omega naught t plus e to the power minus j omega naught t. Basically it is e to the power j omega naught t plus e to the power minus j omega naught t divided by 2, right? So what is the Fourier transform of e to the power j omega naught t? That is 2 pi del omega minus omega naught, and then divided by 2 would be there. So 2 and 2 will get cancelled out. So basically what you will be getting, pi del omega minus omega naught plus pi del omega plus omega naught, right? And for f naught, you can derive it on your own. For f naught as well, it is very simple, right? E to the power j f naught t plus e to the power j minus 2 f naught t divided by 2. So delta f minus f naught plus delta f plus f naught, delta f minus f naught plus delta f plus f naught divided by 2. Delta f minus f naught plus delta f plus f naught divided by 2. And usually we remember it by the diagram, right? If I write it down in terms of f, then there will be 2 impulses of amplitude 1 by 2. And if I write down in terms of omega, then there will be 2 impulses of amplitude pi. One impulse will be there at minus omega naught, one impulse will be there at plus omega naught. Same goes here as well, right? And signum t, what is the Fourier transform of signum t? That is 2 by j omega, or you can write it down as 2 by j, in place of omega you put 2 pi f. So what you are getting, 1 by j pi f. Convolution in time domain will result in multiplication in frequency domain, right? If h of t is real, then what can we write down? H of t would be equals to h conjugate t, right? What is the Fourier transform of h of t? H of f. And what is the Fourier transform of this guy? H of minus f, h conjugate minus f. Now in place of f, if I put a minus f here, what I am doing, in place of f I am putting minus f. So here also I need to do the same thing. So what did you get to know? If ht is real, if ht is real, if ht is real, then h of minus f can be put as h conjugate f. Okay, so this I will be using somewhere. If ht is real, then h of minus f I will put as h conjugate f. Directly I will put in this manner. All good? All fine? Yeah. So all these slides we already know. What is the Fourier transform of e to the power minus a mod of t? That is 2a upon a square plus omega square. All these things will be used. Okay, that's why we are studying it. What is the Fourier transform of e to the power minus at square? So here I ask you to remember a particular formula. This is under root pi by a e to the power minus omega square by 4a. Along with that, another formula is there. For e to the power minus at square, the answer would be e to the power minus af square. In terms of f, it would be e to the power minus af square. Basically, here you put the same thing. Okay. So in terms of f, you will go, if you will get e to the power minus af square directly, e to the power minus at square. Just a second, guys. Yeah, sorry, actually this was the error I was doing. That's what I was thinking. Basically, here you cannot directly put here, if this was the answer, this is something that I ask you to remember always in signal system, that e to the power minus at square will have under root pi by a e to the power minus omega square by 4a, right? Now in place of omega you will put 2 pi f. So what you will be getting, 4 pi square f square divided by 4a. So 4 will get cancelled, e to the power minus pi square f square divided by a. So under root pi by a. Now in place of a, this is the formula in terms of f. In place of a, if you put pi, what do you get? Under root pi, that would be 1, e to the power minus pi square f square divided by pi. So what you are getting, e to the power minus pi f square. So e to the power minus pi t square, e to the power minus pi t square will have a Fourier transform of e to the power minus pi f square. If you can remember this, you can remember this. Usually we remember this one. Okay. Just now you saw that I was about to mess up, e to the power minus at square is equal to e to the power minus af square. That was absolutely wrong. So this is the formula. Then in place of omega you can always put 2 pi f. Then you will get the answer. But usually people remember e to the power minus pi t square. In terms of f domain, it would be e to the power minus pi f square. Basically in place of t directly you put f. So kind of you can say that it is easy to remember in place of f domain. But only it will work when this is pi. Not for any general case. E to the power minus at square will not be equal to e to the power minus af square. E to the power minus pi t square will have a Fourier transform of e to the power minus pi f square. So only for a general case, only for a specific case, only this specific formula, if you want to remember, you can remember that what will be the Fourier transform of e to the power minus pi t square. That would be e to the power minus pi f square in terms of f, right? And what about xt cos omega naught t? So xt cos omega naught t could be written as e to the power j omega naught t plus e to the power minus j omega naught t divided by 2. Right, this is how it could be written. So you know that it can be written as x of omega minus omega naught plus x of omega plus omega naught divided by 2. Similarly, x of f minus f naught plus x of f plus f naught divided by 2. And what does your Parseval's theorem say? So mode of ht square dot dt, basically it is like energy. So if you want to calculate the energy, what you can do in f domain as well, you can directly put in this manner. And if you want to go to omega domain, then this is what you will do. mod of h of omega square d omega. But I told you, whenever in the integration you see omega, never forget to put 2 pi outside. Whenever in the integration you see omega, never forget to put 1 by 2 pi outside. Okay, so these are the formula. These all the standard formula, everything that I have taught here, everything will be used. Okay, 1 by pi t Fourier transform. Find the Fourier transform of 1 by pi t. How will you do it? By the duality theorem, right? What we can do? Duality theorem. So signum t was having a Fourier transform of what? Here we saw it was having a Fourier transform of 1 by j pi f. 1 by j pi f. So in terms of f domain, I need to apply the duality theorem. So this guy comes here. So 1 by j pi t. 1 by j pi t. And then this guy goes here. But in place of t, you will put minus f. Right? And you know one thing. What do you know? That signum is a odd function. So this minus f can come outside and this j goes here. So 1 by pi t. 1 by pi t will have a Fourier transform of j goes here and minus sign can come outside. So minus j signum f. Okay. So this should also you should remember. Now there is a topic called Hilbert transform. There is a topic called Hilbert transform in our signal system. So there I did not teach it. So here I am teaching it. When we were studying signal system, I told you that we will study Hilbert transform in communication system. So let's try studying Hilbert transform. So let's just say someone is saying that find the Hilbert transform of x of t. So what you need to do? You need to pick your x of t and you need to convolve it with 1 by pi t. So basically you can model it as a LTI system where your impulse response is 1 by pi t. So this h of t or this particular system will be known as Hilbert transformer. What it will be known as? Hilbert transformer. So what it will do? You send any signal, it will convolve it with 1 by pi t. This is the job of this particular Hilbert transformer. Okay. If I need to write it down in terms of omega domain or in terms of f domain, so here I got to know that 1 by pi t is having minus j signum f, and in terms of omega domain also you can write it down, right? In terms of omega domain also you can write it down. It will come out to be minus j signum omega. So these are the Fourier transform. So similarly here, if I need to write it down everything in the frequency domain, what I will do? Convolution in time domain will result in multiplication in frequency domain. So y of omega, x of omega multiply with minus j signum omega. So minus j x of omega signum omega, right? And here y of omega will be minus j x of f signum f. So basically what is your h of f here? What is your h of f? This is your h of f, no? Because 1 by pi t, this is your ht. Ht is 1 by pi t. So what is your h of f? H of f is minus j signum f. And what is your h of omega? Minus j signum omega. So can you draw the graph? Surely I can draw the graph as well. Graph of what? Graph of this frequency response, or you can call it transfer function. So I am drawing in terms of f, I am drawing in terms of omega as well. You can draw, same graph will be there, right? So you know how signum f goes? Signum f. For f greater than 0, it would be plus 1. For f less than 0, basically I need to define minus j signum f. How will you define minus j signum f? So signum f, for f greater than 0, it gives the value 1. So minus j for f greater than 0. And for f less than 0, it would be plus j. Okay. Minus j for f greater than 0. And for f less than 0, it would be plus j. Look, these are the imaginary quantity, right? Plus j and minus j are imaginary. So you cannot say, sir, this is positive, this is negative. Nothing. One is plus j, one is minus j. So if I am showing this as positive, this I will be showing as negative. This is the bottom line. So they are the imaginary quantity. So no one is positive, no one is negative, but one is negative of each other. Basically minus j is negative of plus j is negative of minus j. So if I am showing this by plus j, then this I will show by minus j. So this is your h of f, right? What about the angle of h of f? How much angle this will provide? Minus j provides minus 90 degree angle. right? Minus 90 degree angle, and what is the amplitude? Amplitude is 1. So I can write it down as amplitude is 1, angle is minus 90 degree, and here amplitude is 1, angle is plus 90 degree. Okay. So what will be your mode of h of f? Mode of h of f. What is your mode of h of f? If you take the mode, this will give you plus 1. Basically, what is the mode? Here also mode is plus 1, here also mode is plus 1. So mode of h of f is 1. Are you able to understand this point? Mode of h of f that is always 1. So this is also one of the point that will be used somewhere. Very simple thing, h of f is minus j signum f. Hilbert transformer, what is the impulse response, or what is the transfer function of Hilbert transformer? The transfer function of a Hilbert transformer is minus j signum f. If I take the mode, what I will get? 1. What is the angle it is providing? For positive frequency minus 90 degree, for negative frequency, for positive frequency minus 90 degree, for negative frequency plus 90 degree. Okay, and this is how you can make the graph. Let's try finding the Hilbert transform of cos 2t and sin 2t. What is this? This is a LTI system. Okay, Hilbert transformer is a LTI system. So do you know, when we were studying about eigenvalue and eigenfunction, if your cosinusoid or sinusoid is passed through an LTI system, how you can write down the final output? So final output is written as mode of h of omega naught cos 2t minus angle of h of omega naught. What is the value of omega naught here? Omega naught is 2. In both of the cases, omega naught is 2, right? And what is your h of omega? H of omega is minus j signum omega, right? So what will be your h of omega naught? Minus j signum 2. What is the value of signum 2? Signum 2 is 1. The graph of signum. This is the graph of signum. Basically, this graph we draw for h of omega. Basically, this is the graph of h of omega. And if I need to check at omega equals to 2, so at omega equals to 2, what you are getting? Minus j. At omega equals to 2, you are getting minus j. At omega equals to 2, this is actually this is actually f, but in terms of omega as well, the same graph you will be getting. So in terms of omega, at omega equals to 2, you will be getting minus j. So this value will be simply minus j. And signum 2 is also 1 only, so this value will simply be minus j. So h of omega naught is minus j. That means what is the magnitude? Magnitude is 1. And what is the angle? Angle is minus 90 degree, right? And here this was a plus sign. Sorry guys, this would be a plus sign. Are you able to understand this point? Basically, at omega naught which is equals to 2. So at 2 radian per second, I need to see what is my transfer function is giving me. So at 2 radian per second, my transfer function is giving me an amplitude of 1 and angle of minus 90 degree. So it is giving me an amplitude of 1. So 1 I don't need to put here, and angle of minus 90 degree. There you go. This is the Hilbert transform of cos 2t. Okay, Hilbert transform is shown by x cap t. Okay, here if I write down, so this is shown by x cap t. So Hilbert transform of xt is x cap t, which is coming out to be cos 2t minus 90 degree. What that would be? Minus sin 2t, not minus sin 2t. Sorry guys, sin 2t only. So that would be sin 2t. So basically, it is working like a 90 degree phase shifter. Hilbert transformer is working like a 90 degree phase shifter. Cos 2t you applied, and at the output you are getting cos 2t minus 90 degree. Here let's try with sinusoid. At the input what I will apply? Sin 2t I will apply. At the output what I will get? Mode of h of omega naught, right? Basically, at omega naught equals to 2, I need to see what is my transfer function is giving me. It is giving me a magnitude of 1 and angle of 90 degree. Magnitude of 1 and angle of 90 degree, minus 90 degree, angle of minus 90 degree. So this will be the output. Again, it is working like a 90 degree phase shifter, minus 90 degree phase shifter. So what is the answer you are getting? Minus of cos 2t. So Hilbert transformer works as a minus 90 degree phase shifter. Very, very important. So you will remember the graph. Okay, plus j minus j. So at the positive frequency, how much you are getting? Minus 90 degree you are getting. So in this manner, you will be able to remember. Because in the longer run, there will be confusion, sir. Plus 90 or minus 90. So how will you remember? Sir, I remember the graph. Minus j signum f. So plus j minus j. So minus j at positive frequency, it gives me minus 90 degree phase shift. So it works as a minus 90 degree phase shifter. Okay, well and good. So Hilbert transform works as a minus 90 degree phase shifter. Again here 90 degree I have written, minus 90 degree phase shifter. Taking Hilbert transform twice, basically here what I will get, x cap t, and then again I am taking Hilbert transform. So what is my yt is defined as x of t convolution with 1 by pi t, convolution with 1 by pi t. This is my yt. Okay, so if I go in the frequency domain, what I will get, let's go in the f domain only. So y of f will be x of f dot h of f, h of f. What is my h of f? H of f is minus j signum f multiply with minus j signum f, right? So x of f, minus minus will get cancelled out, j and j will become minus 1, j into j will become minus 1. So here you will get minus 1, signum f will become signum square f. What will be the graph of signum f? This will be the graph of signum f, right? Plus 1 minus 1. And if you do the square, then positive part remains the same and negative part will become positive part. So signum square f will be equals to 1. Signum square f will be equals to 1. So y of f will be equals to minus of x of f. So what will be your yt? Yt will be equals to minus xt. So what you are getting here, yt will be equals to minus xt. So if you take Hilbert transform twice, then what you will get, minus xt. And just think about it, no, let's just say xt was cosinusoid. Hilbert transform taking twice. So once if I take the Hilbert transform, I will get 90 degree phase shift. Another time if I take Hilbert transform, what I will be getting? Another 90 degree phase shift. So cos 2t minus 180 degree. What that would be equals to? Minus cos 2t only. Right? 180 minus 2t, second quadrant. In second quadrant, cos is negative. So minus cos 2t. So basically, if you take the Hilbert transform twice, what you will get? You will get the negative of xt. Okay. So if you want to remember it, you can remember it. 2 times Hilbert transform means negative you are getting. Okay. So Hilbert transform, yeah. So this statement I am not writing down. If you want to write it down in terms of statement, then you can write it down that taking Hilbert transform twice will give you negative of the applied input. Okay. The next one, Hilbert transform is a non-causal LTI system which is unstable. It is an LTI system, I already told you. If you are performing the convolution, if we are performing the convolution, that means it is a LTI system. We can perform the convolution only for the LTI system. So it is a LTI system. Why it is non-causal? Because it is defined for minus infinity to infinity. What is the value of t you can take? T you can take from minus infinity to infinity. If it was 1 by pi t ut, then scenario would have been different. But 1 by pi t, that means t goes from minus infinity to infinity. So since your impulse response is non-causal, so surely that the LTI system is also non-causal. And what is the graph of 1 by pi t? This is the graph of 1 by pi t. And if I calculate minus infinity to infinity mode of st dot dt, what it will come out to be? Undefined. Or you can say infinity it will come out to be. Undefined, I should say better. So it is not defined. So it is not bounded. Basically h of t is not bounded. Directly by the graph also you can see h of t is not bounded. So it is Bibo unstable. Right? So I should not write down Bibo unstable. I should write down, it would be unstable. Bibo stable is the word. Bibo unstable is not a word. So your system could have been Bibo stable or unstable. So it is an unstable system. Directly we can see 1 by pi t is not bounded. So why it is non-causal? It is non-causal because t can go from minus infinity to infinity. And surely it is an LTI. Okay. And Hilbert transform of an even function will be odd function and Hilbert transform of an odd function will be even function. Where is the example? Cosinusoid, Hilbert transform I took, sine to t, even, odd, odd, even. Okay. So even to odd, odd to even. Now you need to find the Hilbert transform after each block. So taking Hilbert transform twice, what do you think what I will get here? Minus sine omega t. Then again I am taking Hilbert transform, what I will get? Sine omega t. Taking Hilbert transform twice, what it will give you? Negative of the applied input. Negative of the applied input. And here you know that Hilbert transform works as a 90 degree phase shifter. So sine omega t minus 90 degree, what that would be? Minus cos omega t. And here what you will get? Sin omega t minus 90 degree minus cos omega t. So this will be plus cos omega t. So it is very easy. You would have started 90 degree phase shift, then again 90 degree phase shift, again 90 degree phase shift, again 90 degree phase shift. Okay, well and good. So yeah, that's the end of Hilbert transform. So for this first 30 minutes, we discussed signals and system only, right? So everything about signal system that will be used in our power spectral density that we have discussed. Now we will get started with power spectral density. So what does your power spectral density represent? So power spectral density, let's study about PDF. Do you remember the PDF? Probability density function. So it used to represent how dense your probability is. About the value of x, how dense your probability is. Near at the value of let's just say x equals to x1. So near x equals to x1 there is very high probability. That means it is very high probable that random variable x will be taking value x1. It is very high probable that random variable x will be taking value x1. Right? This is what probability density function used to represent. Now we are studying about power density function. Power density function. Power density function. PSD. Power density function. So power density function would represent the density of power around what? Around frequency. Okay. Density of power around frequency. So how the power of random process is distributed over different frequency range. So let's just say if I make a graph of a PSD like this. PSD is represented by x of f or x of omega. So I am representing x of f versus f. So I am representing the graph something like this. That means around the frequency f equals to x1, around the frequency f equals to f1, there is a lot of power involved for a particular random process. So this is the meaning of PSD. So PSD represents the density of a particular power, density of power of a particular random process with respect to frequency. For a random process, density of power with respect to a frequency. Okay. So how the power of random process is distributed over different frequency range. So this is the meaning of power spectral density. So how do you calculate power spectral density? So first what you will do, x of t is a random process given and power spectral density is only defined for WSSRP. Okay, it is only defined for wide sense stationary random process. Is that clear to you? Power spectral density only defined for WSSRP. So x of t is a WSSRP, it is given. So if it is given, can you find out its autocorrelation function? Surely I can find out its autocorrelation function. I will get Rx of tau. What you need to do, you need to take the Fourier transform of Rx of tau. What you will get? X of omega, or you will get x of f. And this is known as your power spectral density. Okay, power spectral density. Very simple. From the random process, you get the autocorrelation function, you take the Fourier transform, you will get power spectral density. So what do you think, what will be the formula of x of omega, Sx of omega? So that would be minus infinity to infinity Rx of tau e to the power minus j omega tau d tau. So yes or no? Formula of Fourier transform you already know, right? Rx of tau e to the power minus j omega naught tau d tau. Now what will be the formula of x of f? So that would be minus infinity to infinity Rx of tau e to the power minus j 2 pi f tau d tau. And from here what will be the formula of Rx of tau? So Rx of tau. So if I am writing down in terms of x of omega, s of omega, I will call it s of omega, s of f. I will not call x, okay, because it is tough to call sx omega. So I will call s of omega, s of f. Okay. So what will be the formula? The formula will be, if I am writing down in terms of s of omega, so what I will write down? Minus infinity to infinity s of omega e to the power j omega to d omega. Because I will put the limit of omega, I will get the answer in terms of tau. But I told you, whenever in the integration you see omega, never forget to put 1 by 2 pi outside. And in terms of f, what will be the formula? S of f e to the power j 2 pi f tau df. Okay, so this is the formula. Now what is the total power of xt? What is the mean square value of xt in terms of autocorrelation function? That is Rx of 0, right? In place of tau you put 0. So in this formula, in place of tau if I put 0, what I am getting? 1 by 2 pi minus infinity to infinity. In this formula, in place of tau if I am putting 0, what I am getting? 1 by 2 pi minus infinity to infinity s of omega d omega minus infinity to infinity s of f s of f df. Is that clear to you? So if a graph of power spectral density is given, can you find out the total power of xt? So for finding out the total power of xt, what you will do, you will calculate the whole area and then divide by 2 pi. And if the graph is given in terms of f, you will just calculate the whole area. So total power of xt is given by the total area of the power spectral density graph, and it will be made with respect to f. The graph will be made with respect to f. So what will be the unit of power? That would be watt, right? So this should throw watt. This whole x of s, x of f versus f. So you will calculate the area. This whole area should throw watt. So what do you think? What will be the unit of s of f? That should be watt by hertz. Because if this unit is watt by hertz, then multiply with hertz. What you will get? Watt only. Right? Watt per hertz multiply with hertz. What you will get? Watt. So total area under the curve, that is throwing watt. So watt per hertz multiply with hertz. So what is the answer you will be getting? Watt per hertz. Okay, so what is the unit of x of f? This is the unit of x of f. What is that? Watt per hertz. Okay, this is the unit. Now important property, it is defined only for WSSRP. Since it is power, what is x of f? What is s of f? What is your PhD? PhD represent the power, no? So since it is power, it will always be positive. It will always be positive. Positive or 0. Since it is power, it will always be positive or 0. Now you know that Rx of tau is equivalent to Rx of minus 2. Rx of tau is a even function. So if you take the Fourier transform, what you will get? X of f is equals to x of minus f, or you can put it x of omega, s of omega, s of minus omega. What does that mean? That this will also be a even function of power. Even function, power spectral density is also a even function. Very simple thing. And what is the formula of total power? Total power is given by expectation of x square t minus infinity to infinity x of omega d omega. If you see x of omega, whenever you see omega, what do you put? 1 by 2 pi. So this is the formula of total power. All these things are clear to you? Okay. So what all are the two things? That always positive and even. Always positive and even. And in case of Rx of tau, what was the condition? That Rx of 0 will be greater than any one. That means this will be the peak, and Rx of tau will be equals to Rx of minus 2. So here it could be positive, sorry, it could be negative. It could be negative. Rx of tau could be negative, but this cannot be negative. It is always positive. Along with that, Rx of 0 needs to be peak, but here x of s of 0 needs not to be peak, right? What I mean to say is that graph has not to be like this, that at 0 you should get the peak. No, at some other point as well you can get the peak. Okay, at some other point as well you can get the peak. So basically you understand, no, what is the basic definition? Basic definition means with respect to the frequency, how your power is distributed. With respect to the frequency, how your power is distributed. So it's not necessary that all the power will be at f equals to 0. No, power could be at some other point as well. No, so peak can be anywhere, but here in terms of Rx of tau, peak has to be at Rx of 0. because Rx of 0 was representing the total power. So if it is the total power, then it has to be the peak. But in terms of power spectral density, F equals to 0 need not to be the peak. It could be anywhere. The peak could be anywhere. Okay. So these are the difference or properties, whatever you can call it. So will you be able to keep in mind? These were the property of Rx of 2, and these are the property of your power spectral density. More properties we will see. You need to have some patience. Okay. But let's solve a problem first. Let's solve a question. So find the mean of xt, variance and mean square value. Forget about power spectral density. Without even studying power spectral density, can you find the mean of xt, variance and mean square value? Surely I can find with the expression of Rx of 2. Can I find the mean directly? That sir, constant value will represent the mean. What I mean to say is that I told you one thing, that constant value in autocorrelation function will represent the mean only when xt is having no offset. Right? We have done the discussion on this one. So here it should be given that xt is a WSSRP. First thing, this should be given with no offset. Offset means a particular constant value. So there should not be any addition of any constant value. So if it is not having any offset, then you can say it. So mean would be plus minus 2. This would be the mean. Right? What about the mean square value? So for mean square value, what you need to do? Mean square value will be Rx of 0. Right? So 4 plus cos 0 is 1. And you solve this, you can do it on your own. You will get, basically at 0, what you can do is that you cancel tau by tau and then forget about sine. This is the answer, you will get 2 by pi at 0. Basically this will be 0 by 0 form, right? Sine 0 divided by 0. So you need to apply L'Hopital rule. This we have already discussed. I will apply L'Hopital rule. I will differentiate sine 2t. What I will get? 2 cos 2t. 2 cos 2 tau divided by pi. So here tau is gone, and then tau equals to 0 I will put. So cos 0 is 1. So what I will get? 2 by pi. So this is how I remember. Whatever that I get here, no, that is my final answer of tau equals to 0. So what I am getting? 6 plus 8 by pi. Okay. 4 plus 2, 8 by pi. 6 plus 8 by pi. So this is your mean square value. Now variance. So variance will be mean square value minus 4. So 2 plus 8 by pi. Now what I need to find? PSD I need to draw, and I need to find the expression as well. So what do you know? That if you take the Fourier transform, what do you get? S of omega or S of f. So this is the formula given. One has a Fourier transform of 2 pi del omega, right? So 4 will have a Fourier transform of 8 pi del omega. Say yes or no? Right? Well and good. What about this one? Cos 4 tau. So do you remember the Fourier transform of cos omega naught tau? We are writing down in terms of omega. So what was the answer? Pi del omega minus omega naught plus del omega plus omega naught. So what do you think? What will be the answer? So 8 del 8 pi. Sorry, not 8 pi. Sorry guys. Cos omega naught tau. Cos omega naught tau. So pi will come here. So 2 pi del omega minus omega naught del omega plus omega naught plus sine 80 by pi t, right? Sine 80 by pi t multiply with 4. Sine 80 by pi t. This is the standard form. We already know it. So what I am saying, this is my pt. This I am calling as pt. So this will have a Fourier transform of p omega. What is your p omega? You can surely make. What will be my p omega? P omega will be simply sine 80 by pi t. Sine 80 by pi t. So it will go from minus 2 to 2. It will go from minus 2 to 2. Minus 2 to 2 with the amplitude of 4. So how I can write it down? 4 rect omega minus center upon complete width. That would be omega by 4. So 4 rect omega by 4. So what will be the answer you will be getting? 4 rect omega by 4. So my p of omega will be 4 rect omega by 4. omega minus center upon complete width. And let's forget it because we have already seen it. So this is the answer in terms of omega. What will be the answer in terms of f? What will be the answer in terms of f? So for that, what you will do? Here, 1 is having a Fourier transform of del f, right? So what do you do here? 4 will have a Fourier transform of 4 del f plus cos 4 2. So our form was cos 2 pi f naught 2 will have a Fourier transform of del f minus f naught plus del f plus f naught divided by 2. So what will be the value of f naught here? What will be the value of f naught? If I compare with the 2 pi f naught equals to 4, 2 pi f naught equals to 4. So value of f naught will be 4 by 2 pi. So what you will be getting? Here 1 by 2 will come, so 2 and 2 will get cancelled. So delta of f minus f naught. What is the value of f naught? F naught value is 4 by 2 pi plus delta of f plus f naught 4 by 2 pi. And in terms of a rect, I need to write down. So this answer I will be getting sin 80 by pi t. So this is in terms of omega. This is in terms of omega. If I need to make it in terms of f, then what I will do? I will get the same graph. I will get the same graph and then divide by 2 pi. So it would be minus 1 by pi plus 1 by pi. So this will be your P of f. So what will be the answer? 4 rect f minus center upon, basically I divided by 2 pi. So what I am getting? What is the width? 4 by 2 pi. 4 by 2 pi. So here you can put 2 pi. 2 pi f. Basically in terms of omega you are putting 2 pi f, nothing else. But the graph, representation of graph will be different. Are you getting this point? So these are the expression x of omega, s of omega. This is the expression of s of omega and this is the expression of s of f. So expression will not be given, but the waveform will be given. The important part is we need to make the waveform. So let's make the waveform. And here I will make the waveform of x s of f. So 8 pi del omega, 8 pi del omega, 8 pi del omega. Then two more impulses are there at omega equals to 4. The amplitude will be 2 pi. 2 pi here and 2 pi here. 4 minus 4. And then this rectangular graph between minus 2 to 2 with the amplitude of 4. Minus 2 to 2 with the amplitude of 4. Minus 2 to 2. With the amplitude of 4. So this will be the scenario. If I want to find the total power, what I will do? I will calculate the area of everything. Total power. Total power. From this graph, what I am doing? I am finding the total power. What I will do? I will calculate the area of everything. Impulse of 2 pi. Impulse of 2 pi. Plus impulse of 8 pi. Plus what will be the area? 4 into 4, 16. Then divided by what? 2 pi. Do you remember the formula? Calculate the whole area, but don't forget to divide by 2 pi in terms of omega. Whenever you solve in terms of omega, I told you this is the area, but whenever I solve in terms of omega, I will never forget to divide by 2 pi. Whenever I solve in terms of omega, I will never forget to divide by 2 pi. So divide by 2 pi will also come, right? So what is the answer? 8 by pi. 16 by 2 pi will give you 8 by pi. 10, 12, 6. Okay. So 8 by pi plus 6. 8 by pi plus 6. This was the total power. So just the whole area divided by 2 pi. If I need to find the DC value, what I should do? What do you think? What is the DC value? Plus minus 2. DC value is plus minus 2. Or you can call it DC power. So DC power is 4. If I need to find the DC power, what I should do? DC power. Basically, if I need to find the value of mu x square, what I should do? From 0 minus to 0 plus. From 0 minus to 0 plus x of omega dot d omega. In the integration, whenever you see x of omega, don't forget to divide by 2 pi. Why I am doing so? Because you see Rx of tau, this was responsible for your DC power. Considering the fact that xt is having no offset, this was responsible for your DC power. Say yes or no? Mu x square was equals to 4, because I told you whatever the constant value you get, that is the DC power. So whatever the constant value we are getting, that is the DC power, considering the fact that xt is having no offset. So now when you convert it into the Fourier transform, so whatever the impulse that you are getting at omega equals to 0, the impulse at omega equals to 0 will be responsible for the DC power. Can I write down this line? The impulse at omega equals to 0 or f equals to 0 will be responsible for DC power, considering xt has no offset. Say yes or no? If xt is having no offset, then this would be the DC power. This will be responsible for the DC power, right? So what I am simply doing, I am calculating the area, then divide by 2 pi. So this will be my DC power. So what is the area of the impulse? Impulse at omega equals to 0 only, not these impulses. Impulse at omega equals to 0 only. So 8 pi divided by 2 pi. What you are getting? 4. So mu x will be plus minus 2. Is that okay for you? Right? And similarly, you can draw the graph in terms of f as well. So what graph you will be getting? So you can see that impulses are there at omega equals to 0, impulses are there at 4 by 2 pi, and this is the rectangular graph you will be getting. So what I can do? So wherever we are getting the impulses, I will divide by 2 pi. So this is how we convert from omega domain to f domain. So wherever you get the impulses, you divide the area by 2 pi. So if you divide 8 pi by 2 pi, what do you get? 4. Here would you get 1, 1. And you can cross check. Here you get 1, 1. Right? Impulses, the area of impulses will be divided by 2 pi. And here axis, complete axis will be divided by 2 pi. Nothing else you need to do. And you can cross check now. At 4 by 2 pi and at plus 4 by 2 pi and at minus 4 by 2 pi, the area of the impulse is 1. At f equals to 0, the area of the impulse is 4. And in the rectangular graph, this was the amplitude 4. So only the area of the impulse will be divided. Okay, rest all things will not be divided. Are you able to understand this point? What is the area of this impulse? 2 pi. What is the area of this impulse? 2 pi. Divided by 2 pi, 1, 1. What is the area of this square waveform? 16, right? Area of this square waveform. What is the area of this square waveform? 16 by 2 pi. So actually area is already divided. When you go from omega to f domain, the area is divided by 2 pi. The area is divided by 2 pi. So in the impulse, this is not the magnitude, this is the area. So I need to divide by 2 pi. This is the area, I need to divide by 2 pi. This is the area, I need to divide by 2 pi. But this magnitude I will not divide by 2 pi. Are you able to understand this point? This magnitude I will not divide by 2 pi. Why is that so? Because if I divide the magnitude by 2 pi, then my area will change. But my area should be, if this is 16, this has to be 16 by 2 pi. Say yes or no? Understand? So it is coming out to be 4 into 4 into 4 into 4 divided by 2 pi, 16 by 2 pi only. Okay. And another thing I need to take care is that this should be better, because both are having, basically impulse is having an area of 4, right? Impulse is having an area of 4. Along with that, this amplitude is also 4, no? This amplitude is also 4. So this is how I need to make it. Okay, this amplitude is also 4. Area and both are 4 only. From here, if I need to get the total power, so what I will do? I will just calculate the whole area. What is the area? Area of impulse 1, area of impulse 1, area of impulse 4, and area of this is 16 by 2 pi. So what is the answer you are getting? 6, 8 by pi. So this is the total power. And what about mu x square? So that would be 0 minus 2, 0 plus S of f dot df. So S of f, if it is in the f domain, you don't need to divide by 2 pi. So just tell the area of this one, that is 4. So mu x square is equal to 4. So mu x is coming out to be plus minus 4. So what did you understand? From the graph, what will be the total power? What will be the total power? The total power will be 1 by 2 pi whole area of S of omega. And in terms of f, if I need to write down, then simply the whole area under the curve. What is this? This is representing area under the curve, and this is also representing area under the curve. And what about the DC power? DC power will be 0 minus to 0 plus x of omega d omega 1 by 2 pi 0 minus to 0 plus x of f df, right? So what is this? Area of impulse, I need to take it down, area of impulse at omega equals to 0. And what is this? Area of impulse at f equals to 0. Okay, divided by 2 pi. Now is this line correct? Not completely correct. For making it completely correct, what I need to do? Considering the fact that all this will work, considering the fact that xt is having no offset. Xt is having no offset. Then this line is correct. This line will always work, but for this line, there is a condition that xt is having no offset. This will always work. There is no condition. But for this one, for defining the DC value, you need to tell that xt is having no offset. Otherwise, if there is some offset, then it will disturb the DC value, right? And what is the variance? Variance is simply this thing. Okay. So let's see the summary of everything that we have studied. So this will be the slide that will summarize everything. So this 1 hour of discussion will be just summarized within 2 to 3 minutes. So if autocorrelation function is given, I can take the Fourier transform in terms of omega domain or in terms of f domain. What I will get? I will get the power spectral density. If I take the inverse Fourier transform, what I will get? Rx of 2. Formula of Fourier transform, inverse Fourier transform, you already know, right? For mean square value, what does that mean? Total power. So for total power, what you will do? You will take the complete area under the curve in the f domain, but in the omega domain, you will take the complete area but divide by 2 pi. So S of omega d omega. For mean, what you will do? You will take the area of the impulse in f domain. Okay. In the omega domain also, you will do the same thing. ये क्या कर रहा हूँ भाई मैं? S of f, right? you will have the PhD, you will take the area, you will have the PhD, you will take the area of the impulse at omega equals to 0, at f equals to 0, and then here in terms of omega you will divide it by 2 pi. But all these will be true considering the fact that xt is having no offset. Okay, and this PhD is always greater than 0, or you can call it in terms of omega as well. This is always greater than 0 and it is always even as well. Okay, it is always even as well. Another point, peak need not to be necessary, need not to be necessary at omega equals to 0 or f equals to 0. But in case of autocorrelation function, this was the condition. But this is not the condition in your PhD. Okay, so what is the PhD? PhD is simply the Fourier transform of your autocorrelation function for a WSSRP. Then these are the things that we have studied, right? So which of them is a valid PhD? So what all are the two conditions for valid PhD? First condition is always greater than 0. So plus 1 minus 1 gone. Always greater than equals to 0, hold on here. Okay, this is also always greater than equals to 0. Is this always greater than equals to 0? Yes, you can never get the value negative. Here also you can never get the value negative because cos square omega will always be positive. E to the power anything is always positive. E to the power minus alpha always positive, because this is the graph of e to the power, either like this or like this. So it will always be positive. So positive into positive will be positive. So first condition is satisfied in 3 options. Second one is even. So is it even? In place of omega if we put minus omega? Yes. Is it even? In place of omega if we put minus omega? Yes. Is it even? In place of omega if we put minus omega, will you get the same graph? This graph is saying between 0 to 2 you get 1 and otherwise you get 0. So is this graph even? No. For even graph this should have been the scenario, no? But this is not even, and since this is not even, then this will be gone. So these are the two conditions that needs to be satisfied. Okay, well and good. Let's see this question. S of omega is given. All these things will be mentioned that xt is WSSRP, which is having Rx of tau, and this is your PhD that they have drawn. You need to tell the average power. What is the meaning of average power? Average power means, what is the meaning of average power? Average power means total power. That means mean square value. And what is the meaning of DC power? DC power means mu x square. But sir, this graph is not valid. So it may happen that in the examination they will give the graph of only one side. So if they are not giving the graph of other side, then you have to make it. Okay, because you know that it will be even. So just make the same graph. Are you able to understand this point? In the examination it might happen that they give the graph of only one side. So if they are giving the graph of only one side, you have to make the graph of other side. Just wait a second guys. Yeah, so what I was saying that we need to make the graph. We need to make this graph completely, right? So we are making this graph completely. So this is your minus 2, minus 3, minus 2.5. Basically the same graph I need to make, nothing else. So in the examination it might happen that they will give the graph of only one side. So there you will not argue that sir this PhD is not valid. This PhD is valid only, they just gave the graph of one side only. Okay, there will not be any option that PhD is not valid. The options will be some values, or it could be integer type as well. So there you cannot argue there, right? So this graph is given in terms of omega. This graph is given in terms of omega, and you need to find the total power. You need to find the total power. So what you need to do? Calculate the whole area, then divide by 2 pi. So impulse area 4, impulse area 4, 4 plus 4. Don't forget anything. Impulse, done. Now the waveforms. So what is the area of this waveform? 4, right? 2 into 2. So I will write down 2 into 2 actually. Plus, because 2 into this length is also 2. What about this area? So this area will be twice. Why 2 into? Because whatever the area you get here, the same area you will get here as well. So 2 into 1 by 2 into base into height. Total area you have got, then divide by 2 pi. This is your total power. Okay, so what is the answer coming out to be? 12, 14. So answer is 7 by pi. Okay, this answer is wrong actually. Multiply by 10 to the power 3 as well, right? Multiply by 10 to the power 3 as well. This answer went completely wrong. Why it went wrong? Because I did not notice here. This is 10 to the power 3, no? Are you able to understand this point? So this area is 4. This area is also 4. So 4 plus 4, no doubt about that. But what about this area? This area will be 2 into 2 to the power 3. Right? Because this width is 2 into, this is actually 10 to the power 3. This is actually 2 into 10 to the power 3. This is 2.5 10 to the power 3. 3 into 10 to the power 3. Right? So 2 into this width. What is this width? 2 into 10 to the power 3. So 2 into 10 to the power 3. So this area will be 2 into 10 to the power 3 plus 2 into half into base into height. What is the base? Base is actually 10 to the power 3 into height. Okay, so 2 into half into base into height. Height is, base is 10 to the power 3, height is 2. Divide by 2 pi. That is the power. Okay, so this is 8, 4 into 10 to the power 3 plus 2 into 10 to the power 3. 4 plus 4, 8, 4 into 10 to the power 3, and this is 2 into 10 to the power 3. So you are getting 6 into 10 to the power 3. So answer is 8 plus 6 into 10 to the power 3 divided by 2 pi. 4 by pi plus 4 plus, so this will be 3004, right? 3004 divided by pi. And here this unit will be surely watt per radian into second. This unit will be, here unit will be watt per radian into second, because this is radian per second. So watt per radian into second will be multiplied with radian per second. So what will be the answer? Watt. If it is milliwatt, then you can write it down as milliwatt as well. So let's check the calculation again. 4 plus 4, what is the area here? 2 into 10 to the power 3. And what is the area here? Half into 10 to the power 3 into 2. And then twice. So what you are getting? 2 into 10 to the power 3. 6 into 10 to the power 3. 4 plus 4 is 8 divided by 2 pi. So on the upper side you are getting 6000 plus 8, 6008, then divided by 2 will be 3004 divided by pi. So this is the answer you are getting. Okay, this is the average power. What about the DC power? So xt is WSSRP plus no offset. This should also be given. So if there is no offset, then what I can apply the formula? The formula says 1 by 2 pi 0 minus 2 0 plus x of omega dot d omega. So what will be this area? 0 minus 2 0 plus. So length is 2 but width is 0. So 2 into 0, answer would be 0 only. Basically if there is no impulse, then area will be 0 only. No, only from 0 minus to 0 plus, only one guy can give you the area, and that guy is impulse. If there is no impulse, that means area will be 0. Let's just say here there was an impulse of 2, so answer would have been 2 by 2 pi. So answer would be 1 by pi. So DC power would have been mu x square 1 by pi, but there is no impulse, so answer is 0. But this no offset condition is very important, because I have seen this formula in a lot of notes. This formula is there in a lot of notes, not this formula. This formula is there in a lot of notes. This is always valid. But this formula also people write down, but they don't understand the condition that xt should have no offset. In the examination, what may happen is that they will give that xt is having a mean of 3, and this is their graph. This is the graph of their PhD. What I am saying, in the examination it is written that xt is having a mean of 3, and this is the graph of x of omega, s of omega. So there people will argue from 0 minus to 0 plus area is coming out to be 0. So how the mean can be 3? Mean can be 3. What do you understand from here? That means there is some offset for sure. That's why the mean is 3. Are you able to understand this point? The area for total power remains the same. The area for total power will always be valid. But that constant part in Rx of tau, that constant part in Rx of tau This will represent DC power only when there is no offset. If there is some offset, then that offset can disturb a lot of things, right? So if in the examination is mentioned that xt is a WSSRP having a mean of 3 and this is the graph, then you should not be worrying there that sir there is no impulse at omega goes to 0. So how the mean could be non-zero? Yes, mean could be non-zero because of the offset. So offset can make the mean non-zero. Okay. Yeah. So all these things we have done. Okay. This question is done. Very simple. So just to calculate the total area, that will be the total power, nothing else. Now yt is equals to minus 3xt minus 2zt. What will be the PhD of yt considering xt and zt are orthogonal? This is something that we have studied in the last lecture. If yt is defined as axt plus bzt, so what will be its autocorrelation function? That would be a square rx of t plus b square rz of t, right? This formula is valid, plus other terms will also come, plus cross correlation terms will come, plus cross correlation functions, but this will be 0 when xt and zt are orthogonal. So what will be the answer? This will be the final answer. And from here, if I need to find sy of f, what that would be? A square sy of omega. This will be the answer. Okay, well and good. So this we will be using somewhere in one of the problem solving. We will be using this particular answer. So here, what would be the answer? Sy of omega I am writing down. That would be a square, that would be 9, plus b square, that would be 4. This would be the answer. Let's go to the next question. xt is WSSRP. X s of f is given as 1 by w when your f is between minus w to w. You need to find this value. What do you think? What this represent? Can you see? This is representing actually rx of 1 by 4w. Say yes or no. Basically, you need to find the value of rx of 1 by 4w. This is your target. And this graph is already given. What is the graph of PhD? So graph of PhD is this is the graph of PhD between minus w to plus w. Between minus w to plus w, it is giving you an amplitude of 1 by w. Between minus w to plus w, it is giving you an amplitude of 1 by w. So this is the graph in terms of f. But what we remember? We remember the formula in terms of omega. Go to the first slide. This formula that we write down in terms of omega, sin 80 by pi t, right? Sin 80 by pi t whole square in terms of omega. So what I will do? The graph is given in terms of f, but I will convert it in terms of omega. So what I will do? Omega. So if I am converting into omega, so multiply by 2 pi. Basically, from you go omega to f, omega is equals to 2 pi f. So if the value of f is w, then value of omega will be 2 pi w. If the value of f is w, then omega will be 2 pi w, right? So this will be 2 pi w, this will be minus 2 pi w. 2 pi w. So from here, what would be my Rx of 2? What I am taking? Kind of I am taking inverse Fourier transform. What would be my inverse Fourier transform I am taking? So what would be my Rx of 2? So smartly I have to write down. What is the amplitude? Amplitude is 1 by omega. Sin 80, sin A 2 divided by pi 2. Sin A tau divided by pi tau into 1 by omega. This is the answer we are getting. All good, all fine. If this particular graph, if this particular function was given and I ask you to calculate the Fourier transform, will you be able to calculate the Fourier transform? So amplitude is 1 by omega sin a tau by pi tau. So sin 2 pi w divided by pi tau. So 2 pi w would be this one. Well and good. What I need to find? Pi into Rx of 1 by 4 omega. So pi into Rx of 1 by 4 omega. Okay, so what we are getting? Oh, pi by omega into 4 omega by pi. So this 4 omega by pi, pi by omega into 4 omega by pi. So this get cancelled. Sin pi by 2 you are getting. Sin pi by 2. So sin pi by 2 is 1. Pi. Answer is coming out to be 4. So what is the answer? This is the answer, which is 4. Very simple. Let me explain it again. This is something I needed to find. I got to know that xt and another sample is being sampled at 1 by 4 omega. Actually, this is Rx of minus 1 by 4 omega, which will be equivalent to Rx of 1 by 4 omega you call it, or W you call it, whatever you can call it. So this is something that I need to find. Then I know that I am having the PhD. From PhD, if I take the inverse Fourier transform, I will get to my autocorrelation function. So PhD was given, I draw the graph. It was given in terms of f, I will convert it into in terms of omega, because the standard form I remember in terms of omega. So to write down the standard form, 1 by omega is the amplitude, sin a tau by pi tau, a tau by pi tau. What is the value of a? 2 pi omega divided by pi tau. Now in terms of in place of tau, what I need to put? 1 by 4w, 1 by 4w. So 1 by 4w I put, this get cancelled, this become 1 only, and here if I put 1 by 4w, what I get? 1 by 4w if I put, I get 4 by pi, and then it will be multiplied with y, so answer will be 4. Okay, let's go to the next question. Yt equals to x of 2t minus 1. Find sy of f in terms of s of f. PhD of y in terms of PhD of x. So directly you cannot go, no. First you need to find out autocorrelation function. What I mean to say is that from Yt, if I need to reach towards PhD, what I need to do? First you find out the autocorrelation function, and then you go to sy of f. This is the target, right? This is how we proceed. Here you find out the Fourier transform and you will reach it. So first my target would be Ry of tau. So what would be my Ry of tau? Expectation of Yt into y of t plus tau. Expectation of, what is Yt? X of 2t minus 1, x of 2t plus 2 tau minus 1, right? Now what is the difference? Difference is 2 tau. So what is the answer you are getting? Rx of 2 tau. So your Ry of tau is equivalent to Rx of 2 tau. So if I take the Fourier transform here, and if I take the Fourier transform here as well. So if I take the Fourier transform here, what do I get? Sy of f. If I take the Fourier transform here, what do I get? 1 by 2 sy of f divided by 2. Which property I applied? If x of t is having a Fourier transform of x of f, then x of 2t will have a Fourier transform of 1 by 2 goes outside, x of f by 2, right? So this property we applied. This property we applied. This is the array R. This is x, s of f by 2, s of f by 2, s x of f by 2, sy of f. So this is the answer. Okay, very simple. Let's go to next one. This is the next topic. What we will do? We will pass our x of t, which is a WSSRP, passing xt, which is WSSRP, through a LTI system, and this is the impulse response of LTI system, and it is deterministic signal. So comment on Yt. So we have already commented on the autocorrelation function of Yt, right? So all these terms we already know, that we will write down. Now we need to comment on the PhD. So very simple, yt is equals to xt convolution with ht. If I need to comment on the PSD, first I will require the autocorrelation function. So what is my ry of tau? So your ry of tau was given as first term rx of tau convolution with second term h of tau convolution with h of minus 2. What was your rxy of tau? So rx will say that sir I will come here and I am at first, so I will be happy, so no inversion. Here what will happen? Ryx of tau will say that sir rx of tau will say that sir I will come first, but here I am not first, y is first, so I am not happy, I will do this thing. Now from these two expression, can you write down the expression of ry of tau? So yes, I can write it down. Rxy of tau convolution with h of minus tau and ryx of tau convolution with h of tau. So these are the things we already know. What I need to do now? Just I need to take the Fourier transform. There you go. Just take the Fourier transform. If I take the Fourier transform of both of the side, if I take Fourier transform on both of the sides, so what do I get? Sy of f is equal to convolution in time domain will result in multiplication in the frequency domain. So Sx of f dot h of f dot h of minus f. H of minus f. Ht is real, okay, impulse response, it is real. We will talk about real impulse response. So if Ht was real, then Ht was equals to h conjugate t. H of f was h conjugate minus f. So h of minus f was h conjugate f. So this h of minus f could be replaced with h conjugate f, right? So what you are getting from here? Dot h of f dot h conjugate f. X multiply with x conjugate, what do you get? Mod of x whole square, right? Basically 2 plus 3j multiply with its conjugate 2 minus 3j. So what I can do? First you take the mod of 2 plus 3j, that would be 4 plus 9, and then you take its square. So similarly here what I will get? Mod of h of f square. So your sy of f is coming out to be mod of h of f square multiply with x of f. So this is a very, very important conclusion that we have made. Very, very important. Okay. Whatever the PSD of input is given, you find out the Fourier transform of this impulse response, take its magnitude, do the square, and then multiply both of them, you will get the PSD of output. We will solve like 10 to 15 problems on this concept. So it will be remembered, 100% it will be remembered to you. Okay. From here as well you can get the results. Whatever the result that you are getting, you can write down. But this result is the most important. These could be mentioned in the options, that what would be Rxy of tau. Basically what would be, they can ask is that, let me take it a bit this side. Okay. So this was a very important discussion. Here what they can ask, that what will be the expression of xy of f. Directly they will give that there is a LTI system, you are putting a x of t, you are getting y of t. What will be the expression of xy of f? That means PSD of, basically it is PSD in terms of cross correlation, right? Cross correlation, you are finding cross correlation and then you are getting the PSD. So there is no exact name, you cannot call it cross PXD. So basically I am representing by S xyf. What that would be? That would be Rx of f, not Rx of f, Sx of f. Convolution in time domain will result in multiplication in frequency domain. Okay, very simple. Here what will be the Fourier transform? Fourier transform will be S of f. What will be the Fourier transform? H of f. Here also you can do the same thing. Fourier transform only we need to take. What you will get? S yx of f would be equivalent to Fourier transform of Rx tau will be Sx of f dot h of minus f. And from here what answers you can get? From here answers, ये क्या हो गया? Ry of tau. It was Ry of tau. So from here what all answers you can get if I take the Fourier transform. If I take the Fourier transform. So Sy of f will be Sxy f dot not multiplication, dot h of minus f s y of f dot h of f. This is the answer. Okay, but this is the most important one. I hope I have written down as a conclusion as well. Yeah, we will write down as a conclusion as well that there is a LTI system. You are applying a WSSRP, you are getting a WSSRP at the output as well. This will also be WSSRP. If I ask you to find the PSD of PSD of the output, so what you will do? You will take the PSD of input, multiply it with impulse response. So what you will get first? First you will get the transfer function, and then you will do the square of that transfer function, and you will get your output. Okay. So let's write down the conclusion. Xt is passed through Ht. What is the output? Xt convolution with Ht. What is the output in terms of cross correlation? So what will be Ry of 2? Sorry, not cross correlation, autocorrelation. What will be Ry of 2? So Ry of 2 will be Rx of 2 convolution with H of 2 convolution with H of minus 2. So kind of what is happening? H of 2 convolve with, it is just an analogy, okay? This is how it will never be represented in the examination. This way will never be represented in the examination. This is just an analogy, that Rx of 2, H of 2 convolution with H of minus 2. Now what about this one? Sy of f. So what you are doing? You are simply multiplying with, first you take the transfer function, then you do the mode, and then you do the square. Okay. Here also similar thing you can do in terms of omega as well. Similar analysis you can do in terms of omega as well. Here what you will write down? S of omega dot h of omega dot h of minus omega, S of omega dot h of omega dot h conjugate omega. So mode of h of omega whole square, S of omega. Okay. So will this be there in your mind? We will solve a lot of questions. Surely it will be there in your mind. Okay. So total power of yt. What do you think? What will be the total power of yt? So total power of yt would be minus infinity to infinity. This total power I am talking about, minus infinity to infinity, Sy of f dot df. Or you can write down 1 by 2 pi minus infinity to infinity Sy of omega dot d omega. Right. Say yes or no. Now you can replace it somewhat like this. Basically you can put the formula. No, why I am writing down? You can simply put the formula. You can simply put these formulas. Well and good. You can put the formula and you can calculate it. Basically total power will be simply the area of area under the curve. In terms of omega it will be divided by 2 pi. In terms of f it will not be divided by anything. Let's see the questions. With respect to question it will be more clear to you. Yeah, sorry for the interruption. So now we need to solve this question. We need to find the PSD of output yt. Okay, and autocorrelation function of input is given. That means basically if I get the Fourier transform here, what I will get? PSD of input is also given, right? What would be your S of f? Sx of f. What that would be? E to the power minus pi t square. E to the power minus pi f square. You can convert it into the omega, but we are going to solve it in terms of f. So PSD of input is given. You need to find the PSD of output yt. This is the question. So xt is going through a particular system and it is producing output yt. So xt is going through a particular system and it is producing output yt. So what is that system? I don't know. Xt, there is some system that could be pt and it will represent the output yt. So your output yt will be, why I am not representing by ht? Because you know that h of f is given here. No? So this is the transfer function of this system. So here I will represent that this will be the impulse response. That's why I am not representing by h of t. Here I am representing by p of t. So xt convolution with pt. And if I ask you what will be my Sy of f? So you will say that sir, Sy of f will be mode of p of f whole square Sx of f. Here only we derived it. Sy of f will be mode of this transfer function whole square multiply with the power spectral density of input. Power spectral density of input, right? Someone will say that sir, what I will do is that that I will find ry of tau, rx of tau, convolution with p of tau, convolution with p of minus tau. I will get this value and then I will take a transform. Then I will take the Fourier transform and I will get my Sy of f. Why would you do all these things? First you need to find Pt, right? Then you will convert it into P tau, then convolve with P of minus tau, then convolve with Rx of tau, and then you get the final answer. What is Rx of tau? E to the power minus pi tau square. Do you think convolution is that easy? Basically, e to the power minus pi tau square, e to the power minus pi tau square being convolved with a particular signal, then another signal. Do you think it will be very easy to solve? No, this path will be very difficult. So we will always consider all the possible path. If I consider this path, then I go to know that it is very difficult. Then what is the other way? Even if like they are asking PhD, what if they are asking Ry of tau? What if they were asking Ry of tau as well? So in this question you need to find Ry of tau as well. So would you still go here? Would you find out Ry of tau in this manner? I will still go to PhD and then I will calculate inverse Fourier transform. I will get my Ry of tau. Because I know that directly Ry of tau is difficult. So first my target would be to getting the PhD, because I know the PhD of input. I just need to multiply by mod of Pf whole square. So can I get Pf? Yes. What is your Pf? What is happening here? X of t is being convolved with ht. X of t is being convolved with xt. Then x of t directly goes here and then you get output yt. So what is your output yt? Output yt is x of t convolved with ht minus xt, right? Because this part is coming with positive sign, this part is coming with the negative sign. So this is your output yt. This is the sign of summation, okay? This is a summer. Now what I need to find? I need to find this Pf. So what I need to do? I need to convert it into f domain. X of f dot h of f minus x of f. So what you are getting? Y of f divided by x of f. That is h of f minus 1. So from here if you see, if you convert it into frequency domain, what you will get? X of t convolution with pt. So x of f dot p of f would be y of f. So basically your y of f divided by x of f is your Pf. So my target was finding Pf. My target was finding Pf. This will be your P of f. Okay. So your P of f is coming out to be, what is h of f? H of f is j2 pi f. j2 pi f minus 1. So what would be your mod of Pf whole square? So under root 1 plus 4 pi square f square. So mod of Pf will, this will be your mod of Pf, right? Take the mod of this one, a square plus b square, under root a square plus b square, and then do the square. So what answer you will be getting? 1 plus 4 pi square f square. This is the answer you are getting. So mod of Pf square is 1 plus 4 pi square f square. So I already know this one. I already know mod of Pf square. I already know Sx of f. So what is my target? My Sy of f will be mod of Pf square, that would be 1 plus 4 pi square f square into x of f. So this is the answer of Sy of f. Okay. And if I want to take the inverse Fourier transform will not be that difficult. Let's take inverse Fourier transform. So I have to add a page. Why I am taking inverse Fourier transform? I am taking inverse Fourier transform to get the value of Rx of tau, sorry, Ry of tau. So this is my Sy of f, that I am getting as 1 plus 4 pi square f square, 4 pi square f square multiply with xf of f. In the examination, what if they had asked what is your Ry of tau? So people would say that, sir, I will do this process, it will take a lot of time. So what I would say, that you are having the expression of Sy of f, you just need to take the inverse Fourier transform. So let's convert it into omega domain. Okay, let's convert it into omega domain. So x s of omega. So 2 pi f is omega, so what it will become? Omega square. Say yes or no? Do you agree to this point? And this will become s of omega. Did you understand this point? Omega is equals to 2 pi f, no? Omega is equals to 2 pi f. So this is the scenario. Why I am converting to omega domain? Because I am more comfortable in omega domain. Basically, when I take the inverse Fourier transform, I am more comfortable in omega domain. I do my whole calculation in omega domain. When we study Fourier transform, mostly we study in omega domain only. So I know that I need to take inverse Fourier transform to get to get Ry of 2. To get the correlation, autocorrelation, I need to take the inverse Fourier transform. So I am more comfortable in the omega domain. Those who are comfortable in the F domain, they can consider F domain as well. So this is what we are getting, plus omega square x of omega, right? Okay. So one property is there, xt is having x of omega, then d by dt will have, d by dt xt will have j omega x omega, and d square dt square xt will have minus omega square x of omega. So this minus sign goes here, minus sign goes here. So omega square x of omega will be minus d square dt square xt. So what do you see? This is यार क्या कर रहा हूँ मैं? This will be sy of omega. Now if I take the inverse Fourier transform, so you know that Fourier transform of Rx of tau was Sx of omega. Now omega square Sx of omega, omega square x of omega will be what? Minus d square by d tau square Rx of tau. Do you understand this? Say yes or no. Do you understand this or not? Very easily, right? All good. So what you are getting? This will be your Ry of tau. This will be your Rx of tau, and this will be your Rx of tau. So this will be your Ry of tau. Not that difficult, easy only. Directly I would see that it would be Sx of omega plus omega square Sx of omega. So Sx of omega, omega square, that means it is something related with the differentiation. So this is what I will be getting, and this will be my answer. So always consider both of the path. In the 99% of the path, you will go from here. First you will find Sy of f, then you will find Sy of omega, and then you will find Ry of tau. Directly finding Ry of tau is very difficult. That's why in the last lecture we did not solve a lot of problems, because in the last lecture you did not know that this path is also there. So now easier path is that first I find the PhD of output and then I find the autocorrelation, because with respect to the PhD, autocorrelation will be easy for me. All good? All fine? Let's see the next question. In the next question as well, we will do the same kind of thing. Input is given, output is given, input is having the PhD, autocorrelation function and mean. Surely it will be mentioned that it is WSSRP. This is a simple RC circuit, simple RC low pass filter, which will be a LTI system only. It will also be WSSRP. Okay, this simple system, this particular system is nothing but an LTI system only. This is known as RC low pass filter. So RC low pass filter is a LTI system only. In signal system also we studied, in analog electronics we studied, in network analysis also we studied, everywhere we studied. So this is nothing but a LTI system only. You need to find mu y, Ry of tau, Sy of omega in terms of input parameters. So what will be your mu y? So I already know my mu y would be equals to mu x into, you find the transfer function and you put omega equals to 0. So what will be your transfer function? So I will convert everything in the S domain. So what I will get? Y of s divided by x of s. What that would be? 1 upon 1 plus SRC. RC low pass filter, what you will do? 1 upon CS upon 1 upon CS, simply the potential division. 1 upon CS upon 1 upon CS plus R into xt will be equals to, into x of s will be equals to y of s. Y of s will be equals to 1 upon CS upon 1 upon CS plus R into x of s. So what answer you are getting? 1 upon 1 plus RCS into x of s. So this will be your y of s. So y of s divided by x of s will be 1 upon 1 plus SRC. So your transfer function is 1 upon 1 plus SRC. So it should be remembered, okay? Like a lot of time it is used. So directly people remember it, the transfer function is 1 upon 1 plus SRC. So what will be your h of omega? Your h of omega will be 1 upon 1 plus j omega RC. Okay? And if I put omega equals to 0 here, or if I put s equals to 0 here as well, so h of omega at omega equals to 0, what you are getting? 1 only. So your mu y is coming out to be mu x only. Or at zero frequency capacitor will be open circuited. At zero frequency capacitor will be open circuited. So output will simply become equals to input. At zero frequency capacitor will be open circuited, so output will be equals to input. So what will be the transfer function? Transfer function will be 1. So mu y will be equals to mu x. Okay, very simple. Like all these things I don't need to do. Only if they are asking the mean of the output will simply be these kind of equation we have already shown. Omega equals to 0, you will put omega equals to 0, that means it will be 1. So what is the gain? What is the DC gain? DC gain will be 1. So you just need to put the DC gain. Answer would be mu y equals to mu x. Now Ry of 2. So you are having h of omega, or you can say h of s. From here can you get h of t? Yes. So basically if I say that sir I need to find Ry of 2. So what you will do? You need Rx of 2, then you do the convolution h of 2, then you do the convolution with h of minus 2. So from here h of s, what I will get first? H of 2. Then I will calculate h of minus 2, then I will convolve both of them, and after this convolution I will convolve it with Rx of 2. Again a very tough process. So for finding Ry of 2, I will not go to convolution, I will go to our frequency domain. Frequency domain, what does the frequency domain say? That Sy of omega mod of h of omega whole square Sx of omega. So I am already having Sx of omega. Whatever it is, I don't know. I am already having it. H of omega, I am already having it. What is the square? This is your h of omega, right? What will be your mode of h of omega? That would be, just you take the mode, 1 upon under root 1 plus omega square r square c square. And if you do the square, what you will be getting? 1 upon 1 plus omega square r square c square. So what will be your Sy of omega? 1 upon 1 plus omega square r square c square Sx of omega. So this will be your Sy of omega. Now Sx of omega is not given, right? This will be your Sy of omega. Final answer we have got, right? Sx of omega is not given, so I have to keep it as it is. Now what I need to do, basically I need to take the inverse Fourier transform. No, if I take the inverse Fourier transform, I will get my Ry of 2. So Ry of 2 will be equals to multiplication in frequency domain will result in convolution in time domain. Basically you cannot say that sir you take the Fourier transform of this guy and then multiply with Sx of omega. That will be your answer. No, Sx of omega is a function of omega. If I take the inverse Fourier transform of Sx of omega, basically what I am doing is that xt convolution with yt, what it will give you? X of omega dot h of omega. So this is your x of omega and this is your h of xt convolution with ht. Xt convolution with ht will give you x of omega dot h of omega. So this is your x of omega and this is your h of omega. Okay. So from here you will get h of t. What will be your h of t? That will be your Rx of 2. Are you able to understand this point? Dot will be replaced with convolution, and here something I will get. Time domain signal. So I am calling this particular signal as p of omega. So what I will get here? P of 2. So this will be my final answer. P of 2 convolution with Rx of 2. Basically here what you would have done? Rx of 2 convolution with h of 2 convolution with h of minus 2. So what you would have done? First you would have find out h of 2. Then you would have find out h of minus 2 and you would do the convolution. So basically this is your P2. This is nothing but your P2. Here also we are getting the same thing. P2 convolution with Rx of 2. So what will be the inverse Fourier transform of this guy? That is my target. Is this thing clear to you? Is this point clear to you? I have find out my Sy of omega. I need to go to the tau domain now. This is the tau domain. So I am going to tau domain. Not time domain, it is the tau domain. So if I am going to the tau domain, Ry of 2, this will be Rx of 2. Since they are in multiplication, in the tau domain it will be convolution. Now I need to find the inverse Fourier transform of this particular thing. So what do I know? A to the power minus a2 will give me the Fourier transform of 2a upon a square plus omega square. Right? Here what is the scenario? 1 upon 1 plus omega square r square c square. That would be how I need to convert it. 2a upon a square plus omega square, right? So if I take out r square c square, what I will get? Omega square upon 1 plus r square c square. Am I getting this kind of form? Yes. So if this was the scenario here, what I would have got? 2 by rc upon a square plus 1 by r square c square. 2 into a I am taking as 1 by rc. So a I am taking at 1 by rc. So what you would have got? Considering a is 1 by rc, so 2 by rc upon omega square plus a square. What is the value of a square? 1 by r square c square. So this kind of form I am trying to get. If this is my p of omega, this is also my p of omega only. I am just trying to relate. What I am doing? I am trying to relate, nothing else. What I am doing? If I am multiplying 1 by rc here, so here also I need to multiply 1 by rc only. What is the value of a? 1 by rc. Why I am multiplying by 1 by rc here? Why I am multiplying by 1 by rc on both of the side? Basically, first you let me know what will be the Fourier transform of a to the power minus 1 by rc mod of 2. That would be 2a upon a square plus omega square. So 2 by rc upon a square. What is the value of a square? The value of a is 1 by rc. 1 by r square c square plus omega square. Now I see my form. In my form, 1 by r square c square is there. What I am getting? 2 by rc. That means I need r square c square. So what I can do? 1 by rc I am multiplying here. Here also I am multiplying by 1 by rc. And this 2 is creating the problem. So what I will do? I will divide by 2. And here also I will divide by 2. So what I will be getting? This thing I will be getting. So I am getting my exact form. What is this? This is your p of omega only. I just tried to convert this form into p of omega, because I got to know that it is something 1 upon a square plus omega square. If you are getting 1 upon a square plus omega square, then you need to go to this guy, e to the power minus a mod of 2. 2a upon a square plus omega square. What is the value of a? A is 1 by rc. I consider a as 1 by rc. So what I am getting? 1 by 2 rc e to the power mod of 2 divided by rc. So e to the power mod of 2 divided by rc divided by 2 rc. So your ry of 2 is coming out to be e to the power mod of 2 divided by rc divided by 2 rc convolution with rx of 2. This is the answer you are getting. Okay, 1 upon 1 plus j omega rc, then h of mod of h of omega whole square. Then from here you know that what you will see. This is how I am converting it. This is how I am converting it here. I just need to make this form equivalent to this form. So what I did was I put a as 1 by rc. If I put a as 1 by rc, so on the upper side I will also get this form. 2 was creating the problem, so 2 I took downward. 2 I took downward. So 1 by 2 rc e to the power minus 1 by rc mod of 2. So from here what you are getting? 1 by rc into 1 by rc divided by omega square plus 1 by rc whole square. So this was simple mathematics, nothing else. So this would be the answer. Whatever the rx of 2 you are getting, that you can get it. Okay, rx of 2 could be anything. So this would be the generalized answer. E to the power minus mod of e to the power minus mod 2 rc divided by 2 rc convolution with rx of 2. Whatever the rx of 2 you get, you get. Another thing you could have got is that from here you can get the value of h of 2. You get the value of h of 2, then you get h of minus 2 as well. You convolve both of them. This is the answer you will get. When you convolve both of them, this is the answer you will get. So you can try it on your own. Can you get h of 2 out of it? Yes. What that would be? 1 by rc upon s plus 1 by rc. This is how I will represent it. I know that e to the power minus at will give me 1 upon s plus a. So if I multiply by 1 by rc here, 1 by rc here, value of a will also be 1 by rc. So 1 by rc e to the power minus t by rc. Convolution with h of minus 2. What that would be? 1 by rc e to the power plus t by rc. So 1 by rc are constant. So constant part will come outside. That would be 1 by r square c square, and then you do the convolution. You will get your answer. Okay. So you can do it on your own. So better doing the convolution in time domain, you do it in the frequency domain. Once you do it in the frequency domain, you will get the same answer. Is that clear to you? So use your pen, use your brain, you will get the answer. There is nothing difficult. Just signal system and communication system is being mixed now. Nothing else. Okay. Very simple. Very simply. Just the thing is that solving in tau domain will be always difficult. 99% of the cases in tau domain it will be difficult. So we will go to the frequency domain and then we will go to the tau domain again. The task would be to get these values, right? Let's go to the next question. Everything is answered here. Yeah. A random process xt is passed through an ideal low pass filter with the cutoff frequency of half hertz. Input phd is given, output is yt. Which of the statement is true? So what is happening here? There is a xt, it is passed through a low pass filter and then you get some output. What is the low pass filter? The low pass filter is an ideal low pass filter. Ideal low pass filter with the cutoff frequency of half hertz. So everything they have given in terms of f domain. In terms of f domain. This is your low pass filter. They did not talk about pass band gain. This is known as pass band gain, okay? Like when it is passing, how much gain it is providing. So if they are not saying anything, pass band gain should be 1. But they will give it in the examination, they will give it, okay? Pass band gain would be 1. If it is passing, then how much gain it is providing, okay? So this is your h of f. So what is happening is that this is your h of f. Input s x of f is this. This is your input s x of f. So at f equals to 0, the value is 1. At f equals to infinity, the value will be 0. This is your s x of f, which is e to the power minus mod of f. It is passed through a filter and you are getting some output. So how you will get your sy of f? Sy of f will simply be mod of h of f whole square sx of f. Why I am interested in sy of f? Because when I see the options, what they are talking about? They are talking about the mean value, they are talking about mean square value. That means here they are talking about the power and here they are talking about the mean. Now talking about the mean, what is the mean of the input? They did not specify, right? Mean of the input they did not specify. So what I will do is that I will consider x of t as, I will have to consider x of t is having no offset. It should be given because they did not satisfy they did not specify anything about the input mean. So I am considering that x of t is having no offset. So what will be my mu of x? My mu of x will be 0 minus 2, 0 plus sx of f dot df. Can you see any impulse here? No. What will be the area? 0. From 0 minus to 0 plus, whatever the amplitude is there, I don't care. But the width is 0, so answer would be 0. So what would be your mu of y? Mu of y will be mu of x h of f at f equals to 0. What is the value of h of f at f equals to 0? The value is 1, but mu x itself is 0. Okay, they did not specify anything. So yeah, the thing is, mu x could be non-zero as well. Whatever the mu x is there, I don't care. Mu x could be non-zero as well. Forget about it. Mu x could be non-zero. Whatever the mu x is there, I don't care. What will be the relation between mu y and mu x? The relation between mu y and mu x would be mu y equals to mu x dot h of f at f equals to 0. Basically the DC gain. So what is the DC gain of the filter? DC gain of this filter, that is 1. So what you are getting? Mu y is equals to mu x. Did you understand? Mu y is equals to mu x dot h of omega at omega equals to 0. So even if you convert it into omega domain or if you convert it into f domain, only in the omega domain these things will change. So the bottom line is, what is the gain here? Gain is 1. So mu y will be equals to mu x. So this option is correct. Expectation of x square t. What does that mean? Input power. Expectation of x square t will be equivalent to mean square value, and that will be equivalent to the total area. So what is the total area? A to the power minus af goes from 0 to infinity. This area will be equivalent to this area. So what you need to do? You find out from 0 to infinity e to the power minus f dot df. It will come out to be 1. So this area is 1. This area will also be 1. So what will be the answer you will be getting? 2. So the answer you will be getting is 2. So this is also correct. Expectation of y square, that means now you are interested in the final value of sy of f. Sy of f, you are interested in the value of sy of f, then you can find out the value of expectation of y square t as well. So if I find out expectation of y square t, what that would be equivalent to? That would be equivalent to minus infinity to infinity mod of that would be equivalent to Sy of f dot df, right? That will be equivalent to minus infinity to infinity mod of h of f square x of f dot df. Look, now this is non-zero. This is non-zero between minus infinity to infinity. But what would be the graph of mod of h of f whole square? This is the graph of h of f. What would be the graph of mod of h of f whole square? Mod of h of f whole square. This will be the graph of mod of h of f whole square, because mod of h of f will be 1 and whole square of 1 will be 1 only. So now what is happening is that your Sx of f is being multiplied with this particular thing. That means after 1 by 2 everything will be 0, before minus 1 by 2 everything would be 0. If I multiply this graph with this graph, what I will get as my Sy of f. So my Sy of f would look something like this. So that would look something like this. Sx of f being multiplied with Sx of f being multiplied with h mod of h of f whole square, and then it is terminated at minus 1 by 2 and plus 1 by 2. Okay, and this was your input. This was your input, which I can directly copy from here. Both will be multiplied and it will result the Sy of f. Now basically you need to find the area of this guy. Area of this particular graph will surely be less than 2. Do you agree to this point or not? Because if this graph is 2, then here you are calculating the lesser area. Here you are calculating the area from 0 to infinity, 0 to infinity, but here you are calculating the lesser area. What I mean to say is that here it was going from minus infinity to infinity, but now it will go from minus 1 by 2 to plus 1 by 2, e to the power minus. Now mod of h of f square between minus 1 by 2 to 1 by 2 is 1. This would be 1. But Sx of f is e to the power minus mod of f, because this graph is e to the power minus mod of f dot df. So your expectation of y square t would be equivalent to, although answer is done, that it would be lesser than that. Expectation of y square t would be lesser than expectation of x square t. And it is pretty obvious, no? There is some process which is passing through a low pass filter. So at the output, whatever the power you are having here, at the output the power will be lesser, no? Because what low pass filter will do? It will just reduce the power. It was having a bandwidth of infinity, but now the bandwidth has become this much only. Are you able to understand this point or not? Well and good, right? Yeah, so minus 1 by 2 to 1 by 2. Although if someone needs the exact value, then they can find the exact value as well. Dot df. So 2 into 0 to 1 by 2 e to the power minus f dot df. So you can calculate it, you will get the answer. What will be your answer? 1 minus e to the power minus 1 by 2. This is the answer. Okay, you can calculate it, this will be the total power. Surely it will be less than 2. Okay, very simple question. Let's go to the next one. Yeah, this is a very good question. Try it on your own, and I'm pretty sure you guys will do it wrong. Okay, you can do it correct as well, but try it. Try this question. Xt is WSSRP, Yt and Xt, the relation between Yt and Xt is defined as d by dt x of t. Mean is given, autocorrelation function is given. Which of them is the correct statement? Is there any discussion of PhD? What I am saying, is there any discussion of PhD? No. That means this question is not based on this particular lecture, no? This question is based on the previous lecture. There is no discussion of PhD. Anywhere did I mention PhD? No. Autocorrelation function, and all the options are based on autocorrelation function. So try it. Try it and let me know which of the following statement is true. So if I need to find Ry of tau, what I would have done? if I am studying for the first time, if I am a student, then what I would have done, Ry of 2. Here PhD, nothing will click to me. What I would do is that expectation of Yt, this is the basic formula, y of t plus 2, this is the basic formula. Expectation of, what is Yt? Yt is d by dt of xt dot d by dt of x of t plus 2, right? Now what I would do, d square by dt square x of t plus 2. Now expectation goes inside because d square by dt square, d by dt, so this will become d square by dt square, and expectation goes inside. So what you will be getting, Rx of 2, right? Because expectation goes inside, expectation of xt dot x of t plus 2. But here, sir, there is a negative sign involved. So, sir, this answer is, this option is wrong. This, everything is wrong here. Where I am going wrong? What you are doing here? D by dt. Multiply both of them and d square by dt square. What you are actually doing? D by dt. Let's just say xt was u plus vt. And d by dt, x of t plus 2 would be what? U plus vt plus v2. So what you are doing now? You are multiplying both of them and then you are double differentiating. Is that true? No. What this definition is saying, that first you differentiate this, then you differentiate this, and then whatever the answer that you are getting, that you multiply. But what you are doing here, from here to here, what you are doing, like this is just the end of mathematics, right? So when I was studying for the first time, this is how I solved it. When I was a student, this is how I solved it. D by dt, okay, in a very quick manner you take it outside and this is the answer you are getting. And a lot of students would have done it, right? They would say that minus sign would not come. This is a big blunder, absolutely wrong. This, how will you solve it now? So doing in that tau domain, it is difficult. So if doing in the tau domain it is difficult, where I would go? Only task is, I will go to the frequency domain, and frequency domain means PhD. So I will solve it with respect to PhD, because in the time domain it became difficult for me. Is that clear to you or not? Okay. So if I solve by the basic definition, this is how I am messing it up. So what I will do, I will always go to PhD. PhD calculation will be surely easy, that I can tell you. It might happen that tau domain calculation is also easy, but PhD calculation will 100% be easy. So Yt equals to dxt by dt. So it's like there was a xt and there is this output Yt. So xt was being passed through a d by dt and you are receiving this output. So this is your h of t. You cannot call it h of t. No, this is not your h of t. This is not h of t. H of t, how will you find h of t? What h of t does? Yt would have been x of t convolution with h of t. So this is not convolution. D by dt is not h of t. Are you able to understand this point, right? What is h of t, that I will tell you. So if I go into the frequency domain, what I will get? Y of s, or I can go to the omega domain as well. So y of omega, d by dt will be replaced with j omega x of omega. So what will be your y of omega x of omega? That will be j omega. Right? All good. So this is your h of omega. H of omega is j omega. So if I need to find out h of t, what that would be? What would be your h of t? So delta t will have a Fourier transform of 1. If I differentiate it, d by dt delta t, it will have a Fourier transform of j omega. So your h of t will be delta dash t. But this is not useful, right? Your h of t is actually delta dash t. So my h of t is, your yt is x of t convolution with delta dash t. But this is not useful because I have made up my mind that I will go with the frequency domain analysis. If someone asks you h of t, then you can tell that it will be delta dash t. But I have made up my mind that I will go with the frequency domain analysis and I will be solving everything with respect to sy of f. So sy of f would be h of f whole square s x of f. Right? So what is my h of f? H of omega is j2 pi. So what would be your h of f? J2 pi f. So mode of h of f is, mode of h of f would be 2 pi f only, and then you do the square. So what answer you are getting? 4 pi square f square dot sx of f, sy of f. j2 pi f it is. I will take the mode. Mode means this j will be gone, and then I will do the square. This is the scenario I am getting. Right? All good. Now what I need to do? I need to take the inverse Fourier transform. Inverse Fourier transform. Inverse Fourier transform. So I know that whenever I take the inverse Fourier transform, I am more comfortable in the omega domain analysis. This is the f domain analysis. I am more comfortable in omega domain analysis. So what I will do? Sx of omega. What is this? 4 pi square f square. That means what it is? Omega square Sx of Sy of omega. Sy of omega. Sy of omega. Omega square Sx of omega. Now what I need to do? I need to take the inverse Fourier transform. You know that Rx of tau is having Sx of omega. If I differentiate one time, what do I get? If I differentiate one time, what do I get? J omega Sx of omega. If I differentiate twice, here differentiation should be done with respect to tau, because everything is going in tau domain, right? If I differentiate twice, what do I get? Minus omega square x of omega. So this minus sign goes here, minus sign goes here. So what is this? If I take the inverse Fourier transform, if I take the inverse Fourier transform, so Ry of tau is minus d square y d tau square Rx of tau. This is the answer. So yes, first option is correct. Let me explain it again. What you are doing here, time domain in the, or by the basic definition, everything is becoming difficult. So my major task was I will go with the frequency domain. When I go with the frequency domain, this is the first step I will write down. Sy of f is equals to mode of h of f whole square Sx of f. Now my target would be that what is my h of f? So for h of f, what will be the target? Y omega divided by x of omega. You will get your h of omega. From there you can get h of f, right? So how will I get h of omega? Y omega divided by x of omega. And how will I get y omega divided by x omega? Just convert whatever that is given from here. Just convert y of omega will be j omega x omega. So whatever the relation is given, if you go to the frequency domain, you will get the relation between y omega and x omega. So I am getting the relation between y omega x omega. So h of omega is coming out to be j omega. So h of f is j2 pi f. That I put here. I need to take the inverse Fourier transform. I know that I am not that comfortable in the f domain when it comes to inverse Fourier transform. So I will convert it into the omega domain. So this is the expression I was getting, and then I know that I can do this calculation. Omega square, just as you see omega square, that means differentiation is done twice. So from here I get the answer. So Ry of tau will be this. Okay. What will be your mu y? So you know that mu y is equals to mu x h of omega at omega equals to 0. What is your h of omega? H of omega was omega square, right? No, sorry, h of omega was j omega. H of omega was j omega. If you calculate h of omega at omega equals to 0, what you are getting? 0. So whatever the mu x you are having, multiply with 0. So mu y will be always 0. So when you pass a WSSRP through a differentiator, the output will have 0 mean. And I told you what is the ability of a differentiator. Always in the signal system also I told you. Ability of the differentiator is that it will eat up the DC value. D by dt of 2 plus xt. So whatever the 2 is having, it will be gone. This is not a function of time domain, no. So ability of differentiator is it will always eat up the DC value. That means it will always eat up the mean. So mean is gone. So whenever you feel like that, sir, I need to kill the DC value, you always design a differentiator. You design a differentiator to kill the DC value, and you pass your signal through the differentiator. In the output, there will not be any DC value. Okay. So always to kill a DC value, you design a differentiator. Now Ryx of tau, Rxy of tau, Ryx of tau. These things I need to find, but I know that in the time domain it will become, in the tau domain it will become difficult. So where I will go? I will go to my Sxy of f, right? So what would be your, but I remember the formula from here only. Rxy of tau What is that? Rx of tau. Rx of tau will say that, sir, yes, I am coming first, so I am not going to bring any negation, right? There will not be any inversion. So from here I know that my Sxy omega will be equals to Sx of omega dot h of omega. So your Sxy of omega will come out to be Sx of omega dot h of omega. What is your h of omega? H of omega is j omega. So j omega Sx of omega. And you know that j omega Sx of omega is equivalent to d by d tau Rx of tau. So Rxy of tau is equivalent to d by d tau Rx of tau. There you go. D by d tau Rx of tau. D by d tau Rx of tau. And what about Ryx of tau? So you know another thing. Let's do it here. Ryx of tau is equivalent to Rxy of minus 2. Right? Now in place of tau, what you need to put? Minus 2. In this expression, Rxy of tau is d by d tau Rx of tau. So if I need to find Rxy of minus 2, Rxy of minus 2, so what I will do? In place of tau, I will put minus 2. So in place of tau, what I will put? Minus 2. In place of tau, I will put minus 2. Now I know that Rx of minus tau will be equals to Rx of tau only, because it is WSSRP and autocorrelation function is a mean function of tau, right? So what you are getting? Here I can take minus sign outside. So d by d tau Rx of minus tau will become plus tau, and if I take the minus sign outward, this is what I am getting. Ryx of tau. So Ryx of tau is coming out to be minus d by d tau Rx of tau. So all 4 options were correct. You could have solved it in other manner as well. What would be the other manner? What would be the other way of solving it? Other way would have been like this. That what I need to find? Ryx of tau. You know that Rx of tau will come, but it will say that, sir, I am not happy. So it will say, I will bring the negation. So Syx omega, what that would be? Sx of omega, h of minus omega. What is h of omega? That is j omega. H of omega is j omega. So h of minus omega will be minus j omega Sx of omega. So j omega Sx of omega is d by d tau Rx of tau. So minus sign will be outward, d by d tau Rx of tau. Minus sign is outward, d by d tau Rx of tau. So here what you are getting? Ryx of tau. So Ryx of tau is equivalent to minus d by d tau Rx of tau. Ryx of tau is equivalent to minus d by d tau Rx of tau. Okay, so these are the 4 options. Now we will do the same discussion that we have done in our previous lecture, right? X of t will be multiplied with, this time I am doing a sin omega t plus theta. I told you whether it is cosinusoid or sinusoid, in both of the cases the answer will remain the same. So what will be your yt? Yt will be axt sin omega t plus theta. And I told you to remember the answer of Ry of tau. So how will you write down? A. So A will be converted to expectation of a square divided by 2. This xt, that will be converted to Rx of tau. And this sin omega t plus theta, that will be converted to cos omega tau. Say yes or no. Did I ask you to remember this one? Let's write down in a better handwriting. So handwriting will be better. Expectation of a square divided by 2 Rx of tau cos omega tau. So this is my Ry of tau. Okay. Now from here, if I need Sy of f or Sy of omega, what I will get? What will be your Sy of omega? This is a constant thing. Constant thing. Rx of tau cos omega tau. Xt multiply with cos omega t. What did I tell you? Pi x of omega naught. Let's call it omega naught. So here also let's call it omega naught. Otherwise omega will be same, no? Omega is the frequency domain as well. So let's call it omega naught. This is a constant value of omega naught. Omega naught. So x omega minus omega naught plus x omega plus omega naught. right? This is what you will be getting. So here also you will be getting the same thing, pi Rx of, sorry, we are going in the frequency domain. What we are going? We are going in the frequency domain. So pi Sx of omega minus omega naught plus Sx of omega plus omega naught. This is the answer. And if I need to go in the F domain, so in the F domain this formula is more famous. So in the F domain what would have happened here? 1 by 2 x of f minus f naught plus x of f plus f naught. So 1 by 2 expectation of a square divided by 4 Sx of f minus f naught plus Sx of f plus f naught. Okay. Right. So in the F domain this is more famous. In this domain it is more famous. In omega domain as well you need to remember it. You don't need to remember anything actually. You need to remember this formula. And if you remember this formula you can derive these answers as well. Right. Expectation of a square divided by 2 Rx of tau cos omega naught tau. This I already remember. How do I remember? That xt is being multiplied with the pt. What is pt? A sin omega naught t plus theta. It could be a cos omega naught t plus theta as well, where a is uniformly distributed and theta is also uniformly distributed with the length of 2 pi. With the length of 2 pi. So whatever a is there, I don't care much about that. Expectation of a square divided by 2 I will get. Xt replaced with Rx of tau and this will be replaced with cos omega naught tau. You can derive it in the examination, but it will take a lot of time. Not lot of time, it will take hardly 20 to 30 seconds only. You can either derive it. If you are not deriving it, you can remember it. But I would say that you can derive it as well. A square will come, then you would realize that x of t, x of tau would come, and from here cos omega tau will come. So x of t, x of tau will be replaced with Rx of tau, and from here cos omega naught tau would come. So like with the using your brain as well, you can write down this expression. Once you have written down this expression, then you know that to get my PhD, what is the PhD of the output? This is surely WSSRP. Now I need to get the PhD of the output in terms of the input. So what do I see is that Rx of tau cos omega naught tau. This is a standard form. In terms of F domain, what happens? X of f minus f naught plus x of f plus f naught divided by 2. So whatever s of f you are having, whatever the input PhD you are having, one PhD will be shifted to f naught, other PhD will be shifted to minus f naught and then divided by 2. So here already 2 was there, so this would become divided by 4. Is that okay for you? We will solve the problem, it will be all clear to you. You try doing this question. Let me explain the problem. With respect to one question only, we will understand all the concept. So what is happening? Xt is coming, multiply with this cosinusoid. Whatever the output you get, that is passed through an ideal band pass filter, which is having center frequency 8 kHz and bandwidth of 2 kHz. You will get an output yt. You need to find that total power of yt. What is the total power of yt? So try doing it. You can surely do it. And what is mentioned? PhD of a random process xt is mentioned. Xt is surely WSSRP. You will multiply here, what you will get, let's just say you are getting some ZT. So this ZT will also be WSSRP. And when you are passing it through a low, this is a band pass filter, surely it is a LTI filter as well. So this will also be WSSRP. So what you will do, you will find Sy of f, and once you are having the Sy of f, you calculate the total area, that will give you the total power. So my power will be, my total power of yt will simply be the total area of my Sy of f. So my target has become to find out Sy of f. Can I find out Sy of f? Yes. First what I need to do, I need to find out Sz of f. So what will be your Sy of f? Sy of f will be, let's call it, it will give you h of f. Let's just say it gives you h of f. So Sy of f would be mod of h of f whole square Sz of f. Just go step by step. Find Sz of f. First you find Rz of tau. Then from there you find Sz of f. From there you find Sy of f, and then you calculate the area. Will be very, very simple. Draw the diagram, draw the waveforms, and you will be able to get the answer. Let me take a break and then I will come back. Okay. Yeah, welcome back. So did you try this question? So let's get started. First I will draw the waveform of Sx of f, and then I will write down my Ry of tau, sorry, Rz of tau, right? I will write down the autocorrelation function of Zt, and then from there I will get PSD of Z, right? So let's draw the waveform of Sx of f, which is given as when f is between -3 to 3, it is non-zero, otherwise it is 0. So if I put f equals to 3 kilohertz, what I will get? 0. And if I put f equals to -3 kilohertz, what I will get? 0 only. And at f equals to 0, what I am getting? 3000 into 10 to the power -6. That means I will be getting 3 milliwatt per hertz. So what I will do is that I will make the waveform like this. What I am getting is that this is the waveform, right? It is triangular only, no? It is pretty obvious. As the f increases, the amplitude will keep on decreasing linearly. And at f equals to 0, you are getting 3000 into 10 to the power -6. That would be 3 milliwatt per hertz. So this amplitude will be 3. And here I am writing every calculation I am doing in milliwatt per hertz. And this is my hertz or kilohertz. This will be kilohertz, right? And this is in the kilohertz. So my calculation is going with respect to milliwatt per hertz. This is milliwatt per hertz. Are you pretty sure that it would be milliwatt per hertz then kilohertz? Let's check the analysis. So yeah, my calculation is going for milliwatt per hertz, and then this is kilohertz. So here 3 kilohertz they are saying. So here I am writing. Let's keep it in hertz only. Forget about kilohertz. Let's keep it in hertz only. So here what I will write down? 3 kilo. What I will write down here? -3 kilo. So this is 3000. This is -3000. So my y-axis is in the millivolt per hertz, and my x-axis is in the hertz. This is my Sx of f. Then there is a multiplier. Multiply with cos omega naught t, right? So what I know is that my Rz of tau will be, basically first I write down Zt. So my Zt will be x of t multiply with cos 16,000 pi t, right? Cos 16,000 pi t. So what do you get in Rz of tau? Expectation of a square. A is 1. Expectation of 1 square will be 1 divided by 2 Rx of tau cos omega naught tau, right? Expectation of a square divided by 2. Expectation of a square will be 1 because a value is 1. So 1 by 2 Rx of tau cos omega naught tau. This is what you are getting, right? And if I write down Sz of f, what that would be? So 1 by 2 is already there. Now here what will happen? Another 1 by 2 will come. Here if I solve this, another 1 by 2 will come. So what this will become? 1 by 4 Sx of f minus f naught. Here value of omega naught is 16,000 pi. So what will be the value of f naught? F naught value will be 8,000, or you can call it 8k, right? Value of f naught will be 8k. 2 pi f naught is equals to 16,000 pi. That means f naught will be 8k. So f minus f naught, f plus f naught. This is what you are getting. Are you able to understand this point? So what will happen is that this graph center is at 0. So this graph will be shifted to f naught, and this graph will be shifted to minus f naught. The amplitude will decrease by 4. The amplitude will be 3 by 4, right? So what will happen is that this kind of Sz of f you will be getting. That means this is the PSD of Zt. So if you are getting the PSD of your Z, that would be simply this graph shifted like this. Simply this graph shifted like this. Where center is moving to f naught, which is 8 kilohertz. And the complete width was 3k. So this would be 3k. 8k plus 3k, this will be 11k. And 8k minus 3k, this will be 5k. And similarly here, this will be minus 5k. The center will be at minus 8k. And this will be minus 11k. Okay. And what is the amplitude? Amplitude is 3 by 4. Now there is a filter. What is the filter? Filter is centered at 8 kilohertz and bandwidth of 2. So can you make this band pass filter? Centered at 8 kilohertz and bandwidth of, so center is at 8 kilohertz, bandwidth of 2. So center is at 8 kilohertz, bandwidth of 2. That means this complete width is 2. So this will be 9k and this will be 7k, right? And similar thing you will get in the negative hand side as well. So in the examination, what I would do is that I will only solve for one side, because I know that similar thing will be happening in the other side as well. So I will always solve one side only, right? Centered being at minus 8k, this is minus 7k, this is minus 9k, amplitude being at 1. So what would be your mode of h of f? That would also be 1, and if I do the square, that would also be 1 only. So if I multiply Sz of f with mode of h of f whole square, what I will get? I will multiply both of the waveforms now. So here they did not give the passband gain. So passband gain you need to assume should be mentioned. Passband gain would be 1. This should have been mentioned. Okay. So now these two waveforms will be multiplied, because what do you know? That your Sy of f is mode of h of f whole square Sz of f. So now you need to multiply both of the waveforms, and then whatever the resultant graph you are getting, you need to calculate the area. That's it. So how will you multiply both of these waveforms? So here at 7k and 9k, I need to know the values, no? Because between 0 to 7k and after 9k, everything will be 0. So this part will be non-zero, right? Are you getting this point or not? This will be 9k. So from 3 by 4 to you are decaying down to, from 3 by 4 to you are going to 0. From 8k to 11k. That means when you work for 3k, you lose the amplitude of 3 by 4. So when I work for 1k, how much I will lose? 1 by 4. When I am working for 3000 hertz, I am losing the amplitude by 3 by 4. 3000 hertz, 3 by 4. I need to go from 8k to 9k. That means I will work for 1k. So how much I will lose? 1 by 4. 3 by 4 divided by 3, that would be 1 by 4. So here, if the amplitude is 3 by 4, so here what will be the amplitude? 1 by 2. So these amplitude will be 1 by 2. This amplitude will be 1 by 2. Now 1 by 2 will be multiplied with this graph. Are you able to understand how I am doing the calculation? You will write down the equation and then you will find out the value. Irrespective of that, what I would do is that I will use my brain, that this is a linear graph. If it is a linear graph, working for 3 by 4, going for in the y direction, if I lose by 3 by 4, then in the x direction I am working by 3k. So if in the x direction I am working by 1k, that means I will lose by 1 by 4. So this point will be 1 by 2. Now this much graph will be multiplied with 1, and rest all the things will be 0. So between 7k and 9k, you will get this waveform. Are you able to understand this point? So 1 by 2 will be multiplied with 1. 3 by 4 will be multiplied with 1. So what kind of waveform you will be getting? Everything will be non-zero between 7k to 9k. Everything will be non-zero between 7k to 9k. At 7k, it was giving 1 by 2 and it is giving 1. So 1 by 2 into 1, what you will get? 1. And then this you will be getting. This amplitude will be 3 by 4 and this amplitude will be 1 by 2, and similar thing will be happening in the negative side as well. Similar thing will be happening here as well. Three by 4, 1 by 2. So I need to calculate the area of this one. Can I calculate the area of this one? Surely I can calculate the area. But don't forget, every calculation is going milliwatt per hertz, and here it is hertz. So what do you think, what will be the total area? Because what I need to find, power of Yt, that will be equivalent to the total area of Sy of f dot df. So what that would be, whatever the area you get here, the same area you will get here as well. So 2 into, here you can see there is a triangle and there is a rectangle. So what is the area of the rectangle? 1 by 2 into 2k plus 1 by 2 is the height, 2k is the width. 1 by 2 into base into height. Okay, milliwatt per hertz into hertz. So whatever the answer you will get, that you will get in millivolt. Are you able to understand this point? 2 into 1k plus 0.25k millivolt. Milliwatt, not volt, milliwatt. So k and k, what is k? K is 10 to the power 3 and what is milli? 10 to the power minus 3. So 1.25 into 2, what is the answer you are getting? 2.5 watt. This is the answer you are getting. Did you understand this point or not? You made the final graph. How did you made the final graph? Just you have to be patient enough. That's it. You need to have the patience. If you have the patience, you will be able to solve the problem. This was your s x of f, right? You are multiplying with cos omega naught t. You write down the rz of 2. Rz of 2 will say that you shift it and the amplitude will be 1 by 4th. Amplitude will be 1 by 4th. How 1 by 4th? Actually, it should have been a square by 4. A square by 4. But the value of a was 1. It should have been a square by 4. That value of a was 1. So it would be 1 by 4. Shifted here, shifted here. Shifted here, shifted here. Then passed through a band pass filter. Band pass filter is like this, 7k to 9k, gain is 1, 1. Then what is the amplitude you will be getting? This is how you will be getting the amplitude. You can calculate the area. What is the area? There is a triangle, there is a rectangle. So whatever the area you get here, the same area you get here, multiply by 2, answer is 2.5 watt. There you go. Okay. This calculation was going in milliwatt per hertz. This calculation was going in hertz. Solve this question. Find the frequency for which SYF is 0. Okay. Yt equals to, all these things is given. Xt is WSSRP, everything you know. You need to find those frequencies for which SYF is 0. So I need to go to SYF. So I know that my SYF will be equivalent to mod of h of f whole square sx of f. So basically here what is happening is that there was some xt, then it passed through something, xt passed through something, and then you got yt. So there was some xt, something happened with xt, it passed through, the xt was passing through a LTI system, and then you got some yt. So this is something that happened to xt. So yt is given as d by dt of xt plus xt minus t naught. What I am interested in h of f, right? I am interested in h of f. So what I will do? I will go to the frequency domain. Y of f, j 2 pi f, x of f plus e to the power minus j 2 pi f naught, it is 0.5 already given. 2 pi f t naught, value of t naught is 1 by 2, x of f, right? So j 2 pi f x of f plus e to the power j 2 pi f, e to the power j minus 2 pi f t naught x of f. So what you are getting here? Y of f divided by x of f, that is your h of f, j 2 pi f 1 plus e to the power minus j pi f. This is what you are getting, right? So this is your h of f. What will be its mod of h of f whole square? So 4 pi square f square, 4 pi square f square. Then mod of this guy 1 plus e to the power minus j pi f whole square. This will be your mod of h of f whole square. Mod of h of f whole square will be 4 pi square f square. Then mod of this guy, that would be mod of 1 plus e to the power j minus pi f, mod of both of them whole square. So this kind of thing we have studied in EMFT, that how to solve, how to make this as 0. Let me write down the final expression. So your final expression Sy of f is coming out to be 4 pi square f square, 4 pi square f square, 4 pi square f square. Just 1 second guys. Yeah, 4 pi square f square into 1 plus e to the power minus j pi f whole square s x of f. This is your final expression is coming out to be. Now what people would have done is that they will solve this one. How they will solve this one? 1 plus cos pi f minus j sin pi f. Then they will take the mode under root a square, this is the real part, plus under root b square, and then square, and then they will solve it inside 1 plus 2 cos. This is something you will get. This is also a fine method. I am not saying it is wrong. It is also a fine method. You will get something in terms of cos and you will get the answer. But just use your brain. What you need this answer to be equals to 0, right? What I need, SYF should be equals to 0. And I know that what this can give me. This can give me -1. So whenever this guy is giving me -1, my job will be done. Basically, if e to the power minus j pi f gives me -1, all good. Because 1 minus 1 will be 0. And when your e to the power j theta gives you 0, sorry, when this gives you 0, when theta is equals to pi, e to the power j pi is -1. And since it is periodic with 2 pi, so plus 2n pi. That means when theta is equals to, when this minus pi f, you write down minus pi f or plus pi f, both are the same thing. Or let's write down minus pi f. When this minus pi f is equivalent to pi 2n plus 1 into pi. 2n plus 1 into pi. From here what you get? Pi is common, 2n plus 1 into pi. So when this minus pi f is equivalent to 2n plus 1 into pi, your job will be done. Are you able to understand this point? So what do you get here? F is equals to 2n plus 1. Are you able to understand this point? So this is the answer. Okay, F is equals to 2n plus 1. Value of n could, F equals to minus 2n plus 1. So value of n could be anything. And you put negative, positive, it could be anything. But value of F you will take positive only. Value of F you will take positive only. So value of n you need to put negative. If I put n equals to -1, if I put n equals to -1, what I am getting? 1. If I put n equals to -2, what I will be getting? 3. If I put n equals to -3, what I will be getting? 5. So 1 kilohertz, 3 kilohertz, 5 kilohertz, that would be the answer. Or just think about it. Here what I would do is that first in the examination how I would have solved it. I would know that e to the power minus j pi will give me 0. Sorry, e to the power minus j pi, e to the power minus j pi will give me -1. So 1 minus 1 will be 0. So I know that my value of f would be 1 kilohertz. Or kilohertz I cannot say here. Why I can say kilohertz? No. Kilohertz, nowhere I can say that it would be kilohertz or hertz. Frequency will be 1. 1, right? Kilohertz or hertz, can you say that? 1 hertz. Answer would be 1 hertz, not 1 kilohertz. Yeah, so I will get to know that my f will be 1 hertz. Just a second. Yeah. So what I was saying that f would be 1 hertz. So basically in the examination, I will look at this step. I know that e to the power minus j pi f, this has to be -1. So from here only I will get to know that if I put f equals to 1, what it will become? E to the power minus j pi. If I put f equals to 3, what it will become? E to the power minus j 3 pi. That is also -1. If I put f equals to 5, what it will become? E to the power minus j 5 pi. Basically they are periodic with 2 pi, no? Then if I put 7, and there you go. So from here what I would see is that f should be equals to 2n plus 1. F should be equals to 2n plus 1 hertz. So whenever you get 1 plus e to the power j theta, especially I spent roughly around 30 minutes on this particular thing in EMFT, that whenever you get 1 plus e to the power j theta mode of whole square, you never calculate the mode. No, you just spend here, you just sit here, you just stand here, and when you stand here, you will look at this particular thing, e to the power j theta. You need it to be -1. If I need it to be -1, then theta should be odd multiple of pi. So theta should be pi, 3 pi, 4 pi, sorry, pi, 3 pi, 5 pi, 7 pi, and so on. And what if I want to make it maximum? Sometimes in EMFT, you will want to make it maximum. So if you want to make it maximum, your target would be e to the power j theta should be equals to 1. Because here this guy can give you maximum value 1 and minimum value -1. So minimum value will be -1 and then it will become 0 and maximum value will be +1. So e to the power j theta should be equals to +1, and when it will give you +1? When theta is equals to 0, 2 pi, 4 pi, -2 pi, -4 pi, and so on. So never ever solve this mode. Never ever solve this mode. You calculate the mode and then do the square. So calculation will be a bit larger. Rather than that, use your brain. That f should be 1, 3, 5, 7, and so on. So this would be the answer. At all these points, your Sy of f will be 0. Okay, this is the answer. Sy of f will be 0, 4, f equals to 2n plus 1 hertz, where n is any integer. Okay, n is an positive integer because value of frequency will be 4 f equals to n is any positive integer I will write down. So n belongs to whole number. Positive integer means whole number only, no? So 0, 1, 2, 3. Because frequency has to be positive, no? Frequency will not be negative. What is the meaning of this negative frequency? Negative frequency is only showing that it is real. It is coming from real. Real means if anything is real, that would be symmetric. This discussion we have done in signal system, right? So the meaning of negative frequency is just it is telling that the circulation is clockwise. Now what is the circulation? So don't get confused in all these kind of things. Meaning of negative frequency is just that it is coming from a real signal. We are talking about real signal. If you are having real signal, then this frequency spectrum will be even. So for real signal, frequency spectrums are even. Okay. So this is the meaning of your negative frequency. But answer will always be positive. Like frequency can never be negative, no? If time is always positive, time is always positive. 1 second, 2 seconds, 3 seconds. So frequency will also be always positive, right? Although it is not a matter of concern, this will not be asked in the gate examination. I am just telling that we will put the positive value of frequency, that at 1 kilohertz to 3 kilohertz, 5 kilohertz, the answer would be that Sy of f will be 0. So when I draw the graph of Sy of f, I don't know how the graph would come, but I am pretty sure that at f equals to 1 hertz, the value will be 0. At f equals to 3 hertz, the value will be 0. 5 hertz, the value will be 0. In between, whatever the nature of graph will be there, I don't care about that. But at 1, 3, 5, the values will be 0. That I am pretty sure. And similar thing will be happening in -1, -3, -5 as well. Okay. Let's go to the next one. Now we need to study about white noise. So what is white noise? What is white light? Forget about noise. What is white light? So white light gives the intensity in the same direction. No. If I light up a torch here, so that torch will give me the intensity in the same direction. Like all the intensity will be same. In all the direction, intensity will be same. What I mean to say is that white light will give you the intensity same in all the direction. So white means intensity is same. So what do you mean by white noise? That it is a random process who is having same kind of density, same kind of power density for all the frequency. For all the frequency, the power density would be the same. That means what should be the curve? The curve will be flat. For all the frequencies, from -infinity to infinity, all the frequencies are having same power density. So curve will be flat. That means Sx of f will be a constant value. That constant value is written by n0 by 2. Sir, why you are writing down divided by 2? It is just a way of noting it down. Okay. So they will show it by n0 by 2. How they will show it? n0 by 2. So what is a white noise? White noise means PhD is constant. Meaning of white noise is PhD is constant, or you can read the definition: a type of random process which contains equal power at all the frequencies. Equal power density I should write down, not equal power density I should write down. At all the frequencies, the power density is equal. So here, this was your watt per hertz, this is your hertz. So PhD will be flat, that's it. If in the examination white noise is written, if you see the word white, white means flat, that means everything is constant. White light, it will give you intensity same in all the direction. So similarly white noise, that means PhD will be flat. So what will be the value of Rx of tau? What you need to do? You need to calculate the inverse Fourier transform. Inverse Fourier transform. So delta t has a Fourier transform of 1. That means 1 has the inverse Fourier transform of delta t. So n0 by 2 will have an inverse Fourier transform of n0 by 2 delta tau. So this is its Rx of tau and this is its Sx of s. White noise has zero mean. Okay, white noise has zero mean. What I have seen in some places that people will say that, sir, you integrate this. So you know that there is no impulse, so answer should be 0. So that's why mean is 0. That's why mean is 0. This is actually incorrect, because I told you this particular thing is only valid when your random process is not having any offset. So the given condition was that mean is 0. White noise is having 0 mean. This is given. Then you are getting this flat PDF. Sorry, flat PhD. Are you able to understand what I am saying? They have given that mean is 0. Mean will be 0. For white noise, mean will be 0. Right? For white noise, mean will be 0. Does that mean that I cannot have any impulse here? I can still have the impulse here if my white noise is having some offset. Are you able to understand what I am saying? Do you remember the example of A cos omega t plus theta plus B? Right? This was the example. What was our Rx of tau here? Rx of tau came out to be some constant was there, cos omega tau plus 1 by 4. This was a random variable, this was also a random variable. This was our answer. Here our mean was 0. But if I calculate the power spectral density, will I have the impulse? Yes, I will have the impulse. So will I say that I will calculate the area from 0 minus to 0 plus? So what is the area of this impulse? Whatever the area you will get, that will be the DC power. DC power will be 0 actually, because mean is 0. But actually if you apply this formula, your DC power will be non-zero. So there will be wrong because it was having some offset. So white noise is not having any offset and its PSD is flat. So now you can say that mean is 0. Basically, if this thing is coming out to be 0, that doesn't specify that always the mean will be 0. No. The mean can still be non-zero. So this is the formula we use only when we say that white noise is, only when we say that random process is not having any offset. So white noise also will not have any offset. If I add up any offset, then it may have some DC value. But purely white noise will never have any offset and mean value will be 0. So forget about all this discussion. Mean value of white noise is 0. But like if someone says that you are integrating from 0 minus to 0 plus, you are getting the area 0, that's why the mean is 0. No. Condition is given. First it is given that the mean is 0. Then you are saying this thing. From here, this thing is not coming. This thing is given, then this thing is coming. Are you able to understand this point? Right? From here, this is not coming. This was given, then this is coming. That's the difference. This is what I was telling. But no one will ask you in the examination. In the examination, white noise will be having the 0 mean. That's it. Okay. What will be the power? So formula of power will always work whether it is having any offset or not. So formula of power will always work. It will go from minus infinity to infinity as x of f dot df. So when you calculate the whole power, what that would be? Infinity only. Okay. So whole power will be infinity. You calculate the whole area, that would be infinity. So these are the two main important properties, that white noise will have infinite power and mean will be 0. So do you really think that it practically exists? So practically there is no meaning of white noise. Okay. Practically there is no meaning of white noise having infinite bandwidth. What is the bandwidth? From 0 to infinity it is going, no? Here also it is going from minus infinity to 0. So infinite bandwidth is there. What does that mean? Infinite bandwidth with constant PSD. That means power will be infinity because area will be infinity here. So infinite power is not practically possible. So this ideal white noise is not practically available. So what kind of noise is available? So what will happen is that it will have a constant PSD, but with time, with frequency, it will keep on reducing. At higher frequency, it will reduce. So here you will get a finite area. We will solve the problems, you will understand. So from this slide, what you need to remember, only thing you need to remember is this, that's it. White noise will have a constant PSD. That's it, nothing else. White noise will have a constant PSD. Mean will be 0, mean square value will be infinite for ideal white noise. Okay, more points we can see. So your Rx of tau is 0 when tau is not equal to 0, right? Basically, let's just say this was the random process of your white noise. This was the random process of your white noise. So your Rx of tau is coming out to be, what is the graph of Rx of tau? So let's erase it. Let's erase it. Let's draw the graph of Rx of tau. So Rx of tau will only have one impulse, will only have one impulse at tau equals to 0. At tau equals to 0, right? So this have an impulse of area n naught by 2. But if I ask you the value of Rx of 0, so what that would be? N naught by 2 delta of 0. What is the value of delta of 0? That is infinity. Value, area is n naught by 2, but value is infinity, no? Impulse means infinite value. So yes, Rx of 0 tells the mean square value and it tells the total power. Yes, it is coming out to be infinity only. But another thing you can notice is that Rx of tau is 0 for rest all the values. Rx of tau is 0 for tau not being 0. That means what I do is that I calculate one sample at t equals to t, another sample I calculate at t plus tau, where tau is non-zero. That means first sample I am calculating at t, second sample I am calculating at t plus 2. So first sample calculated at t, second sample calculated at t plus 2. I multiply both of them and then I take this thing. What answer I will get? 0. Because I know that Rx of 2 is 0. So any two successive sample, the sample should not be at the same point. This is the target. If one is at t, other one could be at t plus 0.1. It could be at t plus 0.001. It should not be at t only. So any two samples you take, any two successive sample you take, if you take their correlation, if you calculate their correlation, it will come out to be 0. What does that mean? That these successive samples are orthogonal. Orthogonal. Now you let me know for white noise, what is the value of expectation of xt? What is the mean? 0. And what will be the value of x of t plus 2? That will also be 0. So for white noise, these two are 0, right? In white noise, this is also 0, this is also 0. And when you multiply, when you calculate this particular thing, this also came out to be 0 only. I calculated this particular thing, it is also coming out to be 0. So can I write it down in this manner, that it is equivalent to expectation of xt dot expectation of x of t plus 2. Basically, I can take expectation operator in the multiplication, because expectation of xt is also 0 and x of t plus 2, this is also 0. This guy is 0 and this guy is also 0. So 0 into 0 will come out to be 0, and that is coming out to be expectation of x of t dot x of t plus 2. So what do you understand from here? Successive samples are uncorrelated as well. Are you able to understand this point or not? In white noise, mean is 0, mean square value is infinity, and successive samples are orthogonal and uncorrelated. These 3 points are there and it can be asked in the examination. Can I say that they will be independent as well? Absolutely not, because uncorrelation doesn't mean independence. So for white noise, what all points you can remember? What they can ask is that which of the statement is true for a white noise? First one, mean is 0, total power is infinity, successive samples are orthogonal and uncorrelated, successive samples are independent. So fourth statement will be wrong, first three will be correct. Okay, orthogonal and uncorrelated. In case of noise, if they are giving orthogonal, surely they will be uncorrelated as well. Or if they are giving uncorrelated, surely they will be orthogonal as well. Very easily we have proved it, because I know that mean is 0 and autocorrelation function is also 0. So everything is 0, 0 only. So x of t, expectation of x of t into x of t plus 2 will be equivalent to expectation of xt dot x of dot expectation of x of t plus 2. So if this is the scenario, then we can say that they are uncorrelated as well. But uncorrelation doesn't mean independence, right? And what is the bandwidth? Bandwidth is infinity. Now if white noise is Gaussian, so do you remember one thing, that if your xt is WSSRP plus Gaussian, then it will become SSSRP as well. So what do you understand from here? Gaussian white noise will be strict sense stationary random process. Gaussian white noise. White noise is WSSRP. What I am saying is that, let's write down the difference. So for white noise, what we have understood? For white noise, we have seen that it is WSSRP, it is having 0 mean, also successive sample orthogonal and uncorrelated. Now if it becomes a Gaussian white noise, now you know that when you are collecting the sample, this was my white noise, and when I collected the samples at t equals to t1, at t equals to t2, I got to know that PDF of x of t1 was Gaussian. PDF of x of t2, it was also Gaussian. So I got to know that my white noise is Gaussian now. Okay, white noise is Gaussian. So if your random process is Gaussian, and already your random process was WSSRP, so now because of the Gaussian it will become SSSRP, right? Along with that, in Gaussian random process, one another thing I told you, in Gaussian random process, if you get uncorrelated random process, if you say that successive samples are uncorrelated, then surely they will be independent as well. So here you can write down zero mean also stands true, right? Along with that, successive samples are orthogonal, uncorrelated and independent. Is that clear to you all? So when we were studying Gaussian random process, that's why we were studying Gaussian random process. There I told you that if your WSSRP becomes Gaussian, then it will become SSSRP as well. So what I have written, if white noise is Gaussian, then it will become SSSRP as well. Along with that, it will have independence as well. So here successive samples will be independent, uncorrelated and orthogonal. Along with that, this will become SSSRP as well. So if I ask you a true false statement, first statement, white noise is WSSRP, correct. Successive samples of white noise will be orthogonal and uncorrelated, correct. Successive samples of Gaussian white noise will be independent, correct. Successive sample of white noise will be independent, wrong. Successive sample of white noise will not be independent, but successive sample of Gaussian white noise will be independent. Is that clear to you? So this discussion is clear to you. Only for the sake of true false we are doing all this discussion. This discussion will not be helpful for problem solving. Problem solving you already know. PhD will be given, you will solve it. PhD will be given, H of f will be given, you will get the Sy of f. So problem solving will be very easy, but only for the sake of true and false, what I expect is that some question can be framed in true or false in this manner, because in the textbook these things are written. But in the gate examination, they never ask questions from white noise or Gaussian white noise in this manner. How they ask the question? This is how they ask the problem. Like white noise will be passing through a LTI system, what you will get the output. Okay, so these things you already know, because you already know the PhD, then you can comment everything about the output, right? So let's get started. Let's do this discussion now. From this discussion of roughly around 15 minutes, what do you understand is that this is the slide that you understand. Okay, let's get started with the discussion. X of t is a white noise. Okay, X of t is a white noise. H of t is a filter or whatever it is, a LTI system. It is a LTI system having an impulse response of H of t, and you get an output yt. So what will be your Ry of tau? Ry of tau will be Rx of tau convolution with H of tau convolution with H of minus tau, right? Now you just let me know what is your Rx of tau. So Rx of tau is n0 by 2 delta tau, right? n0 by 2 delta tau convolution with H of tau convolution with H of minus tau. Let's just say this will give you some particular function. Any function convolved with delta tau, nothing will happen, right? So what will be the answer? n0 by 2 convolution with H of tau, sorry, not convolution, n0 by 2 is a constant value, sorry guys. Delta tau convolved with H of tau will give you H of tau only, n0 by 2 is a constant value. So n0 by 2 H of tau convolution with H of minus tau. So this is something you will be getting. H of tau convolution with H of minus tau n0 by 2. Okay, and what will be a mu of y? Mu of y will be equals to mu of x, and whatever the frequency response you get at omega equals to 0, but you know that mu of x is 0. So always your mu of y will also be 0. What about Sy of f? So Sy of f will be mod of H of f whole square Sx of f. So Sx of f is constant. So mod of H of f whole square n0 by 2. Did you go? Right? Do you understand this point? So this will be your Sy of f. Very simple, very straightforward, right? Everything is very simple. Ry of tau, you can write down everything on your own. N naught by 2 delta tau. This is answer you will be getting. Sy of f I already know. Mod of h of f dot s sx of f. N naught by 2 I will be getting. What about the total output power? So total output power will be given by minus infinity to infinity Sy of f dot df. So that will be minus infinity to infinity. What is your Sy of f? That is N naught by 2 mod of h of f whole square dot df. So what you are getting? N naught by 2 minus infinity to infinity mod of h of f whole square dot df. Right? So this is one of the expression you are getting. Do you remember the Parseval's theorem? In Parseval's theorem, what did I tell you? Minus infinity to infinity mod of h of t dot dt will be equivalent to minus infinity to infinity mod of h of f whole square dot df. So what you will get here? Mod of h of t whole square dot dt. So let's write down this expression again at the again here. Okay, what is the final expression you are getting? Total output power. So total output power you are getting as N naught by 2 minus infinity to infinity mod of h of f whole square dot df, that will be equivalent to N naught by 2 minus infinity to infinity mod of h of t whole square dot dt. What is this? Let's just say this was your h of t. So what do you think? What is this? Mod of h of t whole square dot dt. What is this? What do you think? Energy of ht, no? Energy of ht. So what is the answer you are getting? N naught by 2 energy of ht. No need to mug up anything. No need to mug up anything. But whenever you get this particular thing and you see this kind of h of t is given, so you will not say that, sir, now I need to find h of f, then I will do the square and all these things I will do. No. You know that this particular thing is equivalent to simply the energy of this waveform, and energy of this waveform you can very easily find out. So N naught by 2 just energy of this waveform. So in this question what they are saying? Input PSD is given, it is passed through a LTI system, LTI filter whose impulse response is given. Zero mean white Gaussian noise it is zero mean white Gaussian noise, that means mu of x is 0. So what will be your mu of y? Mu of y will also be 0. What you need to find? You need to find the variance of filter noise at t equals to 4 seconds. Does that matter? T equals to 4 seconds. No. Why is that so? Because everything is WSSRP. Because yt is WSSRP. So this t equals to 4 seconds doesn't matter. What you need to find? You need to find the variance. That would be equals to the total power minus mu I square. What is this? This is 0. So what you need to find? Total power only you need to find. So basically what they are asking in this question, total output power. So what you will do? I don't remember anything. I don't even know what it is. I don't even know about this slide. So what I will do? I will do that. I know that I need to find total power. So my total power will be, so my answer will be equivalent to minus infinity to infinity Sy of f dot df, and that would be equivalent to minus infinity to infinity mod of h of f whole square sx of f dot df. I know that sx of f is this thing, minus infinity to infinity mod of h of f whole square dot df. Now I know that this particular thing, if I go on calculating, it will be very difficult because I will have to find out h of f and then I will need to calculate. But I remember the Parseval's theorem. And Parseval's theorem says this particular thing. Parseval's theorem says this particular thing. So you take the mode, do the square, and then you calculate the final answer. So n naught by 2 is outside. Do the square. Take the mode and do the square. So this plus a, this minus a will also become plus a, and this plus a will remain plus a only. So what you will be getting? A square into 3. What will be this value? So everything will become plus, and then a will become a square. So a square into 3. So what you will be getting? 3a square. So what will be your final answer? 3 by 2 and not into a square. That's it. This is the final answer. So in this slide, you are not learning anything new. You know that what will be your Ry of tau. Ry of tau was Rx of tau convolution with H of tau, H of minus tau. Rx of tau is n naught by 2 delta tau. So you get to know that Ry of tau. What is Sy of f? Sy of f is mod of H of f whole square multiply with Sx of f, right? So mod of H of f whole square Sx of f is n naught by 2, right? So this also I know. About the total power, I got to know that it is equals to n naught by 2 into energy of Ht. N naught by 2 into energy of Ht. What is the energy of Ht? A square into 3. So 3 square into n naught by 2. So 3 by 2 n naught into a square, that would be the answer. Let's see more questions. So try this one. Xt is the white noise. PSD is given 5 volt per hertz. So value of n naught by 2 is 5 here. What they have given? N naught by 2 is 5. So you will not say that, sir, I will find the value of n naught. Why would you find the value of n naught? N naught by 2 is 5. This is what they have given. Okay. N naught by 2 is 5. It is passed through a low pass filter with the pass band gain of 0.5 and cutoff frequency of 5 hertz. Then it is added with the ZT. It is added with some ZT whose PSD is given. And then you get output YT. What is given? See it very carefully. ZT and XT are uncorrelated. ZT and XT are uncorrelated, not orthogonal. Not orthogonal. They are uncorrelated. Find the total power of YT. Uncorrelation in case of white noise will tell they are orthogonal as well. Are you able to understand this point or not? Basically, whenever the question is based on noise, wherever you see uncorrelation, you will say that they will be orthogonal as well. Ideally, what is the meaning of uncorrelation? Uncorrelation says, what does uncorrelation says? Uncorrelation, Rx of tau. That will say that Rx of tau will be equals to expectation of Xt dot expectation of X, expectation of Xt plus tau, right? So this will be mu x, so this will be basically mu x square. And orthogonality will say that Rx of tau will be 0. And what orthogonality will say? That Rx of tau will be 0. Here what they have given? They have given uncorrelation. Uncorrelation between two signals. What does that mean? What they are saying? That Rxz of tau is equivalent to expectation of Xt dot expectation of Zt plus tau. This is what they are saying. Okay. So this is what they are saying, that this is the scenario. But you know one thing. What do you know? That mu of x will be 0. Whenever white noise is coming, mu of x is 0. Here they don't need to tell it is having 0 mean. You know that it will be 0 mean. So what you are getting? 0 here. So by default it has become orthogonal as well. You started with uncorrelation. So now Xt and Zt are orthogonal as well. But our matter of concern will be here. Whatever the output you get here, let's just say the output I get here is Pt. So what will be my Yt? My Yt will be Pt plus Zt. And somehow if I prove that Pt and Zt are orthogonal, then I can simply add their PhDs. If I prove that they are orthogonal, then I can simply add their PhDs. So what will be my PhD of Sy of f? That will be PhD of Pt and PhD of Zt. But this will be true only when Pt and Zt are orthogonal. Right? You remember this condition? No? Say yes or no. Do you remember it or not? I hope you remember it. What we used to do? First I would find Ry of tau. So Ry of tau was coming out to be a square Rx of tau plus b square Rz of tau. In this lecture as well we have seen it, right? And then I would calculate the PhD. So PhD can be added directly if Pt and Zt are orthogonal. But what is given? Xt and Zt are orthogonal. From here what I can get to know is that Xt and Zt are orthogonal. Now I need to think whether PT and ZT are orthogonal or not. So let me tell you guys, if you are passing this white noise here and this is something you will get, what will be the mean of this guy? What will be the mean of PT? That will also be 0. Mean of PT will be 0, right? So 101% they will be orthogonal. If one of the mean is coming out to be 0, no, then surely they will be orthogonal. What is my target? For calculating, what I need to calculate now? I need to calculate RPZ of tau. This is my target. I need to calculate RPZ of tau. If it is coming out to be 0, then I can say that PT and ZT are orthogonal. Right? So now I need to calculate this particular thing. So what I will do? Just 1 second, guys. Just 1 second. Yeah. So where were we? We need to find RPZ of tau. Right? So what that would be equivalent to? Expectation of PT into Z of T plus tau. Now what is your PT? PT is coming out from XT convolution with HT. I am calling that this is an impulse. This is having an impulse response of H of T. So XT convolution with H of T. So this will be your PT. XT convolution with H of T dot Z of T plus 2. Now, can I write it down in this manner? Minus infinity to infinity H of alpha X of minus alpha plus T dot dt and then multiplication with. Now expectation operator can come inside. It will ignore the integrator. It will ignore H of alpha as well. So what will happen? Expectation operator is coming inside. There you go. Now you know that XT and ZT are uncorrelated. If they are uncorrelated, then you can separate the expectation operator. So what I am doing? First I am applying the expectation operator on, because expectation operator looks only for randomness, and then I am applying expectation operator on this thing. But I know that this is 0. So H of alpha multiply with 0 will be 0 only. Integration of 0 will be 0. 0 multiply with anything will be 0. So what did you get to know? This is coming out to be 0. So what do you understand from here? PT and ZT are orthogonal. So this was the important thing to prove here. This was a very, very important thing. This was not given in the question. What was given in the question? XT and ZT are uncorrelated. So first thing is that, what if I am having the PDF of XT and I am having the PDF of ZT? Can I add both of them? No. If they are uncorrelated, then you cannot add them. If they are orthogonal, then only you can add them. So first thing I proved that, although this was not required for this question, but still I proved that if they are uncorrelated, then they are orthogonal as well. Why is that so? Because this is the beauty, that here expectation of XT is 0. So two signals are there, okay, two random process are there. One is a white noise, other one is some WSSRP, and they are saying that they are uncorrelated, so surely they will be orthogonal as well. Do you understand the first conclusion? First conclusion is, one of the signal is white noise, other signal could be anything. One of the process is white noise, other process could be anything. If I am saying that these two are uncorrelated, so if one of the process is white noise, then they will be surely orthogonal as well. Uncorrelation doesn't apply to orthogonality, that I know. Uncorrelation doesn't mean orthogonality. But if one of the random process is white noise, then surely uncorrelation will tell orthogonality as well. Here also we proved the same kind of thing only. We did not prove it, I was just saying the same thing, that if a process are orthogonal, they will be uncorrelated as well. But here I was talking about the process between XT and X of tau, between white noise and white noise only. But in place of white noise, if some other random process is also coming, then they will also be orthogonal. But our matter of concern was not with XT. Our matter of concern will be with PT, because I need to add PT with ZT. Right? PT and ZT will be added. So can I add their PhD as well? So how can I verify that? Can I add their PhD or not? So for them, PT and ZT should be orthogonal to each other. PT and ZT should be orthogonal to each other. I don't care whether they are uncorrelated or not. My major concern is they are orthogonal or not. So for that, what I did, I calculated this particular thing, and then I got to know that this is coming out to be 0. So they are orthogonal as well. Since they are orthogonal, now I know that my Sy of f will be equals to Sp of f plus Sz of f. So now what I need to do is that I need to calculate the PhD of PT and then PhD of Z is already given, I need to add them. You will see the solution of this particular question on YouTube. People have just calculated this, then calculated this, add them up, and then calculated the area. Nothing, no discussion is there. Like, we did not even start the question, right? We did not even start the question. First thing we are discussing that how we can add their PhDs. This is the important part, no? Because this is the beauty of the question paper setter. He did not give orthogonal here. He gave uncorrelated. And this uncorrelated thing is being used here. How it is being used? Here I have used this thing, and here I will write down in the bracket as well that XT and ZT are uncorrelated. XT and ZT are uncorrelated. So that's why I can use this particular thing, that I can separate the expectation operator. Here this discussion was not important with respect to this question. In this question, this discussion was not important, but this discussion was important. RPZ of tau, if I need to find out, are they coming out to be 0? Yes, that means PT and ZT are orthogonal. XT and ZT are orthogonal, I don't care about that. XT and ZT are orthogonal, I don't care about that. But they are orthogonal, I care about that. Right? So now I need to find the PhD of PT. So can you find the PhD of PT? Very simple. This is a white noise, constant PhD is there, then this is a low pass filter, pass band gain of 0.5, cutoff frequency is 5 Hz. So can you make this diagram? Yes. Sx of S, Sx of F having 5 watt per Hz PhD. It will be passed through a low pass filter. Low pass filter is having frequency response of something like this. 0.5 is the pass band gain, and it is going from -5 to 5. So what I need to do, I will actually require this particular thing, right? Because my SP of F would be equivalent to into Sx of F. So I need to do the square here. So this will become 0.25. Now 0.25 multiply with this one, what you will get as the final SP of F. So this will be your SP of F. This will be your SP of F. So -5, -5. So 0.25 into 5, what that would be? 5/4 watt per Hertz. So just amplitude we have multiplied, because after -5 nothing would be there, plus after +5 nothing would be there. So this is what you are getting. This is your SP of F. But this is something we don't need to calculate. What we need to calculate? We need to calculate the power of Yt. Power of Yt. So power of Yt will be equivalent to what? -infinity to infinity Sy of F dot df. -infinity to infinity. What is your Sy of F? Sy of F is SP of F plus SP of F, SP of F plus Sz of F plus Sz of F dot df. Can I separate the summation? Yes, surely I can separate the summation. So you calculate the power of SP of F, and then you calculate the power of Sz of F, and then you add them up. So what will be the power of SP of F? That would be 10 into 5/4, 50/4, plus what will be the power of Sz of F? That would be 10 into 1 divided by 2, 5. And yeah, this conclusion also I have written down. I forgot to tell this conclusion. But yeah, let's solve it first. Then 12.5, 17.5 watt. So what is this conclusion we have written? This is the answer. Getting the answer was easy, but this problem was having some very good hidden meanings. So hidden meanings were there. So from now onwards, what you will remember, that if one of the signal is a white noise, if xt, which is a white noise, and zt, if they are uncorrelated, then they will be orthogonal to, and if they are orthogonal, then they will be uncorrelated to. So both things will go together. Just as you see, one of the signal is white noise, then uncorrelation and orthogonal both will be there. Now if your white noise is passed through a filter to produce some another random process, that is PT, and it is said that xt and zt are uncorrelated, then PT and zt will also be orthogonal. You don't need to remember it. Can you do this calculation in the examination? Surely you can do this calculation in the examination, right? You will do this calculation, and then you will get to know that yes, they are orthogonal as well. So whatever that we saw here, only we are writing down here. So these are the two conclusions that we are making. So the problem starts from here, the answer starts from here, but the setup of the problem was very nice. The setup of this question was very nice. xt and zt were uncorrelated. From there we proved that pt and zt are orthogonal. So this was the setup, which was very, very nice. Okay, so this slide was very important for this particular question. Then only you could add the PhDs. Otherwise, you could never add the PhDs, right? Let's see next question. So noise PDF is noise PhD is given. What is this? This is your white noise only. The PhD is given. Flat PhD is there. Even if they tell that it is not white noise, you should know that yes, 0.5 watt per hertz flat PhD is there. H of t is given. You need to find output power. What will be the output power? I know that, sir. What will click to me in the examination? My output power will be, my output PhD will be this. My output PhD will be this. This will be my output PhD, right? So now what I will do is that, sir, my output power will be this thing. So Sx of f is 0.5. So I can take out 0.5 minus infinity to infinity. And just as I see this step, I will see what is given. Frequency domain is given or time domain is given? Time domain is given. So I know that because of the Parsifal's theorem, I can convert them. Right? So 0.5 minus infinity to infinity. E to the power minus t square by 2 will always be positive. You need to do the square of this one. So what you will get? 0.25 e to the power minus t square dot dt. So what you are getting? 1 by 2, 1 by 4, 1 by 8 minus infinity to infinity e to the power minus t square dot dt. So what you are getting? Under root pi by 8. So this is the answer you will get. You can solve it. As far as I remember, it was 0.22 under root pi by 8. Under root pi by 8. Pi under root divided by 8. Yeah, 0.22. 0.22 watt. That would be the answer. Okay, very simple. So I will have to change the slide now. Lecture I will not change, but I will have to change the slide. So I will have to pause the video. Few more questions we need to see. Okay, 2 more questions we will see. Those questions are also very good. So I will change the slide now and then I will come back. Okay then, yeah. So let me change the slide. Yeah, welcome back guys. So we need to solve this question. What we are doing here, x of t is a W plus RP. It is not a white noise, it is a random process which is white sense stationary. It is having a mean of mu x and it is having a autocorrelation function of Rs of tau and PhD of Sx of f. It is passed through a Hilbert transformer. Okay, so this is a Hilbert transformer. It is passed through a Hilbert transformer and you are getting output yt. You need to comment on mu y Ry of tau Sy of f, right? So I know that even if I need Ry of tau, I will be comfortable going towards the PhD. So first I will find out the PhD. So my PhD Sy of f would be equivalent to, I already have made the h of f for Hilbert transformer. What is h of f? That is minus j signum f, right? For positive value minus j, for negative value plus j. So mod of h of f whole square s x of f. So can you let me know what will be mod of h of f whole square? Calculate the mod of h of f. What that would be? 1 only, no? Mod of j will be 1. Mod of minus j will be 1. So what you are getting? Output PhD is equivalent to input PhD. If this is the scenario, then Ry of tau will be equivalent to Rx of tau. There you go. No change in the power. What you are understanding? There is no change in the power. Output power is equals to input power. Output power is equals to input power. So when you pass a random process through a Hilbert transformer, your autocorrelation function also doesn't change and your PhD also doesn't change, and surely if it is W plus RP, this will also be W plus RP only because it is a LTI system. So nothing got changed here. Power is also the same. What about the mean? Like, can you say that yt will also be equal to xt? No, yt is not equal to xt. Their autocorrelation function are same, their PhD are same. It doesn't mean that yt is equal to xt. What is yt? Yt is simply x of t convolution with h of t, which is equivalent to 1 by pi t, right? H of t is 1 by pi t. Okay, this is your yt. So you cannot say that yt and xt are equal. Their autocorrelation function and their PhD are equal. Output power is equal to input power because Rx of 0 is equal to Ry of 0 and their PhD are also same, so their area will also be the same. What about mu y? So mu y will be mu x and then h of f is already given at f equals to 0. I need to check. So that will be equivalent to mu of x. Now If I am asking this question in mathematics and I ask you what is the value of h of f at f equals to 0, what is the value of h of f at f equals to 0, you will say, sir, it is undefined because it is not continuous. For f less than 0 it is plus j, for f greater than 0 it is minus j. So f less than 0 is basically f h of 0 minus is not equivalent to h of 0 plus. You agree to this point? So if they are not equal, if h of 0 minus is not equivalent to h of 0 plus, that means h of 0 is not defined. Ideally this should be the answer. But actually what do we do is that we take the average plus j and minus j. When I passed my xt through Hilbert transformer, it was a random process, it was a random WSSRP process, and when I passed it through the Hilbert transformer, I got to know that my output mean is actually coming out to be 0. That means here the value would have been 0. Ideally the thing is they should not be 0. You should say that it is undefined, but actually what do we do is that plus j minus j divided by 2, what answer you will be getting? 0. If I ask you what is the value of ut at t equals to 0, will you say, sir, it is 1 plus 0 divided by 2, 1 by 2? No, that is wrong. The value you will say it is undefined. But here in this particular question, because this statement is written that if a random process, if a WSSRP process is passed through a Hilbert transformer, the mean value of the output will be 0. This kind of statement you will find in a lot of textbook. Hilbert transformer will kill that DC value of the input random process, which is WS. So kind of you can say that this I already know. For an LTI system, this I already know. For any LTI system, this I already know. That means mu x is non-zero, so this has to be 0. That means h of f at f equals to 0, they are taking equivalent to 0 only. So what is your mu of y? Mu of y will come out to be 0. This is your mu of y. Another thing, do you remember the another formula? There was another formula. What was that? Mu of y was equivalent to mu of x multiplied with the area of ht, right? Area of ht. So what is my ht? Mu of x minus infinity to infinity. What is my h of alpha? H of alpha will be 1 by pi alpha dot d alpha. Now if you calculate the area of this particular thing, then you will say that, sir, again it will be undefined because alpha equals to 0 does not converge. So this integration will not converge. This integration will not converge, right? But what you can see, h of t is a odd function. H of t is a odd function, right? If you put h of minus t, what you will get? Minus 1 by pi t, which is a odd function. So h of t is a odd function. For an odd function, if you calculate the whole area, what area do you get? 0. So just like what we are doing, we are just interrelating the things. Ideally, in mathematics, if someone is asking you what will be the integration of this particular thing, what is the answer of this particular calculation? That you are calculating the area from minus infinity to infinity, 1 by pi alpha dot d alpha, you will say it will not converge. Why it will not converge? Because at alpha equals to 0, you will get infinity. That means the graph is not continuous. So this integration also will not converge. That would be your answer. But if I want to say that it is an odd function, for the odd function area, total area is 0. I am just telling that why I can put it equals to 0. Or otherwise, you can just remember a statement that mean of the output of the Hilbert transformer will be 0. Or this is how you can remember that, okay, this area would be 0. Ideally, it is not 0. So bottom line is the mean of the output of a Hilbert transformer will be 0. Is that okay for you? Mean will be 0 and both these things will be equals to the input correlation and input PST. Very simple thing, very straightforward. Let's go to our next question. So next question is pretty good and it will help you solve a lot of problems. So let me explain the setup. So there are two cases. This is the first setup and this is the second setup. This is the first setup and this is the second setup. In first setup, what you are doing? Xt is a WSSRP. Rx2 is given. That means it is a white noise, right? Xt is a white noise. N naught by 2 delta tau. Sx of f will be N naught by 2 and its mean is 0. So surely it is a white noise. Now it is passed through an ideal low pass filter with the cutoff frequency of B and now you are getting some output yt. You need to find the autocorrelation function of yt. You need to find PSD of yt and you need to find the mean of yt. Okay, these things you need to do and you need to tell the output power as well. What is the input power? Input power is infinity. If I ask you here, what is the input power? Input power is infinity. Here also input is not changing, everything is same. Input is not changing, everything is same. But now the filter is not ideal. This is a RC low pass filter. This is a RC low pass filter whose 3 dB cutoff frequency is given as FC. 3 dB cutoff frequency is given as FC. Okay. So this is a RC low pass filter. Again, you need to find the same things. Now, another question is there. You need to find the relation between FC and B such that output power is the same in both of the cases. In both of the setup, output power is the same. Did you understand the question? First, solve the first problem. First problem says that find out all these things. So forget about this setup. First problem is saying that you find out all these things. So Ry of tau, Sy of f, mu of y, all these things you need to find out. So this is your setup. Sx of f is there, h of f is there, and I will get Sy of f. Why I am doing all the calculation in terms of PhDs? Because this is easier, right? Doing the calculation in terms of PhD is easier. Let's just say in the examination they only asked Ry of tau. So what you will do? Sir, Rx of tau convolution with h of tau convolution with h of minus 2. Although this is not that tough because Rx of tau is n0 by 2 delta t. n0 by 2 delta 2. Convolution with h of tau convolution with h of minus 2. So n0 by 2 h of tau convolution with h of minus 2. But now this particular thing will be difficult because this is your h of f. This is h of f, not h of t. So from here you need to get h of tau. How will you get h of tau? From here. How will you get h of tau from here? H of tau. This is a rectangular. That means it will be sampling function. Here it will be sampling function. So do you remember that standard answer? Minus a sine at by pi t. What will be the amplitude? Amplitude will be a. But this was in terms of omega, right? This was in terms of omega. So I need to convert it in terms of omega. So here what will become? Minus 2 pi b plus 2 pi b. So what you will get here? Sine at by pi t. Sine at by pi t, that means minus 2 pi b plus 2 pi b. In place of a, what you are putting? 2 pi b. In place of a, I am putting 2 pi b divided by pi t. And here amplitude is 1. So sine at by pi t, sine at by pi t divided by 2 pi minus b2 plus b, amplitude is 1. So this is your h of tau, and then you need to convolve it with h of minus tau. So this convolution is not that easy, right? This is a sampling function. This will also be a sampling function. What would be your h of minus tau? H of minus tau will also be the same only because it is even. If you put minus tau here, minus will come outside. Here also minus sign will come outside. Minus will get cancelled out. So this is what you will be getting, and then you convolve both of them. So even in the signal system, when we convolve these two kind of signals, what do? We go to the frequency domain only, right? So convolution in time domain will be difficult always. So 99% chances are there that you will be solving the problem in the frequency domain only. So I will solve the problem in the frequency domain. So this is my h of f, but I would require mode of h of f whole square. Why is that so? Because I know that my output sy of f would be mode of h of f whole square s x of f. So will there be any change? No, because amplitude is 1, square of 1 will be 1 only. So what will be the answer you will be getting? Sy of f. The answer sy of f would be, it would be there between minus b to b it would be there between minus b to b, and node by 2 multiply with 1. This is your sy of f. Sy of f. If I need to define my sy of f, how will I define it? What will be the definition? Definition will be n node by 2 between minus b to b. Otherwise it is 0. N node by 2 between minus b to b, otherwise it is 0. Okay, this will be your sy of f, right? But from here I will take inverse Fourier transform to get ry of tau. How do I get ry of tau? I need to take the inverse Fourier transform. What I need to do? I need to take inverse Fourier transform. So when I take inverse Fourier transform, I am more comfortable in the omega domain than in f domain. So I will convert it into the omega domain. This will become minus 2 pi b plus 2 pi b. Amplitude remains the same, n node by 2, n node by 2. What I need to do? I need to take the inverse Fourier transform. So what I will get? Sine at by pi t. Amplitude being n node by 2. Sine at. What is the value of a? Sine at by pi t. right? So you will divide by 2 pi here, multiply by 2 pi here, and not by 2, not 2 pi, 2b. I am multiplying by 2b and dividing by 2b as well. This could also be mentioned in the option. This will be the answer, and this could also be the mentioned in the problem, that 2 pi b2. What this would be? So what you are getting, n naught into b, sink of 2b2. So this is your ry of 2. So both of the things could be mentioned in the problem, sorry, in the options. So this would be your ry of 2. Are you able to understand this point or not? Only ry of 2 they were asking. In the examination it might happen that only ry of 2 they are asking. Still you will go with the frequency domain analysis, because you can easily find out sy of f. From there you can take the inverse Fourier transform. And what about the total power? Total power will be just this area, n naught by 2 into 2b. That would be n naught into b. So total power will be n naught into b. So here everything we have find out. What is the total power? N naught into b. Ry of 2 we have find out, sy of f we have find out. What about mu y? So mu y will be equals to mu x into h of f at f equals to 0. So what is the value of mu x? Already 0. So what will be your mu y? Mu y will be 0 only. In the second case as well, mu y will be 0 only. In this case as well, mu y will be 0. In both of the cases, mu y will be 0. Right? So first question is done. First problem is done. Now what about the second one? Input is same. Now your transfer function is changing. What is your h of s now? Here you are applying the input, here you are getting the output. This would be your xt, this would be your yt. So what is your y of s divided by h of y of s divided by x of s, which is h of s, 1 upon 1 plus src. So what would be your h of omega? 1 upon 1 plus j omega rc. Okay. What would be your mode of h of omega? 1 upon 1 plus omega square r square c square, and you take the under root. Why I am finding mode of h of omega? Because I know that my, let's find out in terms of omega only. So my sy of omega, this I am solving my second problem, okay, second setup. So my sy of omega will be equivalent to mode of h of omega whole square sx of omega. Sx of omega I know it is n naught by 2 only, and now I need to do the whole square of this one. So what answer I am getting? 1 upon 1 plus omega square r square c square into n naught by 2. This is your sy of omega. This is your sy of omega. From this sy of omega, you let me know how will you find out ry of 2. You should be able to do it, because this process, this particular analysis we have already done. Sy of omega we have find out. From here, sy of f, what would be sy of f? From here can you write down sy of f? Surely I can write down, no? In place of omega you need to put f, nothing else. So what will be the answer? 1 upon 1 plus 4 pi square f square r square c square into n naught by 2. This would be the answer of sy of f. But from sy of omega I need to go to rx of 2. ry of 2. Right? So what do you think, what will be the answer? Can I write down directly where I need to go? E to the power minus mode of a2, that would be a square plus omega square. What I need? N naught by 2. Basically, what is my sy of omega? Sy of omega is n naught by 2 is outside, r square c square is outside. So 1 by r square c square divided by omega square plus 1 by r square c square. So value of a is 1 by rc. So e to the power minus mod of tau divided by RC. So 2 by RC divided by omega square plus 1 by R square C square. So what I do is that here I multiply by 1 by RC, multiply by 1 by RC. 1 by R square C square. So here divide by 2. Divide by 2. So this is the answer you are getting, right? So eventually this particular thing I need to put here. So what would be my Ry of 2? So n naught by 2 is a constant, and then 1 by 2 RC would come. So 1 by 2 RC is also a constant. So what you are getting, n naught by 4 RC e to the power minus mod of tau divided by RC. This is the answer you will be getting. This is your Ry of 2. And now if they are asking total power, so here integration will be difficult, no? Like what I mean to say is that here if I find out the total power. So someone will say that, sir, I will do this thing 1 by 2 pi minus infinity to infinity s x of omega d omega. So integration is not that easy. Although not that difficult as well, but not that easy as well. This integration n naught by 2 into 1 by 1 plus omega square r square c square d omega. So not that easy as well, right? And not that difficult as well. Here tan inverse term will come. So tan inverse also you can solve. But from here you can directly get the answer, no? Total power. What that will be equivalent to Ry of 0. What that would be? N naught by 4 RC, right? N naught by 4 RC. This is the total power. People usually remember this answer, N naught by 4 RC, but don't remember it. If in the examination question is coming, you solve it in this manner. If you have enough practice, then you will be able to solve it very quickly, right? Now, what was the next problem they were asking? Find the relation between FC. What is FC? FC is the 3 dB cutoff frequency. What is the 3 dB cutoff frequency of RC low pass filter? What is the 3 dB cutoff frequency of RC low pass filter? Omega C is equals to 1 by RC. Because what is the transfer function? Where is the transfer function? H of omega I have written H of S. So from here if I get the omega C value, you put the denominator equals to 0, what you will be getting? 1 by RC. So that is the 3 dB cutoff frequency. Okay. So from here what will be your FC? FC will be 1 by 2 pi RC. 1 by 2 pi RC. Now what they are saying, what is the requirement? Requirement is find the power such that output power is the same in both of the cases. So in the first case, what was the output power? Now we are solving the next question. In the first case, output power was N naught into B. In the second case, what is the output power? N naught by 4 RC. So what you are getting? B should be equals to 1 by 4 RC. Okay, this is the second question we are solving. Output power should be. Now what they want you to find? They want you to find the relation between B and FC. So what is your FC? FC is 1 by 2 pi RC. So what will be your value of 1 by RC? That would be 2 pi FC. Value of 1 by RC will be 2 pi FC. So what will be the value of B here? Value of 1 by RC. From here can I get the value of 1 by RC? Yes, that would be 2 pi FC. So 1 by RC will be equivalent to 2 pi FC divided by 4. So value of B is coming out to be pi FC by 2. So this is the other answer between the cutoff frequencies. This is the cutoff frequency of ideal low. This is the cutoff frequency of your practical low pass filter. This is the practical low pass filter. This is practically available. You can make this filter, but this is not practically available. This is ideal low pass filter. So what is the relation between ideal low pass filter and what is the relation between the cutoff frequency of ideal low pass filter and your practical low pass filter such that the output power in both of the cases should be same? Is that okay for you? So nothing you will remember here. No need to mug up anything. Just follow the process and you will get the answer. I don't think there was anything tough in this problem. This process was very easy. From here you got this particular expression. From there you need to take the inverse Fourier transform. Then this is the answer you are getting. This was good answer. And then this process was also easy only. For the second question, we saw everything. Here also I need to take the inverse Fourier transform. Inverse Fourier transform is a decent enough thing, but if you have enough practice of signal system, then you will be able to take it very easily, and total power also you can take, and then we need to equate it, then the relation we are getting between cutoff frequencies, right? Very simple question. Let's go to the next one. This is the last question, I guess. Yeah, this is the last problem of your complete random process. After that you will be able to solve all the PYQs. So ideal band pass filter with the bandwidth of 2B is given, center frequency is Fc, you need to tell the expression of Ry of tau. Again, zero mean white noise is available at the input, right? So do it on your own. Okay, very easily we can do it. What will be your Sx of f? That would be n0 by 2, right? Now bandwidth is 2B. 2B in terms of hertz or 2B in terms of hertz only. Okay, this is 2B hertz. This is also hertz. So Xx of f is n0 by 2. Can you make the band pass filter? Yes, this will be the band pass filter. Ideal band pass filter. So H of f, pass band gain is, they did not mention, so pass band gain I will take as 1 only. Center frequency Fc and bandwidth is 2B. Center frequency Fc, bandwidth is 2B. Center frequency Fc, this will be Fc plus B, Fc minus B, and this will be minus Fc plus B, minus Fc minus B. Pass band gain I will take as 1. This is my H of f. What will be my H of f whole square? This will be my H of f whole square. Same. What will be my Sy of f? Sy of f will be n0 by 2 Sx of f, right? What is your Sx of f? That is complete n0 by 2. So what will happen? N0 by 2 will be multiplied with this thing. So what will be your Sy of f? This will be your Sy of f. Sy of f. So this is your Sy of f. Sy of f with respect to f. Okay, well and good. This is your Sy of f. We have made the Sy of f. From here I can easily go to Ry of 2. But how will you take the inverse Fourier transform? What do you see here? What is the magnitude here? n0 by 2. I can surely see that something is shifted to Fc and something is shifted to minus Fc. Do you understand this point? What I am saying? Something has been shifted to Fc and something has been shifted to minus Fc. This I can directly see here. This has surely happened. But whenever I take the inverse Fourier transform, I am more comfortable in what? I am more comfortable in omega domain. So I will go to the omega domain. I will find the value of Sy of omega. So let's see what is my Sy of omega. So Sy of omega will look something like this. Sy of omega will look something like this. Here, just multiply everything with 2 pi, or what I would do is that I would replace everything with omega c. So this amplitude will not change, but this will be omega c, this will be minus omega c, this will be omega c plus 2 pi b, omega c minus 2 pi b. And here also same thing you can write down. I can see that something has been shifted, omega c minus omega c. So what I will do is that I will assume a waveform being centered at 0. I will assume a waveform being centered at 0. This is the waveform I am having. With the bandwidth of 2b only, or you can say 4 pi b. 2b means here it is minus 2 pi b and here it is 2 pi b. I will call this as p of omega versus omega. Now, and let's assume the amplitude as n0. Okay, this amplitude is n0. Now, p of omega minus omega naught minus omega c plus p of omega plus omega c. Let's keep it n0 by 2 only, divided by 2, not divided by 2. Basically this particular thing is happening. This I assumed as p of omega. Now what I did is p of omega minus omega c. P of omega minus omega c, you will get this. P of omega plus omega c, P of omega plus omega c, you will get this. So if I do this process, what do I get? Sy of omega. Do you agree to this point or not? If I do this process, I will get Sy of omega. I assumed some waveform at the center having this bandwidth. Bandwidth is 4 pi b. Given bandwidth is 2b, so it would be 4 pi b in omega domain, right? Now if I shift it by omega c and I shift it by minus omega c, what do I get? I get this waveform. Now if I take the inverse Fourier transform here, what do I get? Ry of 2. And if I take the inverse Fourier transform here, what do I get? Let's just say inverse Fourier transform of this guy will be P2. So that would be P2 e to the power minus j omega c 2 plus P2 e to the power j omega c 2. What I can do? P2 I can take common, e to the power minus j omega c 2 plus e to the power j omega c 2 divide by 2 multiply by 2. Divide by 2 multiply by 2. So what you will be getting? 2 P2 cos omega c2. Now your target is to find out P2. So can you find out the P2? Surely I can find out P2. What that would be? Sin A2 by pi 2 into n naught by 2. So the same waveform I assumed at center and then I shifted it. So I know that this will be my answer. So what is my answer I am getting? Ry of 2. So Ry of 2 is coming out to be 2 into P2. So 2 and P2 this will get cancelled out. So n naught, here you are getting n naught sine of 2 pi B2 divided by pi 2 cos omega c 2. This is what you are getting. So this could be mentioned in the option, or what you can do, here you divide by 2b and multiply by 2b as well. So what you are getting? 2 n naught b sinc 2 b2 cos omega c2. This is your Ry of 2. There you go. This is the answer. 2 n naught b sinc 2 b2 cos omega c2. So always, like, these kind of things we have studied in the sampling theorem as well. Like, we will get this kind of expression, then we need to take the inverse Fourier transform. So how will I take the inverse Fourier transform? What I would do is that I will assume at the center the same, I will take this lobe only, but I will assume that this lobe at the center. If this lobe is at the center, then I can shift it. So this kind of waveform I can write down, and then I can simply take the inverse Fourier transform. So Ry of 2, this is the answer we are getting. So there you go. Here your random variable and random process chapter gets completed. Okay. There is another topic called random binary wave. Okay, random binary sequence we should call it. So that we will see in the miscellaneous. Okay. In miscellaneous we will see about random binary sequence. So once we study digital communication, after that we will come to random binary sequence, or in between only I will take random binary sequence. So your random process is completed and random variable is also completed. I hope you found it helpful. You found it in a great detail as well. So if you found it helpful, you can comment down and you can let me know what kind of content you what kind of quality you got here. Okay. Yeah. Thank you very much. Happy learning.